It's time for the next section, which is Kotlin. You've got a solid foundation in using Java, and you are now ready to move over to the modern language in which to make Android apps, which is Kotlin. I'll be doing a more detailed introduction to Kotlin in the next video, but in summary, Kotlin is a really fun, enjoyable language to use. It fixes a lot of the problems of Java, a lot of the code which we have to type, which is quite long and cumbersome. It fixes a lot of those problems. And I remember before I first tried using it, being a bit nervous. I was thinking to myself, you know what, I've only just started learning Java. Do I really have the headspace for Kotlin? Am I going to find it a long time? Is it going to be frustrating? And I can tell you, honestly, it took me no time at all to learn Kotlin. I immediately found it more enjoyable to use, easier to use, and since I've switched, I've never looked back. So, in this one section, you too are going to make the switch to Kotlin. You're not going to find it difficult, it's going to be enjoyable, and it's going to be a fantastic skill for you to have as a modern Android developer. The ability to code not only in Java, but also in the modern language Kotlin. Okay? So the primary objectives for this section are, number one, to be able to program in Kotlin. So by the end of this section, you're going to be able to make full Android apps entirely in Kotlin. Your code's going to look nicer, it's going to be more modern, and it's going to bring you right up to date with the latest best practice. And the other objective for this section, so that we're not only focusing on programming languages, but we're actually focusing on new important skills in making Android apps, you're going to understand how to pass data to a new activity or screen. Okay, so we haven't actually covered this yet. We've made classes, we've done recycler views on lists, and we've created data within one activity, but we haven't actually passed it to a new screen. And actually a new screen is a completely self-contained, independent, focused thing a user can do, if you remember from a previous tutorial. So this ability to pass data from screen to screen is absolutely crucial if you want to make a nice flow for your users when they do these individual focused things. So that's the two primary objectives. And the project for this section, through which we're going to learn all of this, is the Shameless Self-Promo app. So in this section, you're going to make an app which is going to be a marketing tool for you, the developer. So on one screen, it will have a form where you can type the name of the person you want to promote yourself to, their number. You can type your name. There'll be a checkbox for whether or not you want to include the word junior when you introduce yourself. There'll be a drop-down field giving you a couple of different options for how you want to refer to yourself: Android developer, Android engineer, and then the ability to say immediate start date or provide a specific date. So that will be on one screen, and then when you click preview message, it will pass all of that data to another screen, which will be the preview of a pretty well formatted introduction message that you can use in your real life to promote yourself. And then, just for some icing on the cake, when you click send message, it will use one of those implicit intents, this time to go to your text messaging app. So previously we did one for the email, where we did an implicit intent to send an email, and that launched Gmail on the phone. So this will be a different type of implicit intent that will launch the phone's text messaging app. So as well as the primary objectives, there will be a few more programming concepts, big, important areas of understanding in programming as a whole. So we're going to learn about null, what it means when a variable is null. We've maybe seen this once or twice, but we've not really talked about it yet, and that's very important, especially in Kotlin, as null can cause all kinds of problems and errors, and Kotlin, this modern language, looks to overcome many of these issues with null. So we'll cover null in detail. We're finally going to get onto access modifiers, so these words private, public, protected you may have seen, and this will link very well to how Kotlin has some defaults for these to save us some typing. Okay. And then the final programming concept will be serializable. So this is the idea of taking some programming code, a class that we may have written, like dishes or projects or one of these data classes we've made, and actually storing that, saving that to the phone, and then reading it again. And that will be a really important part of us passing data from screen to screen. As well as the primary objective and the programming concepts, there'll be many secondary objectives, and a few of those include understanding how to read the Android logs or logcat, which you might have seen at the bottom of the screen. If you've ever clicked this or had any problems with your app and trying to work out why it isn't running, you may have seen hundreds upon hundreds of lines of logging of console output. Okay, so we're going to understand how to read that and what to look for and how to filter that down. And then directly relating to that, we're going to actually be able to debug an Android app. So this means when we have a problem, we're going to be able to do clever little things and put breakpoints which will pause our app halfway through running and actually isolate what the problem is. So we're going to be able to do that this section. We're going to know how to use strings.xml to store strings and understand how internationalization works. So we've seen many warnings in our layout code about hard coding strings, typing strings in directly in the layout code. And we're finally going to fix those warnings and do it the correct way, technically speaking, which is to store them in another resource file called strings.xml. And later on, this can help us if we ever need to do our strings in different languages. And then related to this, we're also going to know how to use styles.xml, another file that you'll find in the res folder. And we're only going to do a very simple thing with it this section, which is to change our app's theme colors. So very quickly, we're going to be able to change the toolbar color, the button color, and the status bar color, which is the thing above the toolbar. Okay? So as well as the primary objectives and those programming concepts, lots of other very useful things we're going to cover in this section. And then finally, as always, we're going to introduce some more Android widgets, some more views to build up your library of things that you know, of widgets that you can use in your own projects. So we're going to cover a spinner, which is a simple drop-down field in Android. That's what they call the drop-down. And I've given you 2 screenshots there to show you it before being clicked and what it looks like after it's clicked. We're going to cover a checkbox, which is a fairly standard thing you see both on phones and on the web. Okay, and this is a checkbox that can be toggled on and off. And quite exciting, we're going to cover a text input layout, and by extension, a text input edit text. So these are super-powered edit texts. They combine the hint and the label for the field. So you can see there in the screenshot, contact number is highlighted, contact name is not, so that's grayed out, and then my display name doesn't have any value in it. But when the user clicks on that, the words my display name, that hint, will float above like contact number. Now you may have seen this both on phones and also on the web, and it's a key part of this material design, this Google standard design specification. Okay, so we're going to learn how to use these, and once we use these, we're pretty much never going to look back when it comes to using edit texts. It's just such a convenient and very professional looking way to handle input fields on Android. So, a lot of stuff in this section. Primary focus is Kotlin, but a lot of goodies along the way to develop your Android skill set. So let's get to it. So let's dive straight in and make a new Android Studio project in Kotlin. So I'm back at the Welcome to Android Studio dialog, if you can close down any previous projects and do the same. And we're going to click Start a new Android Studio project. Ensure empty activity is selected, which it is, and then click Next. For the application name, you may have seen in the section overview that I decided to call the app the Shameless Self-Promo App, okay? This is just a joke, really. Sometimes I can find marketing or promotions or sales to be a little bit annoying, and now I'm the one who's going to be marketing myself, so me saying shameless is a sort of personal joke. Feel free just to call it the Self-Promo App if you want, or My Marketing App, or whatever you want, really. I'm going to stick with the joke name just for a bit of fun. So the Shameless Self-Promo App with a hyphen. If you look at the package name, you can see it's done it all as lowercase, but you can't have a hyphen in the package name, and it's put an underscore. And to be honest, I don't really like the underscore, and it's a bit long anyway, so I'm going to remove all of that and just change it for just Self-Promo App. Remember, for the package name, it can be anything you like, really, as long as it's unique if you want it to be on the App Store. Okay, save location is fine. And now for the exciting bit. We're going to change, finally, the language from Java to Kotlin. Okay, so this is the big moment, the big switch. Ensure the minimum SDK is API 21 now, Lollipop. Change it to this if it's not, and then click Finish. Okay, so mine is finished loading, and I'm just going to close the project pane down so we have the code full width. And it's time now for our first look at Kotlin code. Okay, so at this point you might be feeling a bit overwhelmed, or you might be thinking, this looks quite similar. Whichever way you feel about it, the key takeaway is there are a few subtle, small differences, but for the most part it is very similar. Okay. Now, in this tutorial, this first look at Kotlin code, I don't want to go into too much detail about classes, methods, and variables. We'll do a deep dive into those in the coming tutorials. But it will be good to do an overview with a quick side-by-side. So what I'll do is I'll pause the video now and open up a new default Java project, okay? And we'll go over them side by side, see what's similar, and then see some of the few initial differences, okay? So I'm going to pause the video now. Okay, so on the left we have our Kotlin self-promo app, and on the right I've just made an example Java app, which is our Java code. So I'm going to expand the imports on the Kotlin project. So that looks similar, okay? And I will just put the method you see here in a bit of space. I'll put a line break either side, a couple of line breaks. Okay, so going over it, hopefully you do see initially much of it is similar, if not the same. But let's go over some of the key differences. So starting from the top, they both have the package declaration at the top of the file like normal, and they both have the imports. And they are written exactly the same, except for the fact that each line in Java ends with a semicolon. Okay, those three there, we have a semicolon. And indeed, the 2 lines of code in our onCreate method end in a semicolon. Remember, in Java, every line does need to end in a semicolon, unless it's a brace, a curly brace. Okay. Well, in Kotlin, we don't have to do this. Okay, so straight away we get a little bonus, one less thing to forget to put in, one less error for Android Studio to annoy us with, okay? We're going to go into what Kotlin is and how it works in a little bit more detail in the next video. But the important thing to remember is Android works in Java. So all of our Kotlin code is going to get converted to Java code, and some of these default typical things like semicolons that need putting in all the time, we don't need to type them in Kotlin. They will get put in for us automatically when it converts to Java. And indeed, you can put a semicolon at the end of each line like that. Won't be a problem, won't be an error, but we get a warning saying that it's redundant. We don't need this in Kotlin, okay? And this is one of the great things about Kotlin. Anything that is kind of a typical default thing you've got to do all the time, like semicolons or certain keywords in our classes and methods, if they occur very commonly, then you don't have to type them and Kotlin will put them in for you automatically. Okie doke. So, no semicolons in Kotlin. The package and import lines otherwise exactly the same. If we look at the class block, you see here on the left in Kotlin and then on the right in Java. So we still have the word class and the name of the class. Class main activity, class main activity, yeah. And with inheritance in Java we have the word extends and then the parent class, extends and the superclass. While in Kotlin, rather than making us type the word extends, which you have to type every single time you do inheritance, it just replaces it with a semicolon. It's such a common thing when you do a class to often use inheritance or extend something that they've just made it a single character. And then we have the name of the superclass, the name of the parent class. Okay, in Kotlin we have a couple of braces that looks like a method, or in this case actually a constructor. And later on we'll do a Kotlin Foundations tutorial on how classes work in Kotlin, and we'll understand how inheritance and this kind of thing really works. But hopefully you're seeing it is a lot less code to do a class with inheritance in Kotlin than it is in Java. Some things like the word public, which are really, really common in Java, public class and public methods, as a sensible default, Kotlin just says, you know what? If you don't specify one of these things, we will do public by default for you. Okay? So again, it's these sensible defaults, these sensible little things it puts in automatically to save us time typing and to make our code look a bit smaller and a bit tidier. We come down to the onCreate method in Java. We have this @override annotation, which is really common in Java and Android. You're going to be overriding methods a lot, especially in activities and in recycler views and whatnot. Well, rather than having this override annotation with a weird @ symbol taken over a whole line of code, now it just makes it in line next to the method. Okay. Now there's a couple of differences in terms of the return type, void return type, and the way the parameters happen. But you still get the name of the method, you still get the brackets where your parameters go. Okay. But one thing Kotlin does to provide a distinction between classes, constructors, and methods is this word fun. So in Kotlin, they call their methods functions. Okay, so you can think of function and method to be synonymous for the most part. They basically mean the same thing in Kotlin. But in Kotlin, unlike in Java, we actually have to say that it's a function, that it's a method. And we do that with 3 simple characters, the word fun. And I quite like that because I do find coding in Kotlin fun. So I like that I get to type the word fun when I'm writing programming code. So what we get is the word fun that tells us this is a method, this is a function. And this helps us differentiate between classes, constructors, and then indeed our methods. And then if you actually look inside the method, inside the function, apart from not needing semicolons, the rest is exactly the same. Kotlin still does super methods, the app-compat activity super on create, just like Java, the same way, and it calls the setContentView method the exact same way. So I'm going to leave this quick first look Kotlin tutorial video here. The key takeaway I want for you is that there are 1 or 2 small differences, and the most important of those differences we're going to cover in individual tutorials. How variables work, how methods work, how classes and inheritance work. We'll do a deep dive to make sure you fully understand that in Kotlin. But apart from those few small differences, a lot of it is very similar, if not the same. And as you move over to writing code in Kotlin, you're going to find yourself typing less code. You're going to find yourself facing less errors for forgetting to type words you might not remember or putting semicolons at the end of the line. Okay? And if I just make this full screen again and remove these line breaks. And the final key takeaway I hope you're seeing from this first impression is that Kotlin code looks a lot tidier, a lot neater, and frankly, just less code. Okay? So, congratulations, you've created your first project in Kotlin. So let's now do a deep dive into what Kotlin really is and why it's important you learn it. So this tutorial is called Why Kotlin? The purpose is to provide a bit more information on Kotlin, the background, some facts and interesting things about it, before we dive into the Kotlin Foundations tutorials where we start to learn in detail some of the main differences. It's also an opportunity to answer any questions that you might have about Kotlin at the point in the course where we finally make the big switch. Okay, so the big 3 questions I want to clear up in this tutorial is what is Kotlin, why use Kotlin, and then if it's so great, then why not learn only Kotlin? You know, like why did we go through learning Java first? Okay, so hopefully I'll answer these questions for you in this tutorial. So first of all, what is Kotlin? And I've taken a quote here from the official kotlinlang.org website. This is the official home of the people who make Kotlin. So Kotlin is an open source, statically typed programming language that targets the JVM, which stands for Java Virtual Machine. We'll get onto that in more detail in a moment. So it targets the JVM, Android, and JavaScript and native, which we don't worry about at the moment. It's developed by JetBrains. Okay, so JetBrains, in partnership with Google, actually make Android Studio, the software that we use, okay? So the project to make Kotlin started in 2010, and it was open source from early on. So this means that yes, it's developed by JetBrains, but the code is public. They make changes, they put it to the users, to us developers, they ask us questions, they ask for feedback, they let us look over the changes. As a general rule, when software is open source, that's usually a good thing because it means more transparency about the changes and more developer input, so we get to be part of helping it advance and become even better. So the project started in 2010, but the first official 1.0 release was in February 2016. Okay, so it's actually relatively new, you know, just over 4 years old since its public release. To put this in context, Java, which we've already learned, well, that was launched back in 1996, so 20 years earlier. Okay, so Kotlin is 20 years younger than Java, and being so new and learning from all the mistakes of Java presents it with a great opportunity to really improve and make a change for the better. Just covering 1 or 2 other things in this quote from the kotlinlang.org website. So when we say statically typed, Java is statically typed, you know, where you have a variable of type string or type int. Okay, so it is similar to Java in that respect. And in terms of it targeting different things, the Java Virtual Machine or Android, we'll be covering this in a moment where we talk about the idea of where it is your code runs. You know, what is the environment where you give a machine, whether that's a phone or computer, what is this environment? What is the thing that reads that code and does stuff with it? Okay, And it's given you 4 different types of environment there: JVM, Android, JavaScript, and native. So that's a brief overview of what Kotlin is from the makers themselves. Okay, so this is an overview of how Kotlin works on Android. And to do this, we need to do a slight deep dive into how any code we write, whether Java or Kotlin, how that works, how it gets converted, how it gets read, and then how it translates all the way down into performing tasks on the device. We talked about this a long time ago when we first learned about programming languages. So first of all, the code runs on the Android runtime, known as ART or ART. Okay, on older versions of Android, we're talking pre-Lollipop, so pre-API 21. On older versions, it was the Dalvik Virtual Machine, or DVM for short. Okay, but anything Lollipop or later, it will be the Android runtime. This is like Android's version of the Java Virtual Machine, or JVM. Now, don't worry if you've not heard about the JVM before. As mentioned earlier, this is the environment where the code runs. So when you've got your phone turned on, there is a process, a thing, which is waiting to receive the code that we write, this runtime environment. So when the phone is running, it receives this code, and that is the thing that understands the stuff that we type. Or actually, to be more correct, the bytecode of what we type. Okay, so there's this environment, either the Android runtime or on older phones, the Dalvik Virtual Machine, that is running when our phone is turned on, and this is the thing that understands the language of what we're making. And then that in turn translates that into things the phone can do, whether that's connect to the internet, show some pixels on the screen, okay? And once you get past this runtime environment, then you're talking machine code. That's where it's all ones and zeros. We don't care about that, okay? You don't need to know too much about the Android runtime. It's not important to have a successful career to have much of a knowledge of the inner workings of it, okay? But it is good to know that fundamentally, any code that we write ends up being interpreted, read by this runtime environment. On a computer like Windows, it would be the JVM, the Java Virtual Machine, and on Android, if it's Lollipop or later, it will be called the Android runtime. Okay, so if we look now across to the diagram on the right, we can see the flow of this. So we write either Java or we write Kotlin. Okay, so we can choose one of those two top-level, high-level languages. Nice and human-friendly, easy for us to understand. Then the compiler will convert this into Java bytecode. Okay, so this is the first important concept here. Whether we write Java or Kotlin in our files, the Java will have the Java compiler and the Kotlin will have the Kotlin compiler, and they will each convert their language into the same Java bytecode. Even if you write Kotlin, the Kotlin compiler will convert to Java bytecode, the exact same Java bytecode as if we'd written it in Java. And that's a really important thing to understand, okay? Now this word compiler, just a posh word for a computer process which converts our code into some slightly more difficult to understand code usually. Okay, so we write something that's human friendly and then a compiler will convert that into some other code. And in just a moment, I'm going to show you what this bytecode looks like. It's not ones and zeros, it's not the machine code that the Android runtime is going to be dealing with. We'll probably never see that. But it's like a slightly more difficult to read, more technical looking, but long and cumbersome version of our previous Java code, okay? So, to confirm those 2 points, the Kotlin compiler converts Kotlin code into Java bytecode. And this is the same Java bytecode that would be created if we wrote our projects in Java. Let me jump over now to our new project, into one of our Kotlin files, just to show you what this Java bytecode looks like. So, just in our new Kotlin project to show you a little bit of this bytecode that I've been talking about, and also a bit about what happens when you build your project. So when we click the play button, when we run our code for the first time, a new folder will pop up in our app folder on the left, you see here in the project pane. And this is the folder in orange. Now, as a rule of thumb, we don't ever want to be touching or messing around with anything in the orange folders. So you can see there's a couple of orange folders here and there. This is automatically generated code, okay? But if I just expand it to show you, you can see we get these subfolders in the build folder, and we get this intermediates folder, yeah, with a whole heap of folders there. So when we run our code, the Kotlin or Java compiler, if we're writing Java like before, will read our files and it will generate a whole load of new files. And those files will be in the build folder of our app folder. It's not a folder we're ever really supposed to touch or mess around with. And it's in here that our bytecode and the compiled code will be saved. I'm going to close the project pane down to leave the code full width. And I'm going to go to a useful little thing that exists that you will never really need to look at. So don't worry about remembering this. But I can go to Tools, Kotlin, and then Show Kotlin Bytecode. So let's click this. I'm going to drag it across to be half the width. And if we look down this, it's very difficult to read, very cumbersome. As you can see, lots and lots of lines and numbers and paths. It's not very user-friendly. I personally would hate it if I had to type this when making Android apps. But if we scroll to the very top and actually look at it, public, final, class, main activity, extends, and then protected on create, it's actually Java. This is not Kotlin bytecode. There is no Kotlin bytecode. This is Java bytecode. Okay? So we write Kotlin files or Java files, and they both get converted to this. Okay? I can click decompile to see what this would look like if it was in Java. Okay, so if I click this now, I get a new file. Okay, there's some extra junk here, these grayed out methods. But if we actually look at it, public, final class, main activity, extends app compat activity, protected void on create, bundle, saved instance state, set content view. Okay, it's actually very similar to the Java code we've seen before. A few little differences, a few extra performance things like a view cache that we don't need to worry about, but hopefully you're understanding the concept that whether we write Kotlin like this, or if we write Java a bit like this, it's going to end up as the same Java bytecode. And this is how Kotlin works. And this is how we're able to write Kotlin that works with Java code and Java code that works with Kotlin code. It all fundamentally ends up as the same Java bytecode. And Java bytecode is not a language that we ever need to understand or even look at really. Okay? So back to the presentation. Now the final bullet point says, from the point of it being in Java bytecode, from there, the process of making it to the runtime environment is the same. Okay, so whether you write Kotlin or Java, it will become Java bytecode. It goes through another compiler even lower down, a DEX compiler. Don't worry about remembering this or understanding this at all. And that will convert the Java bytecode into an even more, in my opinion, difficult to understand code. An even more lower level code, as we call it, closer to something that the computer can directly understand. Okay, so our Java bytecode gets compiled again by a DEX compiler. Don't need to worry about this. That makes DEX bytecode, which is horrible to look at, and that gets given to the Android runtime, the ART, or the Dalvik virtual machine on older phones. And at that point, this runtime environment, this running process in the phone that separates our apps to make sure that the apps don't cross over, and if your app crashes, it doesn't break the phone, this runtime environment takes care of it from this point. And that's the thing that ultimately makes the ones and zeros to show pixels on the screen, and sound coming out your phone, and all of those physical things that a computer or a phone can do. Okay? So, key takeaway, Kotlin compiles to Java bytecode, just like Java. So moving on, why use Kotlin? So again, quoting from their website, Kotlin is more concise. Rough estimates indicate approximately a 40% cut in the number of lines of code. It's also more type safe. For example, support for non-nullable types makes applications less prone to null pointer exceptions. Okay, so in this section we are going to do a programming concept on null, something you may or may not have seen before. It's a major problem with Java, a variable being null and then trying to do something with it and it causing the app to crash. Major problem. We'll do a deep dive on this in that programming concept tutorial, but Kotlin has some language-specific tools and support to help prevent this, to help overcome this, so it's never a problem again, okay? As well as many other type safety things when we talk about variable types and whatnot. So, taking this again from their website, so they mentioned concise. Kotlin drastically reduces the amount of boilerplate code. We've seen a little bit of this in the second tutorial where we looked at the new project, but you're going to see later on in detail the extent to which we type so much less. Okay, whether it's sensible defaults or reducing things like those on-click listeners you've seen where there's new, view, on-click listener and all those lines, you're going to see how much smaller and more concise it is. We've mentioned before just then safe, avoiding entire classes of errors such as null pointer exceptions. So we're going to see very soon some of these safety mechanisms and ways they can prevent these quite problematic errors and crashes. And a final one from the website is interoperable. Leverage existing libraries for the JVM, Android and the browser. So forget the JVM and the browser, but leveraging existing libraries for Android, you can use Java libraries. You can even write your own Java classes and it will still work with your Kotlin code. Okay, you can swap Kotlin for Java, Java for Kotlin, because it all compiles to the same Java bytecode. It doesn't matter, it doesn't make a difference. So it's really flexible to use, to move old projects over to, or to make brand new projects that use slightly older libraries or Java libraries. Okay, so there are many, many benefits to Kotlin. Just showing you some stats very quickly. So this is correct as of September 2020. It's from a website called appbrain.com. They specialize in analyzing app installs, the Play Store, downloads, percentages of apps and demographics and all that kind of thing. So from left to right, as of September 2020, the overall app installs, this is everything from the Google Play Store, the overall app installs that contain Kotlin is 28% of all apps. Okay, so that's quite a significant proportion. Now, what they call new app installs, so percentage of apps that have been made more recently, that then rises to 38% that use Kotlin. So as new apps are coming out, more and more are starting to move over to Kotlin. And the one on the right is the most important one I want you to take away. The top 500 apps in the US Play Store. So this is the best, the highest performing, the most downloaded, the big apps, the Facebooks, the YouTubes. Okay, these top 500 apps in the US Play Store, 67% of them use Kotlin as of September 2020. This is what the pros do. This is what the big apps do. The majority of them use Kotlin, and I really think that you should too. Okay? It's new, it's modern, it's easier, it's less code, it's cleaner, faster to understand. It has safety mechanisms and improvements that solve a lot of the problems of Java, that language that is 20 years older than it. Okay? Many, many benefits. It's the way that many app developers are moving. You in your Android developer career, you're going to work for a company and it's likely they're going to want you to know Kotlin as it's the language of the future and it's the way that things are moving. Okay? Which then leads to my final question that I want to answer for you. So why learn Java first? You know, if it's so great, why not only learn Kotlin? Why have I spent so many tutorials in this course going through Java to now switch to something that you're saying is maybe better? This is slightly a matter of opinion, but it's one that I stand by strongly through having gone through both, and from now being a senior Android engineer, I can tell you the value of this. So, 3 reasons really. Reasons why understanding Java is a big benefit. So many libraries are still written in Java. When we click through to see the behavior of methods and classes of libraries, and a big example of this is app compat activity, if you were to command click or control click on set content view, that library is in Java. Many of the Android libraries are written in Java. They still work, they're rock solid, they've been thoroughly tested. They saw no need to switch them over to Kotlin. They wanted to provide some extra support to some legacy apps that are still using only Java and for which there may be some performance issues if they were to switch to Kotlin. So they've left them in Java. We can then more easily understand that code if we know Java too. There are many libraries that are out there that are still in Java. Not just the Google or Android ones, okay? And if you want to really know what's going on there, yes, you're going to know Kotlin, but you're also going to know Java and you're going to understand what's happening and it's going to make you a better developer. Kotlin can mask some of the underlying behavior of the code. So Kotlin aims to be concise, easy, look clean, but this can mask what's really going on. So there's concepts on interfaces, visibility modifiers that are coming up later in this course. They do some clever things to massively reduce the amount of code that you need to type, but in doing this, you might not really understand what's going on, like what an interface is. So when we do an on-click listener, what's really happening there? Because in Kotlin, an on-click listener is very easy, but it will help you to understand what a view.onClick listener interface, as it is, it will help you to know what that really is. So by only learning Kotlin, you kind of miss the opportunity to really dive in and see what's happening there. So if we understand Java, we understand these shortcuts in Kotlin. So we ensure a deep understanding of our Kotlin code. So you're not only going to know these wonderful Kotlin shortcuts, you're going to know what they're doing in terms of Java. So you're going to understand Kotlin code that little bit stronger. Okay? And the final point, Java is still incredibly popular and common. Java is still the second most popular programming language, and this is true as of September 2020. It's from the source you can see there, tob.com, the TOB index. Not sure how you pronounce that, but it's a universal measure of all of the programming languages that are out there. It's not the list of what's the best or which performs the strongest. It's ranked by how many people are using it, how many jobs are available in it, how much code is written in the language. And it's presently number 2, okay? So knowing such a popular language as this, a second language to your Kotlin, it's only going to be a strength to you, making you a well-rounded developer. There's going to be no harm to you knowing more than one language. It's going to make your CV look stronger. As well as this, if and when you get a job as an Android developer, you may need to work on an existing project, a slightly older project, which is in some ways written in Java. This may happen to you in the future. They're going to ask you to convert it to Kotlin. They're going to ask you to maintain it, to develop it. Okay? And you are going to stand out so much stronger as a developer that knows both Java and Kotlin than a developer who only knows Kotlin and can't work with that Java code. So that's 3 big reasons why you knowing Java is a massive strength. That said, from this point in the course, we're going to heavily focus on Kotlin. We may refer back to Java when we do some programming concepts, but for the most part now, it is all about Kotlin. It's going to be super quick to switch over because it's so easy, very similar to Java as you've seen. So let's get to it with our first Kotlin Foundations tutorial coming up next. It's time for our first Kotlin Foundations tutorial, which is on variables. I'm back in Android Studio. I've closed down all the project files, and in the project pane, I've closed all of the project folders, and I'm just in scratches and consoles with scratches open. So because now we're going to have Kotlin Foundations scratch files, as well as our programming concepts, I'm going to make a separate folder for our Kotlin Foundations tutorials. So if you right-click on scratches and do New Directory, and we'll just call it lowercase Kotlin space Foundations, and enter. And we'll put our Kotlin scratch files in here. Right-click on the directory that we've just made, and do New Scratch File. And this time we're going to choose Kotlin. Okay, so you may need to scroll down for this. It's in alphabetical order. Mine's at the top because I've done one before. Okay, so now we have a new Kotlin scratch file. Kotlin files ending in .kts and our Java scratch files ending in .java. We'll rename this file so we know which one it is for reference. So right click, refactor, and then rename file. Don't do the rename one, so rename file only. Okay, and I'm going to call it variables.kts and then refactor. So we know how to do variables from Java. We specify the type and then the name, and then it's equals. So variables do look a bit different in Kotlin, but once you get used to it, they are super easy. So for a variable, we type the letters var for variable, then a space, and then the name of our variable. So the name comes first before the type. So we'll call this my Kotlin variable. And the way we specify type in Kotlin is a colon immediately after the variable, like that, then a space, and then the variable type. So we'll do string first of all. Okay. And then from this point, it's the same as Java. So we do equals and then the value. So speech marks, and we'll say my new Kotlin variable. And remember, in Kotlin, we don't need to do a semicolon, which is fantastic. I'm just going to close the project pane to make this full width. Now you'll notice on the right, we have what looks like a log or a console output. So this is showing us that we've just declared a new variable and it's giving us the name of it and the type that it is. And if I want to see what the actual value of this is, I can just type the variable on a new line like this and wait a moment, and then the value of it will pop up on the right. So this is one thing that I absolutely love about working in Kotlin scratch files. We no longer need to do the system.out.println thing. We can just type the variable and we get an almost immediate real-time log or console output to the right. So it makes it a lot easier to see what we're doing. You'll also maybe have noticed as well, we don't need to put any of our code inside a class or in a main method like we did in Java. In Kotlin, we can just type variables and methods or functions. We can just type them in a blank file, so it's much, much easier to work with. Okay, so looking above at that variable, we can see it's different in that it starts with the var to tell us that it is a variable. And the other main difference is that rather than the type and then the name, it's the name and then the type after a colon. You'll see this colon character used quite a lot in Kotlin, whether that's in place of the word extends. You know, when we saw main activity extends app compatibility, we saw how they used a colon there. So when used with variables, it's the name of the variable, then a colon followed by the type. So we'll do a comment above this as a note. So above the variable, make a new line, do // So we type var for a variable, then the name, and then a colon followed by the type, just like that. And this is a normal variable, so we can change this. So I can do my Kotlin variable equals my updated variable. And then just to see on the console to the right of the output, I can type the variable again. And if we wait a moment, we'll see the my updated variable value to the right. So nice and easy for us in Kotlin Scratch files to see our updates. Good. So I'm going to do a few line breaks now. 3 line breaks. There is one other major type of variable when we work in Kotlin, and that is a variable where once we assign it, it doesn't change again. It remains fixed. We've not really done this in Java. It is possible in Java. You would add the word final before the variable. You'd say final string and the variable name, and that would say, once I've set it, this will not change again. And this can be a very good thing to do. It's a good way to stop your code changing when you don't want it to be changed. An example of where we might use this is in the BMI calculator or any app where we have like a form where we capture all of the edit text values. Well, we would make a local variable for those values. You know, we would set them in like a method like calculate BMI or whatever. We would declare those variables in that method at the point where we need them. And once we've set them, we wouldn't then change them again later in code. We just want to capture them. So in that instance, a final variable, a variable which can't be changed, is exactly what we want to be using, really. So the way you do this in Kotlin, rather than var for variable, we type val for value, like a fixed value. So my fixed value. And this time, just for a change, we'll make this of type int. And in Kotlin, int is with a capital I. So my fixed value int, like that. And we'll make that equal to 6. And then if I just type my fixed value, so we can see that on the right. Okay, we can see that there. So if I then try to change this, my fixed value equals something new, like 3, well, we get an error. And when I hover over this, val cannot be reassigned. So if we want to declare a variable, and then we assign it a value, but once it's assigned, we don't want it changing in the future. We don't want anybody else in our code changing it. We want it to remain fixed. Then we use val. And this is quite a common thing to do in Android projects where we capture values from a form. We want to capture the values that are in the form, but we don't want anything in our code to then change that. So a val is exactly what we would need. So I'm going to comment that out. That won't work. I'll put a space next to it, and then I'll just put a note. So I'll put a little arrow that says, this won't work. A val cannot be changed once assigned. So just above this major second type of variable in Kotlin, the val, we'll put a note to explain this. So / type val for an what's called immutable variable. So that's the posh word for a variable that can't be changed. It can't be mutated. Okay, it's fixed. So immutable means it can't be changed later. And I'll do another line, and in brackets I'll put a note saying you can think of this as a read-only variable or a fixed value. Okay? So we set it, we assign it once, and then that is fixed. From that point we can only read it, we can't write to it, we can't update it. So read-only or fixed value. So that's the two main types of variable in Kotlin, a var for a variable or a val for a fixed value. But there's one other thing in Kotlin that is super cool. You see above where we declare the type, colon string for the string variable and colon int for the int variable, well, Kotlin can actually infer the type from when we set it. It can actually determine what it is automatically, and we don't need to specify it. So for example, if I do a normal variable again, var, my inferred variable type equals, I'll do another string, no need to specify the type. Okay, so do you see there, I've not done colon string. I could do if I wanted to, but if I remove it completely and we look to the right, if I just drag this over a little bit, we can see it's already worked out that it's a type string. It's inferred the fact that it's a string. Okay, and I can change this to the number 27. If you look to the right, it's inferred that it's an int. And if I change this to true, it's inferred that it's a Boolean. So this is a super cool thing with Kotlin, these shortcuts. Okay, if I just go back to my string, if I'm setting my variable at the point where I declare it like this, and I can see in black and white, there it is, a string, then I don't need to specify that it's a string, but Kotlin knows. And just to prove this, if I then do my inferred variable type, we can see no need to specify the type, there it is. And then if I try to put in a different type of variable, so let's do my inferred variable type equals 7, okay, we get an error. And when I hover over this, it says the integer does not conform to the expected type string. Okay, so even though we didn't specify string here, even though we didn't do this, Kotlin knows it's a string, and you get all of that security of knowing that this container, this variable pot, can only have a string inside it, just like in Java. Okay, so let's comment this out and just put a little reminder saying this won't work. The inferred type is string. So we will put another note above this saying we don't need to explicitly specify the type. Kotlin can infer the type from the assignment. I'll just move this over a little bit. Okay, and that is pretty much all we need to know about variables in Kotlin. So either var for a variable or val for a value, something that's fixed, then the name of the variable. Then if we want, we can specify the type of the variable, colon string, colon int. But if we declare a variable and assign the value straight away like this, then we don't need to specify the type. In fact, this is the preferred way to do it without specifying the type. So where possible, don't specify the type. It's cleaner, it's easier to read, and anybody looking at this variable can see it's of type string. Okay? And just to finish this tutorial, I'll give you my really helpful reminder for remembering var and val. So one final comment, and I'll put remember var for variable, brackets, it varies, it can be changed later, and val for value, brackets, a fixed value. Okay, and for the time being, that is all we need to know about Kotlin variables. We'll get the chance to apply this very soon once we build our layout and then start to reference those views in the layout. So let's do that next. I'm back now in main activity in our project. I've closed down the Scratch file from the previous tutorial. So we now need to build the layout for our self-promo app. So to do this, we want to be inside activity_main, the layout. There's a few ways we can get to that file. We can go to the res folder, so res, layout, and then double click that. We can do shift and then start typing activity_main. But I thought I'd show you one of my preferred ways to jump around files. So here I am in mainActivity.kt, the main activity class. And where it says r.layout.activity_main, I can control click or command click this. So you can control click or command click resources and indeed classes like app_compat_activity to jump to that file. So I quite like to do this, jumping around files by control clicking. So control click on activity_main, and that brings us straight into the file. I'm going to close down the project pane now to give me more width. So we'll delete all of this content now. We will eventually get onto constraint layout, but in this case, a simple linear layout is going to be absolutely fine to stack our fields on top of each other. In terms of the top element, it's a really good idea whenever you make a layout which has even a slight possibility of filling the full height of the screen, definitely put it inside a scroll view. Even if it fits within the height of our design preview to the right, and even if it fits within the height of our emulator or real phone, it is quite possible you will have some users on a smaller device, whether that's smaller in size or smaller in resolution, and we want to make sure that they can see or scroll to all of the content. So good practice, we'll put this inside a scroll view, autocomplete, and we'll give it the necessary layout width, match parent, and layout height, match parent. Okay, especially important with your scroll views, do make sure they both say match parent, otherwise it won't work properly. And I'm going to swap the self-closing tag for a regular right arrow. So I get my closing tag, and then I'll make the next view group, the next container, be linear layout. So I'll make this be match parent for width, but wrap content for height. So if indeed it is bigger than the screen, that doesn't matter, it will be as high as it needs to be, and the scroll view will take care of the rest. I'm not going to forget my orientation, which will be vertical, and then a normal right arrow, so we get our normal closing tag. So we're now ready to start building out our layout. So the first thing we need is 3 fields, one for the contact name, one for their contact number, and then one for our preferred display name. I did show you in the section overview a new Android widget called the text input layout, that special material design thing where it combines the hint with the label. I'm going to cover that in the next tutorial, as I don't want this layout building tutorial to be too long. So for now, I'll just put a regular edit text, as we've done before, and then in the next tutorial, we can look at upgrading that to the text input layout, or the text input edit text. So for now, an edit text will be fine. So edit text, width match parent, and height wrap content like normal, and we'll give it a hint of contact name. We'll make sure to give an ID to all the views that we will need. So all of our edit text we want to have an ID for. So ID, autocomplete the plus ID, then edit underscore text underscore contact name, and then a self-closing tag. I'm going to copy this 3 times. So 1, 2, 3. We'll get some errors because we've got some duplicate IDs. So this will be the contact number. Edit text contact number, and this will be my display name, and edit text my display name. I can see on the right that the spacing isn't very good for the elements, and also that they go too far to the edge of the screen. But what I'll do first is get all of the elements in the view and then fix the paddings and margins later. Feel free when you're building layouts to fix margins as you go. My preferred way is just to dump everything on the screen first and then tweak those finer touches later. So that's our 3 fields. The next thing we need is a checkbox to say whether or not we want to introduce ourselves as being junior or not. Okay? And nice and easy, it comes as part of the default Android library, so no imports, no dependencies, no build.gradle. We can just do left arrow and then checkbox like that, capital C, capital B. Okay, so that's all we need. Again, I'll make the width be match parent, but I'll make the height be wrap content. And then the attribute we want for this is text. So we actually want to set the text on this to say include junior inside single quotes. And this checkbox just gives the user the ability for a simple true or false, on or off kind of thing, just like a normal checkbox that you would have seen on numerous mobile apps and on the web. We'll give it an ID, following the convention that I like, which is the name of the element in snake case, so lowercase check underscore box, underscore junior. That will do. And then self-closing tag. The next thing we need under this is Android's version of a drop-down field. So we can select from one of a finite number of different options. So Android's name for the drop-down is called a spinner. And again, this comes included in the default dependencies. We don't need to add anything special for this. So left arrow, capital S, S-P-I-N, autocomplete the spinner. We will make the width match parent, the height wrap content. Now we're not going to see anything to the right because a little bit like with our recycler views, we need to give it the items with an adapter. It's nowhere near as complicated as a recycler view adapter, but it's something we need to do in code. We need to set the layout and then set what array of items we give it, okay? but there is something we can do in the XML to give us that design preview. So if we use our tools library again, so tools like that, and then a colon, then if I click on tools, I can do Alt Enter or Option Enter and import that. And then the attribute we can use, like with our recycler view list in a previous section, is this one called list item. So by doing tools list item, we can specify, just for the purpose of our design preview to the right, a layout so we can, see something. And we will actually use the layout that we'll later on be using in our adapter that we'll make. And it starts with Android, so do @Android, it's from Android's default libraries. And then layout, /, then simple underscore list underscore item underscore 1. This is one of Android's useful template layouts that we can use, and it'll be absolutely fine for our dropdown or to complete that. And then we'll do an ID. So ID autocomplete plus ID spinner underscore job underscore title. Okay, and then a self-closing tag. And if we look to the right, we can see we now have a layout for our spinner, which makes it easier for us to do things like margin and padding in just a moment. So we're nearly there. The final two fields are a checkbox to say whether or not it's an immediate start date, and if not, then an edit text to input the date we're available from. So we'll do another checkbox, capital C, capital B, autocomplete, match parent for the width, wrap content for the height, text we will say immediate start, and then the ID will make check underscore box underscore immediate underscore start, self-closing tag. And then finally, if not an immediate start, one final field, an edit text. So match parent, wrap content, the hint we will say available from date, and then the ID we will make edit underscore text underscore start underscore date, and a self-closing tag. So I'm going to do Control-Alt-L or Command-Option-L to auto-format this so I get all of my IDs at the top. So let's do this now. That looks better. And I'm going to scroll to the top. So that's all of our fields. Let's do a tiny bit of margin and padding to make these be laid out a bit better. So on the linear layout, not the scroll view, on the linear layout I will make padding to squeeze everything in, and I'll do something fairly big, 48 dp. That means none of our elements, none of our widgets will go too close to the edges, which is good. We can leave the first edit text, but then for the subsequent edit texts, we want to have a little bit of margin. So let's do margin top, and we'll say something small-ish, like 8 dp. That looks okay. I'm going to copy that whole line by triple clicking, Control C, and put it on the next one. So that spaces those first three edit texts quite nicely. I'm going to do the same 8 dp for the checkbox as well, give that a bit of space. Yeah, that looks okay. I'll copy that line for the spinner. I'll do the same amount of margin for the checkbox below, and then the same amount of margin for the final edit text. So looking at that, 8 dp for all of the margin tops seems to be just about right. So the final thing we need then is a button to submit the form. Okay, so we will do a button. We'll make the width match parent, the height wrap content, and then text, preview, message, and then an ID of button preview, self-closing tag. We should probably give a little bit more margin to separate the button from the form a bit. So let's do margin top 24 dp. That looks nice. And it looks a bit boring with the default grey. So if we want to actually have our button with some basic styling to give it the colour from our app's theme colours that we will change later in this section, we need to apply one of those style attributes. So style with no namespace, just like that, style. And then if we do @style, we get access to some of the default styles that we get when we make a new project. So we'll do style /, and if you just type the word button, capital B, button, okay, and then you see that filters down to quite a few different styles with the word button, and then just type capital C for coloured. Don't put the dot, but just put a capital C, so button, coloured. Okay, that filters down to 4 different styles that have button.coloured in it. If I scroll through them, I can see there's 2 with widgets.appcompat and 2 with textappearance.appcompat. Okay, no need to understand these subtle distinctions between these. Just for now, if you go with widget.appcompat.button and then .colored, that will give us our accented button, our button that will follow the color of whatever our app's theme colors are. And again, we will get into styles, we'll get into the app theme colors in a later tutorial in this section. Okay, but now we have a nicely spaced form with all of the elements that we need and a nicely styled button. I'll do one final Control-Alt-L, Command-Option-L to bring the ID for my button to the top. Okay, and that is all of the elements that we need on our screen. So we can move on to the next tutorial where we will upgrade these edit texts for something a lot more modern and in keeping with Google's very popular material design specification. So let's do that now. I've launched the project as we have it so far on an emulator, which you can see here, just so that we can have a look at our layout, look at the form, and see what it's like to interact with. So we have our checkboxes. We can toggle these on and off like this. They just work out of the box. We have our drop down, but presently there's no values inside it, so it looks a bit silly, just an empty drop down. We have our button, which looks nice with the accent and the nice click effect. And then we have our standard edit texts with the hint inside. Now I'm just going to fill these out to show you what it's like for the user. So I'll click inside contact name and I'll just type Jane Muck salesperson. And then their number can be some fictional UK mobile number. Then I'll do my name. Okay. Then I'll just put some date inside here. 24th October 2020. Okay. So if I just close the keyboard. So one major drawback with the standard edit text is even though we can have a hint which guides the user what to type in when the field is empty, once we fill it in, well then we lose that hint. And unless we have a separate label, some kind of small text view either to the left of it or above it, then after the user has typed in the value of the field, they no longer get a guide as to what that field was for. And that might be just about okay for a simple app like this, although even then it would be nice to have the reminder as to what each field is. But can you imagine a more complicated form, a form where some of the fields might be very similar, first name, middle name, last name? You're going to want to give the user that guide even once there's a value inside the field. Okay? So in the section overview, we talked about this new widget called the text input layout. Then that also comes with a special edit text called a text input edit text, all as one word. Okay? So this comes straight from the Google Material Design Library. These are not views that we get by default in a blank project, so we are going to need to find the dependency for this. And you might think, oh, I can just do Android text input layout dependency, find that. But actually what we're going to want to get is the whole material library. So we're going to go now onto the internet and find the dependency that we need for our material design library. So let's do that now. Okay, so I'm going to search Android material dependency that you can see there and search. Now there is a link to developer.android.com, but this particular one you want to get from material.io. So not all libraries come always from the developer.android.com. This one we want from material.io, because material design isn't just for Android. It's for iPhone, it's for web, it's for any design style that wants to use this kind of paper-like design style that they pioneered. So material.io, we'll click this one. And then if we scroll down a little bit, we get to the dependencies section and we'll copy this line. So I'm going to triple click this and copy. Now you'll see they haven't put the version number in here. They've just put arrows and then version. And they don't actually specify in this document what the current version is, which is a bit unhelpful. However, in the latest version of Android, when we copy this line in, Android Studio itself will tell us, hopefully, what the latest version number is. So let's just copy this line exactly as it is. So back to Android Studio. I'm going to minimize the emulator now. And we need to go to our build.gradle file. So you can do Shift or I'll do project. And it's the build.gradle file, not at the top level, not this one, but the one inside app that we need. this one here. So double click the one inside app. Okay, and then if we scroll down to the dependencies block, and I'm going to put it under these ones that say implementation. I'm not going to put it next to the test ones. I'm going to copy that line exactly as is. And yep, straight away Android Studio gives us a warning. When I hover over this, it says a newer version is available, 1.2.1. So I can swap out this version placeholder for 1.2.1, and then the warning goes away. I'll remove the line breaks, and I'll click Sync Now, or the little elephant icon, either or. Sync Now, and that's going to go on the internet, take our shopping list, take our ingredients, and it's going to download those files. Okay, that appears to have finished. So now we can go into activity_main and replace those edit texts for our special text input layouts. So activity_main, and we can start replacing these edit texts. So just above the first edit text, I'm going to make a few line breaks and do a left arrow, and with a capital T do text, capital I, input, capital L for layout. Okay, you can see as I type that I do get an autocomplete, but because my font's quite big, it's not very helpful. Can't really see it. Although if I press down on my keyboard, the down arrow, I do see the full thing there. So it's quite a long namespace, the whole com.google.android thing. But text input layout is the one that we want, so go ahead and autocomplete that. And just like the other fields, we'll do match parent and wrap content. And this time, rather than a self-closing tag, this is actually a container. This is a view group, a bit like linear layout. So we'll do a right arrow, and then we'll get the normal closing tag. Okay. And then I'm going to cut and paste the edit text into this. So Control X, and then I'm going to put it inside this layout. So right now we have a text input layout with an edit text field inside it. Now this should work, but best practice is to change the edit text for a text input edit text, just like our text input layout. So double click edit text and start typing capital T, text, capital I, input, and then capital E for edit, and then autocomplete that. So we're going to upgrade our edit text to a text input edit text. So this pattern of a container of a text input layout with a text input edit text inside, yes, it's more code, it's a little bit more work, but this pattern will become pretty routine after a while. You'll get used to it because of all the goodies and the value that it brings doing it this way. Now we can leave the hint in the edit text, but the documentation recommends we put the hint actually on the text input layout, not the edit text. So go ahead and cut this, Control X or Command X, and we'll put this in the text input layout. If we look to the right, we can still see our hint. And just to get a feel for what it's going to look like when there's some text inside it, let's do a tools text in the text input edit text. So make a new line, do our tools namespace, colon, and type text, autocomplete, and we'll do a made up name. We'll just say example name or whatever you want. Remember, because it's under the tools namespace, this will never show in our project. Now if I look to the right, I can see that our hint has floated above the edit text value. So when the field is empty, like contact number, the hint will fill the field, and as soon as the user clicks in it or enters a value, that same hint will float above. So we get the best of both worlds, okay? So I'm going to go ahead now and rush through changing these things. Feel free to pause the video as I do this, but I'm going to do it quite quickly. So I'm going to surround each edit text with a text input layout, match parent, wrap content, a normal right tag, because the edit text goes inside it. So cut and paste, change this for a text input edit text. Okay, move the hint to the text input layout. And then just so we can see what it looks like, put a tools text attribute in with an example number. So this can be 07711223344. Very good. And let's do text input layout above this, match parent, wrap content, normal arrow, cut and paste this inside, sort the line breaks out, cut the hint and put it in the text input layout. As mentioned, it would work with the edit text, but it's better practice to do it on the layout, and then change the edit text for a text input edit text. And then I'll do a tools text attribute, and I'll do my display name. Okay, and then just the final available from date. Same thing, text input layout above it, width match parent, height wrap content, right arrow, then move the edit text inside, change the edit text for text input edit text, and then cut and paste that hint into the text input layout. Just adding a tools text attribute with an example date. We'll do 25 October 2020. Okay, I'm going to do a Control-Alt-L, Command-Option-L to make sure all those attributes are in a nice tidy order. Okay, remove some of the pointless line breaks. Yeah, that's looking pretty good. Yeah, that's looking quite tidy. One of the final things that I will do, just while we're in this layout file, is each of the edit texts, I'll specify what the input type is. This way, for our phone numbers, we can ensure that only a numeric keypad comes up. And then when we do a date, we'll get a numeric keypad with a slash for the month, okay? So let's do our contact name. We'll do input type, just like that. And we'll say text cap words. After all, most names have each name being capitalized, so text cap words will be good. For the contact number, I'll do input type. I can actually type phone, so that may even give us the plus symbol as well. For the my display name, I'll do the same, text cap words, input type, text cap words. And then for the available from date, we'll do input type. And then if you type date, then when the user clicks that, they'll get the keyboard specific to that type of content. Okay. One final auto format. And that looks pretty good to me. Let's run this now just to see what clicking around this layout is like. Okay, right now all the fields are empty, but when I click contact name, the value floats above and the whole field gets highlighted. If you look at the keyboard, it gives us capital letters first of all. So Jane, and when I do a space, it capitalizes automatically for me. That's because we did input type cap words. Okay, I'll type the rest on my keyboard. Contact number, when I click this, we get a numeric keypad, which is a really nice experience for the user. Okay, my display name, I'll type this one. And if I close the keyboard and scroll down, and when I click the available from date, we get the slash, so I can do 25/10. Okay, so if I just close this field down, in your experience as a developer, you may hear the term user interface or UI, and then user experience, UX. So UI and UX, user interface, user experience. So the user interface would be the actual layout itself. What does it look like? How pretty is it? How clear is it? What are the fonts? What are the sizes? That kind of thing. What does it look like? And then the user experience, if I click in this date field again, is this sort of thing. It's not just the way it looks, but it's how it is to interact with a user. So just by saying input type date and then getting this numeric with a slash keyboard, that's a nice experience for the user. I hate typing in dates on my phone where I get presented with an alphabet keyboard. Totally useless. It makes me have to fiddle with my keyboard. So we have a nice user interface with the well-formatted fields, but then we also have a nice user experience as we click through and we get a keyboard appropriate to what we're typing. Okay? I've just realized I've forgotten to put the margin top on my text input layouts. I'll quickly do that now. So, don't need it on the first one. Margin top 80p. I'm going to copy that line on the other two text input layouts, the one at the bottom. Auto format, and I can click the run arrow, which looks like a looped arrow with the A, and that should apply those changes without it restarting the whole thing. So let's apply those, and in just a moment we see, there we go, we have the spacing. Okay, so very good. We have the new text input layout, part of material design, looks really nice, behaves really nice with the floating hint that you can see. Yeah. And we've even covered the concept of a user interface and the user experience, UI and UX. The text input layout is fantastic UI and quite a nice UX. Okay, let's dive in now to the Kotlin code of our app. I'm back in main activity now in our Kotlin main activity class, And it's time to show you how finding the views on the screen, the find view by ID thing, works in a Kotlin project. Much of it is the same. One or two differences with variables that we've already seen in that Kotlin Foundations tutorial. And also I get to show you the fantastic way that Kotlin handles button click listeners a lot easier than in Java. So underneath set content view, let's declare a variable for our button first of all. Now we're going to declare a variable and assign it straight away using find view by ID, just like in Java. So because we're assigning it, it's going to remain fixed. The value isn't going to change. So because of this, we will use VAL for a value rather than VAR, because we're not going to change this button reference later. So val, we'll call it the preview button. The name of the variable comes first, remember. And then it's of type button. I did mention that sometimes we don't have to put the type can be inferred, but in a moment you're going to see why in this case we do need to put the variable type. So colon, and then the type button. And then this is going to be equal to find view by ID, r.id button preview. Okay, remember, no semicolon. So after we've declared the variable, the find view by ID thing works exactly as it did in Java. So I said in the Kotlin Foundations tutorial on variables, it's preferred to not specify the type where possible, that we can omit this. However, if I do this here, if I delete the colon on the button where I specify the type, we get a warning, and when I hover over the warning it says there's not enough information to infer what the variable is. So in this find view by ID method, there's nothing in this that tells the main activity what the type is. We can actually specify the type using those diamond brackets here. You know, we've seen this before in some of our adapter code. So we could put button in there, and now the problem goes away because main activity knows what's being returned by this find view by ID. So you can do this, but I find this a bit more fiddly to type, so I prefer to actually not use the type diamond brackets like we do in our adapter. I prefer to leave that off and just declare the type. So this would be one example where it is preferable to specify the type, makes the code look nice and clean, and also main activity knows what type of view it's finding. So that's all we need to do to find our preview button, and let's now see how button click listeners work in Kotlin in Android. So on a new line, we'll do preview button dot set on click listener, just like before. So I'm going to start typing this, and you'll see we have a couple of options. We have set on click listener with the view.onClickListener like we've seen before. We have this option, okay, with the brackets. But actually, there's another option in Kotlin. If I just undo that, the top one doesn't have view.onClickListener. It just has some curly brackets with 3 dots inside, and then some weird view goes to unit syntax that we don't need to worry about at this exact moment. If you do this one, the one with the curly brackets and that view arrow unit thing, and autocomplete, then we get some curly brackets. And I can put a new line in between these brackets, a couple of lines like that. And believe it or not, in Android for button click listeners, that's all we need to do. Okay, so in a later section we will cover in detail the concept of interfaces, because a bit like an abstract class, but with some subtle differences, a view click listener is what's called an interface. And there's some understanding we need to go through just to unpick how that's a bit different to an abstract class. Okay? But in short, if you get an interface like the click listener with only one method, which we remember is called onClick, then Kotlin lets you just do these curly brackets, and all of that other boilerplate background code just happens under the hood. So in short, we can do set on click listener. Notice that we don't have any brackets here. There's no normal brackets, but what we do have is just the 2 curly brackets, and then this is our on-click code, which is brilliant. So what I'll do now is just a toast, and doing toasts in Kotlin is identical to how it is in Java. So toast.makeText. The context will be this screen, so this. The text will just say, my button click works in Kotlin, or whatever you want, just for fun. And then toast.length long, and not forgetting .show. So that is identical to Java, apart from the semicolon. Let's just run this now to see this working. And when I click the preview message button, my button click works in Kotlin. Brilliant. So I'll go back to this code now, and we'll do a couple more things by finding some of the other views. So I'll delete the toast for now. So delete all this, and let's actually make a method, a separate block of code in our main activity to keep our code nice and tidy. So underneath here, I'm going to type on preview clicked, and then the curly brackets, just like in Java, and I'm going to use this error to create the method if you can do the same. For now, do what I'm doing and use the error to create the method. We haven't covered functions and methods in our Kotlin Foundations tutorials yet, so we'll happily let Android make the code for us for now. So I'll do Alt-Enter, or you can click the little red light bulb and do create function, but I'll do Alt-Enter, create function, and then you can see we've got a private method, a private function below. And in this, I'm going to find just a couple of the edit texts, or the text input edit texts. I'm going to find a couple of those views and then just put the value of those fields in the toast. So let's do a val for our contact name edit text, and it's of type colon text input edit text. Okay, so contact name edit text of type text input edit text equals find view by ID r.id, and it was edit text contact name. And I'm going to duplicate this line, so Control D, Command D, and I'd call this one contact number edit text, and just make sure I change the ID to contact number. Okay, so I'll create a little template string from these edit texts. So I'll do a val. Remember, these are all fixed values. Once we assign them, they're not going to change later. We don't need VAR at the moment. So val, our test string, I'll call it. This time I won't specify the type because it will be inferred. So just do equals now. And we'll do contact name edit text dot text. Okay, so not get text, but actually just text in Kotlin, a little bit easier. Dot toString. In Java, it would have been get text. And actually that still works in Kotlin, but there's actually an easier way. It's saying we can use just text. So contact name edit text dot text to string plus, we'll do a comma and a space, and then plus the contact number edit text dot text to string. So we've just made a little test string to show that we can get the values out of our edit text fields. And I'll do another toast nice and quickly. Context of this, the text is our test string, and we'll do it for a long time, toast.lengthLong.show. And let's run this now. So now I can put a name in here, John Salesman, and contact number, just a fake number. And then when I click the preview message button now, I can see those values in the toast. So that's a first look at doing some of those things we used to do in Java, like finding a view on the screen and assigning it to a variable. And we've also seen the awesome way that Kotlin handles on-click listeners. No more boilerplate code, just a pair of curly brackets and then the on-click code. Fantastic. It's time for our next programming concept, which is on Null. If you can close down any project files and have the project pane open at the side like me, for this programming concept, we're going to do this in Java. Yes, we've switched over to using Kotlin, but to explain this concept of null, we need to do this in Java, as in Java, null can actually be quite a problem. And then afterwards, we'll do a Kotlin Foundations tutorial to see how Kotlin solves this problem of null. Okay? So in the Scratches folder, but not the Kotlin Foundations folder, if you can right-click and do New Scratch File and scroll down to find Java, or it may be at the top as it is in my case. So a new Java Scratch file. And here we are back in some Java code. Hopefully still fairly familiar to you. I'll put the main method in some space by doing some line breaks either side. For me to illustrate how null works and the problems that it causes, it will help us to have an example class to make an object out of. So underneath the class Scratch, underneath these braces, let's make a new class, and we'll call it class dog, just like that. And curly braces, and we'll keep it nice and simple. We'll have one field, so string name, semicolon, and one method, public void bark, no parameters, and we'll just do a system.out.println, and we'll just do woof woof. Okay, So there's our simple example class, which we can make some objects out of, which we can make some variables out of to help us illustrate what null is in Java. So in the class scratch, we're going to make a class variable. So after the opening curly brace, do a line break, and we will do a variable of type dog, and we'll just call it my dog. Now we're going to be calling this, or rather assigning it, in a static method. We haven't covered static in detail yet, but one slight change to make for this variable, just put the word static in front of it. You can't do things with non-static fields like this from a static method, for reasons we will go into later. So just to solve this problem for now, just put static just here, and then dog my dog. So now we can work inside our main method. We have declared a variable at the top of our class of type dog, and we've given it a name. So that has assigned some space in memory, a pot in which we can put a dog object. And we can go ahead now and do my dog equals a new dog, like that, with a semicolon. We can give then my dog a name, we'll call him Fido, okay? And then we can do the method bark. So we can do my dog.bark. Okay, and if I run this code now, this will just work. Let's run this. Woof woof, no errors, no problems, everything works as expected. I'll just close the run pane down. But what happens if I remove this assignment here? So I remove my dog equals new dog. Okay, we don't get any warnings, we don't get any errors in our code. We have our dog variable declared at the top of the class, and then we're doing things with that variable here, but we haven't assigned it. So let's see what happens when we try and run this code now. Okay, we get a red error. Exception in thread main, and then we see this java.lang.null pointer exception. This is one of the most problematic exceptions, the most common and frequent error or exception seen in Java, the null pointer exception. For now, you can think of the word exception and error synonymously. Okay, an exception, an error, a crash. So it all comes down to this thing here at the top where we declare the variable. So there's a few important things to know about this. When we talk about a variable, dog, my dog, that variable there, it's important to understand that that is not actually the dog object. That is a reference to the dog. Okay, so that sounds confusing. What do you mean by that? Think of it not as the actual dog, the actual barking living object that we're going to make in a moment. Think of it as a remote control. Okay, so when we say dog my dog, we reserve a bit of space in our computer's memory in which to put a dog object. So we've reserved that pot. That pot is presently empty. There's nothing in it. And then when we have dog my dog, that my dog name, that is the remote control. It's not the actual object. That object is hidden away somewhere in memory, but it's the remote control to point to things. So if we scroll down to our dog class, we know our dog object will have a name, it will have some behavior, the bark method, okay? So our remote control, this my dog remote control, has access to those things. It's not the actual dog, it's the tool with which to access the dog, the remote control. So here, in these methods here, our remote control is saying, give me the name, go bark. But this is not the actual dog. And the problem is, when we've declared our variable, which has reserved a bit of space in the memory, the place to access the dog, well, initially that space is empty. And this is the meaning of null. So let's put a comment above this variable, / and say, in Java, comma, when we declare a variable, but don't assign an initial value like this, okay, well, by default, it will be null. This is the remote control. We can access all the buttons on the remote control, like the name button and the bark button, but we don't actually have anything in the pot. So the remote control is pressing these buttons, and those buttons are acting on nothing, on null. And that's the meaning of a null pointer exception. The thing that this remote control is pointing to is null. You're trying to do things on null. You're trying to command nothing to do something, and we get a null pointer exception. The variable is pointing to something that is null. Okay, so I know I'm repeating this a lot, but it's really important to understand this notion that the variable itself is not the object. It is just the pointer, the remote control to that object. Okay? So if we don't assign a variable, then it is null. If we'd have done the assignment here, then no problem. This will run. Because this remote control here is pointing to a newly created dog object. In memory, this dog object is sitting there. But if we don't assign it, then by default, it is null, even though we have the remote control, even though we have the variable and the space in which to put the dog. That space is empty. So let's comment these two lines out. So command / control /, and I put a comment just to the right of the first error. We'll put an arrow and I'll say, there will be no error in our code. Okay, so when we're developing, when we're writing the language, we won't see any red errors. We will think everything is fine. But this will throw an exception. Let me just close the project pane down. This will throw an exception, brackets error, when it runs. And this is a real problem. We don't get the safety of knowing we've made a mistake in our code. It's only when the app is running in front of real users, real potential customers, and it will go crash, it will bang, and it will break, and it won't be able to recover. And that will be the end of the experience for your user. Your Android app will close. Okay, so no error in our code, no error when it compiles. Okay, we can build, we can run our code, but then at runtime, it will throw an exception. So we can now assign our dog later on. So my dog equals new dog, semicolon. And we can do the same things. Now we can do my dog.name equals Fluffy. And we can do my dog.bark, and that will work fine. And just to show that our name field works, I suppose we could do a system.out.println and say the dog's name is space, and then we can add the my dog.name. So we can run this code now, because now our remote control, our my dog remote control, is pointing to something. The remote control buttons has something to act on. So let's run the code now. Woof woof, because of our bark method, and the dog's name is Fluffy. So no problem. But in Java, yes, we can assign a variable after we declare it. So we've declared it where it was null, but then we've assigned it. But it's possible to do this. My dog equals null. And now we've made it null again. So now I can do my dog.bark, and we don't get an error. We do get a warning because Android Studio is a little bit clever. It's trying to help us out. If I hover over this, it says the method will produce a null pointer exception. So this is an extra thing that Android Studio is trying to do. It's trying to help us. It's able to see there's null directly above, and it's trying to warn us. But it's not an error. This code will still run, but it will crash when we run it. So let's try this. So woof woof, my name's dog is Fluffy. So this code here is running. And when we get to here, line 17, you can see it there on the error, null pointer exception. This remote control that we're pressing a button on, the bark button, is pointing to null. It's pointing to nothing. And so the code breaks, it can't work. So let's comment this line out. So just do control / command /. We'll do an arrow and we'll say this will throw an exception because now my dog is null again. Okay? So it's worth pointing out that pretty much most variables can be null in Java. So let's do a string underneath this dog. Let's do static string. We'll call it a null string. It's null because we're not assigning it. We've made the remote control, we've made the reference. You've heard me use that word reference before. We've made the reference. There's the space in memory for the string. We haven't assigned it. So I can do a system.out.println on that string. So let's do system.out, a null string. That will run. The string is null, but fortunately it's able to handle at least printing that. So let me show you what I mean when I run this. So yeah, we get system.out, it just prints the word null. Okay, so that works. A string can report that it is null. But what happens if I try and do a method on this string? So we'll do a null string. We have to uppercase, is empty. We've seen that one before. So there's lots of methods we can call on a string object, on a string variable like this. So let's try and do to uppercase on our string, even though it's null. So semicolon. So what do you expect will happen here? Exception in the thread at line 21. Where's line 21? It is here. null pointer exception. Okay, so we'll just put here, we can't call a method on our null string. Now, it's worth pointing out that while pretty much most variables, most objects can be null, there are a small number of types of variable in Java which cannot be null. They always have a default value. And we've actually seen some of these before. If I just scroll to the top, and then underneath a null string, I put a line break and we'll say primitive data types cannot be null. They always have a default value. We've seen some of these primitive types before, e.g. int, double, float, boolean, etc. Okay, pretty much in Java, any of these variables that start with a lowercase letter. So let's make a primitive variable now just to show you what I mean by this. So if I do static lowercase I int and do my int variable and then a semicolon, you might think initially that that would be null like everything else. But these primitive symbol types, they always have a default value. So if I scroll down now and try and do system.out.println and then put my int variable, rather than seeing null, we will see 0. Okay, so as it turns out, an int variable defaults to 0. Okay, a boolean variable defaults to false. And if you type Java primitive data types, you will see the fairly small list of these types of variable. We've seen most of them, okay? And it will tell you what all their default values are. For all of the number types, it's pretty much some variation of 0, 0.0, 0.0f for float, okay? So, null, when a variable container, when a pot in memory is empty. And I have just seen that I've spelled initial wrong. Apologies if you've seen this all video long and it's annoyed you. There we go. Do make sure to rename this Scratch file. I've actually forgotten to do that. So open up the project pane, right click, and we'll do refactor, rename file, and we'll just call it null, null.java. Okay, I'll close that down. So now we've seen the concept of null and the dreaded null pointer exception in Java. Let's now move on to our next Kotlin Foundations tutorial and see how Kotlin seeks to solve this problem and how we can do some extra things on our variables to give us safety for this kind of problem. So let's do that next. Having introduced the programming concept of null, which is a problem in Java, we now move on to our Kotlin Foundations tutorial on null safety in Kotlin. I've closed down all of the files and I have my project pane open. If you can right click on the Kotlin Foundations folder and do new Scratch file. And then we'll make sure Kotlin is selected this time. And then we have a brand new Scratch file. Let's go ahead and rename this straight away. So right click the Scratch file and then refactor and just rename file and call it null safety.kts. And then we can close the project pane to give us full width. So in the last tutorial, we saw that in Java, when you declare a variable, if you don't assign it at the point where you declare it, then it will be null by default. Well, let's see in Kotlin what happens if you try to just declare a variable but not assign it. So we'll do var my unassigned variable. We'll make it of type string, and then we'll just do a new line. Well, straight away this is an error, and if we hover over it, it says the property must be initialized or be abstract. And we're not going to worry about abstract for now. So straight away, Kotlin does not let you just declare a variable and then not assign it to anything. And Kotlin goes even further than that. When we declare a variable, we have to decide at the point where we declare it whether or not it can be null. So we need to say upfront if the variable is nullable or not. So let's delete this top line and let's go through this step by step. So from a blank file, we're going to make a nice clear heading for the two different types of variable, the null ones and the non-null ones. Now to do comments, we can do // that's fine. This is a comment, and I can do another line and another // another line and another line. But when we have multi-line comments, it can get a bit tedious putting a slash slash for every line. So with comments, there's another way. If you do a slash and then a asterisk or a star and then press enter, you can see it automatically then closes that with a star and an asterisk. So now inside this slash and star slash you see here, we can type a multi-line comment. Just like this, no need for slashes every line. Okay, so this is an alternative way to do comments, and it can make some of the headings look a bit clearer in comments. So slash star and then a new line, and we'll put in capital letters non-null variables. So we'll look at the way that Kotlin handles non-null variables first. So by default, variables cannot be null. So when we make a regular variable in Kotlin, unless we do something special with it, it cannot be null. So when it's declared, we must assign it straight away. So let me show you what this looks like. We'll make all of these VAR for variables. We won't use VAL for this. So VAR for variable, a non-null variable. We'll make it of type string, and that will equal hello. Okay? And then if you look on the right, you can see we have a variable of type string. And this is a non-null variable. Okay, we cannot do this. Null cannot be a value of a non-null type string. So this, like this, is a non-null type. I'll just undo that. So if I try and do a variable like this and not assign it, unassigned non-null variable of type string, if I try and do that, we get the warning, it must be initialized or be abstract. Okay, so we'll comment this line out, control/command/, we'll do an arrow, won't work. We must assign non-null variables when declared. Okay, easy enough. And once we have a non-null variable, we can call methods on that variable as normal. So if I use non-null variable above and do one of the string methods, let's do to uppercase. And if you look on the right, you can see we have hello in uppercase. So with a non-null variable, all is good. That variable can never be null. Android Studio or Kotlin knows it can never be null, and everything is safe. So let's put a note above this. We'll say note, we can call methods on non-null variables as normal. And you'll see in a moment an example where we can't just call methods like this. So fairly straightforward for non-null variables. We declare them as we already know from the Kotlin Foundations tutorial on variables. The only thing to remember is you can't declare one but then not assign it. You must assign it once you declare it. Okay? So now let's move on to nullable variables. So we'll do slash star and then a new line, and in capital letters, nullable variable, a variable that can be null. So to declare that a variable can be null, we add a question mark after the type. So let me show you what this looks like. So we'll do a VAR, we'll call this a nullable variable, and we'll do a colon, and it'll be of type string with a question mark. Now we're getting an error because property must be initialized or abstract. So this can be null, but unlike Java, we must still explicitly say what this variable is when declared. So if we want it to start off as null, like it is in Java, then we do equals null. Okay, and that is fine. We've declared a variable which is nullable, a nullable string, but Kotlin goes one step further and says, you know what? If you want it to be null straight away, you need to explicitly tell me. This is no good. So hopefully straight away you're seeing how Kotlin takes null a lot more seriously. And if we look to the right, we can see that our variable is indeed of a nullable string because we have the string with a question mark. So wherever you see a question mark after a type in Kotlin, that is saying it's a nullable type. It's a string, but it could also be null. Okay? So just to remind ourselves, we'll do a nullable variable not assigned to null. Okay, we'll make it of nullable type string, and we'll comment this out because this is an error. So control/command/, we'll do the arrow and we'll say won't work. we must explicitly assign it to something, comma, including null. Okay? So you must always assign your variables. And then I can use this variable above, so nullable variable, and I can assign it now to, now we are assigning it a value. Okay? And because it's a nullable variable, because it's of type string with a question mark, we can also make it null again. No problem. So we'll put a note above this, // note will say, we can make it null again if we want. This variable is nullable. Okay? But what now happens if we try to call a method on our nullable variable? So let's do nullable variable dot to uppercase. And if you look closely, we have an error. If I hover over the red underline, only a safe or a non-null asserted call are allowed on a type nullable string with a question mark. So this is where things get interesting. If we scroll up to the non-null variables, we can call methods and properties and whatnot on non-null variables as normal. But when we have a variable that could be null, Kotlin has a few extra things we need to do to be absolutely sure how we access that. You can't just call a method like this on a nullable variable. So let's comment this out. And we'll say, this won't work. This is a nullable variable. And this is where Kotlin really comes into its own, and it handles what they call null safety. So let's make a few line breaks for a new section. We've covered our two types of variable, the non-null variables and a nullable variable. Now let's do a new section, so /*, and we'll say this is null safety. We have to take extra steps when dealing with nullable variables. So let's declare a new variable for this little mini section. Let's do var. We'll call it another nullable variable. We'll make it of type string with a question mark. So we're saying it's a string, but it can also be null. And just for a change, this time we will initially assign it. So we'll say we'll assign it ... but this can still be null. So even though it's initially a string, it has the potential, it has the ability to be null later if we want it to be. So let's make some line breaks. I'm going to scroll down. So the first way that Kotlin handles null variables, the first tool for null safety, is what's called, we'll do a // 3 stars, the safe call. Okay, I'm using these 3 stars as my mini heading. I'll do another //. So I won't do this in a comment block like above, I'll do it on individual lines. And we'll say to call any property or method on a nullable variable, we can do a safe call. And we'll do one more comment line. We'll say we put a question mark after the variable, then we can call the method or property. So let me show you what this looks like. So I'll use my null variable, another null variable. If I just do to uppercase, you see we get the error. But if I undo that, and if I put a question mark and then do dot to uppercase, no problem. And if I look on the right, we can see we have the string, we'll assign it, but this can still be null. We have this now in uppercase. So this is a nullable variable, but if you put a question mark after it, then you can call dot and then a method or dot and then a property as normal. Okay? So what happens if the variable is actually null? So let's now change this variable and make it null now. Okay? So another nullable variable, question mark, to uppercase. Everything is okay, no error. And if I scroll down to line 42 on the right as well, if I scroll down, line 40, sorry, it returns null. So the variable was null, and when we do our null variable question mark dot to uppercase, the overall result of this is just null. So we'll put a comment above this to say what's happening here. If the variable is null, then the whole line of code will return a null value instead. Simple. So this line is very safe. If it's not null, it will work as normal, but if it is null, it doesn't matter how many methods or properties you access on it, it will just return null for the whole line. And if you have multiple methods that are chained together, so method on method on method, let me show you what happens. Another nullable variable, that can be null, so I'll do a question mark. Then I'll do 2 lowercase for a change, okay? Now if I want to do another method like capitalize or something, that's a method on a string, I get the little red underline here, okay? So we do a safe call there. If I wanted to do more methods, I do question mark method, question mark method. So because all of this whole line, and indeed all of this line, sorry, because all of this can be null, if I want to chain another method, then I must do question mark and then another dot. And then it will work, okay? So this is a very simple but very effective way that Kotlin handles nullable variables. You can call methods and properties on them, but you must call them safely with a question mark. If it's not null, it will work as expected, but if it is null, then the whole line will just return null and the code will not break. So that's one way of null safety, and it's worth saying the one other way that you can handle a null variable when you're using it. So do a couple of line breaks. So the other way is 3 stars, non-null assertion. So we're now stepping back into dangerous territory now, okay? So do another comment. If we are certain a variable will not be null, we can do a non-null assertion. One more comment. We put a exclamation mark, so 2 exclamation marks after the variable. Then we can call the method or property. If I just scroll down a bit, but this is different to the question mark. This isn't saying this could be null, so try and do it if you can. This is saying, we promise you, Android Studio, we promise you, Kotlin, that this is null. We're so sure that if it's not null, you may throw a null pointer exception. Okay, let me show you what I mean. So we'll make this variable not null now. We'll say, now it's not null. So we know it's not null, but the Kotlin compiler doesn't. As far as they're concerned, this variable can still be null. But maybe we do some clever code that will guarantee us that it will never be null. Let's do an if statement. So if this variable, now we know equals for null, but we were to say it's not equal to. So exclamation mark equals, not equal to null. I don't think we've seen this before. So 2 equals for is equal to, and exclamation mark equals for not equal to. Okay, something new may be there. So if this variable is not null, then the nullable variable, guaranteed to not be null, exclamation mark, we assert that this is not null, a non-null assertion, and now we can do 2 uppercase. So this is us in our code knowing absolutely at this point the variable cannot be null, so we can do exclamation mark. Okay, but the important thing to note, and it's the final thing we'll say in this tutorial, note, we must be sure about this. If we are wrong and it is null, this will throw a null pointer exception. And we're back into the problems of Java again, okay? Quite a few comments there. I'll just close the log pane on the right and go to full width, okay, with that icon there. So, 2 types of variable in Kotlin. Non-null variable, where you declare the type as normal, or you can even infer the type, and it will still be non-null. Okay, so non-null variables like this, and we can call methods and properties on them as normal, or nullable variables, where we do a question mark. Whenever you declare a variable, you must assign it. If it starts off as null, then you must explicitly say null when you declare it. And then if you have a nullable variable, then Kotlin has 2 mechanisms for dealing with nullable variables, 2 ways of creating null safety. There is the safe call, where you put a question mark after the nullable variable. And if it's not null, it will work as normal. And if it is null, the whole line will just resolve to null. It will just return null. Or if in your code you are certain that it is not null, you can do a non-null assertion with 2 exclamation marks. So here we've checked that it's definitely not null, so we know at this point in the code it's not null. This is safe, okay? But we must be sure about this, because if we do this, change that to null, and then remove the if check, then this code will break and it will throw a null pointer exception, okay? I'll just undo that. So that is non-null and nullable variables in Kotlin, and then how Kotlin handles this with their tools for null safety. I'm back inside main activity of our project. I've closed down all of the files and the project pane. So now that we know about null and we know about how Kotlin handles null, it's time to apply this and get a reference to all of the things that are in our layout that we need. So looking down at the onPreviewClicked method, you can see we've already got a local variable for 2 of our edit texts, the contact name and the contact number. And while it could be okay to just get all the references inside this method, inside this function, as local variables, there is one slight performance drawback to this. And that drawback is that every time the user clicks the button, it's going to perform a find view by ID for all of those elements, for all of those views. As a rule, it's pretty bad practice to find the views any more times than we need to. It should just be once, really, and we should be doing it at some point in the onCreate method. So I'm going to comment out all of the onPreviewClicked code for now. So select the lines, Control/Command/. So really, we either want a local variable in here, in the onCreate method, or we want it as a class property, as a field or class variable. Okay? So thinking about it, it's going to be fine to have the button as a local variable just here. So a local val, because we set the onClick listener once and then that's done. But the rest of the code is going to be in an onPreviewClicked method just down here. So if we were to do local variables above the button, well, they wouldn't be visible in this onPreviewClicked method. So we would want all of the other views on the screen to be a class variable at the top, like we've done before. So I'm going to go into the activity_main layout and just double check all the things that we need to get a reference to. So Command click, Control click on the actual layout here. So looking at the right, we need 1, 2, 3, 4 edit texts, or text input edit texts. Contact name, contact number, my display name, and the available from date. We need 2 checkboxes, the junior checkbox and the immediate start checkbox, and 1 spinner, our job description, our job title spinner. We've already got the button as a local variable, which is fine. So we will declare these at the top of the class, as we've done before in Java. So if we go ahead now and actually just copy the contact name edit text from here. So if you look, I'm going to select the VAL all the way up to the variable type. So Control-C, Command-C, and paste that. Well, straight away we get an error. And if we hover over it, we've seen this before, property must be initialized or be abstract. So remember, in Java, if you just did a variable but didn't assign it, it would create the variable and then the value would be set to null. But Kotlin won't let you do that, not by default anyway. So we can't assign this yet, because with views, you can't do find view by ID before the set content view method here. So we can't assign it straight away, so it will need to be null by default. So do you remember the way that we make a variable null? We add a question mark after the type. Now that still will be no good, because if we want it to be null initially, we have to explicitly say it's null. So we do equals null, and then the error goes away. There is still one problem with this variable, and that is that we've got it as VAL for a value. A value, once assigned, can't be changed. So this variable, as it is now, would be stuck as null forever. If I try to do contact name edit text and assign it here, contact name, we get the error that says val cannot be reassigned. So the final change is to make these proper variables VAR for variable. So VAR, and the error goes away. And also, we're getting a warning to suggest that this could be private, as it's not being used outside of this class. So we'll go ahead and let Android Studio do this error for us. I'll do Alt-Enter or Option-Enter and make contact name edit text private. And that is a pretty good class variable for our view. A private var, the name of the variable, a nullable text input edit text. There's a question mark there. We initially assign it to null because in Kotlin we have to. We can't do this. Okay. And then we set it later. I'm going to duplicate this 6 more times for our 7 variables that we need. So 1, 2, 3, 4, 5, 6, 7. And I'm going to change these variable names. So we have the contact number edit text. We have the my display name, edit text. We have the start date edit text. And then we have the two checkboxes. We have the junior checkbox. So we need to change the type to checkbox here. Checkbox, capital B. We have the immediate start checkbox. Change the type to checkbox. And then we have the job title spinner, the drop down for our job title. And that is a spinner. Good. So we have our 7 variables that we need to be class variables that we need to be able to see in any method. And we have our button as a local variable, which is absolutely fine because we're only setting a click listener in onCreate. That's all we're doing with a button. I'll remove the line break. And in the onCreate method, I will assign those after set content view. So contact number edit text equals find view by ID, r.id edit text contact number. In fact, I'm going to duplicate this, it'll be quicker. So Command D or Control D, 2, 3, 4, 5, 6, 7. This is my display name edit text, and that is edit text my display name. The start date edit text, that's the edit text start date. Good. Then the two checkboxes, so we have the junior checkbox, that's our checkbox junior. The immediate start checkbox, that was checkbox immediate start. And then the job title spinner, which is our spinner job title. Good. Okay, so to recap, when you declare a variable in Kotlin, you must assign it to something, even if that something is null. So for our class properties, for our views up here, we have to do exactly this. A variable, a var, of a nullable type with a question mark, and then assign it to null. So I can now uncomment this, Command / Control /. I can delete the two local variables. So now we're using the class properties. And we have a problem. If I hover over the red underline, only safe, that's question mark, or non-null asserted, that's 2 exclamation marks, only safe or non-null asserted calls are allowed. Okay, so remember, this is a nullable variable. So if we want to access this, we either do a question mark on both of them, or the 2 exclamation marks. So the question mark, remember, if this is null, then the whole expression, all of this, will resolve to null. And same for this. So if for any reason we made a mistake with finding our contact name edit text, then all of this would be null. So that would be null plus the comma plus null. It would resolve to just being a comma, okay? So that would be safe. If we do 2 exclamation marks, well, this code is now dangerous. This is a non-null assertion. We are promising Android Studio this will definitely not be null. So there's no possibility of this resolving to null now. But if we're wrong, if we forget to assign this, or we get the ID wrong and this ID isn't in our layout, then this will throw a null pointer exception. And for now, I'm going to leave the code like this with the non-null assertion, because in the next tutorial, I'm going to show you how when we make a mistake, when something goes wrong, when our code crashes, how we can see what went wrong and where it went wrong in the next tutorial, which finally talks about the Android Studio logcat. We now move on to knowing how to handle when things go wrong. What happens when the app breaks or crashes or things don't work as expected. Maybe if you've copied along perfectly in this course, you've had no problems with your code. Possibly you've had some problems or typos. It happens to all of us, so don't worry if you have. So at the very top of our class, we have a load of nullable class properties. All of these things here can be null. Now, we do presently set all of them in onCreate. So at this point, they will no longer be null. And then when we move down to the onPreviewClicked method, where we use a couple of those edit texts, we have a decision to make as to whether or not we do the safe call with a question mark in Kotlin. So if either of those two things are null, then the whole line will return to null. Or we can do the more dangerous non-null assertion, where we guarantee this is not null. Sometimes this is desirable when we don't want a nullable expression, when we definitely don't want this to be null. Okay, so let's see what happens if we do some dangerous code like this, Or indeed, if we were in Java land where this would be the norm, variables are nullable by default and there is no safe call like this. So what happens if we have some dangerous code but we make a mistake? So let me now comment out the line where we set contact name and contact number. So I'm going to highlight those two lines and do Control/ or Command/. So now we have these two nullable variables at the top. They are initialized to null because we have to initialize things in Kotlin, but we forget to set them. We don't set them. And we are asserting here that they are definitely not null, even though we've made a mistake, just like it would be in Java. So let's run this code now and see what happens. Okay, and the app is installing and launching. Everything is fine. If we look at our code, there's no dangerous code in the onCreate method, but when we click onPreviewClicked, we're going to be doing a non-null assertion on those two edit texts, even though they are null. So let's click the button, and the app closes. And it's a feature of the more modern versions of Android that the first time an app crashes, it won't warn you, it won't pop up with an error, but if the same app crashes twice, if I just open it again and press the button again, if the same app crashes twice, then you get the pop-up dialog. So in recent versions of Android, to provide a better experience for normal Android phone users, the first time an app crashes, you don't get a dialog, it just closes quickly in the background. But then if it keeps crashing, then you get the dialog. So the app keeps stopping. Okay, so there's a problem there. So how do we start to find out what went wrong if we don't know what went wrong? And the answer is, at the bottom of Android Studio, where we have our run pane, we also have another pane called logcat. So go ahead and open logcat now. And as you can see, we have lots and lots of output, pretty much everything that's going on with our phone right now. I'm just going to scroll up to stop it from endlessly scrolling. Okay, good. Two things to look out for when you first look at this is number one, that in the top left drop down, it has definitely got your running device selected. You may have an older version of the emulator that you close down in this drop down, and it will say disconnected or dead. You may have your real phone if you've plugged this in. So whatever is the device that you're running the app on, make sure this is the one that is selected. In my case, I only have my emulator, so that's fine. Then in the second box, you have another drop down. Now the app is currently closed, so it says no debuggable processes. So we don't have any app from Android Studio running. So this is just an output, if I scroll up and down, of everything on the phone that is logging. Think a little bit like our system.out.print lines, okay? Just simple console logs. So this is everything. So if I run the app again, and now you can see it is automatically changed to my app. So we have com.vinnormal or whatever your package name is, the app here, okay? And this is good now. So now it filters to only the output from our app. And as you can see, it's a lot less. And pretty much all of the logs start with the date, the time, a random number, but then our package name. So we know this is from our app. And then the log message is here. Lots of D and forward slashes, okay? So I'm going to leave this logcat open with my current running device selected and the app selected, and I'm going to make the app crash. So on the emulator, I'll move it over here. I'll press preview message, and then we get a whole load of red error output. Okay, if I just minimize the emulator. So there's a further drop down. To the right of where it has our app in the drop down, we have a drop down with the word verbose. So that means pretty much everything, every log there is. And we can change this to different levels of debugging, and they go in increasing level of seriousness. So debug, info, warning, and error. So if you ever get a crash, it's likely there will be an error output on the console. So if we select this to error now, it will only show errors. And we only have one, a fatal exception. Fatal meaning the app couldn't recover, the app crashed, it closed, okay? And if we look at this error, we can see null pointer exception. Okay, so we were expecting this. If I scroll down in my code, we did a non-null assertion here on a null variable, but it's even more helpful than that. If it can determine it was something specific in your application code, then it will actually give a link to the specific line. So you can see these blue links here. These are our files, the things that we typed. And more often than not, it is the topmost line that will be the problem. We had an onClick method, which is this one here. Yeah. Then we did our own onPreviewClicked method, which is this one here. And then if I click this top link, line 39, we can see the exact line which caused the null pointer exception. Okay, so if you get any random crashes in your app, go to Logcat, make sure your device is selected, make sure your app is selected. If there's too much output, if there's too many things, then filter it down to error, and then you may see the most recent error. It will tell you what the error was, what the problem was, and hopefully a blue link to where it happened, and you can click it and the cursor will appear on that line. So we can go one further than that. We can add our own private messages to ourselves in the Logcat. If I do above the error, if I do capital L for log, L-O-G, and then a full stop, and then there is various methods for D, E, I, V, W. E for error, I for info, D for debug, V for verbose, and W for warning. Okay, so we will do a D for debug. This is us debugging our own app. So we can now do our own log. It takes two parameters. One is a tag, a thing that will be at the start of the line. So let's do, this is my tag, something that we can search for, that we can see in the console. Okay, you can put something funny there if you want, whatever helps you find it. And then the message. So we can say, currently, contact name edit text is, and then we can actually do the object, contact name edit text to string. So this is a nullable variable. If there is something in contact name edit text, we should see an output that tells us that we have something there. And if we don't, then this null.toString, that should say null. So we can now see exactly what the problem is by doing our own personal log. So let's run this app again. Okay, you can see that it's cleared the console. It's got a small error, unknown bits set in runtime flags, but that doesn't seem to be a problem. It's not a fatal error, it's not a fatal exception. You do get some random things in the console, in the Logcat. If I click the preview message again, I expect it to crash, but hopefully we will get a bit of extra info, our own personal tag above where it crashes. So let's click the button now. Yes, it's crashed again. If I take off the filter for error and go back to verbose, or even debug, that will show all of the logs that are debug or more serious. So we'll filter by debug. Okay. And I can see this is my tag. Currently contact name edit text is, and then it says null. So we've done our own investigation there. We've seen specifically what the problem is by testing one of the variables. Okay. And in this console, you can do Control F or Command F. So we could type the word tag with a capital letter, and then we can see where our tag is. Okay, so initially the Logcat can seem a bit overwhelming, especially on verbose mode, because you have every single bit of output that your app does, and there will be lots of things happening in the background. But you can add your own tags to your own messages, and you can search by those tags to find them. You can filter down to just errors like that. And then if I just expand this a little bit, you can see what the problem is and click on the specific lines to see where it went wrong. So now it's on line 41, okay? So that is a first little look at the Android Logcat, and we've also covered adding our own logs with log and then one of those levels, E for error, D for debug, I for info, W for warn, or V for verbose, okay? We now know that when things start to go wrong with our app, if we get a crash or something wrong with our code, we can open up this Logcat at the bottom, and we can scroll through and try and see some of the errors, some of the log output to tell us what went wrong. By default, it's going to be every single log in our app, verbose, okay? And we can filter it down to error. And with any luck, it will give us a reason, null pointer exception, and then a link to our line of code. So this would be a first way to try and diagnose what went wrong with our app. Now in this case, we actually have two variables, the contact name edit text and the contact number edit text, that we're both doing a non-null assertion on. So we could look at this null pointer exception, click on this line of code, and realize, okay, something's caused a null pointer exception. It's probably one of these two variables because I've done a non-null assertion. But the error doesn't tell us which of the variables is the problem, or indeed if it's both. So then what we can do is we can do our own investigation. We can type out our own log, give it our own tag, and once we've given it a tag, we can do Control F or Command F, or indeed just type in the search bar at the top, type any of those words from our tag. So I'll type capital letters tag, T-A-G. Obviously make sure it's on debug mode, and then we can see our tag, and then we get our investigation. Currently contact name edit text is null. But then of course we'd have to do another log to see if contact number edit text was null as well, or run it twice and change it over. So even though the ability to log ourselves is a way we can try and get to the bottom of when things go wrong, it's still not ideal. It's a bit long-winded, and surely there's a better way. So when we talk about problems with our code, we're talking about bugs. A bug in the code, meaning something in the code that is incorrect, something that has been done wrong that is causing the crash or causing the problem, whatever that problem might be. So we presently have a bug in our code, and that bug is we never set these two variables, yet we're doing a non-null assertion. Just like if it had been written in Java, we declared the class properties at the top, there, and by default in Java they're null, and then we never set them. Okay, so logcat and our own custom logs are useful, but there's a really convenient and powerful way to find out what happened, what went wrong, what state the code was at the point where it went wrong. And this is the whole point of debugging. So I'm going to remove this line, log D, okay, and delete the line break. And I'm going to uncomment one of these lines. So I'll uncomment contact name edit text. So we have a null pointer exception. If I just remove the tag, we have a null pointer exception at this line, but we have two potential variables that could be null. And we don't have to do lots of complicated logging to find this out. So next to the line that's in question, line 40 for me, or whatever the line is for you with the test string on, click next to the number and a red circle will appear. And this is called a breakpoint or a debug point. Okay, this is a way that we can tell Android Studio to stop the code when it hits this point, to pause, and then we get a really powerful console where we can see what state our app is in at this point. So put a breakpoint or a debug point on the line where we set the test string. I'm just going to close the logcat for one moment. Now we're going to run the app again, but rather than pressing the play button or one of the two rerun buttons if your emulator is still open, rather than clicking one of those two buttons, we're now going to click the green bug, which is our debug button. So when we click this button, it runs the app just like normal, but it attaches a debugger, a process that is listening to the code as the code is running and then communicates back to Android Studio. So this is exactly what you want. So go ahead and click the debug app, ensuring you have a breakpoint on the test string line. Let's do this now. It may take a bit longer while the debugger attaches, and the app is running as normal. We didn't set any breakpoints in the onCreate method, so far everything happens like normal. If you look next to the breakpoint we did put in onPreview clicked, you see there's a check mark, a tick, and that is the debugger telling Android Studio that it will be absolutely fine to stop and pause the app when this breakpoint is hit. Sometimes you can put a breakpoint in a very difficult place and it's not possible to stop, but this one's absolutely fine. It's ready and waiting. So let's now click our preview message where normally the app would crash and see what happens. Okay, so the app hasn't crashed, but our line has been highlighted and the app has actually paused on this line before this line has actually run. Okay, so that's a key thing to note. When you put a breakpoint or a debug point, it will stop before the line runs. So I'm going to go ahead and minimize the emulator and talk through what's happening here. So at the bottom of Android Studio, we now have a debug pane that has popped up. Okay, and there's a few complicated looking buttons. If I just click off so that pop-up goes away, good. So we have a few complicated looking buttons, but the key thing to note is we have a debugger and our console, which is a bit like our logcat. So if I were to continue, we would get the error in here. Okay, so back to the debugger. On the left, we have the point at which our app has paused, the very last bit of code which has run, our onPreviewClicked method on line 40. You can see that there, that's from our app. And before this, you have every single other bit of code that has run prior to this code running. So when we have an activity like this, when you do things like click on views and run click listeners, there's a whole bunch of behind the scenes code that happens. Many other methods that happen in the background that we don't really care about. And the error doesn't come from there. Usually the error comes from our code. So here we are on preview clicked, the most recent method, our method that is running and paused. And the key thing is this pane on the right, the variables pane. And you can see we have just one collection of variables, and it's under a category called this. And it's telling us that this equals our main activity. Remember, we've seen this before, and it usually pertains to this particular instance of the class. So we are in main activity. This is an object that has been made automatically by Android. So this means this object, this version of main activity. So if I expand the this category of variables, we can see a whole bunch of variables here, many variables, most of them starting with the letter M. All of these ones that start with the letter M, these tend to be variables that you get for free when you extend from an app compat activity. So don't forget, we are extending an app compat activity, so we get all of the variables and properties and methods and whatnot that come with that. So you can ignore pretty much all of these, but at the top are the variables that have come inside our activity, inside our child class main activity. We have the strange $findViewCache method, which we very briefly saw when we looked at our Java bytecode, so you can ignore that one. But apart from that one, the next 7 variables are our class variables. Contact name, contact number, they appear to be in alphabetical order. So we can now look at this breakpoint in onPreviewClicked, and at this moment in the code, these variables are like this. Contact name edit text, well, we have an object there, we can see it. Text input edit text at 9668, a unique identifier. And we have some more identifying code to the right. In fact, all of our views, all of our properties have an object. They refer to something except for contact number edit text. So we have used a breakpoint where the code went wrong, running the app in debug mode and then looking at the variables. And by doing that, we can see it is indeed the contact number edit text that is null. I can put a breakpoint on the next line, and then to proceed to the next breakpoint, I would do resume program, but of course when I click this it would crash. So let's click this now, and going to the console we can see the same crash just like our logcat. Okay, line 40, null pointer exception, but we know why. So that's a first look at Android debugging, and that's probably the best way we could have found to get to the bottom of what our problem was. I'll now uncomment this line, so our code is now working. And I will just show you a couple of other things that are useful to know about our debugger. I'm going to put a breakpoint just somewhere in our onCreate method, and again in onPreviewClicked and the next line. Okay? And I'll put just one more random breakpoint here actually. So I'm going to debug the app again. Okay, that's now running. We can see the check marks to tell us that these debug points are okay to use, and the app has stopped just after set content view on that next line. So onCreate line 25, I can see that there. I can see all of the variables, and I can see at the moment that they are all null. Okay. You can proceed to the next breakpoint with the play pause looking button at the top left, resume program. In fact, I'm just going to put one 3 lines down. So let's click this now. And we can see contact name and contact number, they have now been assigned. They're blue, showing us that they're a recent update. But my display name edit text, that is still null. Remember that the breakpoint stops before that line of code runs. If I pressed resume program again, it would go to the next breakpoint. Maybe you want to step through the code line by line without having to add a red circle every single time. So I can actually remove all of these, and next to console, next to those 3 lines, you see step over. Clicking the step over button will go down to the very next line where you are. Make sure you press step over and don't press step into, because if you do step into, you're going to go into the find view by ID method, and you're going to end up going deep inside some of Android's default code, which sometimes is what we want, but not at the moment. So by doing step over, we go to the next line down. It just steps to the very next line down. It doesn't go into any of the methods that we're calling. Okay? So you can go through line by line, and every time you jump you see the most recent update in our variables. Junior checkbox has been set. Okay? If I press the resume program button now, it will go to our next breakpoint, which actually there are no more breakpoints because this code isn't going to run yet. So when I click this, there's no more information in the debugger, So if I open the emulator, we've gotten through all the code and the app is no longer paused. But when I click preview message, we're back in here again. I can see that all of my variables are now not null. And when I press play to go to the next line, no crash, everything is fine. And if I remove these breakpoints now, I can see the app actually works now. And I can type in my details and everything works as expected. So that is the super useful debugger in Android, where you can pause your code, see what the variables are at the point where the code goes wrong, and it is by far the quickest way to get to the bottom of those problems, of those bugs that are in your code, which is fantastic. We move on now to a very useful benefit of using Kotlin in our Android projects. We've got all of our views declared as class properties, as you can see, and we've assigned them all in onCreate. We know about the way that we declare Kotlin variables, either var for variable or val for value, and we know that we can't just declare a variable and not assign it to something. So even if it's null, we have to assign it to null. And for a screen like our main activity where we've got lots of views, this whole process is quite time consuming and it takes up a lot of lines. We have 7 views, we have 7 lines where we declare the variables class properties, and we have 7 lines where we assign them. Okay, we have an extra line where we declare and assign the button straight away. We realized we could keep this as a local variable because we only use it once. But that's still 15 lines. And not only that, but because these are all nullable variables, because we can't assign them here, we have to either use a non-null assertion or the safe call with a question mark. So this whole process of using these safe nullable variables and declaring them and then assigning them, it takes up a lot of lines of code and it makes our variables a bit difficult to work with. Every time we use them, we've got to do a question mark or 2 exclamation marks. What if I told you that Kotlin on Android comes with a bonus tool for handling all of this hard work with find view by ID? I mean, even in Java, we'd have to declare them as properties and do find view by ID and onCreate, right? So it's a lot of work whether it's Java or Kotlin. Kotlin makes it safer, but then also makes it extra hard work. Okay? So to show you this fantastic tool that Kotlin on Android has, we need to go to our build.gradle file in our app folder. So open up the project pane, ensure that it's on project of course, and in our self-promo app folder, don't go to the project build.gradle, but go to the app folder and go to the app build.gradle and double click this. And if we scroll to the very top, we see these apply plugins. We don't need to go into too much detail about what these plugins are, but these are plugins for Gradle. And remember, Gradle is our system that builds our app. It takes our Java code and generates the file which can be run. Okay, it's our build system. We don't need to go into too much detail about what happens under the hood, but these plugins at the top, they give our whole app some tools that we can use. For example, without the apply plugin com.android application, our app won't work at all. Yeah? And without our apply plugin Kotlin Android, we wouldn't be able to use Kotlin in our app. So these are just some really high level things that make our app work at all. Okay? And when you make a new project, they're going to be put in by default in our app build.gradle. It's not a thing you often need to change or do much with. Okay? But the key one is the last one. Apply plugin Kotlin Android extensions. So this extra plugin gives us lots of freebies, some useful extras that we can use, one of which is a solution to our find view by ID problem, okay? So if you've made a new Kotlin project through the new project wizard like normal, this line should be here. If for any reason it's not, then copy it exactly as you see, apply plugin : single quote, apostrophe, Kotlin Android extensions. We need this line to be able to use the wonderful tool that we're going to use right now. Okay, so ensuring we have Kotlin Android extensions in our Gradle file, ensuring we have this plugin, you can now close the build.gradle app file, back to our main activity, and I'm going to close the project pane for now. I would like you to delete all of the class properties, delete all of the places where we assigned them. And you know what? Let's delete the line where we declare and assign our button. So all we have now are the 3 times we use our views. The preview button on click listener and the 2 edit texts in our test string. But right now they are an error. Okay? So those Kotlin extensions allow us to use a thing called Kotlin X synthetic. Now that's a very complicated, weird sounding name, but all it is some generated boilerplate code that basically lets us use the views that are in our layout, all of those XML IDs. It lets us just use them exactly as we typed them. Okay, so to confirm, no more variable, no more find view by ID. We can just type the ID exactly as it is in our layout, and we can just use it. This does not come at all in Java, but with Kotlin extensions, with Kotlin X synthetic, this is a tool that lets us use the IDs in our layout. So to show you what I mean, let's jump right now into our activity_main. So control click, command click this. Okay, so let's take, for example, our button, very, very bottom. So we call the ID button_preview. Okay, we're following one of the Android conventions for snake case for our IDs. So let's go to main activity. Let's double click our error, our preview button, and start typing lowercase button_preview. And if you have the Kotlin Android extensions in that build.gradle file, if you have that plugin, then we can just autocomplete this. So go ahead and autocomplete button_preview, and that's all we need to do. If I just show you what happened there, if you go to the import at the top and open it up, okay, we've got quite a few unused imports here, so we'll leave those ones for now. But at the very bottom, import Kotlin X, standing for our Kotlin extensions, our useful bonus tools from that plugin. Okay, so this gives us this weird Android.synthetic thing. And you don't really have to worry about what that means, but Android.synthetic.main. We have access to all of the layout files. Okay, Kotlin will look at our layout files and they will generate some code in the background for us automatically. So all of that find view by ID, all of that making variables, they are all bundled up in here automatically thanks to our Kotlin extensions. How good is that? So if so far you're thinking that there's not that much of a benefit to using Kotlin, well, here's one absolutely huge benefit. We've just saved 15 lines of code. If I just close the imports now, no more class fields, no more declaration and assignment for our button. So if I just change this, edit text contact name, we don't need the question mark anymore, edit text contact number, we don't need the safe call. Just to confirm, we do have to be a bit careful that we are importing views from the layout that we're using. Later on, you're going to see when we make our summary activity, it is possible to accidentally use a view from a different layout, and then you would get a null pointer exception. But as long as you ensure that you're importing the synthetic, the Kotlin X stuff for your layout, then these views will not be null. Okay? So these are null safe. We don't need to worry about doing a question mark or an exclamation mark. There's no errors here, and we can just run this. So let's go ahead now. We're going to delete the toast and the test string, and let's gather up all of the values on our form nice and quickly using these Kotlin X synthetic variables, these automatically generated view variables from our layout file. So we have our contact name, and that will be our edit text contact name dot text to string. Let's do our contact number, and that's our edit text contact number dot text to string. Then we have my display name, and that is edit text my display name dot text dot to string. Then we have our checkbox, so it was the include junior, and that was a checkbox junior. And to get the true or false value for whether or not this is checked, the property is not .text, it is .isChecked. Okay, so as we start to play with our checkbox and our spinner, our new widgets for this section, you are going to see some new properties. Don't worry about memorizing them. This project is going to be reference code for you should you want to use them again. So the property is checkboxjunior.isChecked. That's all we need. That will be a Boolean. That will be a true or false value. Then we have our spinner, our drop down. Now we haven't made the adapter, we haven't made the values for it yet. However, it was a job description. That was the value of the drop down. So we'll do spinner job title. Should probably change it to job title. Oops, just to be consistent. So job title, so spinner job title, and the property is dot selected item. Now this won't automatically be a string, okay, because the spinner can take any object. It can take any type of thing, you know, like a dish or a project, you know, one of our classes. We're going to give it strings, so we'll just do a toString to ensure that this job title variable is a string. Okay, if I do that, you can see it's a string. If I don't have toString, then there's a problem because selected item could be anything. Okay, so we'll do .toString, we'll remove that, so that will be a string, fantastic. Then we have another checkbox for immediate start. Okay, so that's checkbox immediate start dot is checked. And then we have our final edit text, which is if it's not an immediate start, then we can provide a specific date. So this is our start date edit text. So edit text start date dot text dot toString. And that is all we need to do. So we have removed all of the class properties, we've removed all of the variable assignments. We're using the Kotlin X, these wonderful Kotlin extensions, to just use the IDs that are in our layout automatically. All the boilerplate code happens in the background, okay? And then in our onPreviewClicked method, we are just gathering up all of those values, ready to do something with them, which we'll do in the next tutorial. Following on from that fantastic tutorial where we use those Kotlin X synthetic variables, where we can basically just use our view IDs in our layout straight away, comes another fantastic benefit to using Kotlin. What we want to do now to make sure our form works, to make sure all the values are gathered up, what we want to do is a quick toast, just like before, where we display all of those values. It's a bit more work now though, because we have 7 values. So let's go ahead and make the toast. So toast.makeText. So the context is this screen, so this main activity. The text, I'll just do an empty string for now, so speech marks. And we'll do toast.length_long and then .show. Our standard template for making a toast. And just above that toast, I'll make some line breaks, and we're actually going to build a string here. So let's do val, and we'll call it our test string again. Okay. So thinking back to Java, and also thinking back to the last time we did a string in Kotlin, if you want to use both hard-coded text, where we type our hard-coded values here, but then add other variables, then we end up doing something like this. A string in speech marks, then a plus, then another variable, plus speech marks again, some more values, not forgetting our spaces, plus another variable, yeah? And this is really susceptible to mistakes. We might forget to put a space, we might forget to do a plus, you might get horribly kind of confused, or you might forget a speech mark and then end up including your variable inside the hard-coded string. Okay, if I just undo all of that. So yeah, this method of combining our hard-coded values, just meaning we actually type it into the code like that, and then a variable, and then plus, and then adding it together, that's got a fancy word called concatenation, and that just means adding the strings together, okay, combining them. But it is very error prone, and possibly you've had some of those problems yourself in previous tutorials. Well, straight away now, having done this, if we look, we have a very friendly yellow underline giving us a warning or a suggestion. So let's do Alt-Enter or Option-Enter, or you can click the yellow light bulb, but I'll do Alt-Enter on Windows. Convert concatenation, that's the fancy word for a string combination, convert it to a template. So let's go ahead and do this now. Interesting. So now we just have one string. You see we have these speech marks at the start, speech marks at the end, but then our variables are now actually inside the string. The only difference being they are preceded with a $sign. Just let me just put the space after the word here that I forgot. And this is Kotlin string templates. So rather than doing that painful concatenation where you've got to keep doing pluses and remembering the spaces and all that kind of stuff, you can just type your string once. You can hard code typing it like we've done here. And whenever you want to use a variable, you can just use it in line. And all you've got to do is remember to do the $sign. So let's now very quickly, using this string template, let's go ahead and preview all of our values. So delete all of the contents, and let's do contact name, then a colon, and then we'll do $sign, and you can start typing the variable, and then you can use autocomplete like normal. So there we go, contact name. Then we'll do a comma. Let's do contact number, colon, space. So for me, I find this so much easier because it's much more natural to remember to put in the spaces when you're looking at the text like this. I frequently forget to put in spaces when I do the concatenation style because it just looks a bit weird with all those plus symbols. So for me, using templates is much more natural. I can see what I'm doing. So let's do contact number, autocomplete, and we'll do my display name, colon, and then my display name variable. Now the include junior is a Boolean value. So let's do include junior and a colon. I'm just going to scroll to the right. I'll do the $sign and then include junior. Now our include junior variable is actually not a string, it's actually a Boolean. If I just show you this. So include junior, if I was to say this was of type string, like this, well, it's going to complain because the checkbox .isChecked actually returns a true or false. It returns a Boolean. Okay, so this is actually a true or false value. I'm just going to remove where we specify the type because it's always better to let Kotlin infer that where possible. So you might think this would be a problem in our string template. We're including a variable that's not actually a string. But the Kotlin string template system is actually a bit more clever than this. If you include a variable that's not a string, then it will call the toString method on that variable. Remember, all objects do have a toString method. In previous sections, we've actually done our own version of the toString method, if you remember. We've overridden this and done our own version. So on a Boolean variable, if you call toString on it, well, if the value is true or false, then the toString method will return the word true or false as a string. So we can just do include junior. No need to do the toString method. As you can see, it says redundant. Okay, so no need for that. We can just use the variable as is. We'll keep going. Apologies, I am going to be going quite wide on this line, so you'll have to scroll horizontally with me. The next thing is the job title, and that is our job title. Now remember, at the moment, we are using a spinner with no values in it. And actually, we may run into a problem in a moment, which we're going to have a look at when we try to run this app. But job title is a string, so that should be fine. We'll keep going. Then we have our immediate start, whether they should start immediately or not. So $sign immediate start. And then finally, we have, if not an immediate start, the start date, colon, $sign, start date. So, phew, that's a pretty long line we've got there. But using a string template makes it a lot easier to see what we're doing. So we have our test string, so now we can copy this and put it inside the text. So delete those speech marks and put that there. We'll remove that line break to keep it nice and tidy. Whoops. Okay, good. So let's run this now. And we'll see what happens when we click the button. Because remember, our spinner has nothing in it at the moment, it's empty. So, click run. Okay, so we'll go ahead now and fill out this form. So contact name can be Stephen Sales Smith. I'm sure that's not a real name, but whatever. Contact number, just some fake UK mobile number. I hope that's a fake number. Apologies if it is your number and you're getting called all the time. My display name, I will refer to myself as Vincent Norman, the posh version of my name. I never call myself that, I'm always Vin. Okay, I'll say I am a junior, so we'll include the word junior. Now remember, at the moment our spinner doesn't work, there's no values inside it. Okay. Now immediate start, I'll leave this as false for now, we'll give a specific date. We'll say we can start from the 14th of December 2020. So we filled out our form. Let's see what happens now when we click preview message. Oh, it looks like our app has actually crashed. So what can we do? How can we find out what's going on? Let's open logcat. I need to make sure I've got the correct emulator. So that one's disconnected. Let's go to the one that's running. Okay, and make sure we've got the app. Good, so we're inside our app now. I'm actually going to leave the whole form empty and just press the button because I actually do know what the problem is with this. So just to save some time, click preview message. Okay, and that's crashed. We get the pop-up saying it keeps stopping because it's crashed twice. Now, if I scroll up in my logcat, we've got the dreaded null pointer exception. They've tried to call toString on a null object. And what's the line? Let's click it. In onPreview clicked, it's our spinner line. So we've tried to call toString on this selected item, but the selected item is actually null. Okay, now because this selected item property, this value comes from Java code, if I just control click it, command click it, this is some Java code. Okay, it doesn't declare that the thing it returns could be null, it just says object, which is like anything. Yeah, so unfortunately our Kotlin code doesn't know this could be null, otherwise it would be throwing up a warning saying we have to fix this. But not to worry, we now know that this is throwing up a null pointer exception. Okay, we know this selected item can be null, and we know from our Kotlin Foundations tutorial there's a way we can handle this. So can you think what the safe way would be to deal with this toString method? Because you can't call toString on a null Java object. So what's the answer? The answer is to put a question mark after the selected item. So just with one character, we've made this code safe, even though we don't have anything inside our job title spinner yet, by using a safe call, by using a question mark to say, if it's null, then make the whole line be null, then we've solved the problem. So if I run the app again, and just open my emulator, okay, we've got a new logcat, I click the button, and we don't get a crash, okay? And if I fill out the form again, nice and quickly, Stephen Salesmith, Vincent Norman, we'll include Junior, and we'll start on the 14th of December 2020. Now, if I click preview message, I get the toast with all of my values and true and false. You can see for the immediate start, include Junior, so we can use Boolean variables in our string template. And even though we have a null job title, it just returns the word null. Okay? So, that is the fantastic string templates, the super useful Kotlin string templates, which makes building up strings with multiple variables much, much, much easier. And as an added bonus, we got a chance to apply our learning with using the Android logcat to find out a problem, a crash in our app, and then use our Kotlin Foundations knowledge to fix it. Fantastic! It's time for another Kotlin Foundations tutorial, this time on functions. I'm in a brand new Scratch file under the Kotlin Foundations folder called Functions. Okay, so I right-clicked, went Refactor, and then Rename File, and I've called it Functions. So if you can go ahead and do the same, I'm going to close my project pane, and then if you can rejoin me when you're at this view with the Kotlin Scratch file called Functions, the code editor, and the log to the right. So notice that this tutorial is called Functions and not Methods. In Kotlin, when you write a block of code and give it a name, like our Java methods, they're actually called functions. They can also be methods too. That's more to do with if it's part of a class, like you've seen, like onCreate. That is still a method, okay? But for the time being, for the purpose of this tutorial, I'll be referring to them as functions. You can think of them the same way as methods in Java. In terms of the structure, there's no difference. So in terms of the learning in this tutorial, there's no difference. It's just down to where that function is as to whether or not it's a method or just a function. Okay, so Kotlin functions. We've already had a go at making a brand new one in our main activity. We typed the name of the function and we used the Android error to create that function for us automatically. Many things are similar and there's just one or two things that are slightly different. So in Kotlin, the way that you declare a function is with the letters F-U-N for function, the word fun. And then it's the name of the function. So we'll just call this one with a lowercase, just like our methods, make, and then capital N, noise. Make noise. We'll do a pair of empty brackets, so no parameters, and then our curly braces. So just there we've made a new function in Kotlin, and you can see on the right that the log confirms that we have a make noise function available to us. Ignore the word unit for now. And in this, we will actually do a system.out.println. Now we could do it the old-fashioned way. We could do this. If you look at that suggestion, it says that we can actually use a println function. So one of the many, many useful shortcuts that Kotlin gives us, another one is a shortcut to that println function. So just println, all lowercase, println, and we can put inside here arg, exclamation mark, exclamation mark. If you look to the right, you can see we don't get any output there because we haven't called this function yet. So what we'll do, below this function, outside of those brackets, we will now call this function. Make noise and the brackets, and if we wait a moment, we get the output, arg. Okay? So for a basic function or method with no parameters and no return type, it's pretty straightforward. Fun for function, and then the name of the function, and then our brackets like normal. So let's put a comment above this, so a new line, // and let's say functions start with the word, single quote, fun, comma, then the name of the function. Notice how we don't have to specify a return type. In our Java methods, we had to do void and then the name of the method, and void was saying there was no return type. Well, in Kotlin, with functions, if the function doesn't return anything specific, we don't have to put anything. So that's nice and easy. So what if our function has a parameter? So let's make a new function, and we'll call this one greet, and then we'll pass into this function the name, so we'll greet a person. So similar to the way we do variables in Kotlin, rather than the type first, like it would be in Java, we do the name of the parameter first. So we'll say the word name, and then a colon, and then the type. So if you can think of the parameters in a function, just like when we did our variables, okay, so the type comes after the variable. Variable name, colon, type. So it has the same structure. And we'll do another print line, so all lowercase println autocomplete, and inside here we'll do hello space, and we'll add the name. And if you think back to a previous tutorial, we have a suggestion, and that's saying we can convert this concatenation, where we do the plus, to a template. So let's go ahead and do that now. So this is good, we're applying that previous learning, and we have used the name, and we're greeting the person. Let's add an exclamation mark after the variable, so hello name. You can see on the right we have our new greet function with a name parameter. So let's now use this function. So we'll do greet, autocomplete, and I'll greet myself. And if we look to the right, hello Vin. So functions with parameters, nice and easy. Let's make a note, // parameters are the name of the parameter, then a colon, then the type. And I'll put in brackets here, like a variable, just to remind ourselves it's the same format. Good. And just to show you a function with multiple parameters, we'll do fun, and this time we'll have a method called birthday cake. And we'll have the first parameter be the name again, so name string. And then just like in Java, we separate our parameters with a comma. And then we'll do a second parameter called age, and then we'll make that of type int, and then we'll do our brackets. And we'll do print line again, so println, and we'll do happy birthday, and this time we'll use our string template straight away, do $ name, so we're using that name variable, happy birthday name, exclamation mark, now, comma, blow out your $ age candles, exclamation mark. Remember, even though age is not a string variable, it's an int, it will work just fine in a string template. The toString of an int is just the number in string form. So the number 12 would be the string 12. Okay, so that's absolutely fine. Let's test out our function now. Birthday cake, we'll do somebody else, Jenny, and we'll say she's 25. And if we look to the right, happy birthday Jenny, now blow out your 25 candles. So that works just fine. So we'll do one more comment for the function with multiple parameters. So we'll say multiple parameters are separated by a comma, just like Java. So there's no change there. Very good. So that is 3 functions that don't return anything. We do the print line inside the function just so that we can see some output. We could, of course, return those values to wherever is calling the function. So let's do a function now that returns something. So do fun for a new function, and we'll call this one multiply. And we'll do 2 parameters. We'll do number1 of type int, and then number2 of type int. And for now, we'll just do the curly brackets, but we'll change this in a moment when we need to return something. So let's do the curly bracket. And I'm just going to scroll down a bit. So we could do in this function something useful where we just multiply the numbers together. So number1 times number2. But right now, that's not doing anything. We could do a print line where we print that, but this function might be more useful to just return that value. Like in our BMI calculator way back in a previous section where we just return the value. So then we can let the place where it's called handle that value. It can do what it wants with it. So the way you return a value is with the word return again. So we'll type return with a lowercase and then a space. And then we have an error. And that error is because we've not actually specified in the function that we are returning something. So if I hover over the error, it says type mismatch required a unit but found an int. So forget the required unit thing for now. We'll talk about that in just a moment. But if we do Alt Enter or Option Enter or click on the red light bulb, we can change the return type to be int. So let's see what happens. And do you see that? After the parameters brackets, after there, we get a colon and then the type. So this pattern in Kotlin of having a colon and then a thing, whether it's for variables or parameters, or in this case a return type, it's incredibly common. So in the case of a function, if you want to return something, after the brackets you do colon and then the type of thing it returns. And that will now work absolutely fine. So let's now use this. Let's assign the result of that function to a variable. Let's do a value, so just a fixed value result, and we'll make this equal to multiply, and we'll do something easy like 5 times 3. On the right we can see we have our result variable, but we haven't used it yet. Let's now use it in a string template. Let's just type a string right now, so speech marks, and then we'll do 5 multiplied by 3 is, and then we'll do the $ and result. And if we look to the right, 5 multiplied by 3 is 15. We know that works. So here we have a function that returns something. So let's put a note and say to specify a return type, it is a colon after the parameter brackets followed by the type. And just as an extra reminder, let's also say in brackets before the opening curly brace. That thing there, okay? So we don't put it there, that would be horrible. So we put it after the parameter brackets, but before the first opening curly brace, before the function body, okay? So if I just remove this again, I want to show you something that's worth knowing. So the error said requires unit but found int. So a slightly odd sounding thing with Kotlin functions that you don't need to worry too much about. If I just scroll up to my very top function, we've got a function called make noise, and you can see that it says it returns a type unit, as does greet, as does birthday cake. So it's a feature of Kotlin that all functions return something, but if actually you don't want them to return anything specific, it returns this very basic type of object called a unit. You can think of this like the word void in Java. Okay, so we said private void and the method name, and void means it doesn't really return anything. Well, in Kotlin, every function returns something, but if you don't specify anything, it returns this weird unit object. And that's basically like void. Not quite exactly the same, but it's just like an empty, pointless, basic object which you do nothing with. In fact, on this make noise thing, I could say we return this unit thing, but you know, this is redundant. We don't need to type this by default. So I'll just remove that. I could put return unit there. Okay, but that's also pointless. It does this automatically. So For a basic function that returns nothing, we don't specify a return type. Under the hood, it's returning this weird unit thing, but that's not anything we need to worry about. That's not anything you're ever really going to use. So you could think of it like the word void, okay? So right now, because we haven't put :int, this is expecting a unit. It's expecting that, but we're actually returning an int. So as soon as you specify the return type, the error goes away. Again, don't worry too much about this unit thing. In practice, you're probably never going to use it. You just need to know that if you don't want to return anything, like in our birthday cake method, then don't specify a return type. And then we don't have to have the word return anywhere. We can just do some generic utility stuff like this. Okay, so that is a standard function with no parameters, a function with one parameter, a function with two parameters, and then a function that returns something. Okay. Now, Kotlin goes one step further than this with some extra cool things. Sometimes, like in our multiply function, you might just have a one-liner. It might be a one-line function that just returns one thing. Well, if you have a one-liner function, there's 3 different ways you can do it, each slightly nicer than the last. So let's make a new comment, and let's do 3 stars to make a new section, and we'll say there are 3 ways to do a one-liner function which returns something. And you'll see what this means in just a second. So, first of all, apologies for a bit of duplication here. There's the regular way, which is with curly braces, these things, your normal function or method body, and then the word return, and then specifying the return type. So just for a recap, we'll do a function, we'll call it square, to square a number. We'll give it one parameter called number, we'll make it of type int, and we'll make it return an int. So we're going to literally square this number, we're going to multiply it by itself, and then return that int value. And we'll do some curly brackets. So we can now do number times number, but of course we're getting an error because we actually need to return this. It's expecting an int to be returned because of this. So let's do the word return. So we have a regular function which returns a value with our curly braces. Well, if it's just a one-liner, you can do what's called a function expression. And a function expression doesn't use these curly brackets, it uses an equals. Let me show you this. Let's do function, let's call this one square2. So just our second way of doing a square function. Again, we'll give it a number parameter of type int. We'll do :int, we'll specify the return type, but this time, rather than a curly bracket like that, we'll do an equals. And now we can just do number times number. How good is that? We don't even need the word return. This almost looks like we're assigning a variable, doesn't it? We have the name of something and the type of that something. In fact, if you got rid of this, and then change that to val, that would be a pretty good way of doing a variable. So this is a function expression where you declare a function with or without parameters, specify the return type, and then just do equals, and then a one-liner. So let's put a note there. We can do a one-liner function as a one-liner. And I'll put in brackets a function expression, okay, with no curly braces, and instead using an equals sign after specifying the type. Apologies for the long line there, okay? So rather than the curly brackets, rather than a function body, we just do an equals after we specify the return type. And then we can put our one-liner there. And the equals kind of implies the word returns. It equals this value, so we don't need the word return. So if you've got a one-liner function, I highly recommend doing a one-liner function expression like this. Okay? And the third and final way of doing this, which is even shorter, even more succinct, we can do it as a one-liner again. Okay, I'll put in brackets a function expression and inferring the return type. So this means there's no need to specify the return type. This is a bit like our Kotlin variables. So this time I'll do fun square3. I'll do our number parameter again, int. And this is where I would normally do :int to specify the return type, but this time I'm not going to do that. I'm just going to do an equals and number times number. And that's it. And just like in our variables, Kotlin knows that when you times an int by an int, the result is going to be an int. Kotlin knows this, so we don't need to specify the type. So how quick and easy is this compared to our previous full block body like that? And just to show you that all of these work as expected, I'll do square the first one and I'll do 5. Oops, and you can see 25 there. Now I'll change this to square 2 and leave number 5 there. And scroll down again, 25, and then square 3. And scroll down again, and we have the same number 25. So, function expressions, simply meaning a function where you use the equal sign to immediately return a value. That's a function expression where you use an equal sign. These are a really quick and easy way to return values if you have a very simple function. If you need to do it on multiple lines, you need to do it the regular way with the curly braces. So hopefully you've enjoyed some of the nice things that Kotlin does with functions or methods. Personally, I do find them pretty fun to use, and that's not just because they start with the word fun, but they've simplified all of the things in Java that were a little bit long-winded and difficult to type. They've made it quick and easy. So now you're able to make functions yourself. That is functions or methods in Kotlin. It's time for another programming concept, this time on access level modifiers. I've closed down all existing files. To teach this concept, we're going to work it through in a Java Scratch file. So if you can right click on the Scratches folder, not the Kotlin Foundations folder, but the one above it, right click New Scratch File, and make sure you select Java, either from the top or if you have to scroll down. So Java, I'm going to do my usual thing and put the main method in a bit of space, just like that. And let's go ahead and rename this file now. So right click on scratch.java and we'll do refactor, rename file, and we'll call this access space level space modifiers and refactor. And then I'm going to close the project pane so I've got full width. So when we talk about access level modifiers, we're talking about these words public, private, protected that you might have seen, or if we don't specify an access level at all. This relates mostly to your class fields, your class variables, and your methods. So to show this, underneath the Scratch class, outside of this, let's make a new class, so class, and let's call it access level modifiers. Just like that, uppercase for every word, and then curly braces. So when we say access, we mean which other classes, which other files can access our fields, which other classes can access our methods. And there's actually only 4 levels. So we'll put a comment at the top of this class, so // and we'll say there are 4 levels of access in Java. We'll do a colon, and public, protected, default, and private. So there's only 4 levels. We'll do another comment underneath and say these are shown below from most visible to most restricted. So let's do 4 string fields right now. So first of all, the most visible is public. So public string, remember in Java we put the variable type first, public string, and we'll call this one a public field. The next most visible is protected. So the word protected, and then a string again, and we'll call this a protected field. Then the next level in Java is what's called the default access. And this is the level of access where you don't specify anything. So we'll just say a string here. So we're not giving this any specific access, so it's a default access field. And then finally, the most restricted is the private. So private string and a private field. So to illustrate the level of access that these 4 fields have, we'll assign them to a string value which describes that. So starting with public, we'll make that equal to a new string, and we'll say this can be accessed from any class. Simple as that. If you declare a field or a method public, any file, any class in any folder, in any package can use that method, can use that field. Okay? So that is the most visible, the least restricted. Next is protected. So with a protected field, we'll do equals. This can be accessed from either, and there's two scenarios for which files can access this. A class in the same package. You can think of that as the same folder, but specifically it's the same package, and I'll show you what I mean by this in just a moment. Or a subclass, and by that we mean child class. Okay? So to show you what I mean by same package, I'm going to jump over now to our project pane and our app folder. So open the project pane. If I just go into our project and I'll go down into app, the source folder, main, Java, all the way to our main activity. Our main activity is in the com.vinnorman.selfpromo-app package. If I just quickly open the file, you can see at the top, there's the package. Okay? And pretty much always, this should match the folders as you see them here. So you can think of them as folders. Same folder, same package. Okay? If I make another class in this same package, or same folder, then this will be able to access main activity's protected fields. But if I right click and make a new package like this, a new package, don't do this, just this is for illustration only. If I make a class in this new package, which is a different package, this will not be able to access the protected fields in main activity, and main activity will not be able to access the protected fields of classes in this package. Okay? So when we say same package, we mean sort of like the same folder. So with the protected field, it can be accessed from either a class in the same package or a subclass. So if I go back to these packages here, if I made a class in the new package in a different package, then by default that wouldn't be able to access main activity's protected fields unless it extended from main activity. If I made some child class of main activity, if I use inheritance, then even though it's in a different package, it would still be able to access those protected fields. Okay? I'll just close the project pane for now. So if that sounds a bit confusing, or you're struggling to remember this or know exactly what I mean, what I will say is you don't really need to worry too much about the protected field, and indeed the default field, which I'm going to mention in a moment. The most common ones are public and private. Okay? But good to know, protected field, it's the second most visible. It can be accessed from any class in the same package, or a child class, a subclass, which again can be in any folder if it's a subclass. And this leads nicely onto our default access. If we don't specify anything, then this can be accessed from a class in the same package only. So default access and protected access are very similar, but default's a bit more restricted. It's only from classes in the same package. If it's a subclass or a child class and it's in a different package, then it wouldn't be able to access them with the default level. Okay? And then finally we have our private access. This can only be accessed from within this class. So private does exactly what it says really. It means it is only accessible from within that class. Nobody outside the class can access that at all. Well, not directly anyway. So to show you what I mean by this, I'm going to make three methods. We'll do a public method. So public, it won't return anything for now, so we'll do public void, and we'll call this a public method. We'll do a protected method, so protected void, a protected method. We'll skip doing a default method, we'll just do a private method at the bottom. So private void, a private method. Okay. And what we'll do is we'll do a quick system.out.println in each of these so we can show where we are. So I'll do system.out.println in the public method. And I'll copy the whole line to both these places. And then this is in the protected method and in the private method. Okay? So we have our 4 fields and we have our 3 methods. First of all, I'll show you what we can and can't access. So if we scroll to the top now into our Scratch file, we'll make a new access level modifiers object. So in Java, the variable type comes first. So access level modifiers, our level tester, we'll call it. And that equals a new access level modifiers class, semicolon. So first of all, we'll try and use the private field, level tester dot a private field. You'll see that autocomplete doesn't even work for this. I do a semicolon, it won't say that this isn't found. It will actually tell us that a private field has private access. So it knows that field exists, but we can't use it. That is an error. This will not run. Okay, so let's comment this line out, and we'll do an arrow, and we'll say, won't work. This is a private field that cannot be accessed outside its class. Okay. Next we have our private method. So let's do level tester.aPrivate method. Okay, slightly different error highlighting. This time they've underlined it, but if you hover over it, similar thing. A private method has private access, so we can't use this either. So we'll comment that out and we'll say, won't work. This is a private method that cannot be accessed outside its class. Very similar thing. So the public and protected, they will work because for the purpose of Scratch files, it treats them like they're in the same package. So actually protected and default, they would both work in our Scratch files. So let's just prove this now, and we'll do our level tester and we'll do a public method. And we'll just go ahead and run this. And we have in the public method from there, okay? So we can't directly access a private field or a private method, but we can access them indirectly. So to show you what I mean, I'm going to change my public method to actually return a string. So that's expecting a string to be returned, and under our system.out, now we can return a private field. I can use autocomplete. So just because we declare some fields or some methods private, like our private field, it doesn't mean that we can't give them out to the world, to other classes some other way, just not directly. So here we're using a public method to expose this private field. We're getting a couple of warnings because a private field is saying this could be a local variable. We're only using it once, so you can ignore that warning. And we're getting another warning saying that our return value is never used. But if I now do this, if I do string and I put returned private field, that warning goes away because we're capturing that return value. So if I just scroll to the top now, so we've got that private field from our public method. So if we do a system.out.println now, we can say got the private field from a public method. The field is, and then we can add that returned private field. So if we run this now, no error, everything works. We're in the public method, and then we log got the private field. The field is, this can only be accessed from within the class. And likewise with our private method, even though we can't directly access it, we can call it from other more visible methods. So if I go to our protected method, which our Scratch file can access because it's in the same package, and I, in this method, call a private method, well, now, in our level tester, I can do level tester.aProtected method, and when I run this, we get in the protected method and in the private method. So you see, we can declare some things private in our classes, a private field and a private method, but that doesn't mean that the outside world, the outside classes will never see them or never use them. It just means they can't directly access them. And it is very common to restrict the inner workings of our class, some things that we don't want other people to directly call, but then expose it through something else that is slightly more public, just like this. Okay? So we'll put a comment above this protected method and we'll just say / the below protected method is okay to call, as in these Scratch files it is as if we're in the same package. Do another line. This method then calls its internal private method, and so we can see the output. So that is the basics of access level modifiers. On the surface, quite simple, just different levels of visibility for our fields and methods from outside the class where we write them. And for the time being, you can not really worry too much about protected or default. It is public and private that is going to be most useful to us. So that is the concept of access level modifiers. We've covered that here. But to really solidify our understanding of why it's important and why we would bother with this and why we wouldn't just make everything public, I'll show an example that will illustrate why it's really important to not just expose everything publicly and to really think about what things we want to be available from outside the class and what things we want to be private and be contained inside the class. So we'll do that next. So we've covered access level modifiers, the concept. We've covered the what, but I want to spend this tutorial digging into the why. I want to show a very clear example of why it might be important to have different visibility for methods and properties. So to demonstrate this, if you can scroll to the very bottom of the Scratch file, underneath the access level modifiers class, and we're going to make another new class. So we're going to make a fictional scorekeeper. We're going to imagine that we're going to make a system which other games can use, and they can use our code, our library, our class to handle the score. So we're going to make this scorekeeper class, and other games and other users are going to use this. Okay? So let's make the class scorekeeper, just like that, with a curly brace. I'm going to scroll down. This will have a very simple responsibility. It will keep a record of the scores for 2 players. It will allow us to say that one of the players has gotten a question correct, and when they do, it will increment the score. It will report back that that player got the question right, and showing what the current score is. And then when one player gets to 5 points, it will report that that person has won. Okay, so a very simple scorekeeper class that other games and other apps could use. So we'll have 2 properties, and for now we'll make everything public. So a public int, a number, and we'll make this player1 score, and we'll initialize this to 0. And we'll do another one for public int player2 score equals 0. So that's the 2 class variables, the fields. And what we'll do is we'll make a couple of methods to increment the score for each player. So we'll do a public method, public void, player1 correct answer, no parameters, and we'll make some brackets, and we'll just increment the score. We could do player1 score equals player1 score plus 1. We could do that, but there's actually an easier way to do this, and that is player1 score plus plus. So that does the same thing. That's the same as saying player1 score equals player1 score plus 1. That will increment that by 1. And what we'll do is we'll do a system.out.println, and we'll say in here, player1 got 1 right, exclamation mark. And then what we'll do is report the current score. So we'll say player1, then we'll put a space, and we'll add on the player1 score variable. And then we'll add another plus, and then we'll add some more text. We'll do a hyphen, then a space, then player2 and a space, and then finally we'll add on the player2 score. And what I'm going to do to save time, I'm going to copy this whole method. So I'm going to select all of it, Control-C, Command-C, and paste. I've got an error because we've got the same method name twice. I'll change it to player2 correct answer. I'll make this player2 score plus plus. And then I'll change the text to player2 got 1 right. And then we'll leave the same score reporting like that. Okay? So let's go ahead now and test out this new class. So all the way up to the Scratch file, and make a few line breaks, and we'll do scorekeeper, so a new scorekeeper object, just like that, scorekeeper equals new scorekeeper. And let's now just test out our scorekeeper app. So let's do scorekeeper.player1 correct answer. And then we'll do scorekeeper player1 correct answer again. So we'll say that player1 gets the first 2 correct, and then we'll do scorekeeper.player2 correct answer. So let's go ahead now and run this and see what the output is of our scorekeeper object. So run. Player1 got 1 right, player1 1, player2 0. Player1 got 1 right, 2 0. Player2 got 1 right, 2 1. So we have a very simple class, a very simple system for keeping score in a game that other games and other apps could use. Okay? Let's develop this a bit further. So go down to the scorekeeper class again. Let's have a system to check for the winner. So let's say public void check for winner and curly brackets. So we'll say if player1 score double equals for equals, if the score equals 5, so if they reach 5 points, then we'll do a system.out.println player1 wins, exclamation mark. And then we'll do else if player 2 score equals 5. I'll copy this line, delete the line break, and change the text for player 2 wins. So we have a very simple check for winner method, and it will be good to call this from both the player 1 correct answer method and the player 2 correct answer method. So whichever player gets a question right, we will call the same check for winner method. Okay. So until they get to 5 points, nothing will be reported. So if I just scroll up now, and we'll do a fictional game. So it's 2-1. I'm going to duplicate this a few times. I'll just do it 5 more times. So 1, 2, 3, 4, 5. And we'll do player 1 correct answer, then player 2 again. So 3-2, then player 1 again, 4-2, 4-3, and then player 1 can win it in the end. Right, so let's run this to make sure that our check for winner method works. I'm just going to expand this a little bit. Okay. Player 1 got one right. We have 2-1, 3-1, 3-2, 4-2, 4-3, 5-3, and then player 1 wins. So our code works. What I'm actually going to do, I'm going to add a system.out above the scorekeeper. If I just close this, let's put a system.out. We'll print a blank line, and then let's duplicate that, and then we'll put a separator. We'll say scorekeeper demo. Just so we can see the separation between the two tutorials, the previous access level modifiers class and this scorekeeper class. So let's run that again to see how that looks. Okay, so we have our scorekeeper demo there. Good. So this code works. We've made a very simple class, the scorekeeper, that other people could use. We could make this a library so people could use a dependency in their apps and they could use our scorekeeper. But let's see how safe this code is. If I go to the top, after my scorekeeper app, I'm going to comment out this fictional game we've played, and I'm going to do this: scorekeeper.player1 score equals 5. And then I'm going to do scorekeeper.check for winner. And let's run this code now. Player 1 wins. But we haven't even played a game yet. Okay. So by making the player 1 score accessible, it's possible for some malicious code for some game to write the app in a way where it's possible to cheat. It's possible to manually set the player 1 score. And by having the check for winners method public, it's possible to check for a winner before even a single question has been answered. Okay? So it's not very robust, it's not very secure, our scorekeeper class. It's possible for anybody to use our code but then immediately cheat with it. And we don't want that. We want it to be impossible to cheat using our fantastic scorekeeper class. So let's comment out the player 1 score equals 5, and let's make a note next to it, so an arrow, and we'll say, "This isn't good!" exclamation mark. It's possible to cheat with our scorekeeper code, exclamation mark. This should be private. And we'll comment out this line as well, and then we'll say with an arrow, while this maybe isn't as dangerous as manually changing the score, this isn't great ... We don't need to check for a winner unless the score changes. This should be private also. Okay, so we have one thing, the class variables, the player 1 score, the player 2 score. That's really a problem that we exposed, that you can manually change the score. And then we have another thing which it's not great. They shouldn't be able to check for winner. So let's now go down to our scorekeeper class and let's improve our code. Let's make the player 1 score private and the player 2 score private. We'll leave our player 1 correct answer, player 2 correct answer public, but we'll make our check for winner private. Okay, so now if I just close the run pane, we've improved our code. If I go to the Scratch file and I try and do scorekeeper.player1 score equals 5, not possible. It has private access. And if I try and check for a winner, like this, it has private access. But if I uncomment our fictional game here, if I select these lines and do Control/Command/, we have exposed the necessary public methods. So it is possible to use our scorekeeper and play a game, but we've made it impossible to cheat. So let's now run this code. And our scorekeeper demo works even with the private fields. We're using them in our methods, in our public methods. We're using the fields here, and we're using that private method, check for winner. But the check for winner method is called from inside the class, from inside the scorekeeper. Okay? So hopefully that shows a very simple but clear way in which the use of public and private has a benefit, how it improves our code. A couple of simple rules to think of when you're developing. Only make something public if you have to. If you don't call a method, if you don't call a field from outside the class, then make it private. And what you'll find is, as you're working with Android and developing apps, if it can see that you're only calling fields and only calling methods from inside the class and nowhere else, it will actively suggest you change things to private. In fact, we may have seen this once or twice already with some of our class properties, our fields. Okay? So try to make things private if possible. Be very clear about the things you want to make public. And just before we move on from access level modifiers, it'll be worthwhile to explain how Kotlin handles this. So if I go to our project and I go to Kotlin Foundations and our most recent one, our Functions Foundations lesson, I'm going to close the project pane. I'm going to close the side dialog. Okay. Kotlin handles public and private exactly like Java. So you can make something public, you can make something private, but it's gone with what it thinks is a sensible default. Often, public is the access level modifier that we use the most. Okay, this is arguable, it's not always the case, but often you find yourself making functions public, you make things available to other classes, and there might only be one or two inner methods that handle some of the utility, some of the behind the scenes calculations. Okay, so because public can often be the one we use the most, then by default, all functions are public. Don't confuse this with best practice. Best practice is, of course, to make things private if you possibly can. But if you don't specify anything, then the function will be public. And if I just take our greet function here, if you want to make it private, you add the word private. We're getting a warning because we're not inside a class, so the word private doesn't really make sense in Kotlin when it's not inside a class, okay? But that's how you would do it if you had a function or a method inside a class. Of course, there's the word protected as well, but again, it doesn't make sense outside of a class, okay? So by default, in Kotlin, things are public unless you specify otherwise. And that's just Kotlin trying to save us a bit of time, because in many Kotlin projects, public is the most common, okay? But our simple rule is, if you can, make something private. Only make things public if you absolutely have to. So that is access level modifiers, what they are, why they're important, and how they work by default in Kotlin. So let's get back now to our app and start developing the next screen. Now we have our preview activity and we've got our intent to move to it. It's now time to learn how to pass data, to pass values between activities. You might have thought that maybe we could do some kind of method or function on the preview activity and that main activity could call it, some kind of set data function. But the reality is with activities in Android is that fundamentally they actually don't know anything about each other. In this intent here, we're sending an instruction, an intent, an explicit intent to start a specific screen in our app. But main activity will have no reference to that preview activity. It won't know anything about it. Under the hood, when we launch this intent with start activity, the Android system will look up, it will look in the manifest to make sure we have this class, which we do, and it will make a new object. It will make a new version of this preview activity. So it will make a new instance of this class. But back in main activity now, we won't have any ability to get hold of that object. We won't have any ability to get hold of that version of preview activity. So I know this might seem a bit confusing, but it's really important to understand. When you do an intent to move to a new screen, the Android system handles that, but you don't get any reference in the activity that you're moving from. Okay. So we can't interact with preview activity at all from main activity. So then you might think, well, how can we possibly pass data along? And the answer lies in the intent itself. So way back in the previous section where we first learned about intents, we realized that an intent was quite literally an intent to do something. Hey Android, I'm main activity, the this word here. This is the context. I intend to move to this screen. Can you fulfill this for me? and that's an explicit intent where we give a specific class in our project. The other option, of course, is an implicit intent where we don't say a specific class, we just say an action, a thing that we want to do. But the intent is quite literally the thing we intend to do. Well, now is a really good point to further our understanding of how intents work and what an intent is by introducing another analogy. So think of an intent like a letter. So in our letter, we put who the letter is from, and that's the first parameter. So this screen, this version of main activity. And then we write in the letter who to. So from and then to. Okay? We then give that to the postman, and the postman is the Android system. So with start activity, we hand it to our postman, and then our postman looks at our letter and decides what to do with it. So it sees preview activity, it looks in our manifest, which is our address book. It looks in our manifest and goes, okay, yep, I know who that recipient is. And then off it goes to that new activity, and then it commands it to start. So an intent is a bit like a letter. Well, what's one thing that's true of letters? You can put other things inside them. So our intent, our letter, with a from and a to, can have some additional contents. And this is how we go about passing other things to our new screen. So actually the process of doing this is quite simple. So we'll make some line breaks under the variable. So we do preview activity intent, our letter, our intention to move to a new screen. And the method that we call on this intent is put extra. So we've got our default letter, from which screen to which screen. That's our default letter. But if you want any additional data, if you want any extra data, then you call the method put extra. So let's do exactly this. So full stop, put extra, and you can see we have a whole load of methods. They all look the same on my screen because I've got a really big font. But basically they have a key, an identifier, the name, and then the value. And those values cover most of our simple, our primitive data types. Int, byte, character, long, float, short, double, boolean, okay? So we'll do put extra, autocomplete. As you can see, we need two parameters, an identifying name and a value. So we need to give a name for each bit of data we want to pass, and whatever name we give it in this activity, the origin of our intent, it needs to match in the destination. So we'll go ahead and add our contact name first. So I'll do a string, and I'll simply call this contact name. The string can be more or less whatever you want. It can have spaces, it can have underlines, underscores, capitals. It doesn't really matter. So contact name, and then we'll put in our string, the contact name string. So this is the structure. We get our intent variable, we call the method put extra, we name our bit of data, we name our additional extra bit of contents, and then we put the contents in it under that name. So later on we can retrieve this using this name. Okay? I'm going to go ahead now and duplicate this 7 times for our 7 bits of data. So 2, 3, 4, 5, 6, 7. So I'm going to go ahead now and give each extra bit of data, each thing that we're passing, a unique name, and I'll make sure to change the variable over. So for example, I'll change contact name to contact number, and I'll change the variable over. Okay, so I'm going to go ahead now and pause this and unpause it once I've done all of that. Okay, so I've changed all of those values over. So for the name, the label for our extra bit of data, it can be any string you like. As you can see, I'm formatting mine quite nicely. As long as when we retrieve it in the destination activity, it is exactly the same case, the exact same spaces. So you are free to use whatever format you would like. Okay, so now we've done that, I'll remove the line breaks. So the next thing to do is to retrieve those values in the preview activity. So I'm going to head over to preview activity now. So we don't have much here at the moment. We have our set content view, and then we're manually changing the text just for a demonstration. So I'm going to delete this line for now, the text view.text. And under set content view, I'm going to retrieve the values here. So in any activity, the intent that was used to start it, whatever that intent might be, is available to us. So we will have started this preview activity with an intent from main activity. So all activities have access to the intent. As a reminder, this is one of the benefits of inheritance. This comes as part of the features of the app compat activity that we're extending from. Okay, so because we're extending from app compat activity, we have access to the intent object. And the way you get access to that is simply by typing the word intent with lowercase. You can see in brackets it says from get intent. If we were in Java, we would have to type get intent. It's a method. But in Kotlin, it looks a lot like a property. a variable like that. So that will be the intent, the letter that the postman has delivered. That will be the intent that started this activity. So on this, we can then get those extra bits of data one by one. So if I do full stop, yes, we could put more things into this intent, but actually we want to get the data out of it. So type get for get, and then you can see rather than just one get extra method, we have specific methods for each data type. Get boolean extra, get byte extra. Okay, so you need to know what type of thing you're getting out of your letter. So in our case, it is strings for all of them. So we'll do get string extra, and then you need the name that we assigned in the previous activity, the key, the label, okay? So this system with the unique names, that's what gives us the ability to have multiple strings, multiple ints, or multiple booleans, or whatever. So we'll get our first string out, which was contact name. So this line here, getting the intent and then calling get string extra on it, this will return a string if one exists under this key, and if not, it will be null. So let's assign this to a variable. So val our contact name. So if there is a string under this name, then it will be saved into this variable. And it's a nullable type. If I try and do type string, you can see you get a warning if we spell the name wrong, or we forget to include this, or this doesn't quite match up with something, then this will be null. Okay, so it is actually a nullable string. Okay, I'm going to remove the type. I'll let Kotlin infer that. So again, I'm going to copy this 7 times and make sure all the keys match. So I'll pause and unpause once I've done all of that. Okay, so I've done that. If you can do the same. So we've used our intent to put extra things, extra bits of data along with the letter, along with the explicit intent to start the activity. We've used the intent to store those extra bits of data, and we're retrieving them by name in the next screen, in the next activity. Okay? So just to test that this all works, let's quickly make a template string from this. So we'll do val our test string, and we'll make that equal to contact name, and we can use our $sign for our wonderful string templates that Kotlin has. So contact name, then a comma, then contact number, $sign, contact number, my display name, and then my display name. It's going to be one of those long lines again, I do apologize. Include junior, colon, and then we'll do $sign include junior. Job title, $sign job title, immediate start, $sign immediate start, and then start date, if not, and then start date. So there's our quick string template. And just to show this on the screen to make sure it's worked, I'll do a new line. We will set this on our text view. So we'll get our text view message, and we'll make the text equal to this test string. So now we can go ahead and test all of this to make sure it works, to make sure that we can pass all those values from activity to activity. So let's go ahead and run the app now. So I'm going to quickly fill out the form to make sure it all works. So contact name will say Richard Recruiter. His number, my trusty fake UK number. I'll do Vin Norman. I'll say that I'm junior. We don't have a job title drop down yet, so that's fine. I'll say not an immediate start, but I'll say we're starting from the 24th of November 2020. And we'll click preview message. So when we do this, we'll make that new intent in main activity, put all of those extra bits of data into our intent, into our letter. And then in the preview activity, it will open that letter, open that intent, and it will get out all of those extra bits of data one by name. So let's click preview message, and there we have it. Now, if we look at this, contact name, yep, contact number, that's good, my display name. Now, my display name is null, so we've got one mistake there. Include junior is null, job title is null, and immediate start is null. So we've got some mistakes here. So let's see what went wrong. Well, first of all, for the 2 checkboxes, include junior and immediate start, they are not strings, they are actually a boolean. If I try and do a string here, you'll see that doesn't work. However, in preview activity, we've done get string extra. So the fix for this is to change it to get boolean extra. Okay? And with boolean, you need a default value. It can't be null. So we'll say if they haven't specified, it'll be false by default. And we'll do the same for immediate start. So get boolean extra, and we'll say by default immediate start is also false. Okay, so that'll fix those two. What other mistakes do we have? My display name is null and the job title's null, but we know why the job title's null because the spinner, the drop down doesn't work yet. So my display name, something's gone wrong. Well, here in preview activity, I'm trying to get it with the name my display. But in main activity, I typed my display name. So I would love to say that this was an intentional mistake to prove how important the key is. But in honesty, that was a genuine mistake. But good to know. So if you make any mistake in the way you type and then retrieve the name, the label for your bit of extra data, it will just return null by default. Or in the case of booleans, whatever your default value was. Okay. So if I run this again and quickly fill out the form, Sarah Sales, my trusty number, oops, my name, I'll say include junior, yes, and immediate start, yes, no, I'll leave that as no, and then 23rd of November 2020, and now if I click preview message, my display name works, include junior is true, immediate start is false. So that is passing data from activity to activity. We've covered thinking of an intent like a letter, from and then to, and then the ability to include extra things inside there. And then we put them inside with put extra, put the extra bit of data, and we label it. With put extra, we don't have to specify the type. The intent will know what's being put into it. We just have to name it. But in preview activity, we have to call get and then the specific type. So if we make a mistake, if we do get string extra when really this was a boolean, then as you saw, that will be null. Okay, so we have to get them one by name, and we need to know what the type is. And that is the way to pass data from activity to activity inside an intent. The final thing we need to do on our form is get our spinner, our drop-down, working. And the good news is it's actually super easy and quite similar to something we've done before. So if you think of your spinner, your drop-down, if I just show you in activity_main, so you have the little arrow and then you have some contents. And the best way to think of spinners and how they work is much like a list. So we've already used a list view, a basic widget for adding an array of things, whether that's strings or objects. You give it an adapter and then the list view takes care of the rest. Well, the spinner works in much the same way. So if you think of a spinner like a list, we just need to make an adapter, give it an array of things, and the spinner will take care of the rest. So let's jump back over to main activity. And after where we're doing the button preview click listener, make some line breaks, and we will make a new adapter here. So just like when we did the list view, we don't need to do any complicated recycler view adapter with extending classes and view holders. We can use that simple, ready to use array adapter, just like we did for the list view. So we'll make a new adapter variable, we'll do val, because we're not going to change it later, and we'll call it our spinner adapter, and we'll make that equal to a new array adapter. We'll be getting onto classes in Kotlin very soon, but just as a quick reminder, when you make a new object, you don't need the word new in Kotlin, so we'll just do the class. So with a capital A, array adapter, just like that. And you can see we've got the diamond bracket with the type inside. So we could do this, and we could put string there, because we'll be putting strings inside this array adapter. But you're going to see in just a moment that Kotlin is going to be able to infer the type. Because we're going to be giving it an array of strings, it will know that it contains strings, so we don't actually need this. The wonderful benefit of Kotlin type inference, a bit like with our variables, okay? So do the normal brackets, and we can see it needs 2 or 3 things. It needs the context, so we'll say this for this screen. Then it needs a layout, and we can use one of those template default layouts. So we'll do Android, so one of Android's layouts, .r.layout, and then there's plenty to choose from, and the one you want to do is simple_spinner_drop-down-item. That's the one we'll use. That will give us a very simple but well formatted, well spaced with nice margin or padding, a nice drop-down layout for our options. And the last thing it needs is the array of strings. So I'm just going to leave this for a moment. I'm going to press escape. So that's going to be an error for now, but that's okay. Now the way that we declare array variables in Kotlin works a bit different to Java, and also that array initializer block that we've used before in Java, it doesn't quite work like that in Kotlin. So I will show you these differences here and now. A couple of small changes, but I don't think it warrants a completely separate tutorial. So we'll cover this now. So above the spinner adapter, let's make a new variable and we'll call it our spinner values. So if I just show you what the variable type looks like now, we'll do a colon. So you might think we can just do, like Java, string array. But this syntax isn't recognized in Kotlin. So the Kotlin equivalent would actually be the word array with a capital A, and then our diamond brackets to specify the type. Now personally I prefer this. We so rarely use those square brackets in Java, and for a new person coming into the code it would be difficult to know immediately that those square brackets do mean an array. Whereas here in Kotlin we explicitly say the word array, and we use those diamond type brackets that we do see quite often in both Java and Kotlin, these diamond type brackets. Okay, so that would be the equivalent of doing string array like that. And then for the array initializer block, we would just do those curly brackets and start doing our strings like that, separated with commas. But again, this isn't recognized in Kotlin. The equivalent would actually be a very useful Kotlin method, a Kotlin function called array of. And then inside these curly brackets, our comma array comma values. Okay, so two changes there. To declare a variable which is an array, we say the word array and then the diamond type brackets, although we can actually remove this now because Kotlin can infer that we have an array here and it can see that inside it is strings, so it knows that's an array of type string. And the array initializer block, rather than just doing curly brackets, we have the function array of, and then we pass in our values. And again, I also prefer this because I'm used to these curly brackets being class blocks or on-click listener blocks, things like that. It's not very descriptive just seeing curly brackets for an array initializer, but when you see the word array of, and then the values, to me that reads really clearly. Somebody coming into a project from a different language who doesn't know Kotlin would be able to look at this and see what's going on. So now we can pass in spinner values there, and that is our spinner adapter done. What I will do for the purpose of this tutorial is I will actually leave the array and then the type string in. Even though Kotlin can infer this, it will probably be really good for you, for your reference code, to see how arrays work in Kotlin. For educational purposes, I'm going to leave this in if you want to do the same. So we have the spinner values, we pass them into our adapter, and then the last thing to do is to set it on the adapter. So I'll do spinner job title. From our Kotlin extensions, we can just use the view ID, and then it's adapter. Spinner job title.adapter equals the spinner adapter. And that is all we need to do. Remember, in our onPreviewClicked function, where it says job title, we're doing spinner job title.selected item, could be null. So then we do .toString. Because actually, in our array adapter, we can pass in any type. We could pass in project, dishes, okay? But because we're doing toString, it will get the string version of that. And in the case of our string array, it will just literally be the string as we typed it. So these 3 lines here are all we need to do to add values to our dropdown, to our spinner. Create the array of values, make our simple array adapter, giving it a layout and the values, and then set that adapter on the spinner. And then we retrieve that value with the property spinner.selectedItem. Okay, so let's change our array values to the ones we want to use in our project. So we'll have the option of being called an Android developer, or we'll have the option of being called an Android engineer. That's the 2 most common ways of introducing ourselves. I'll remove the last value. So let's now go ahead and run this and see our new spinner values. So you can see there we have Android developer, our first value in our array. And when we click that, you can also select Android engineer. So let's quickly fill out the form. Salesperson. I'll say I'm a junior Android engineer with an immediate start date and preview message. And there you can see on our message preview, we now have job title, Android engineer. So that is spinners in Android and arrays in Kotlin. It's time for another Kotlin Foundations tutorial, this time on classes and objects in Kotlin. I'm in a new Scratch file under the Kotlin Foundations folder, which I've renamed to Classes and Objects. If you can go ahead and do the same, and then I'm going to close down the project pane for the rest of the tutorial. So we'll start off first of all with a basic class in Kotlin. So just like Java, it starts with the word class in lowercase, and then the name of our class, starting with a capital letter. So we'll call this a Kotlin and then class, like that. And then our curly braces. Always start your classes with a capital letter and then a capital letter for each word. Upper camel case as that's known. Okay? And what we'll do is we'll just give it one property and one function to show how similar it is to Java. So we'll do a var for a variable and we'll call it a class property. And we'll make it of type nullable string. And of course we need to initialize that. So we'll initialize that to null. So we have one class property, a variable, and then we'll do a function. So fun, a class function, no parameters, and we'll just do something simple like print line, I'm a class function, my property is, and then we'll just use our string template and add in the class property. Okay, so nice and simple there. Not much at all that's different to Java, apart from the way we do our variables and functions. The class itself looks very, very similar. So let's make a note at the very top. We'll do triple star and we'll do capital letters and we'll call this classes, just to show how basic classes work. And then we'll say underneath, a basic class is highly similar to Java. Okay, so now let's make some objects from this class. Let's make some new instances of that class. So we'll do a val, a VAL, we won't change this. So we'll do class test, we'll call it. And then the way you make a new object in Kotlin, we've seen this already once or twice in this section. We don't need the word new like we do in Java. We just do the class. So Kotlin, class, and then the brackets like that. Okay? So let's make a little note of that. Let's say in Kotlin, we don't need the new word when we make a new object. So that's one little shortcut already that Kotlin gives us from Java. Let's now just test our object out to make sure it works okay. So we will do class test dot a class property, and we'll set this to something like setting the class property. And then we'll call our one function, our one method, a class function. And then if we look to the right, we can see in the preview, I'm a class function, my property is setting the class property. Okay, so nothing terribly new there for classes. So we move now onto one of the first major benefits to the way that Kotlin does classes, and that is in the way they do their constructors. So if you can go ahead and put that new heading. If we think back to Java, we would define our class a bit like we've done at the top here, and then the constructor would look a little bit like a method. It would be its own block inside, starting with the name of the class. It would have parameters, and then typically we would pass in all the variables we needed and then set them with this.variable equals variable, this.name equals name. Okay, quite a long, cumbersome, time-consuming process. Well, in Kotlin, the constructor immediately follows the class name, and adding val or var makes the value a class property or variable. So if that sounds confusing, let me immediately show you what I mean. We'll make a new class now, so type the word class, and let's call this class with constructor. So now, rather than doing curly brackets and making a constructor somewhere inside here, do the regular brackets just like we were doing a function. Okay, so the brackets go there. So now, inside these brackets, we can put the class properties, the class variables, directly. So let's give this class a property right now. So we'll give it a variable, something we can change. We'll do var, and then we'll call it a class property, and we'll make it of type string. And believe it or not, right there inside those brackets is both a constructor and defining the property. What I'll do to really make this example clear is I'll do a few more properties, a few more values inside this constructor, and I'll show you what this is doing under the hood. So we have a regular class property of type string, and notice that it is not nullable. That's just a regular non-nullable string. I'll get into this in just a moment. Let's also do a nullable property. So I'll call it a nullable property. and I'll make this of type nullable string with a question mark. No need to initialize it though. No need to do equals null. I'll explain why in a second. I'm just going to scroll across. As well as doing a VAR for a variable that can change, we can also do VAL like normal with our variables, with our properties. So I'll call this a fixed property. And just for a change, I'll make this of type int. And a final thing we can do with our variables inside this constructor is set an access modifier, the visibility. So let's make our last variable, our last property, private, a private variable, and we'll call this a secret property, and again we'll make it of type string, and then we do our curly brackets, and then we're into our class. So I know this is quite a long line here, but in that one line we are doing both the constructor and the properties. So in terms of properties, putting these variables inside these brackets, inside this constructor, is the same as doing this. Yeah, it's the same as defining the property like we normally would. Of course we're getting errors because we've defined it twice. Let me just quickly pause the video and unpause it so I can show you all of those variables. So what Kotlin is doing with this system of having the brackets after the class being the constructor and the properties is it's combining two things. It's combining the constructor and the property. So these four variables here create properties just like this. So I'm going to comment this out, and we'll put a little note to say the above inline constructor, in line with the class name, has the effect of creating properties just like below. Okay, so let's cover a couple of other things here. You notice that most of our properties are non-nullable. Now if we scroll up to the very top, we made a nullable class property here, and we had to assign it to null. We couldn't do this. Error says must be initialized, okay? But because all of these properties are inside the constructor, well, it's not possible to make this class without having these values. So because of this, because we are demanding these properties in the constructor, it's possible to have non-null properties like this, okay? So using the Kotlin constructor is very powerful for multiple reasons. If you want to make them nullable, no problem, add a question mark, okay? So let's make another note to say exactly this. Because we demand these values in the constructor, the properties can be non-null. And just one final note, we can choose var or val if you want a variable or a fixed value, and we can state access modifiers. For example, private. And we'll just put in brackets, they are all public by default, as we learned previously. So a few things to note there, but this Kotlin constructor is incredibly powerful. Let's now play with our new class underneath. So we'll make a new val, because we're not going to change it. We'll call it our constructor test. And that equals a new object. We don't have to say the word new. Okay, so new class with a constructor. And I'll make a class property be my name, Vin Norman. The second one, a nullable property. I'll just say this could be null. Then we have a fixed property, which is a number. So I'll make it the number 7, my lucky number. Everybody's lucky number. Okay, and then the final one is a secret property, the private one. So let's just call this shush, comma, it's secret, exclamation mark. So we're making a new object and we're calling its constructor, which in Kotlin is inline next to the class name. And in doing so, not only do we set the parameters, the values of that constructor, we also can define the class properties right there in one place. No more duplication, no more this.name equals name, this.age equals age, okay? Much, much shorter, much, much easier, and in my opinion, much, much clearer. So let's now do a toString method on our class with a constructor so that we can see what all the properties are set as, a bit like in our class function one above. So let's override the toString method. Just like in Java, every class can override a default toString method. So if you start typing lowercase t, to and then string, you can see the method there available for us to override. So let's go ahead and do this and see how Kotlin handles the override word. Okay, we'll just escape that for now. And we'll change the return delete super.toString, we'll delete the parent class default behavior, and we'll just return an empty string for now. Okay? So if we look now, the override is in line. Before, it used to be over the top like that. Yeah? But that involves an extra line for every single override, and overriding is incredibly common in Android. So to save some lines, to make things easier, Kotlin puts it in line like that. Okay? Let's make a quick note about that. Let's just say the override annotation is inline at the start of the function. Nice and easy. So let's now do a really detailed toString for this class. Let's say the name of the class, then some brackets, and then let's say what all the properties are equal to. So we'll do class with constructor. So we're going to show what the class is, then do some normal brackets like that, and then we'll do something like the name of the property, then an equals, and then we'll use our wonderful Kotlin string templates, so $, and then we can put the property value in line like that. So we'll do that for each property, separated by commas, so a nullable property equals a nullable property, comma, a fixed property equals a fixed property, comma, and then a secret property, which we can access because we're inside the class now, aren't we? So that's fine to access from here. Okay, so we've done a nice, useful little toString method there for our class with constructor. So let's now use our toString method by doing a print line on our new object. And we could do constructor test.toString, we could do that, but actually the toString is superfluous. We can just do the object because it will automatically call the toString. So when we do this, if we look to the right on line 38, class with constructor, then you have the property equals, and then whatever value we set it to. If I just drag this across a little bit. Okay, so that's quite a useful toString method there. The type of our class and all the properties and the values they're set to. Okay, drag this back over here. So to show you these different properties we have at the top here, including a warning, which we'll get rid of in a moment. So our first property was a regular var, a class property. So we can change that. So let's do our constructor test object dot a class property, and we'll change that to something else. I'll make it my full name, Vincent Norman. Okay. Now we didn't make the first property nullable. As you can see up there, it's string, not string with a question mark. So if I try and do constructor test dot a class property equals null, well, we have the error telling us that we can't make null a value of a non-null string type. So we'll comment that out and we'll just say, can't make this null. This property is not nullable. Okay. Then our next variable was nullable. So if we do constructor test dot a nullable property, because we put the question mark above there, then we can make this null, and that's absolutely fine. Then if I actually just quickly look up, we had our fixed property. Now, if I hover over this, it's saying this could be private. So Android Studio can see that we haven't called this from anywhere outside the class, so it's suggesting it could be private. But when I access it here, constructor test dot a fixed property, when I call it just to see what the value is, which is 7, then you can see that warning goes away. If I then try to change it to something like 12, it says val cannot be reassigned because in our constructor we set this variable to be val. So this should all be recap of our knowledge of variables. So we'll comment this out and we'll say can't change this value. We set the property to be a val in the constructor. Okay. And then the final variable we had, if I scroll up, was our secret property. But we changed the access modifier to be private. We made it not visible outside the class. So, of course, just like with a regular property, if I try and do constructor test dot a secret property, if I try and even access it, we get a warning that says we can't access it, it is private in the class. So again, we'll comment this out and just say we can't see this property, we set this to be private in the constructor. So a bit of recap there about our variables, nullable versus non-nullable, var versus val, and also our access modifiers by having the word private, okay? But hopefully you're seeing that in this constructor, we are also defining the class properties, and we can do anything we want with them, just like if we defined them here in the class body like normal. Okay? So that is constructors. Incredibly useful, incredibly time-saving. There's just one final very quick basic thing I want to show you before we leave classes for now, and that is a new type of class that Kotlin calls a data class. So make a new heading, 3 stars, and we'll say data classes. If we think back to our project class or our dish class that we made in previous sections, they weren't really doing anything that complicated. They weren't calculating a BMI or doing anything advanced. They're pretty much just holding values for us, a data container. So if this is the case in our code, then we can use Kotlin's special data class. So let's go ahead now underneath this and type the word data and then class. And I'll just call this with a capital letter, of course, my data container. And we'll do a constructor. In fact, you have to do a constructor with a data class, so normal brackets, and then we'll just set a few standard variables. We'll make them all vals, so val, some data, we'll make it a string, we'll do some more, which will make a boolean, and then yet more, and that could be an int. Okay? Now you may be thinking, well, what's the difference? And the short answer is not much. It's still a normal regular class. We could just do this without the data word, okay? However, it does a couple of things under the hood, gives you some extra behavior, one of which we're going to see in just a moment, which does make it quite useful for inspecting our objects, for looking at our data classes and seeing what's inside them. So let's just make a quick couple of notes under this heading. Let's say we can use a data class if our class mainly just holds values, and we just add the word data in front of the word class. This comes with a few benefits, which we're going to see in just a second. One of which is a useful descriptive toString method. So if I scroll down, I'm not even going to give this data class curly brackets. We don't need to, there's no contents. Because we've annotated this with the word data, it has some default behavior for some of these methods already. So to show you this, without doing anything else, I'm going to make a new val called a data class test. So a new object. We'll make it equal to my data container, and we'll set those values in the constructor. So we'll go for a string, hey, true or false, we'll do true, and then an int will say 5. Okay, so we've made a new object, a new data container, and we've given it those values. I can now do print line and pass in this new object, just like that, and let's see what the output is. If I just scroll this across a bit, go to the very bottom, the name of the class, my data container, and then brackets, and each of our properties and the value that is set. So pretty much, if I just scroll up, all that we did previously, if I show you in the code, we had to do it with this big long line here. Okay, so if I just scroll back down again, if you annotate a class as data, you get some useful benefits like this, one of which is a very useful toString method. Okay, I recommend if you're creating a class just to hold data, always annotate it with the word data. Define all the values you need in the constructor, and then it becomes a very short, simple class that just acts as a container for your values. Okay, and we'll get a chance in just a moment to apply this in our project when we look at finding a better way to pass data from screen to screen. Okay, so basic classes, constructors, and data classes in Kotlin. I'm back now in main activity in our project, looking at the onPreviewClicked method. So we can see in this method there's quite a lot of lines, quite a lot happening just to do something fairly simple. We're retrieving all of the values from the form and saving each one to its own variable here. And then after we create our preview activity intent, we're putting each individual value one by one as an extra and naming it as such. Hopefully you're seeing that this doesn't appear to be the most optimal way of doing this, the cleanest way of coding this. If I just jump over to the preview activity, we have a similar problem. We have to retrieve each extra one by one, save it to a variable, and then we use those variables one by one. So if I just go back to main activity, so having learnt about Kotlin classes, and in particular that data class, this would be a perfect opportunity to create a class for our message, which will basically be a data container. It will hold those values. Okay, so let's go ahead now and create this class before then coming back to here and then refactoring this, which is the posh word for changing the code to improve it. You can press the target button to get to the folder that we're in. So there's my package. I'm going to right click and do new Kotlin class. So not new activity now, just a new class and a Kotlin class this time. And selecting the word class, we'll simply call this, with a capital M of course, message, and then enter. So we have a new class, and all this class is going to do is hold each of those variables, a data container. So this is a perfect opportunity for us to use our new data class. So in front of the word class, type the word data in lowercase. And we're getting a warning because in a data class you must have a constructor with at least one value, at least one property. So let's go ahead now and delete the two curly brackets. We're not going to have a body in this message for now. So delete those and do your curly brackets. And now we need to put at least one value. Let's put these into here one by one, and we'll make all of them a val, a V-A-L. As once we make our new message object and give it all the values once, we're not going to need to change those values later. So let's put all of those properties in this constructor now. So val contact name is a string, val contact number is a string. Notice how I'm making all of these non-nullable. One of the benefits of the Kotlin constructor. We have val my display name string. Apologies, it is going to be a long line again, but we are going to do something about this in just a second. My display name string, then val include junior, which is a boolean, then val job title, which is a string, then val immediate start, which is another boolean, and then if not, val the start date, which will be a string. So that's all of our properties in our constructor for our Kotlin data class. Okay. Now, something I'm going to point out just now. You may have noticed throughout this course this faint grey guideline that Android Studio puts in. This is a recommendation that really our code shouldn't be any wider than that. So in the case of something like this, a constructor with lots of properties, lots of parameters like this, we can actually put these parameters on separate lines, and it is absolutely fine in Kotlin. So a quick and easy way to do this, you can click anywhere inside the constructor, and you can do Alt-Enter or Option-Enter, and you'll see there's an option to put parameters on separate lines. And if you go ahead and select that and press Enter, it will format this nicely for us. Okay, you see that? It puts each one on its own line with a nice indent, still separated by commas like that. And now we have our data class. We can see all of our properties there, but because they're inside these regular curly brackets you see there, it is still a constructor. So that is a nice, neat and tidy data class. So we can now go back to main activity and start using this class. So in main activity, I'm going to make a few line breaks between the variables and the intent. And we will make our new message class here. So VAL, message with a lowercase. We could specify the type. We could say it's of type message, but when we do equals and our message class with a capital M, Kotlin will infer that. So we'll do exactly that. And then we do our brackets. So that's our new object. And if you look above, you can see the prompt there prompting us for our 7 values. So we could go ahead and put contact name, contact number like that. But you know what? We don't actually need those local variables. So what we'll do instead is we will extract the values from the widgets on the screen directly into our constructor. Let me show you what I mean. If I just undo those 2 variables. So for contact name, I'm going to copy this edit text.text.toString and put that in directly. Okay? And then a comma, and then the edit text contact number. Okay, so you see what I'm doing here? I'm copying the actual value directly from the screen and loading that into our constructor. No need for the local variable. So another comma, copy. And as you can see, already this line is getting quite long. So I can click anywhere inside these brackets, anywhere inside this object constructor. I can do Alt-Enter or Option-Enter, and you'll see we have the option to put arguments on separate line. Now don't worry too much about the word arguments there. I've been referring to the things inside our methods, inside our constructors as parameters throughout this course. Parameter is the name for the thing when you write the constructor, when you write the method. P for the thing you expect to be passed in. Argument is the actual value. So here we're actually passing in the value. So A for actual values, A for arguments, and P for the thing you expect to be passed in, P for parameters. Okay, so arguments, parameters, similar but not the same. So these are the arguments, the actual things we're passing in. I'm going to go ahead now and put the rest of these on individual lines. So new line, comma, job title, comma, immediate start, comma, and start date. Okay, now we have an error, and that is because this is a nullable type string. Remember, selected item could be null. We've put this question mark here, okay? So, dead easy fix. We go back to our message class, and for our job title, we make it of nullable type. And you know what? If the user selects immediate start, if they're going to start immediately, then we should pass in null for the start date as well. So we'll make start date also nullable. Okay? But we'll demand that the other 4 values are indeed definitely passed in. And the error goes away. So, these are our arguments, the actual value we give it. These are the parameters, the things that we want passing in. Okay? So now that we have our message class with all of the values given to it in the constructor, we can remove all of these local variables. So now we just have one variable. We still have a problem though, in that we were passing each individual value one by one with its own individual name. Now we could simply replace this with message.contactName and message.contactNumber. We could do that, but it kind of doesn't achieve what we wanted, which is to only pass one thing across to our new screen, this complete message class. So let's go ahead now and delete all of these extras. Now, let's see what happens when we try to put our message variable as an extra. So we'll do preview activity intent dot put extra. We'll call it our message, and then we'll try and put in the message variable. Okay, we have a problem. None of the intent put extra methods can handle this type of object. You see there's a whole bunch there. Boolean, string, int, double. So a message isn't one of these types. So how can we possibly give an intent this message object? And if you look near the top of this error, there's one type of variable we can do, and that is called serializable. So in the next tutorial, we're going to look at the quick and easy way that we can make our message class serializable, and we're also going to dig into exactly what serializable means. So let's do that next. It's time for the final programming concept of this section, which is on serializable or serialization. In the last tutorial, we saw that we have a problem passing our message object into an intent because it's not a string, it's not an int, it's not one of these simple types. But we did see that there's a type near the top of this suggestion, of this error, called serializable. Okay? Now for this tutorial, the actual change we need to make is very, very small. It's just one symbol and one word. So I could go ahead now and tell you what to type, and that would be the end of it. It would take about 15 seconds. However, even though the process of what happens under the hood with serialization is rather complex, I do think it's important that you understand fundamentally what serialization is. So we're going to head over to a Scratch file now and go through this in a way that hopefully will make sense. And even though we don't really need to know what happens under the hood with the way that serialization works, we at least know what it is and why it's important. So open up your Scratches and Consoles folder and open up Scratches. Now we are going to do this concept in Kotlin, but it's not a Kotlin Foundations thing, this is a Java thing. So we will make the Scratch file in the Scratches folder. So right click on the Scratches folder and do new Scratch file, but we'll make it a Kotlin Scratch file. And I'm just going to rename the file now. So right click on Scratch, refactor, rename the file, and we'll rename it to serialization. Okay, and refactor. So a quick warning, the majority of this programming concept tutorial is going to be typing out comments and finding a simple way to understand the process of what serialization is. Feel free to paraphrase some of these comments or to not include things that are obvious to you or add extra comments if it will help you understand, okay? There's not actually that much programming in this tutorial. We'll start off by just creating a very basic data class. So we'll do data class, we'll call it person, and we'll do val name, so a name property in the constructor, and an age property of int. And I'm going to go ahead and close the project pane now, so we've got full width. And just above this class, let's make a comment and we'll say a normal class, okay? And now underneath this class, let's go ahead and make a new object, a new instance of this class. So we'll do a val, we'll call it my person, and we'll make that equal to a new person object. I'll just give it some values. I'll pass in some arguments. So we'll call the name Chris Coder. Age can be 25. So we'll make some comments above this, some recap stuff. So when we make a new object, this instance, this version of the class, this instance, it's live in memory. So our app, our code is running, and there's a bit of memory space where all of our app's processes live. So this instance is alive in memory, in our app's memory, okay? So let's expand upon this point. It lives within the runtime environment for our app. And if you remember from the early tutorials in this section, in our case, it's going to be the Android runtime, or the ART, or the Dalvik virtual machine on very, very old phones. But just let's think of this as the Android runtime. So we make a new object in our app. This object lives, it's stored, it's saved, but it's within our app. It's in our app's memory space, okay? So what happens if we want to send this somewhere else? If we want to send it to another app, or we want to save it, close our app down, and then come back into our app and then have this object back again, recreated again. The object that's alive now in memory is no good to us because that won't exist anymore, okay? And even with our activities are single, independent, focused things that a user can do. They kind of live separately. So the fact we have a person object or something alive in one activity, that's kind of no good to the next activity. We need a way of passing that to the new activity, or indeed a new activity in a different app, okay? So let's make a comment to explain what I'm talking about here. If we want to send an object somewhere outside of our current live environment, we need to, and there's a posh word coming up here, persist it. And I'll just put in brackets after this. So by persist, what I mean is save it, store it. What we mean is it will survive beyond our app's runtime environment. It will survive beyond the memory of our current running app. That's the meaning of the word persist. So you can think of it like saving it or storing it. But we need to keep it alive beyond our app's memory, if that makes sense, okay? So on a new line, relating this now to our problem, we want to take our current living object, our message class that we've made in our project. We want to take the object and put it into an intent, put it in that letter as an extra bit of data. Well, unfortunately, our current activities memory, our current screen, that current environment where our activity is running, that instance of the object is no good. We need to find some way to persist this, to save it, to store it, okay? So let's say exactly this. This persisting is necessary to pass data in an intent. And this is just one example of where it's needed. Particularly as intents, if you remember, can be used to pass data to other Android apps. So you might think, surely there's a way we can pass it to an activity, and in reality it is a little bit more tricky to do from activity to activity, but it's even more difficult to pass from application to application. We need a way to save it, to store it somehow, that is understood beyond our app's memory. Okay? Now you might think, well, hang on, I'm putting in strings and ints and booleans and those kind of things, and that's fine. Well, yes, an intent can automatically persist simple variables, for example, int, boolean, string, etc. So these simple things already built into Android, already built into Java, is the ability to save those, to store those. That already exists, that mechanism. Automatically, we get that for free. And the final point of this mini paragraph, however, an instance of a class So an object like our person object that's alive above, this cannot be automatically persisted. Not by default anyway. Now there's actually many ways you could persist something, could save something, saving it to a file, database or whatnot. Now one quick and easy way to persist an object is through serialization. We can make the object serializable. Now the actual mechanism of this is rather complex. We have our object alive in memory now, and then the Java system, not even Android, Java takes our object and converts it into a stream, a sequence of bytes. And these bytes look horribly confusing, lots of zeros and random numbers and letters, okay? But our living object is converted to the stream of bytes, and then those bytes are saved somewhere. Now that somewhere could more or less be anywhere. It could be a file in our storage, so a text file or something like that. It could be saved to a database somewhere, or those bytes could be just saved to a different area of memory. Rather than our app's little memory space, it could be the whole phone's memory or another app's memory. But the fundamental thing is the object that is alive now is converted to bytes, and those bytes are stored one of a few places. And then the place that then needs that object, it will read those bytes and it will know how to rebuild that object exactly as it is when we saved it. So serialization is the process of taking a living object, converting it to some bytes, saving that somewhere, and then reading those bytes and recreating the object exactly as it was. And that's serialization, okay? So let's go through those steps so we have a record of this. So we'll do our comment block now, do slash and star and then enter. And then just to the right of it, we'll do steps. And then we'll do a few indents and we'll just detail what these steps are so you've got a record for it. Feel free to paraphrase this, feel free to do it in your own way or draw a diagram or whatever you want to do. So the first step is we tell Java that our class can be persisted. And doing this is incredibly easy. As I mentioned, it was one symbol and one word. It's done by just adding colon serializable after our class. Okay, that's all we need to do. So then our class can then be serialized when needed. And various parts of the system will do this for us. An example could be by being put into an intent. We would put this serializable class into the intent. The intent would handle the serialization for us. We don't need to do anything. Another example could be writing it to a file. There's ways you can take a serializable class and then store that in like a text file. Okay, so it can be serialized when needed. That living object is converted into a stream or a sequence, if you like, of bytes. Horribly complicated looking stuff. We don't need to worry about that. These bytes are saved somewhere. For example, it could be a file, a database, some different memory in our system. And then, when needed, these bytes are read from where they were persisted or stored. And finally, these bytes are used to recreate the object as it was before. Let's remove that line break. So this is the process of serialization. Quite complicated under the hood, quite simple in terms of what we need to do. So to show you how simple it is to make a class serializable, to make it able to be converted to bytes, we will do one here. So data class, we'll call it our serializable person. We'll give it a val name string and a val age int. After those brackets, we do a space, a colon, then a space, then serializable, like that. And we'll do an autocomplete so this Scratch file can import this. You can see at the top, we've imported this serializable thing. Okay. Later on, we're going to get into what this colon means when we do our Kotlin foundations on inheritance. And especially we're going to see what the serializable thing is in the next section where we take a proper look at what an interface is. But all you need to know right now is to make any basic data class, any class with simple values like this, serializable, to make it able to be saved or persisted, you can add colon serializable, and then the Android system or the Java system will take care of the rest for us. So one final note, we add colon serializable to tell Java that instances or objects of this class can be persisted or stored. So let's now jump over back to our project and quickly apply this. So in main activity, you can see it's saying this message can't be stored as any of those types, but third from the top we see serializable as a type. So we go to our message class, which I still have open, and at the very end, after the closing bracket, I do a space, a colon, and then serializable like that. And when I go back to main activity, the error goes away. We've made our class serializable. I'm going to remove the line breaks, tidy this method up a bit. So we've now successfully put our nice tidy message class into the intent, and in the next tutorial we can go ahead and retrieve this new message class and start using the values directly from our message class. Now we have our new message class and we've made it serializable so we can put it in our intent as an extra. It's time to move to our preview activity and retrieve this. So let's head to preview activity now. So I'm now actually going to delete everything after set content view, and we're going to do this again properly. So let's remove all of these lines. So the first thing we need to do is now retrieve our message intent. So we'll make a new variable and we'll call it message. So the first thing we need to do is access the app.compat activities intent, the intent that started it. And we do that simply by typing intent. So this is the intent that started the activity. So now we can do get, and there's all those different types there, string extra, int extra, boolean extra, but we now need to get serializable extra. So we'll do speech marks, and the name of this serializable extra was message. Now we have one problem. If I try and make the message type be of type message, well, Android knows that this is a serializable class. It's found a serializable object, but it doesn't know that it's a message. It could be anything. Person, dish, project, message, whatever class could be serializable. Okay. So there's one final thing we need to add. We need to tell Android specifically what this class is. And we do that by saying as message. So we have a serializable object and we're converting it to a message. We're saying this serializable, let's have it as a message, please. I think it reads quite well. This serializable as a message. This is a thing called casting, which we haven't covered at all yet, and I will do a deeper dive into that when we see it more frequently. But in simple terms, it's a way of telling Java, or Kotlin, that a more vague type of object, like an object's parent, or a serializable object, or something a bit ambiguous, we're specifically saying what exact type of class it is. So this vague serializable object, let's have that as a message, please. We can get rid of specifying the type there. We can let Kotlin infer that. Now we have to be careful with this, because if we get it wrong, if we say it's as something else, and it's not actually a boolean, it's not actually a dish or a project, there will be a crash here. Not a null pointer exception, but a different kind of crash. A class cast exception. Okay? In simple terms, we make the vague serializable object into our specific message object, and we are sure we know that it's a message from the way that we've coded this. So we now have our message object exactly like it was in the previous screen. So now would be a good time to build out our message exactly as we want to format it. So underneath, make a new variable and call it our message preview text. And we'll just make this equal to an empty string for now. So we're going to be doing quite a long message now, and it's probably going to have several lines. Now you can put line breaks into a regular string. I could do hello, and I can put a line break in with a very specific thing, a backslash and an N, something called a string literal, which we don't need to focus on too much now. But a /n inside a string, you can see that Android Studio colors that orange. That will put in a blank line for us. So I could do hello, blank line, and then this is my next paragraph. And that would put one complete line space between hello, the first line break for the next line, and the next line break for a complete empty line between these two, okay? But this is going to be a very, very long line. So Kotlin has another very useful thing it can do with strings. If you delete all this and do 3 speech marks, and you can see that it auto-completes the closing 3, So we have a total of 6 speech marks. Well, if I now make a line break, and you can see it's added the words trim indent, but don't worry too much about that right now. Well, this is now what Kotlin calls a raw string. It's a different type of string literal to our /n. And what this means is everything we type inside these pairs of 3 speech marks will be interpreted literally in its raw form. So any line breaks, any special characters will be included as part of our string. And this is the raw string feature, which is yet another bonus of Kotlin. So now we have this string literal in this space here, exactly as you see it, underneath the first 3, but above the last 3, we can fully type out our message now. So we'll do hi, and then we're going to access our message object. So do $message autocomplete, but we don't just want the whole message, we want a specific property. So if you do full stop, and we'll do contact name. And you can see it's put the variable inside these curly brackets now. If you just use the variable on its own, no need for the brackets. But if you call any of the properties, then you do need the brackets like that. But Kotlin will take care of that for us. So we have hi contact name, we'll do a comma, a line break, and then another line break. You can format this message however you like, or you can copy mine. It's entirely up to you. So my name is $message, full stop, my display name. I'm going to move the cursor outside those brackets. And I am, now this is the point where I would say if I'm junior or not, and it's also the point where I would say which of the 2 job titles. So it could be I am a junior Android engineer, I am an Android engineer, I am a junior Android developer. But there's a slight problem, well, in English anyway, because junior doesn't start with a vowel, but Android engineer does. So if I'm a junior, I would say I am a junior. But if I'm not a junior, I would say, and I am an Android engineer. So we've got a slight English formatting issue here. So I could put a lot of complicated code inside the preview activity. I could do these. If they're junior, say this. If they're not junior, say that. But actually, I think it'll be a lot tidier to do this as a method on our message class. So let's go to our message class now. After serializable, do the curly bracket. So now we have a class body. And let's do a function called fun get full job description, just like that. And then curly brackets. So we can do the if statement and the logical stuff inside here. So let's say if include junior. So if we're including junior in our greeting, we'll do some stuff. Else, if they're not junior, we'll do some other stuff. So if they are junior, then we'll say I am a speech mark, a junior, and then the job title. I am a junior Android engineer. I am a junior Android developer. Otherwise, we just say an Android engineer, an Android developer. Okay, so nice and simple. If they do include junior, a junior Android engineer, a junior Android developer, otherwise an Android engineer. Of course, we need to return a string. So to specify the return type, we do :string afterwards. Okay. And now we're getting an error because we must return something. So we could do return a junior job title, otherwise return the other value. Just auto format that. Now look how clever Kotlin and Android Studio can be. This is saying return should be lifted out of if. So in Kotlin, you can actually return an if statement directly. Let me show you what this means. Do Alt-Enter, Option-Enter, lift return out of if. So do you see, they put the return before the if. So we don't have to type the word return twice, which is great. Let's see if we can clean this up even further. Well, we're actually allowed to put the if all on one line. So let's actually remove this curly bracket, then delete. Okay. Remove this curly bracket, then delete. Remove this curly bracket, then delete. And then remove the final curly bracket, and then auto format. So if you have a very simple one-liner if statement like that, you can put it all on one line. So return if junior this, else that. What else could we do? Well, now the whole function is a one-liner. So from your knowledge of the Kotlin foundations on functions, what could we do? We could make the whole function a function expression. So if you click on return and do Alt-Enter, Option-Enter, you can convert it to an expression body. If I just delete that. Do you see that? So no more curly brackets. We've swapped the curly brackets for an equal sign. And what else could we do with Kotlin? Well, rather than specify string specifically, we can let Kotlin infer that. So how much simpler, clearer, and less typing is Kotlin than Java? We've gone from this, a full block body with 2 returns, all the way to a one-liner. The other thing we should do while we're here is sort out the availability. So let's do another function called getAvailability. And we'll make this equal to, and we'll do another if statement. If it's an immediate start, we'll just say the word immediately. Else, if it's not an immediate start, we can start from the start date. So 2 useful little functions in our message class that will format this nicely for us. Notice how we don't need any curly brackets in this function expression because we have our if statement all on one line. Okay? This will look probably quite new, quite alien to you, but I just thought I'd show you the way that the pros do it, taking advantage of many benefits of Kotlin: function expressions, type inference, an inline if statement, and string templating. Lots of cool Kotlin stuff there. Now we can go back to our preview activity and use these functions. So my name is message.myDisplayName, and I am a message.getFullJobDescription function. We can call that function directly in our string. How cool is that? We'll do a full stop, and let's do the next line. I have a portfolio of apps to demonstrate my technical skills. And remember, guys, you do have a portfolio of apps that is growing with every section. That I can show on request. Let's do a new line. I am able to start a new position, $message, and we'll get the availability. That's going to say either I can start a new position immediately, or I can start a new position from our date. So a full stop. Please get in touch if you have any suitable roles for me. Thanks and best regards. Full stop, and we'll delete the last line. So that's a message that I think is formatted quite well. You are totally free to change this however you would like. You can change that getFullJobDescription method and the getAvailability method. You can do anything you want with the values that we have in our message object, okay? As for this .trim indent that is put at the very end, because this is a string literal, it would put all of these tabs or spaces in to our message, and our message would look really weird. So Android Studio has been quite helpful there. When we did enter on that string literal, it knows we probably don't want to keep the indents in. So it will automatically remove all of these silly indents. Okay? I'm just going to delete that for you. So that should be all we need to do. So now we can set this variable, this message preview text, on our text view. So let's do text view message.text equals our message preview text. And then let's see what this looks like. So let's go ahead and run the app. So I'm going to fill out this form. So the contact name can be Rachel Recruiter. Contact number, the usual, easy to type. My name, Vin Norman. I'll say I am junior. I'll go for Android engineer just for a change. And I'll say immediate start for this example. And preview message. Hi Rachel Recruiter. My name is Vin Norman and I am a junior Android engineer. So that reads nicely. I have a portfolio of apps to demonstrate my technical skills that I can show on request. I am able to start a new position immediately. Please get in touch if you have any suitable roles for me. Thanks and best regards. So in my opinion, that would be a really polite and professional way to introduce myself to a recruiter. And now I've got an app to do it for me automatically. We will do the send message functionality very soon. If I go back and change this form, I'll do it again. Richard Recruiter, Rachel's brother, 07711 223344. My name, I'll do my posh name now, Vincent Norman. I won't include junior. I'll leave it as Android developer. And now I'll do an available from date. I'll say 24th of December, Christmas Eve, 2020. And then I'll do preview message. My name is Vincent Norman and I am an Android developer. So that's formatted nicely. I am able to start a new position from 24th of the 12th, 2020. So that is the bulk of our app working very, very nicely. Not much more now to do to get this fully working. So well done if you've made it to this point. We're nearly there. We're very close to completely finishing the app. The final thing to do will be to use an implicit intent to launch the phone's text messaging app, to launch the SMS app. So there's two more things to do. We need to set up the button click listener for our send message button, and then we need to work out how to use an implicit intent to send this preview text, as well as the message contact number, so we can pre-populate the contact number in the phone's text messaging app. Before we do that though, looking at the code we have so far, the onCreate method is getting quite big. As a rule, best practice, you don't want to be putting lots of logic, lots of code inside the onCreate. It's much better to split it up into small functions. So the first thing we'll do is we'll take everything to do with retrieving the message and setting the preview text. We'll put that into a new function called display message. So the quickest and easy way to do that is select all of these lines after set content view and do Ctrl-Alt-M or Command-Option-M, or you can do right-click, refactor, and then function to extract the function, okay? But I'll do Ctrl-Alt-M, and then we can go ahead and name this new private function you can see it's going to make below. So we'll call it display message. And you see that? It's made a new private function with all of that logic inside it. So now our onCreate method reads a lot better. We set the content view, and then we display the message when this activity is created. Okay? So then the next thing to do will be to make another function where we set up our button. So underneath display message, let's make a new private function. So we'll do private fun setup button, no parameters, and then we'll do our function body with those curly brackets. And then we'll call the function below here, so setup button, and autocomplete. Now we're going to need these two variables, the message preview text and the message. We're going to need these in our setup button function. But we have a problem. They're presently local variables. And if you remember from a long time ago when we first learnt about variable scope, a local variable like these two, they are only visible, they are only accessible within that function or that method body, okay? So we're going to need to make these two variables, the message object and the message preview text string, we're going to need to make them class variables, properties. So let's go to the top of the class, and after the class opening curly bracket, make some line breaks. And for now we'll just do var, because we're going to set it later, and we'll use the same name. So message, that's of type message, and of course we need to initialize this to something. So at this point we'll have no choice but to do a question mark and assign it to null, like that. And we'll go ahead and do the same for the message preview text. So var message preview text, we'll make it of type string, and again we'll make it nullable, then assign it to null. So now we've got two class variables, two fields with the same name. So what we can do is we can delete the local variable. If I just delete the word val, okay, and the same for message preview text, you can see now that here we are setting these two variables. But we've got a slight problem. Now the message object below, it could be nullable. So we get a strange error talking about smart casting and mutable properties, but you can pretty much ignore that warning. The problem is that this now is a nullable variable. See? Message can be nullable. So to be able to use it, we'd have to do a question mark. And you can see when I put the question mark in, it goes away. So we could do that. That is absolutely fine to set a nullable variable, set it in the display message function, and then just every time we access the message variable, just put a question mark, do a safe call. But now's a really good time to introduce a new, better way of handling class variables that we will be eventually setting, and once they're set, they will never be null again. So delete all of these question marks for now, or undo that. So we'll leave those errors exactly as they are. And what we're going to do for the message field and the message preview text field, these two class variables, is another special Kotlin trick. So delete question mark equals null from both of them. So now we have two variables, but we're saying they are non-null, and we're not assigning them. So if you have something like this, a class property, a class field, which you don't want to be null, you don't want to have to keep using the question mark, but you can't assign it at the top, you have to assign it later in our example, we have to assign it after onCreators started. So we can't do anything special here. We have to assign it later. But we know that once we've assigned it, once we eventually set it on a method that will definitely run, our onCreate method and our display message, they will definitely run, then once we've set it, it will never be null again. Well, then you can put the word late init in front of the word var. So start typing in front of var, late init, all one word, all lowercase and then space. So late init does pretty much what it sounds like. We're saying we're going to initialize this later. This is a promise. We are promising Android Studio that even though we haven't assigned it yet in this class property, we will definitely be assigning it later in a method that will definitely run. And we promise Android Studio that we will assign it first and then access it later. And as you can imagine, this is quite a common thing to do. It's not always possible to assign it or initialize it at the point where we declare it at the top of the class. We need onCreate to run to be able to get our intent. But we know that we will definitely be assigning it. So it's like a promise. We promise to initialize this later. So late init var, a variable that's initialized later. And then you can make it non-nullable. So we'll go ahead and do the same for our message preview text. So we'll put the word late init in front of it. We're getting a warning saying that this could be private. Actually, they could both be private. So let's make both of them private. So a private late init variable message and message preview text. Now, just like with our non-null assertion, where we do 2 exclamation marks, we have to be a bit careful. If I delete this line and we've not assigned the message, then this will throw an exception. We've told Android that we will definitely be initializing this later, but we haven't initialized it, yet we're trying to access it. Okay? So a bit like with our double exclamation mark, with our non-null assertion, you have to be a little bit careful with late init that you do definitely initialize it later. So I'm going to go ahead and undo that and put that line back in. But the benefit now is, with a late init variable, we don't have to make it nullable. We don't have to put the question mark or initialize it to null. And as long as we're sure that we definitely assign it, we definitely initialize it later before we access it, that it's absolutely fine and we can use it without the question mark. And the other benefit is we can now use this in our setup button method, because these are now class variables. They are properties. Okay? So let's go ahead and quickly make our button click listener. So type the word button, and it's our send message button, and we'll do .set on click listener, and then that automatically puts in the curly brackets for us. And inside here, I'll put a quick comment. We can do our send message intent. Okay, and we'll do this now in the next tutorial. The final bit of functionality that our app needs to be feature complete is for the send message button to open up the phone's text messaging app, or the SMS app. So when they click the send message button, it passes through our preview text as well as the message contact number to the text messaging app. So if you remember from a long time ago, in our restaurant app, we use what's called an implicit intent, rather than an explicit intent where we specify which activity to open. We instead specify an action, something we want to do, and then the phone will look through all of the apps and see if any of the apps can fulfill that action. Previously we did this for an email action. Now we need to find out the way to do it for a text message, or an SMS as it's known. So I'm going to head over to my browser and I'm going to search for Android Common Intents and then search. And then we want this top one, developer.android.com guide, Common Intents. And this is our big long page with all of the different actions that we can do. Okay, there's lots and lots of stuff here. Let's just recap though what an implicit intent is. So an intent allows you to start an activity in another app by describing a simple action you'd like to perform. This type of intent is called an implicit intent because it does not specify the app component to start, the activity, but instead it specifies an action and then provides some data with which to perform that action. So this is our implicit intent, and on the right hand side in the page contents we have all these different actions we can start, from alarm clocks and calendars. Before we did the email action, and the one we need to find is for text messaging, which is at the bottom there. So compose an SMS or an MMS with an attachment if needs be. So click on text messaging. So in the text messaging section we can see to initiate an SMS, that's a text message, or an MMS, that's a multimedia message, use one of the intent actions below. and then pass some details through. So if we scroll down, we have a couple of examples, okay? But just looking at the very top, we see we can use action send to, action send, and action send multiple. And I'll be the first to admit that the documentation isn't very clear on the differences here. So let me give you a tip. In my experience, it's always best to use the action send to rather than the other two, unless you want to send it to multiple people, of course. So do use the action send to. If you use the send to action, you then need to specify one of these data types, SMS2, MMS2, okay? So use send to, and then specify whether it's an SMS message or an email message or whatever kind of message, okay? I'll go through this in more detail when we go back to our project and copy the code in. So we use send to, and then we have this as the data. If we scroll down now, there's a couple of examples here. They're in a function called compose MMS message for a multimedia message, so we won't be using the attachment for the picture, okay? But we will have the SMS body. If you look at the second example, it says, if you want to ensure that your intent is handled only by a text messaging app, and not, say, by an email or a social media app, then we want to use the send to action and then include the SMS2 data scheme. And then if we look below, we have the example there. They have it in both Java and in Kotlin, which is really good. So you can choose which language. Obviously, we're now using Kotlin. Now, when I look at their example, the example actually looks a little bit wrong. They're using the intent action send, okay, but they should be using this send to action. So don't worry about this example code. We'll copy it and then change it to work for us. So what I'd like you to copy now is not the whole function, as we're going to be putting this inside our button click listener. And don't bother with this if statement with the resolve activity thing. We don't care about that. Just copy this intent block. So val intent equals, and then both the curly braces stopping just before the if statement. So go ahead and copy that, and then we'll go back to our project. So we'll replace the comment with this new code. So paste. Now we've got a few errors because we need to import all of these new classes. So if I click on any of the red errors, we get the little underline. I can do Alt Enter or Option Enter, and I can import that. So that brings in all the intent stuff. And we're going to need this weird URI thing. So click on that, Alt Enter, Option Enter, and import that. And we can delete this attachment line as we're not going to be sending a picture. We're not going to be sending a multimedia message. So let's go ahead and delete this. So the first thing I'd like you to do is change this to action send to. In my experience, there is a subtle difference between the two things, but it's hard to explain. But by using send to, along with this data SMS to, it's a lot better for ensuring it opens the right kind of app. Okay, action send is a bit more vague, but action send to, we can specify this SMS to thing to guarantee we'll open our text messaging app, and we can pass through the number as well. Now, if you look after our new intent object here, we have a dot apply and then some brackets. Now this is a new special Kotlin thing that we haven't covered yet. It's the equivalent of doing this. I'm just going to show you this. You don't need to copy this. I'm going to make another intent called intent to. I'll do the intent action send to, and I'll stop there. Okay. Then I can set properties and methods on this variable. I can do intent to dot data and do the same thing. I can do intent to dot put extra. Okay. So this apply block, which I will cover in a later section, is a fancy Kotlin trick to stop you having to keep calling the same variable, intent to dot data, intent to dot put extra, intent to dot this, intent to dot that. If you're going to be calling the same variable over and over again, in Kotlin there is this trick where you can use this apply block. Don't worry about that for now. We will leave their example code. So I'll just delete my example below. Okay. I just didn't want you to see something new and be confused by it. So this is the same as saying intent.data, intent.putExtra. So we can delete the comment saying that this ensures only SMS apps respond. So we'll delete that. And after SMS2, we will pass in our message contact number. So we can use string templating, do $, message, and then do dot, and we'll do the contact number. So what this will do is it will include in this URI.parse, in this URI string that you can see there, it will include SMS2 and then the mobile phone number of the person we want to contact. And what that will do is when we go through to our text messaging application, it will pre-populate their number, which will be a better experience for our users of our app. Okay, And the final thing we do, just like a normal intent, we put in this extra bit of data. The name is SMS body. It must be exactly this, okay? And then we pass through what should be our message string. Now at the moment, our message is our custom object. It's not a string. So what we really want is this message preview text. We want to copy this through, okay? So go ahead and change the message object for message preview text. And that is our intent done. So now we can do start activity and do the intent. And that is all we need to do. So to recap what we've done there, we make a new intent object. Rather than specifying this screen and then a specific activity, we instead do an action, send to. This is an implicit intent. So Android will look on the phone and see any app that can handle action send to with this type of data, SMS to, okay? We got this bit of code from the documentation. We don't need to remember this or memorize this, okay? But what this will do is it will ensure that only a text messaging app can respond because we have SMS to. And then we put in the intent, we put in our letter, that extra bit of data. We give it the name of SMS body because our text messaging app knows how to receive this kind of thing. And we give it our message preview text. So that's our special implicit intent to open up a text messaging app. And then we simply start activity. So let's go ahead now and run this app to confirm that this works as expected. So run. So let's now fill out this form properly. So this can be Edward employer, and their number can be my special. So my name, I'll go for Vin Norman. I'll say that I am a junior. I refer to myself as an Android engineer. And I will not do immediate start. I'll say I can start from Christmas Eve, why not? 24/12/2020. Okay, so I'll preview the message. That looks pretty good to me. So now when I click send message, the phone jumps to the phone's text messaging app. It automatically includes their contact number at the top, which is fantastic. So conversation with 07711. And if I just click and drag up here, I have the whole message ready to send. So that is our app now complete, working as it should. We'll do a couple more tutorials after this where we clean some things up, get rid of some warnings, and make our app as professional as possible. But the app now works as it's supposed to, and you could install this on your phone and start using this yourself to promote yourself if you wanted to. So very well done if you've got to this point. Okay, let's move on. We're getting towards the end of this section. We've got the bulk of our app working nicely. So now's a good time to try and tidy up a few of the last warnings and errors and small fixes to make our project as good as possible. I'm now in the activity_main.xml layout file, if you can go ahead and do the same. And if we look at this file, if we scroll up and down, and in particular if we look to the right where the scroll bar is, we can see there's these little yellow lines, and each of these yellow lines correspond to one of these warnings that are inside our layout file. So as you can see, pretty much anywhere where we've typed a hint, or anywhere where we've typed text, like in our checkboxes, we're getting a warning. And we can click on these little horizontal lines to jump to a warning. Okay, so when I hover over this warning, it says, hard-coded string contact name should use string resource. Now we've been seeing this warning all course pretty much. It's not a problem, it's not going to affect the performance of your app, but it's not best practice. So this thing of actually typing in the words we want to use in the file, whether that's typing in our text values in these layout files, or if it's setting text in our activity classes in our code, this is called hard coding. We're typing in the value as we want it to appear exactly where we set it. Now in a small project like ours, it's not too much of a problem. We've probably only got about 10-15 times where we're typing strings or typing hints or setting text on our checkboxes. We don't have too many. But there's two big reasons why later on this can become a bit of a problem. The first is consistency. Take a look here where we say contact name. Well, in a larger app, we might use the words contact name multiple times. We might have it as a hint for a field. We might have it on a contact details page. We might use these words, contact name, over and over again. So we could type it in each place that we need it. But then later on we decide, actually, I don't want it to say contact name anymore. I just want it to say name. Well, then you've got to remember every single place in your code where you used the words contact name and then change them. And then of course you might forget one or two, and then your app starts to breed inconsistency. So consistency is the first reason why it's not a good idea to hard code these strings, as it's warning us. There's another reason which we'll cover in the next tutorial to do with localization. This is the way of using different strings for different languages. And these two reasons, consistency and the ability to cater for multiple languages, depending on what language the user has on their phone, these are two pretty strong reasons why we shouldn't ever really hard code our strings. So there's a way we can actually store these outside of our code as a resource. So go ahead and open up the project pane on the left, and I'm going to start with all the folders closed to show you exactly where these string resources are kept. So in our project, open up the top folder, and it's our app as normal. It's our app source code, it's our main source code, and it's not Java code, it's a resource. So open up the resource folder. Now so far we've only looked at layout resources. In fact, this activity_main.xml, this is a layout resource, and this layout file would be kept in the layout folder. We may have seen our drawable folders when we were playing around with images. We'll ignore the mip-map folders for now, but the final folder to note is this one called values. So if you go ahead now and open up the values folder, and you can see we have three different resource files already there: colors, strings, and styles. So let's go ahead now and double click the strings.xml and see what we have. We have what looks like a very simple XML file with one top element, resources, and inside this resources tag we have a singular element called string, all with lowercase. And this string has one attribute called name, and that name equals app_name. So there's a few places that our app uses their app name. It's used in the phone's app drawer underneath the icon to show the name of the app, and it's also used by default as the label for the toolbar. So rather than hard coding these values, instead they store the string once here with the name app name, and then if I jump over to the manifest now, manifest, and I click where it says in grey the Shameless Self Promo app, that's actually a shortcut to this string resource, @string/app name. It's possible to manually type the app name here. That's okay, but better is to store it centrally in this strings.xml file. So I'm just going to close the manifest down for now. So we can make strings that we define in this file, and then we can refer to them in our layout files or in our Java or Kotlin code. And we can refer to the same string resource multiple times if it's used in multiple places, and this makes it a lot better for consistency. And also it gets us set up for the next tutorial where we can start to handle localization, which means handling other languages. So let's go back now to our activity_main, and we can see here we have a hint called contact name. So rather than typing it manually here, let's create a string resource in that strings.xml file which has the same value. So underneath this first string, let's make a new tag, do lowercase s for string autocomplete. Autocompleting populates the name attribute automatically, and we'll call the string hint_contact name. And then if we move to the right and do a right arrow, that gives us our closing tag. And inside these tags now, we can type our string. No speech marks, just type the raw value, so contact name, just like that. Now, if I jump back to activity_main, I can delete contact name, leave the speech marks, but now we're going to refer to a resource. So do the @ symbol and then do the word string. And it gives us a few values we can choose here, but if we do / and then we can type the name of our string. So our string was called hint_contact name. So we can go ahead and autocomplete that. And now we're referring to this string resource. And we can actually get the layout file to show us what this value is. If you click on the string name, and on Windows you can do Control and then the minus key next to 0, or on Mac it's Command and the minus key next to 0. And doing that will turn it grey, which is showing you the value of the resource. And then to see what the actual resource is, you click on it again to expand that. So all we've done is we've moved that value from being hard-coded in the file into our strings resources file. So let's go ahead now and do the same for contact number. So I'm going to duplicate this line, Control D, Command D, and I'll change this to contact number. And then I'm going to change that to contact number. And then I'm going to jump back to the activity underscore main, delete the contact number value, the hard-coded value, and do @string / hint, and then select contact number. And I can do Control- or Command- if I want to see what that value is. Okay? There's another way to convert a hard-coded string in our layout files to a string resource. If we go to the next error, which is my display name, and click in the middle of the warning. Now, if you click the light bulb or you do Alt-Enter, Option-Enter, there's an option to extract string resource. This can be a very quick and easy way to convert those hard-coded warnings into values. Press Enter, and we can give it a name, so we'll call it hint_my_name. The resource name doesn't need to match the value that we show the users. The resource name is something identifiable for us. So there's no standard convention here. It does need to be lowercase separated with underscores, so snake case. But in terms of how you name it, that's entirely up to you. I like to go with how it's used and then a description. So we're using this as a hint. So I start with the word hint and then do an underscore and then something that's familiar to me. And my name works for me. So for a button, I might have button_submit or button_preview. Okay? You can use whatever resource names work for you. Do though try to keep it in lowercase with underscores, snake case. And by default, by using that extract string resource suggestion, it pulls through the value that we had hard-coded. So I can just press OK now. And if I go to strings, I can see it's put that in for us automatically. So for the rest of these hard-coded values, I'm going to go to each one and I'm going to do Option-Enter, Alt-Enter and extract them. So this is checkbox text and it's include junior. And this one, extract, also checkbox text, and this is immediate start. Then we're back to our hints again. So extract string resource, hint, available from. And the last thing is our button. So Alt-Enter, Option-Enter, extract string resource. So this is a button, text, and it's our preview button. Okay, and if I jump now to our strings file, I can see all of those resources created here. Okay, so if we now go back to this file and look at our scroll bar on the right, we have no more warnings. And in fact, at the very top right, we have a green tick that says no problems found when we click it. We've now fixed all of the warnings in this layout file. If I just click the target to go to the layout folder, I'm going to do the same thing in the activity_preview. If I look on the right, we've only got one warning. It's for our send message button. So I'm going to do this one manually. Just for practice, I'll do string button text, and it's our send button. And that said send message. So now back in activity_preview, I can delete the hard-coded value, do @string / button, and then select the button text send string resource. And if I click outside the button, I get the magic green tick to say no more problems found in this file. So that's an introduction to the strings resource file. So best practice in your layout files, don't hard code type the value, create a string resource just like this, and then refer to it with @string and the name of your resource. Okay? In the last tutorial, we took a first look at our strings.xml file to create string resources. We learned that in this XML file, we can put a string element inside a resources tag, and that creates a string resource, which we can then refer to both in our XML and later on we'll see in our Java or Kotlin code. The two reasons why we should always do this when handling strings in Android is one, for consistency, but the second big reason to use a string resource, to use this strings.xml file, is for a thing called localization. If I just head over to my browser now, and if I type Android localization and enter, and hopefully towards the top you'll see developer.android.com topics resources localization, and it says localize your app. So if you can go ahead and click this, and just reading through the description, Android runs on many devices in many regions. To reach the most users, your app should handle text, audio files, numbers, etc. in ways appropriate to the locales where your app is used. So this includes things like languages for your strings, for your text, okay? Now there's a very specific way to do this. If I just click on the right where it says using resources for localization, and we'll scroll down to there. So it says we put the app's default text in our res/values/strings.xml. If I just jump back to Android Studio. So by default, we use this regular values folder, just like that. And anything we put in here, by default, the app will use the resources in this file, in this folder, okay? If I jump back to the browser. So we should put the text strings in our default language. So the language we expect most of our app's users to speak, which in many cases will be English. It may not be, depending on where in the world you want to launch your app, okay? Now if we scroll down, it says how to create alternative resources. So in the res folder, we can do res / and then a qualifier. So we use values by default, you see there, but we can add a suffix to the word values for a specific language. So we can have a folder called values-fr, and that's where we put all of our French strings, all our French resources. Values-ja for Japanese. And there is a specific list of accepted qualifiers. You can't just call it what you want. It has to be values-fr for French, okay? And they've got a link to that on this page. So what I'll do to show you what this is and how it works, we'll make a couple of strings now that will handle the French language. So if I go back now to Android Studio, so I'll close the layout folder and I'm going to click on the res folder. By default, our app will use all of our values inside the values folder. But let's now make a folder that will handle the values for the French language. So right click where it says res and do new directory. And we'll call this one values-fr. And it must be exactly like this. So values-fr, all lowercase. And you can see now we have a folder underneath the word values. And I'm going to right click on this folder and do new value resource file. And I'm going to make another strings.xml. In reality, you can actually call the strings file whatever you want. You can have multiple files if you want to group them. It doesn't really matter as long as all of these string elements here are inside a resources tag. But by convention, we call it strings.xml. And if I expand the folder, we can see we have strings.xml in our French folder. So now in here, I can provide specific string values for the French language. So I'll do new tag string, and I'll just pick one for now. I'll pick the contact name, and it's important that I name this exactly the same. So hint underscore contact underscore name, and then the right arrow, and now I have a space to type contact name. So in French, this would be nom du contact. Okay? Now, if I go ahead and run this app on the emulator, and we look at the field, contact name, we can see nothing changes. And that's because this phone is set to English. But if this phone then changes its language, I'll just go into the settings, I'll type language, language as an input, and then languages, English. I'll then change this to French by dragging that to number 1. Well, you can see at the top, even in the settings app, languages has changed into French there, and all of the other text in this app. So they're using string resources correctly. And then if I go to my task switcher and then go back to our app, you can see the name changes to nom du contact. Okay? So if you want an app which handles multiple languages, you must use these string resources as the way to achieve this. If I go back to our default values/strings file, you can see we've got some warnings or errors, and it's saying that these strings haven't been translated in French. So Android Studio is assuming that this is a mistake, that we've missed some of our translations. It's not an error that will stop your app from running, so actually we could ignore this, or you can do Alt-Enter and you can mark the string as non-translatable. And as you can see, it gives you a translatable attribute that is false, and the error goes away. You don't have to do this, but I hate having layout fails or programming code which have errors in them. So let's go ahead now and translate our app name into French as well. So I'll go above here and I'll do string app underscore name, and shameless self-promo in French I believe is autopromotion sans vergogne, just like that. Apologies to any French-speaking students for my appalling pronunciation there, but autopromotion sans vergogne, self-promotion without the shame, or shameless self-promo, okay? And then if I go ahead and run the app, you can see we have autopromotion sans vergogne as the app title, and then nom du contact as our first field. The rest of them, because we didn't provide a translation, it goes to the default, which is in the values/strings file. And if I close the app and go to the app drawer, you can see as well the app has even changed in the app drawer. Autopromotion, you can see there. Okay. If I then change the phone language back to English, and then go back, you can see the app goes back to its original name, the Shameless Self-Promo app, and when I open it, all the fields turn back to English. So you are free at this point if you want to continue and translate the rest of these strings to French. I'm actually going to delete the French file for now, as it's not really the purpose of this app to handle it in multiple languages. But you are now free if you want to translate this into Spanish or French or whatever language you like. You'll have to check the Android documentation for what folder name, if it's a different language to French. Okay, so I'm going to go ahead and delete the whole folder. So right click, delete, then all those warnings go away. So that is localization in Android and how to provide specific resources, specific strings for a specific language. As I mentioned in the previous tutorial, my recommendation to you is anywhere you use a string, if that string is something that your user will see, then put it as a string resource. Okay, let's move on. We've pretty much finished the app for this section, our Shameless Self-Promo app. The app works as expected. It previews the message, it sends it through to our text messaging app, and we've even fixed those hard-coded string errors that we saw in the previous two sections. There's just one final thing that would be really nice to do in our app to give it a bit more personal style, and that is to change some of these default colors. As you can see, every single one of our apps so far has had the same default theme colors. A light purple for the toolbar, where the app title is, a darker purple for the status bar, where our network signal and time is, and then this green accent color for our buttons, or for our checkboxes, or for when we're selecting a text input edit text. You can see the same green there. Okay, so we're going to see where these default theme colors are set. We're going to see how to change them. So we're going to have a first look now at the two files that help control our app theme and also our app's colors. Okay, so I'm going to minimize the emulator. So I'm in Android Studio with all the files closed and the project pane open with the top level project folder closed. As a little mini test for yourself, see if now you could navigate to where the strings.xml file is located from the previous two tutorials. Remember, it's in that values folder in the res folder. Okay, so see if you can pause the video and get there yourself. If you can't do that, then follow along with me. So we open up the project folder. It's in our app, source files like normal, the main source files, and it's not Java or Kotlin code, it's a resource. So we open up the resources folder, the res folder, and at the very bottom we have values. And in there we have our strings.xml file, but we also have two other files, styles.xml and colors.xml. So let's go through these one by one. Can you double click the styles.xml file first? When you make a new project in Android Studio, by default it will give you this base application theme. You can see it here in the comment. It will give you the styles.xml file and it will make a style resource. If you look, we have the same resources tag that our strings.xml had. Okay, so inside that same resources element, but this time it's not a string element, it's a style element. Okay, and in this style element we have a name attribute, which is the name of this style, and by default it calls it app theme, but we can change this. This could be your app theme name if you wanted. I'm going to leave it as the default app theme though for now. And quite importantly, it has a parent. So much like with our Java and Kotlin classes with inheritance, where you can have a parent class, styles can have a parent style. So you can see we have this parent and then this kind of long theme.appcompat.light.dark action bar. Leave this exactly as is for now. This is a standard base template theme which gives us lots of goodies and lots of nice looking things and the right toolbar text color, the right background color. Okay, so don't change this, don't delete this for now or things won't work as you expect. But then inside this style element that we've called app theme, we have the space to customize the theme. You can see there's a little comment there saying we can customize the theme here. And each customization is in an attribute called item. Okay, so item name equals, and these names, they can't just be anything. You can't make this up. Okay, it must be a specific item name in the whole Android theme system. Okay, so the Android theme knows what color primary is. It knows what color primary dark is, and it knows what color accent is. In fact, if I just load up the emulator to the side of this, so color primary in the Android theme system, amongst other things, that will control the toolbar color, where you see the app text, the app title. Okay, the color primary dark, that will control the status bar, where our network symbols and notifications are. And then the accent color will be used for any of the widgets that can have a selected state like edit texts and our checkboxes, and it will also be used for the background of things like buttons and other widgets. So going back to Android Studio now, we define a new style name here. We leave the default extending from this parent, this base theme in Android, and inside this style element, that's where we can put our customizations by selecting specific items by name, and the names do need to match, and then we can start to control and customize the theme. Okay. Before I show you how quick and easy it's going to be to change these simple theme colors, I want to show you the one place where this theme, this app theme, is used at the moment. So if you can head over to the manifest, either in the folders to the left, or you can do Shift Android manifest and autocomplete. So in our manifest file, you can see we have the application element. Yeah. And in the attributes, we have at the very bottom, Android:theme, and that equals a style resource. You can see we have the @ symbol, meaning it's a resource. So @style / and then the name of our theme. And if you decide to change the name from the default app theme, then it would need to match here. Okay, I'm going to leave mine as the default app theme for now. So by applying this theme here in the manifest, these styles, those colors, all of the nice looking user interface touches that come with that parent theme, it will be applied throughout the application on every activity. Later on, you'll learn it's possible to apply themes to specific activities. So you could have a different style, a different theme for each individual screen. And later on, you'll see you can even do this for individual views, individual widgets. You could have a button following a specific theme. Okay. For now, though, we'll leave it as the theme for our entire application. So we'll have the same primary and primary dark and accent color for all screens in our app. Okay. So I'm going to close down the manifest now. So you can see in these items, it's referring to another resource, @color, a color resource. Okay. It is actually possible within these item tags to hard code a color. You could do hash and you could do red. That's perfectly acceptable. There's no warning, no errors there. But much like with our strings, it is best practice to extract your colors to a color resource, to not hard code them. For the same reason, really, if you have a red color that you are using in multiple places, but then later on you decide to change it ever so slightly, well, rather than having to remember everywhere you used that red color, you can instead change the resource. So I'm going to undo this and leave our color primary resource. So maybe you can guess where these color resources are located. If you look left, you can see we have a colors.xml file. Or of course you could control click or command click to jump to this. So I'm going to open the colors.xml file to the left. And we have another resources element. And inside this element, we don't have strings, we don't have styles, we now have colors. Okay. And again, these color names can be called whatever you want. It could be my primary color, or you could call it my simple purple, or you could simply call it red. Okay, so you can name these however you would like. Again, I'm going to leave them as the default because color primary dark, these make sense to me. But what I am going to do now is I'm going to change these color values to something that I like a bit better rather than these purples and greens. And the quick and easy way that I'm going to do that is by clicking on the preview color, this little square you can see there. That brings up our color picker. And I could adjust the slider and choose a color and drag it around. I could do that. You can see it changes the hexadecimal code to the right. Yeah. But instead, I'm going to choose some default colors from these color palettes you see at the bottom. So this says material A200, material accent 200. So I'm going to choose not an accent color for the primary color, but I'm going to choose a simple material 400. That's a nice simple non-accent color. And I'll choose a blue this time, a nice royal blue. So I'll go for that color there. You can see that changes the hexadecimal code. Then I will click off, and then I'll choose the primary dark color. And I'll do a much darker version now. I'll do material 800. And I'll choose this darker version of the same blue. Okay. And then for the color accent, I'll choose something that contrasts with blue a bit better than green. I don't think blue and green go that well together. And I'll choose it from the material accent color palette. Remember, material design, Google's really famous and popular design specification. By choosing colors from their color palettes, you'll get some nice mixes, some colors that work well together. And I think I'll choose a red, an accent red color. And I'll click off. Actually, I think the primary color is a bit light, so I'm going to choose that and change it to material 500, not 400. Okay, that looks a bit better to me. So, jumping back to our styles.xml, we're referring to 3 items in our theme, the color primary dark, and the color accent. And in turn, these values are color resources found in our colors.xml file, okay? So if you go ahead now and run the app, and you can see we now have a nice blue color for our toolbar, a darker blue color for the status bar, and then a nice red accent color, which will be both for our buttons, for our checkboxes, and also the highlight when we select our edit texts, as you can see. So feel free to change those colors to whatever you think looks good. So now you know a quick and easy way to change your app's theme by using styles.xml, and you also know how easy it is to change those simple theme colors, primary dark, and the accent color. So that completes our Kotlin section. Our app is now fully complete. Well done for getting through all of this. It's been a big section. We've made the big jump to Kotlin. And from this point in the course, we will be working pretty much entirely in Kotlin from this point forward. It's time for our next challenge, building forms. As a mobile application developer, the ability to build forms, that is pages with input fields to gather data, this is such a fundamental and core skill to being a mobile application developer. Whether that's a login screen, registration form, adding a new contact, it's likely in your career making Android apps that you're going to need to build a form. So this challenge is all about the process of building forms in Android. So thinking back to our previous section, the things that we want to achieve in this challenge are as follows. We want to create a registration form for a new user. So we're going to apply our skills from the previous section where we made the shameless self-promo app, and we're going to apply this to creating a registration form when a user creates a new account. This is quite a common thing when making a mobile application. To give you an example about what I mean, if you look in the top right there, we have a login form, a registration form, okay? That's just an example I found on the internet. We're going to have a go in this challenge at making our own registration form, a bit like the one you see on the right, although you are free to use whatever colors you would like, okay? In this challenge, we also want to be able to pass the user details from that registration form to a summary screen. So this will give us a chance to practice creating a data object, a data class, and then sending that through to another activity. We want to do the whole challenge in Kotlin, and then using some of those new Android widgets, those new views that we learnt, we want to use a text input layout and also a spinner as part of our registration form. So that's the 4 main things we want to achieve in this challenge. So the scenario. Imagine this is for a startup company's brand new app that they're making. You have accepted a job working as the sole Android engineer at a brand new startup company. This is quite a realistic scenario. There's lots of great job opportunities for small, grassroots companies that are just getting started. And if you were to accept a job in one of these companies, it's likely that you would be the only Android engineer. You would be solely responsible from taking the idea from a concept through to an actual prototype. Okay? So they want you to build their app from scratch, and the first task is to allow users to register from the app. It's quite probable that if they're making a new app, a new idea, there would be some kind of login for this app, so a registration form might be a pretty good place to start. Before connecting the app to the web, they want a prototype of a registration form, and then a summary page prior to registering. So we're not going to worry about the process of passing that to the internet and creating the account. All we want to do in this scenario is make a prototype registration form and also then the confirmation, the summary page, which will give us a chance to practice passing our data from activity to activity. Okay? So finally, the acceptance criteria. It is done when there is a user registration screen with a drop-down, that's a spinner, for a title, and input fields for first name, last name, email, phone, and password. So you can lay out this form however you want, but we do want those fields on our registration form. Clicking a button on this registration screen moves to a summary screen displaying the user's details. So we're going to have two activities in this challenge, a registration page and a summary page. The user's email address and phone number on the summary screen are clickable, and clicking them launches the relevant app on the phone. So just for a bit of practice, we're going to have a go at using two of the implicit intents that we've been using in this course so far. One intent to move to the email app on the phone, like Gmail, and another intent to either move to the text messaging app or possibly even to launch the phone dialer, the phone app, so they can make a phone call from that number. Okay? So that's the challenge. There's no criteria specifying what this form looks like, so you can go online, look at some examples, find some apps with registration forms that you like the look of. You're free to lay this out however you want. We do want a spinner, a drop-down for the title, and we want to be using text input layouts, text input edit texts for the fields, so first name, last name, email, phone, and password. So make a new project in Kotlin, get started on your own, give this a go. If you get stuck, then in the following tutorials we'll have a code along of my approach to making a registration form and a summary screen. So good luck, and I'll see you in the solution. This is now my solution to making a registration form app with a registration page and a summary page. I'm in the Welcome to Android Studio dialog. I'm going to click Create New Project, Empty Activity, then Next. I'm going to change the name. Now feel free in your example to have used a fictional startup company app name, but just so I can recognize this in my portfolio, I'm going to call it the registration form app, just so I know what it is. Package name com.vinnorman. The name of the app, that's fine, and the save location is fine. I'm making sure the language is on Kotlin for this challenge. Minimum SDK API 21 Lollipop. I highly recommend this, don't do anything earlier. And then we can click Finish. Okay, and Android Studio seems to have finished loading. I'm going to do the usual things that I do when I make a new project. I'm going to change the project pane view from Android to Project and just drag it over a little bit like that, as well as opening the top folder, the project folder. Very good. So this app is going to have two activities, the registration form and then the summary activity. So what I'll do is I'll do the registration form in main activity. I won't bother renaming this, it's fine just leaving it as main activity. In fact, I always like having a main activity in my apps, whether at work or my personal projects, as that reminds me which activity is the one which starts when the app starts. So the first thing I want to do is flesh out the main activity, the registration form layout, just to get the widgets and the views on the screen so I can start using them in the code. So I'm going to move over to the activity_main, and I'm going to change it to split view, and I'm going to get to work. So the first thing I'm going to do is delete the constraint layout completely, like that. Now, if there's any chance that the contents might be taller than the height of the screen, then get into the habit of always starting your view with a scroll view. And then if there are any phones where the content doesn't fit on the page, then they've got that scrolling function. We've got quite a few fields here, title, first name, last name, etc. So there's a good chance on some phones this might be too high for the phone. So I'm going to start with a scroll view, and I'm going to go ahead and put in the layout height, make it match parent, and then layout width, and make that match parent. So with scroll views, always make it match parent, make the scroll view container fill the screen, and then the contents can be bigger than the screen if necessary. I'm just going to drag this over a little bit so I've got more width. That's better. And I'm going to change the self-closing tag into a normal opening and closing tag with a right arrow, like that. Good. So the view group, the container I'm going to use for all the contents, I'm going to use a linear layout. So linear layout, this will be match parent for the width, but wrap content for the height. It's this that will make the scroll view work as expected. I'm going to set the orientation to vertical, and this should be absolutely fine for our screen contents. Now, in previous tutorials, you might have seen me doing some styling and formatting and padding and whatnot pretty much when I make the layout. This tends to not be the way that I work normally for either my personal projects or when I'm at work. What I usually do is I get all the elements that I need on the screen. I don't style it. I don't bother if it looks terrible or looks boring or not complete. I just get all the elements that I need. Then I go and do the programming. Then I go and make it work, make it functional. And then once the app works and functions as expected, then I go back to the layout and put the finishing touches. You're free to work whichever way works best for you. I just find that sometimes we can get bogged down in trying to make it look perfect before it even does anything. So in this solution, I'm going to show you the way that I normally work myself on my own projects and when I'm at work. So the first thing I want at the top is something that says this is the registration page. So I'll just get a text view. I'll make it match parent and wrap content like I do for most of my text views. I won't need an ID for this text view as I'm in a linear layout. I'm not using relative layout, so I don't need the ID to make any of the views relative to this view. And also I won't be changing any of this from the programming code. So before you give all your elements, all your widgets an ID, just take a moment to think if you actually need an ID. And in this case, I don't. I'm going to set the text with Android text. For now, I'm going to hard code the string. So I'll say this is register, but later on I will look to extract these strings to my strings.xml file, as that's best practice. So I'll leave that for now, just getting all the elements on the screen. So the next thing I want is a spinner, a drop down for the title. So I'll do spinner, that comes by default in Android. I'll make it match parent, and I'll make it wrap content, and then I'll do a backslash. Now, looking on the right, I can't see that spinner because it doesn't have a layout. Remember, for spinners, we need to create a simple adapter, then set the adapter. So what we can do, a bit like with our recycler view, is we can do tools, selecting that and pressing Alt Enter or Option Enter to import tools. And I can do list item, just like in our recycler view. So if I do something from the Android default layout, I'll do Android layout, and I'll do simple list item 1. And then if I look to the right, I can see the spinner is in the layout. That just makes it a bit easier for me to see what's going on. So I will need to give the spinner an ID. So we'll do ID spinner title. So now we need to move on to our input fields for our first name, last name, email, and so on. So we could use an edit text for this, but actually, as part of the challenge, we want to be using the text input layout. That better user interface, that better user experience for having the hint and the input field combined. Now, I've upgraded to a more recent version of Android Studio, and on recent versions of Android Studio, when you make a new project, you do get the Google material dependency when you make new projects by default. If I just show you that by going to the app folder on the left, and the app build.gradle file, not the project one, but the app one. And if I scroll down, you can see here, line 40, we are adding the material dependency. So if in your build.gradle file you don't have this line, then you can go ahead and copy this as on my screen, or you can do a Google search and Google Android material dependency, okay? But to use text input layouts, they don't come by default in the app.compat library, the default library we always get, okay? You do need this material dependency. So just make sure you've got this line, and then if you haven't, add it and click sync or click the elephant. And once you have this line and you have synced the Gradle file, you can go back to the main layout and you can start typing the text input layout and autocomplete, okay? And then we do match parent and wrap content, a bit like our text views. And I'm going to do a normal opening and closing tag like that. And then inside this, I'm going to put a text input edit text, match parent wrap content, and I'm going to give it a hint. So hint will be first name, and then self-closing tag. Okay. I'm not going to give this text input edit text an ID just now, because to save a bit of time, I'm going to copy and paste this for all of the fields that we want. So I'm going to select the whole text input layout, this whole block here, Control C, Command C. I'm going to copy that, then underneath it, I'm going to paste it for each field. So we have first name, last name, enter, enter, email, enter, enter, phone number, enter, enter, and then password. And now I'm going to go back and change the hints and also add IDs to each of the edit texts. So starting with first name, I'm going to add an ID. This can be our edit text first name. I do normally make the ID, the start of it, match the type of view. So really I could do text input edit text. And this is considered good practice to start with a type of view followed by something unique like first name. However, because I pretty much only use text input edit texts, I don't use edit texts anymore, I do this myself as a shortcut. I just call them edit text underscore first name. Okay. It is a really good habit though to start your XML IDs with the type of view that it is. It makes it a lot easier to find it when we're working with it in our programming code. So edit text first name, I'm going to copy this line to speed things up later. So next it's our last name, and I'm going to change this error to edit text last name. Then it's our email, and I'm going to change this to edit text email. Then it's our phone number. I'm just going to do NO dot for short, NO. Give it an ID of phone number, or even just phone will be fine. And then we have our password. And then ID, edit text password. Okay, so if I look on the right, it looks terrible, but I've got all the things that I need. The heading that says register, the drop down for title says item 1 just now, but don't worry about that. Then first name, last name, email, phone number, password. So the last thing that I need is a button. And as we're using this google.android.material library, rather than using a regular button like this, I'm actually going to use the materials material button. So if you type capital M for material and capital B for button, then autocomplete, that uses the material button from the material library. Works exactly the same as a normal button, but in my opinion it looks just a little bit nicer. There's a couple of little visual touches, and later on when we look at our styles or our themes, when we use some of these material styles and material themes, this button will play a little bit nicer with those themes than the default Android button, if that makes sense. So width I'll say match parent, and then height wrap content, and then text we'll say create account, and then a self-closing tag, and I'm going to give the button an ID, so ID button underscore create underscore account. Okay, that is all the things that we need. I said I wouldn't style the form now, and I won't, but I do just want to put some padding on the linear layout, as I hate that look with all the things right to the edges. So I will just give it some padding, something quite big like 36 dp. Okay. Yes, the items need styling. Yes, they need some margin in between them, but I've got everything that I need in the layout file. So I'm ready now to move over to main activity and start the programming for this screen. So we'll look at that in the next tutorial. Now we have all the items that we need in our layout, and we've given IDs to the ones that need them. We can move over to main activity and start making the registration functionality work. So I'm going to close down activity underscore main and the build file to just leave my main activity. So I'm going to put the onCreate method in a bit of space. And there's a couple of things we need to do in this registration form. We need to set up a spinner. So I'm going to type a function that doesn't exist yet called setup spinner. That's our drop down. I'll leave the error for now. We also need to set up the button click listener. So I'll just call this setup button for now. Remember, it's a really good practice to not dump all of your code in onCreate, but instead extract the bits of setup that you're doing into their own functions. It just makes the onCreate method look a lot cleaner, and if we get a crash, if we have to debug some problems, it makes it a lot easier to see what happened and where it went wrong. Okay, So setup spinner, setup button. So I'm going to use these two errors to make these functions. So I'll do Alt Enter or Option Enter. And I've got the option there to create the function setup spinner. So I'll do that. Okay, and I'll delete the to do. I'll do the same for setup button. And I'll delete that to do. I'm just going to move the method underneath setup spinner. I'm a little bit OCD or obsessive about having the functions roughly in the order that they might be called. Okay, you don't have to do this, of course. So setup spinner, setup button, and then just one more function which I'll type manually for when the user clicks the create account button. So I'll do another private function, create account, and then curly brace. Okay, so that's the three functions that I'm going to need. So we'll start by setting up our spinner first. So we know with Kotlin we get the advantage of being able to call the views directly. We don't need to do val spinner equals find view by ID. Okay, we don't need to do this. However, as I mentioned earlier, I've upgraded to a more recent version of Android Studio. So before we could just start typing spinner underscore title and that would work. However, in recent versions of Android Studio, we don't get the Kotlin extensions plugin by default. Okay, so double click the build.gradle in the app folder again, and at the top where it says plugins, we need to add the Kotlin extensions one. So it's ID, then a comma, Kotlin -Android -extensions. If you are still on an older version of Android Studio, you won't need to do this. In fact, yours might look a bit like apply plugin. Okay, yours might look like this. In Gradle, this is exactly the same as putting it inside a plugin block, okay? So if you have this line or this line, that is fine. You don't need to do this. But if you want to be able to call the views directly just by their ID, then you will need this line. So go ahead and add this if you haven't got this in your build.gradle in your app folder, and then click sync now. So now we do have the option to import the spinner title. So we don't need to do find view by ID. Okay, so we have access to our spinner. So, three things we need to do for our spinner. We need to have the array of items we want, the list of things inside our spinner. So let's do a val, a fixed variable called our titles. And then remember, it's not our array initializer block in Kotlin, it is actually array of, and then we can type our items directly. So I'll do a few here. I'll do Miss, Mrs, Ms, Mr, MX, and then some official titles like Doctor and Professor. Okay, there's actually a huge list of possible things there. Feel free to put whichever ones you would like in there, okay? That's just a random selection. So the next thing then is to construct an adapter. Now in our recycler views from previous sections, recycler view adapters are very complicated. We have to extend from a couple of classes and do some inheritance and abstract methods. But remember, for a simple spinner, a simple dropdown, we can use Android's dead easy array adapter. So I'll make a variable called our title adapter to adapt titles into a view. And we'll make a new array adapter. This is Android's super easy, simple array that we can use. No need to do the type for string, because in a moment we're going to give it the titles strings above. It will know what to do. So the context is this screen. And for the layout, this is actually for the drop down for when they click on it, not the actual selected item. So for this, we'll do android.r. So this is one of Android's default layouts. .layout. And it's simple spinner drop down item. Okay. This gives a very nicely formatted, nicely spaced with a nice amount of margin drop down item. Okay. And the final things it needs is the objects. You can see there, objects, any kind of array, and we'll give it our titles. And there we go. The error on array adapter goes away because it knows what type of things inside it. It knows it's a string. Good. So we have our titles, we have our title adapter. So the last thing to do is on our spinner underscore title is set the adapter. So dot adapter equals our title adapter. So that is our spinner setup done. For our button, we just need to set the button click listener. So let's do button underscore create account, and we will set on click listener. And if I select the second one with the curly brackets, that gives us our dead easy, simple looking click listener block. Okay, I can make a new line. And then now from here, we can call our create account method. So that's all of our setup done. So the final thing to do is our create account behavior. So remember, we have title, first name, last name, email, phone number, and password. We could pass those through one by one to the next screen, but it's going to be much, much better to gather these all up inside a data object, a class. So let's go ahead now and make a new class. I'm going to use the target button here to move to where main activity is. And in the same folder as main activity, I'm going to create a new class. So right click, new Kotlin class, and I'm going to call this user. And you can see on more recent versions of Android Studio, we now have the option to do a data class straight away. So I'm going to do this. And then I'm going to make some line breaks inside the curly brackets. This is where we can put our class constructor. So a few line breaks. And I'm going to start typing the properties, the class fields inside this constructor. So val title, that can be a string. Val first name, string. Val last name, string. Val email, string. Val phone, string. And val password. Just a whole bunch of strings, okay? Now, if you remember from the previous section, to be able to pass this to a new activity, it needs to either be a primitive variable, like a string, boolean, int, double, or it needs to be serializable. And because this user class, this user object, has only primitive or simple variables like string, we can make it serializable just by doing colon and then serializable. Okay, so that is all we need to do to be able to pass this object, instances of this class, to a new activity. So we can go back to main activity now, and then we can set up our user when the user clicks the button. So we'll do val user equals a new user object. And I'm going to make some line breaks, and we'll simply gather up all of the values from the views on the screen. So the first is the title. So we'll do our spinner title dot, and there's a lovely property called selected item. Okay. Now remember, the spinner doesn't know what type of item this is. It could be a string, but it could be an int. It could be an object, a custom class, but we know that it is a string. So we can say to Android Studio, hey Android Studio, this is definitely a string. Give me the selected item as a string. Okay, that casting thing that we've seen once before. And the error goes away. If we did not have strings inside this spinner, then that would cause a crash. So got to be careful with that one. And then comma. And then we can simply get all of the values out of our edit texts. So edit text first name dot text. And it doesn't return it as a string. It returns it as an editable. So we have to do toString, okay? And for the final 4 fields, I'm going to actually duplicate this line 4 more times. 1, 2, 3, 4. And I'm just going to change the ID. So edit text last name, edit text email, edit text phone, and then edit text password. So when the user clicks the create account button, it will call the create account function here. And what it will do is it will create a new user object, and it will create that object. It will use the constructor to construct it from all of the values of the fields and the spinner on our registration form. So the final thing to do will be to pass this to a new activity, to a summary screen, but we don't have this activity yet. So what I'll do is I'll stop the video here, and in the next tutorial we'll add the second screen. And because the next screen is much simpler, we'll do both the layout and the programming code all in one go in the next tutorial. So let's do that next. We've set up the layout for our registration form, and the main activity code is pretty much finished. We've set up our spinner and the button, and in the button click method, create account, in that function we're getting all of the values from the fields and the spinner on the page in our user object. So the next thing to do now is create the summary activity, the next screen to pass this user object to. So I'm going to right click on the same folder as main activity and do new activity and empty activity. And this one I'm going to call the summary activity. Just like that. Make sure it's Kotlin and then click finish. Okay, so we're ready now to start building out this layout as well. Okay, I'm just going to put the onCreate method in its own bit of space. So I can see that I've got the activity underscore summary file there, but I can also control click or command click this purple activity summary layout file there. So let's click that. That's a pretty fast way to jump into another file. I'm going to change it to the split view, and we're ready to start building this out. Now I'm only going to show a few things on this page. I'm going to have a heading and then just 3 text fields. Okay, I'm going to combine the title, first name and last name all into one text view. And I'm only going to show the email address and phone number. I'm not going to show the password. So that's only really 4 text views that I need. I'm confident that this will fit on pretty much any screen. So this time I've decided to not do a scroll view. Okay, so I'm just going to change it to a linear layout. We'll do the height, match parent, and the width match parent. So we'll have it fill the screen. So later on we can put a background color on it if we want to. And I'll do a regular opening and closing tag like that. Not forgetting, of course, orientation vertical. Otherwise it will look a bit weird. Good. So I just need 4 text views. I need 1 text view, match parent wrap content, that will be our heading. So the text can just say something like your account details. Don't need an ID because I won't be setting that text in code. And what I'll do is I'll copy and paste this 3 more times. So Control C, Command C, 1, 2, 3, 4. And I'm going to change this to tools.txt. Okay, so I'm going to import this, Alt Enter, Option Enter. I don't want this actually showing on the page. And this can be Mr. Full Name User. I'm going to copy that actually. And this can then say the email at address.com, the user's email address, and this can be the user's phone number. And I will need IDs for these 3 text views. So ID, text, view, user, full name. ID, text, view, email address. And then ID, text, view, phone. I'm going to do a quick auto format. So Control Alt L, Command Option L. That's better. That puts all the IDs on the top. So until we come back to this later and style this, that's all we need to do in the layout file. So I'm going to close this for now and make sure I'm in summary activity. So there's a few things I'm going to need to do here. First, I'll need to retrieve the user that's been passed through. So I'll type a function that doesn't exist yet. Then display the user. And the final thing will be to set up the click listeners for the email address and the phone number. So I'll put setup click listeners. Okay. And I can now create a function for each of these. If I start from the bottom one and do create function and delete the to do, then as I go through each of them, it will put them in the correct order this time. Okay. So that's quite a neat and tidy way to do your activities, to think of all the things you need to do for your setup in onCreate, and then to type functions that maybe don't exist yet, and then use those errors to create those functions. It keeps your code really, really tidy. And then if there is a crash, it will tell you what function, what method the crash happened in, and that's really, really useful. Okay, so as I'll be using this user object, not just in retrieve user, but in display user and in our click listeners, I want the user object to be a class field. So I'll do a var for a variable called user. I'll make it of type user. However, I don't want it to be nullable. I want it to be non-null. So if I say late init at the front, then we're telling Android Studio this will definitely be initialized later on. We're making a promise there, okay? And we're going to retrieve it. We're going to set it here. So the user equals, and we get our intent object, our intent that exists in our app compat activity. So intent dot, and then it's get serializable extra. Now we haven't passed this through yet, but when we do, we'll call it user. And remember, this can be anything serializable. So we do as user, a bit like for our spinner. Okay. So we're getting a serializable that can be any serializable thing, but we know it's going to be a user. So we cast it. We say, this is definitely a user object. So that retrieves our user. So to display it now, we can just set the text on those 3 text views. So the first is our user's full name. So text view user full name dot text equals, and I'll use a string template here. So I'll do $user dot title, and then a space, and then $user dot first name, and then a space, and user dot last name. And it's complaining because it thinks that this is a hard-coded string. It thinks we should use a resource string instead, okay? But actually, I'm going to do something even better in my opinion. Rather than having the summary activity be responsible for this, I'm actually going to have the user object be responsible for this. So in our user object, I'm going to do the class curly brace. I'm going to make a new function, a non-private function. So I'll just do fun, and we'll call it get full name. And I'll make this a function expression. So I'll do the curly brackets, no parameters, and then equals, and I can do my string template here. So $title, then a space, $first name, and a space, $last name. No need to put the user dot title here because we're inside the user class. We can just refer to the properties directly. So now in summary activity, I can delete the string template and just do user dot get full name. And that's a really clean and tidy way to handle that, having the user object here being responsible for displaying its own full name. Okay, so get full name. Then we have text view email address dot text equals user dot email, and then we have text view phone dot text equals user dot phone. And the final thing then is to set up our click listeners to launch those implicit intents. So you might be thinking, well, we haven't got buttons on the screen, we've only got text views. Well, the magic little secret in Android Studio is any view can be clickable. We've seen this before when we've made a card view clickable in our restaurant app. So we can actually make the text views themselves clickable. So I can do text view email address dot set on click listener and select that second one down with the curly brackets. Okay. And I can make a new line after those curly brackets and do the same thing for text view phone dot set on click listener. So that will make the email address and phone text clickable. So the final thing to do in these click listeners is to actually do the implicit intents. So we'll start with the email address one first. We've done this a couple of times before now. So val intent, a new intent variable. Okay, if I just import that. Rather than saying this screen and giving it an activity, we can just do an action. Okay, so intent.action send to. Remember, you can Google Android implicit intents and you can see the full list of how to do this, or you can copy mine because we have done this one before. So from that documentation, from those guides, I know to do intent.data equals URI.parse, this address thing, URI, and then I give it a string, which is mail to with a colon. And it's doing that guarantees that it's opened by an email app. And then I do $, because I want it to be the user's email address. Okay, so URI.parse and then mail to colon using string templating and putting user.email. So that will pre-populate the user's email in Gmail or whatever the email app is on that user's phone. Then all I do is start activity and I give it the intent. So that will make the email address clickable, launching the email app on the phone. Now, for the phone number, we've had a go once or twice at doing a text message. So when you click the phone number or you click a button, it will launch the text messaging app on the phone. Well, just for a change, I want to show you that you can also use it to put the number into the phone's dialer. You can't make it make the phone call automatically, not without a very high-level permission. But if you just want to copy that number into the phone's dialer so it's ready to make a call, that doesn't require any special permissions. So we can do val intent, okay? And you would find this on the Android guide to implicit intents, how to make a phone call. So we'll do intent, and it's an intent.action_dial. Simple as that, okay? And then we can do intent.data equals URI.parse. And this time you'd see from the guide, we'd put TEL and a colon. So not mail to, not SMS to, but tell, then a colon, and then just the phone number, user.phone. And then, just like above, start activity, give it that local intent variable, Remember, this variable only exists in this block because it's a local variable. And believe it or not, that should be our app feature complete. Okay, it's not going to look pretty, but it should work. So let's go ahead and run this now and test this. So clicking run in the toolbar. Okay, and there's our horrible looking registration form. So the register title's a bit small there. Okay, I'll change this to Mr. And I'll do my name, Vin Norman, my fake email at email.com. Phone number, I'll just do my usual silly phone number. And then password, I'll just say is password. In the next tutorial, the last one where we style this app and make it look pretty, we'll do some nice things by making the email input expect an email, so it will give us the @ symbol, the phone number to be digits only for phone numbers, and we'll also look at how we can obscure the password by hiding the characters and also having a show and hide symbol there. So we'll do that in the next tutorial, but for now this is fine. And when I click create account, nothing happens. Now why is that? Let's go back to our main activity. So in our create account method, we create the user object, but we don't pass it to the summary activity. So dead easy, we can do a new intent, so val intent, and this time it's an explicit intent. So I do intent, and I'll import that, so Alt Enter, Option Enter. So for an explicit intent to move to a specific activity in our manifest, we go from this screen, and then we give it the name of the activity, class. So summary activity, : class.java. This weird symbol just to say we actually want this specific class file. Okay, so that's the intent. We then do intent.putExtra. And remember, we called it user with a capital U. And then because our user class is serializable, we can just pass in that user object. And that's fine, no error. And then start activity, the intent. So that's going to fix that. So if we run this again, and I'll just quickly fill this out. So Mr. Vin Norman fake address.com. Okay, password. So now when I click create account, we move to the new screen and you can see your account details, Mr. Vin Norman, fake address, 07711223344. The email address and the phone number don't look clickable, but when I click them, we see it launches the email address, pre-populating the email, which is fantastic. I just switch back to the app, and if I click the phone number, you can see it launches the phone's dialer and it pre-populates the number ready to call. So our app is feature complete. All we need to do now is style it to make it look pretty, make some things look more clickable, and look at one or two new tricks, some things we haven't covered with our layouts and styling that you might want to use in your future personal projects. So let's put the icing on the cake and do the finishing touches in the fourth and final solution tutorial coming next. It's time now to move on to the styling part of this solution. So I've got the emulator on the screen just to look at what we have so far. We have all the elements we need on our registration form, but it doesn't look very good. Now I can see that I've got the name of the app, registration form app, in the toolbar, and then the word register again on the contents of the page. So I've decided that what I want to do is actually completely remove the toolbar, have an activity without a toolbar, and then we can start to style the font, make the register font bigger, and just make this view fill the whole screen as much as we can. So we're going to look in a moment at how we would do that using our themes or our styles. And then once we've removed the toolbar, I'll be adding a background color or a gradient background color to the whole screen rather than this default white. And I'll show you something else we can do with the themes or the styles to adjust all of the font so they show up nicely on darker backgrounds. Okay, I'll just minimize the emulator for now. So in the project pane, we want to be opening up the resource folder. So app, source, main, and then resources. And we're going to need the registration form layout. So let's go ahead and open that. Activity_main. We'll also change the background on the summary screen, so you can go ahead and open that as well. And then we want to go into our values for our themes. Now, if you're in an older version of Android Studio, the file will be called styles.xml. If you're on a more recent version of Android Studio, it will be called themes.xml. So either styles.xml, themes.xml, it doesn't matter what it's called, but go ahead and open it. Okay. If you're on an older version with styles.xml, you may see a slightly different parent here, which we'll talk about in just a moment. And you may see less values than you see here. So in recent versions of Android Studio, they've updated this a little bit, but it doesn't matter. The file can be called whatever you want, as long as it's inside a resources tag, and then inside a style tag like this. It works a little bit the same way as our strings files does. You can call the file anything. It could be called cheese.xml, okay? But as long as it's inside a resources tag, it will get added to our app's resources. So we're actually going to start in this file. The most important thing to have an app that doesn't look totally weird is that you do inherit the top level style, this one here, from a parent. Now on older versions of Android, if you have a styles.xml file, it's likely this will be theme.appcompat or something different. But we're using the material components for our text input layout, these things here, okay? And actually in modern versions of Android Studio, this material components library is added by default. It's just a standard thing given to all new projects, as it is best practice. So if you are on an older version of Android and your file is called styles.xml and you see theme.appcompat, can you go ahead and copy this out as you see it? Theme.M for material components, .day night, we'll talk about this in a moment, .dark action bar. Okay? If you have themes.xml like I do, then it's fine as it is. So the first thing we want to do is actually remove the toolbar to make our activity layout be full screen. So the simple way we can do this is, rather than having .dark action bar, if you delete this and do .no capital A action bar, and you can see it there. Okay, don't use the .bridge one. So .no action bar, and believe it or not, that simple change there will remove the toolbar from all of your activities. Okay, so if I go ahead and rerun this now on the emulator, and you can see there our activity is full screen, so we don't see the word register twice, which is fantastic. So actually removing toolbars is very straightforward. If you wanted to have toolbars on some activities but not on others, you would either need to make multiple styles, okay, a no toolbar version and then a toolbar version, or you can actually add toolbars manually into the layout. You can actually put them in here. It's actually possible to manually add toolbars and action bars into the code like this. Okay, but no need for now. So that's our app without a toolbar. The next thing I want to do now is add a color to the background. So go to activity_main. And the simplest way to add a background to the whole activity, the whole screen, is to give the top view, whatever it is, in our case it's a scroll view, is to give that a background. So if I start typing background and autocomplete, Android:\background, and it's actually possible just to give this a simple color. So we can use the default color of black. Obviously that's no good, but backgrounds can be colors, but they can also be pictures, images, and just general drawables. So what I want to do is make a very subtle gradient color background, a bit like we saw in our bucket list app where we made a gradient overlay. If you remember on the home screen for things to do and places to go, we had a picture and we had a slightly translucent fading to black overlay. That was a gradient. So we're going to do a similar thing here, but this time we're going to make it the background to the whole activity. So a quick and easy way to make this is to do @drawable, as if we're choosing an existing drawable that we have, /, and then we can type the name of a drawable that doesn't exist yet. So I'm going to call this gradient background. And as you see, we get an error, and just like in our code, you can do Alt-Enter, Option-Enter, and use this error to actually create the file. So do you see there, create drawable file? So I'll select that, and then we have the opportunity to give it a root element, the top tag. So we're going to change this to a shape, just like we did for our gradient drawable in the bucket list app. So change that to shape, ensure it's in the directory called drawable as it is, and then press OK. And that'll do two things. It will put the file in the drawable folder, as you can see there, and it will also open up the file so we can start editing it straight away. So I'm going to move the project pane over a little bit and move the preview over a bit, okay, and make some line breaks. So the way we do gradients is inside our shape element, we do another element called gradient, just like that, and we give it a start color, I can leave it blank for now, an end color, leave it blank, and an angle. Okay, and doing it 270 degrees will make it go from top to bottom vertically. And then a self-closing tag. So from this point, you would be free to play around and try whatever gradient colors you want. I've already done the hard part of playing around and finding out what colors work well. I want a really subtle gradient that almost looks like a solid color, but just gives it a bit of visual interest by not being quite solid all the way through. So my start color, I'll type the hard-coded color for now. So hash 303F9F. A nice dark blue there. And you can already see that's trying to fade to black because I haven't given it a second color. And the end color, a very similar but not the same blue, hash 295BC1. So a slightly lighter blue. And if you look to the right, you can see we have a very subtle gradient. If I make the start and end color the same, you can see how plain that looks. And some people do like that look, a really simple, clean, modern, plain color. Absolutely fine to go for that. But just for good practice, I wanted to show you gradients again. And I quite like that. So if I go over to activity_main now, you can see we have our gradient background. And I'm just going to go ahead and apply that to activity_summary as well. So this time it's a linear layout, not a scroll view, but it's our top level element, our top level view on our screen. And because it's match parent, if I make this the gradient background, that will also fill the screen. But the final thing we need to work on, if you look to the right, you can see that the font colors by default are all fundamentally dark colors. They're colors that expect to be on a slightly lighter background. If I also show you an activity_main, we'll ignore the text input layouts because they have their own white background, but everything else, the text view and of course the spinner, they are designed to go on fundamentally light backgrounds. And this is due to a property of our theme or our parent theme. So just go over to your themes.xml file again, or styles.xml. Now on older versions of Android, where you have styles.xml and theme.appcompat, it may either say dark or light. On more recent versions of Android, you get in the material components this .dayNight .noActionBar. Now this is a pretty cool trick. This means it is possible for the user to have dark mode or light mode, depending on what they've got set in their phone. And in a later section, I'll show you how we can use this to have a dark and a light mode in our apps. For now though, we want to fix it to being one or the other. So we want to make it dark colored backgrounds, but light colored text, rather than the default, which is a light background and dark text. So the way we do this, delete everything after material components. To get that standard light look, I could do full stop and then light. So that is our light colored background with dark text, and then no action bar, as we had before. So if I go to activity_main, you can see there's no change there. It is still dark colored text because it's expecting it to be on a light background, as you can see there, .light. So you might think to put light text on a dark background, we would do .dark. But ignoring those theme overlay things, actually that isn't the way you do it. It's actually dark by default, believe it or not. So if we specify nothing and just do .noActionBar, then the default is it expects a dark colored background, and then it provides all light text and light spinners. So if I now go over to activity_main, you can see now the text view is light, the spinner is light, and the same is true for activity_summary. Okay, so we've made 3 changes there. We've put in .noActionBar to remove the toolbar. We've removed the day-night thing, which is for light or dark mode, depending on the user's settings. We've removed that, and we've manually set it to just .noActionBar, which makes the background dark by default. You can see if I remove the background, it's a dark colored background, okay? And if I now run this on the emulator, you can see we have our full screen app, our gradient color, and then our lighter colored text and lighter colored spinner. Fantastic. Okay, let's move on. Now we've got the basics sorted with our full screen activity, our background color, and the font color looking okay. The next thing I want to do is put some space in between each of the elements just so I can see what's going on. So I'll work from top to bottom. So text view, the register text view will say margin top, and we'll give it 24 dp just to bring it down the page a little bit. I'll also do 24 dp margin top for my spinner. And then I'll do 12 dp for each of the text input layouts. So margin top 12 dp. And I'll copy this line and I'll paste it. In terms of working out what's a good amount of margin, it's a little bit of trial and error. A good tip I once learned is to start with too much and then reduce it. It's better to have too much than have things too crammed together. But through trial and error, I've worked out that this is a nice amount of spacing. And then for the button, I'll do something a bit more. So I'll do margin top, something like 36 dp, just to separate the form from the action button. Okay, so that looks a little bit better. Now if I just quickly run this on the emulator, already it's a lot better being spaced out, but if I click on the text input layouts, we can see what these do at the moment. So as you can see, the hint floats above, but unfortunately the accent color, the selected field color, looks really bad on that dark background. And to be honest, this purple accent color you can see for the button as well as the highlighted field, it just doesn't work very well with our blue at all. So later on we're going to want to change that color, the accent color, or in terms of the material library, it's actually the primary color which denotes this accent color. Okay, so we'll do that later on. But before we do that, let's keep working through styling the individual elements. So starting with the text view, back to the top. I want to bring the text size up a bit, so we'll do text size, something quite a bit bigger. We'll go for 24 SP. Remember, SP scaled pixels, so if the user increases the font size on their phone, then this will increase with it, which is a good thing for accessibility for people with vision impairment, that your app will respond to them. So the font size is much better being large, but we want to change the font family to something a bit more modern, so we'll do sans serif light, and you can see that just makes it a little less bold and looks a bit more modern and clean. Now, for the most part, I'm happy leaving the spinner as it is. The font color is okay. I would like our spinner item to have a nicer font. Now I could go to the adapter in code and make a custom adapter with a custom layout and then specify what the font is in that layout file, but that's an awful lot of work. There's actually a quick and easy way to change the font on all of these fields and the button and indeed the title too. If you head over to your themes or your styles.xml file, and then inside our main style, our registration form app style, at the bottom where it says customize your theme here, and we'll make a new item. So do item, then you can do Android font family, just as if we were doing it in a text view in our layout file, and then a normal right arrow, so we get the closing tag. And inside this, we can just type sans serif light. And what this will do is it will change the default font for everything in our app. So if I now go to our activity_main, you can see the spinner and the text input layouts and indeed the button all now have this sans serif light font. So I can actually remove that from the text view, and then we have ourselves this nice modern font throughout the app. And of course, if I wanted to change a font for one specific element, I could do font family on the text view and do something like sans serif black if I decided I wanted a bolder title. Or I could do sans serif on its own for like a medium effect. In fact, I will leave the text view as sans serif a little bit heavier, and everything else can be sans serif light. Okay, so if you want to add an attribute to everything in the app, you can put it inside your style, your app theme like this. Okay, so that is the font changed for all of our elements. So looking at the text input layouts, if I just jump over to our emulator now, so the default behavior for these is the hint sits inside this text input layout with a line at the bottom and this ugly dark background we have at the moment. And when we click inside, that hint floats above. It's a bit difficult to see that purple on the black, but you can maybe just about see that the hint sits inside this box. So there's kind of a line with a box on top and everything sits inside. And that's the default style. It does look a lot nicer with a light background, I will admit. Okay, so if I go back to our layout file now, quite usefully, this material.textfield.text input layout that we get with our material library, that material dependency, it comes with a couple of default styles that look and work quite well. Inside our top one, the one that says first name, but inside the text input layout field, not the text edit text, but the text input layout, this one here, make a new line and type the word style without the word Android. just like that. Remember, style is a default attribute for all XML files, so we don't need Android. If you now start typing with a capital T, text, capital I, input, capital L, layout, and then you browse up and down, you will see we get 2 or 3 different styles. Get outlined box, filled box dense, outlined box dense, okay? If you go ahead now and change this style to materialcomponents.textinputlayout.outlinedbox and autocomplete, and then look to the right, you'll see that rather than an underline with a box with a background color, we just get this outline with a nice curved border and the hint sitting inside, okay? So I quite like this default style, especially if you have a colored or a non-plain background. This outline box can work quite well. So if you go ahead and copy that style and paste it to all of the text input layouts, being careful to put them in the text input layout and not in the text input edit text. Okay, and then just one more. And if we go ahead now and run this in the emulator, I'll show you the behavior of the hint. I'll show you the behavior of when you select a field, where the hint goes. So I'm going to rerun this in the emulator. So you can see we have a nice, clean and modern looking form. And if I click inside first name, I know we've still got that awful purple color, but hopefully you can still see that that hint floats up to the top of the box inside the line. For me, I think that's a really nice, modern way to put the hint. And if I start filling out the form, you can probably see better where that hint sits when it's not selected. Okay, so the text input layout.outlined box that you can see here is a nice style you can use that's ready-made, doesn't need much work to look good. So the last thing to do will be to sort out this awful accent color. So to do that, head over to your styles or your themes. Now, if you're from an older version of Android, you'll probably see color primary dark, and color accent here. You can ignore all the secondary stuff for now. If you don't have these, that's not a problem. But if you are on the older version of styles.xml, please change color primary dark and color accent to these 2 values here, color primary variant and color on primary. Okay? If you're on the themes.xml, that's fine, you can leave it exactly as is. So on older versions of Android with theme.appcompat, the color for the button and the color for the selected fields used to be the color accent property that you would see inside here. But the material components library, it takes the accent color from our primary color. So if we go ahead now and change this color primary to something that will look a bit nicer, that will fix our ugly accent color issue that we have. So for now, I'm just going to hard code the color here. It's not good practice. It's better to move it to the colors file, but for now, I just want to show you the fix. So we'll do a hash, and I've decided that a nice light colored blue will look good with our blue sort of style. So 42A 5F5, a nice bright blue. And you can see that immediately changes the button in our layout preview here. And if I run the app and I select the different fields, it's a lot easier to see what's going on. And the color kind of works well with our blue theme. Okay. So the registration form's looking pretty good now. We just need to move on to the summary screen, style that, and then do some general finishing touches, both to the look of the app and also to the tidiness of our code. So click on activity_summary. So first of all, we'll give the whole screen some padding like our last screen. So we'll do padding 36 dp. So we've got some padding to squeeze everything in. We'll give the page title the same margin top 24 dp. And we'll give it the same text size of 24 sp. But we'll change the font from the default sans serif light to just sans serif. Okay, so we'll have that slightly heavier, slightly more bold font. And then to separate the details from the top heading, we'll actually do quite a lot of margin now. We'll do 48 dp, really separate the form details from the title. And we'll slightly increase the size of this. So we'll do text size 16 sp, but we're happy to leave it as the default sans serif light. On the email address, we'll give it text size of 16 again. And I'll copy that to the phone number as well. We'll do margin top 24 dp. So we'll have a fair bit of spacing between the items just to make it nice and clean and clear. And we should probably do something to tell the user that the email address and the phone number is clickable. Remember, we have those implicit intents to go to the email app or the phone dialer. So a simple way we could do that, just like on a web browser, if we color that with our accent color, it will look like a link. So if we do text color, now I could go to the themes and copy this color and copy and paste it. I could do this. But this now illustrates the reason why it is good to move your strings and your colors into a separate resource file. If I decide later on I want to change this color slightly, make it a bit brighter or a different kind of color, a different accent, I would have to change it everywhere it's typed. So on the left in the project pane, if you go to colors, we can add a color here. So let's go ahead and make a new color resource. We'll call it our blue_accent, something that's meaningful for us, and I'll paste this color inside here. Okay, so now if I go back to the themes or the styles, I can change our color primary to this color blue accent. Okay, if I look at activity main, it keeps everything the same. So now in our activity summary, rather than copying and pasting this same hexadecimal color code, I can just refer to @color blue accent. And then if I ever decide I want to change this color slightly, rather than changing it everywhere, I can just change it in one place. So if we go ahead now and run this app, and just quickly fill out the form, Finn, Norman, just do some made up password, and create account, and then we have a nice summary screen as well, which we can click. Okay. There's just a couple of final changes I would like to make. This dark colored status bar, which is our primary variant color, this dark purple, doesn't really work very well with the gradient background. And in fact, if I actually make the color of the status bar the start of our gradient, then it will make our activity look like it blends into the status bar. So all I've got to do is open our gradient background, take the start color. In fact, I'm going to name this. We'll call this our blue dark. Okay, so I've made another color resource in our colors.xml file. And if I take that start color, if I copy that and make this the blue dark color, I can then refer to that in the gradient. I can say @color blue dark, and in our themes I can make the color primary variant also our blue dark. So now when I rerun the app, you can see the background blends into the status bar, making it look like our activity is completely full screen. So there's a nice little trick for you. When I click on email, I don't get given an @ symbol. When I click on phone number, I don't get given a numeric keypad. And when I type the password, I can see the password. So the final little change to make to provide a better user experience will be just to change the input type of those fields. So back to activity_main. So for the email field, which I can see is here, in the edit text, I can change the input type. So do input type autocomplete, and we'll make this an email address, text email address. Okay. For the phone number, input type, we can make it a phone. And then for the password field, input type, we can say password, text password. And by doing text password and not text visible password, that will give us our obscured fields. But because we only have one password field and we don't have a password confirmation field, it's much nicer to give the user the option to have a quick peek at their password. So if you move from the text input edit text into the text input layout, you can type password toggle enabled and select true. And if you look to the right, we get the little symbol of the eye. So when we run the app now and we fill out the form, Vin Norman, email, I can see I get the @ symbol because we've told Android this is an email field. So that will help out the user. test@email.com. When I click on the phone number field, I get a numeric keypad. So that's a nicer experience for the user as well. And when I type the password, the characters are obscured. But if the user clicks the I, they can see their password and they can show and hide it. Okay, create account works, and these two buttons work. And the final thing we should do to be a good citizen is extract all of our hard-coded strings. So nice and quickly, click on each of these warnings, Alt-Enter, Option-Enter, extract string resource, and we'll call this activity main register title, all with underscores. It's good practice to start with the where, followed by what it is. Okay, you can call it whatever you want though, as long as it's lowercase with underscores. So activity main register title, the hint, activity underscore main first name hint. I'm actually going to copy activity underscore main to save some time. Last name hint, email hint, phone number hint, password hint, and this is the create account button text. Okay, and when you complete all of these warnings, you get the magic green tick to say your file is completely free of warnings, which is fantastic. On the activity summary, we have a warning for the phone number because we've hard-coded it, but we can use tools.txt because this is just a layout preview, so that goes away. And then the only string we need to extract is the your account details. So activity underscore summary underscore heading. And when I click on the document, we also get the green tick. So quite a few finishing touches there. Hopefully you've picked up one or two useful tricks there, like some of the input types, like the password field, being able to set a font family for your whole app rather than in every single place, getting used to extracting your strings, extracting your colors to specific resources, like in your colors file, so then you only need to change them in one place. Okay? But if I go back to the emulator and press back, that to me looks like a pretty nice registration form, and all of the ideas in this challenge solution you are free to take and apply to your own apps, if your apps have any sort of form in them. So congratulations if you completed all or some of this challenge on your own. It's time for a new section, and this section is called Fragments and Bottom Navigation Bar. You will no doubt have seen many apps on your mobile phones, whether Android or iPhone, which have a tab at the bottom of the screen, a bottom bar with different options, different screens you can go to, and those screens that you switch between using that bottom bar, they exist on Android in what's called a fragment. So this is an absolutely crucial skill for you as an Android developer in being able to build app layouts which are really easy to navigate for your users, as well as developing your understanding of fragments in general. We do use them for our apps with a bottom navigation bar, but they have many other uses as well, as you'll find out throughout this course. So the primary objectives for this section, by the end of the section you're going to be able to understand how fragments work, how they are similar but not the same to activities, how they can live within an activity and be, as the name suggests, for a small portion, a small fragment of the screen, okay? And also by the end of the section you're going to be able to create an app with a bottom navigation bar, and you're going to be able to navigate between fragments, between screens, using that bottom navigation. So the app we'll be making for this section is the Record Keeper app. I've always enjoyed cycling, and also in 2020 I really found myself getting into quite a fair bit of running. I happened to find myself with a bit of free time in 2020, as many of us may have done. So this is a useful app for me. I do have some fitness and health apps where I do log my runs and my bike rides. However, the place where I can see my personal bests, my personal records, isn't always that easy to find, and I don't think it's very well designed. So this app actually benefits me in my personal life. This is for me where I can store all of my personal bests or personal records. So as you can see in the app, we have a bottom navigation bar for running and cycling.
So you can switch between the two screens. And then we have the content of each section, the fragment as it is, as you'll soon see, which has a nice picture for running, a nice picture for cycling, and then it has each record that I'm interested in. So for the running, it's the best times, the personal bests. So 5K, 10K, what was my lowest time? And for the cycling, it's different things that I'm interested in. There aren't really any set distances for the sort of biking that I do. So it's my kind of other personal records, longest ride, biggest amount of hill climbing in one go, or what was my best average speed for a certain ride. As we go through this section, you will be able to tweak this and add any records that may be important to you, or indeed any different sports that might be important to you. The concept is the same. So, the Record Keeper app. As usual for all of our sections, we'll cover some core programming concepts. Not as many in this section, although one of them, the first one, interfaces, can seem a very complex and intimidating concept. Actually, interfaces themselves are very simple, but the way they're used and the reasons why they're used, that's a bit more subtle, that's a bit more nuanced and at times complicated. So I'll be making sure to really make the concept of interfaces clear to you, why you would use them, examples of how you've already been using them, and also give you tips on when you might want to make an interface yourself to solve a certain programming problem. So we'll do a deep dive into interfaces and how they're used. And then the second concept is much more simple, the when statement in Kotlin, or in Java they would be called a switch statement, and how they can be used as an improvement to lots and lots of if, else if statements. Okay? As well as our primary objectives and those programming concepts, some secondary objectives. The first one, the activity lifecycle. We'll be able to cover this in one or two tutorials, so it's not a whole section, it's not a whole primary objective. However, it's a very, very important thing to understand. The fact that when you have an activity on the screen, the process of it being created, recreated, paused, destroyed, what happens when the phone rotates. There's actually quite a lot of things happening under the hood with an activity. You would have already seen some of this without even realizing it in our onCreate method. So when the activity is created by the Android system, okay, so you've already seen one of the lifecycle functions, the lifecycle methods on create. So we'll be doing a deep dive into all of the lifecycle methods, what happens when an activity is created, and what happens when it is paused, recreated, or finished. And also we'll see how that's relevant to our app, especially with our bottom bar and our use of fragments. We're going to see how the activity lifecycle fits in and why it's important. Also, as an extra bonus, we'll look at option menus and menu resource files. So for option menus, think of the things like those three dots in the top right of the app you might have seen, the three-dot menu, and you can tap this and you get some more options for things to do. So that is an option menu, and we'll also see how this then relates to our menu resource files, how we define a menu. And we'll also be using these same menu resource files to help make our bottom navigation. That will also depend on a menu resource file. Okay? And this section will continue to develop our library of Android widgets, Android views that we can use in our layout files. So first of all, of course, the bottom navigation view, as it's called in Android, or you can call it the bottom bar or bottom navigation bar. But the widget is called a bottom navigation view, as you can see there. And we use that to switch between fragments. And finally, we're going to understand how the constraint layout works. That default layout that we've seen many, many times right from the first section. We're going to learn how it works, how, while slightly more complicated, it's very, very powerful. A view group, a container to pin or constrain edges of views to other views. You can think of it a bit like a supercharged relative layout, but much more powerful and much, much more flexible for building professional modern layouts. So, let's get to it. Before we dive into making our new project for this section, I just want to show you what selecting the bottom navigation app template does in the project setup wizard. If you remember back to the very start of this course when we first looked at the project setup wizard, I did mention that at some point in the course we would explore one or two of the templates to see what Android Studio gives us when we select them. So just for an exploration, we're going to go ahead now and select the bottom navigation template, see what things we get. We're not actually going to use this for making our project for the section. We'll be doing it all manually, doing everything from scratch, as it's the best way to learn what's going on. Not only that, but there's one or two things in the template which are done slightly differently, aren't necessarily the best way to do things or the most appropriate way to do it for this particular project. But what we will do is we'll have a look at this, see the main components, see the main pieces, get a feel for the sort of things we're going to be exploring and learning about in this section. Okay? You don't have to make this project with me now. You can just watch the video and see what I'm showing you. But if you want your own reference copy of the bottom navigation template, then feel free to go ahead and create this project with me. So I'm at the Welcome to Android Studio dialog. I'm going to select Create New Project. And by default, it selects Empty Activity. But this time, we're going to find in the list Bottom Navigation Activity, which for me is next to Empty Activity. So select this and then click Next. Now for the application name, I'm just going to name this something descriptive to remind me it's the bottom navigation template that we're just exploring. So I'll simply call it Bottom Navigation Template App. I'll leave the package name as the default and the save location is fine. Leave the language as Kotlin, of course. And for the minimum SDK, at least API 21, at least Android 5.0. If you have a recent version of Android Studio and yours is even higher than this, that's fine. But if it's lower, make sure from now on it's always at least API 21. Okay, and then click Finish. Okay, and mine's now finished loading. So depending on what version of Android Studio you have, you might have a different file or a different view to me here. But I've got activity_main and some mobile_navigation file that we're not interested in for this tutorial. So I'm going to close down mobile navigation. I'm going to leave activity_main, and you can see mine's in design view. So if yours is in code, then make sure it's either in split or design view. So I'll leave mine as design view, and we can see a bottom navigation bar, this bottom navigation view down here. So straight away in this template, we have a layout with a bottom navigation bar that we can start to customize and make our own. If I just go to the split view, and if I bring the project pane across a little bit, you can see we have the constraint layout that we've seen a few times before, and we are finally going to learn how to use this in this section. And then we have a bottom navigation view. And it's this bottom navigation view, if I click on it, you can see that corresponds to the bottom navigation bar that you see there. The way that the users will switch between the different screens or the different fragments. You can also see we have this fragment element that we don't need to worry about too much. We'll be doing ours a slightly different way to this, but you can see our first little sneak peek at the concept of fragments. Okay. So I'm going to head over to the project pane now on the left and change the Android view to project as normal. And I'm going to press the target button to quickly expand the folders to where activity_main is. And you can see alongside activity_main, this layout, we have three more layouts. Fragment home, fragment dashboard, fragment notifications, which corresponds to the three things that you can see in our bottom navigation bar, our bottom navigation view there. I'm not going to bother opening these files for now because at the moment they're pretty blank, there's not much in them. But what I will do is I will open some of the programming code. So if you can open the Java folder and then navigate to where the main activity is, you can see there. So we have the main activity, so let's go ahead and open this. And as you can see there in our code, we have our bottom navigation view. And then we have some stuff which is going to differ from what we do in this section. We have these things relating to nav controller, setup nav controller. So everything from line 18 down. This is a slightly new way of configuring bottom navigation bars and fragments, this concept of the navigation controller. We're not going to worry about this nav controller mechanism in this section. What this does is it does a lot of the wiring up, a lot of the connecting of the bottom bar and the fragments and the switching between the mechanism. It does a lot of that under the hood. Now, from a convenience point of view, this can be really good, really desirable. From a learning point of view, it's actually no good because we never actually learn how fragments work, how fragments are switched, and how you can tie it into a bottom navigation bar or something else, okay? Also, while at first it can seem convenient to have these controllers that take care of it all for us, it's not always appropriate to use this new nav controller system. Sometimes when you get more complicated projects, it can actually cause more problems than it solves. For example, in the company which I work for, with our very popular app, we don't use the nav controller, but we do have a bottom navigation view. Okay, we do it all manually. It gives us more control. It makes it clear for us to see what's going on. So I just wanted to show you in this template, if you start to use this yourself, which is absolutely fine, you may need to do some research on this nav controller system. A lot of it is taken care of for you in this template, but actually you don't have to use it. And you're going to see yourself in this tutorial as we start to learn about bottom navigation view and about fragments and about switching fragments and we know how to switch between them as the user changes the bottom navigation option, okay? We're going to learn it's not too difficult, and actually understanding how that works is more important than using this nav controller, okay? So you can ignore all of this, but there is one thing that the template does that I really, really like. If you look over on the project pane, we have main activity, and then we have a folder called UI, standing for user interface. And when we open this user interface, you can see 3 more folders, or 3 more packages as they're known in Java or Kotlin world. One for each of the destinations, home, dashboard, and notifications. And inside there, you have the 3 fragments, as well as a view model that we don't worry about in this section. So if I go ahead now and open up our home fragment, you can see a class which looks slightly like an activity. We have an onCreate view method rather than an onCreate method, okay? And then we have some code we don't understand. We have some stuff relating to a view model that we won't be using in this section. We won't be needing this. But in the template, this is all taken care of for us, and we can start customizing the fragment layout that you see here, fragment home. We can start customizing this just like a normal layout. And then we can start doing things in the code to change some of those views, like setting the text on the text view. Okay? So the last thing we can do in this quick overview, this quick exploration of the bottom navigation template, is run the app. We can see what it looks like and what the basic template gives us. So let's go ahead and do this. Okay, and you can see on my emulator we have home, dashboard, and notifications on the bottom bar. And when I click between them, you can see this is the home fragment, this is dashboard fragment, this is notifications fragment. So you can see those are swapping and switching between. Okay, so we get a basic template when we select that from the project wizard. And feel free to explore this yourself and try and make a project yourself using this. We, however, are going to build our bottom navigation app completely from scratch to learn how all these things work under the hood. If I go back to Android Studio, the key thing is we have our activity, we have our different fragments, you can see notifications, home, dashboard, and then in the activity layout, activity_main, we have a bottom navigation view, and we have somewhere or something with which to swap out our fragments. So those are the key things to take away from this. Let's now go ahead and make a brand new blank project for our Record Keeper app and build this whole thing out from scratch. I've closed down the bottom navigation template app, so I'm back at the Welcome to Android Studio dialog. So now let's create the project that we're going to be working on for the rest of this section. So let's click Create New Project. And this time, leave it on Empty Activity. We want to do everything ourselves from scratch here. And click Next. So this now is going to be the application name, the thing that goes in the manifest at the top of our toolbar. So I'm going to call mine simply Record Keeper. Feel free to change the name if you want. I'm going to change the package name off of com.example. Seems to have reverted back to that recently when I updated. So I'll do com.mydomain simply because one day I might decide to publish this. I probably won't publish this app. You're free to publish it yourself if you want to. As long as if you make lots of money off it, you give me some share of the royalties. No, I'm just joking. So com.vinnorman.recordkeeper, you call yours what you want. And then save location is fine, Kotlin and API 21. So that looks fine to me. We can click Finish. Okay, and we're into our new blank project. As you can see, a lot less boilerplate code generated for us, but that's just the way we want it. I'm going to move the project pane over, change it to the project view, and put my onCreate method in a bit of space. Good. So the first place to look in our empty project will be inside the activity main layout. And if I switch this from design mode to split view, okay, we can see just a simple constraint layout and our text view in the middle. So we can go ahead and remove the text view. So we will be doing an overview over how fragments work and how they relate to an activity. But in simple terms, as a quick introduction, the main activity, this main activity class at the top, this screen, this will be like the parent screen that holds everything. It will have our toolbar, it will have our bottom navigation bar so the user can switch between screens or switch between fragments as it is. And there'll be some kind of container where we swap out the fragments, okay? So this will be the container, the parent for the whole app. So on this screen, we're going to need simply the bottom navigation bar at the bottom here, and then a container to change out the fragments. And rather than using linear layout or relative layout again, this time we're going to finally learn how to use constraint layout. And as the next thing that we need to do is add the bottom navigation view to this layout and put it at the bottom, we're going to need to know how to use constraint layout now. So with text view deleted, leave this constraint layout element here with the opening and closing tag, and let's dive in right now into learning how this constraint layout works. I'm going to split the three main things that we need to know when working with constraint layouts into separate tutorials. So in the project pane, I've made a new layout file called constraint_layout_1. We'll do the 3 tutorials in 3 different files. So if you can go ahead and do the same, get this constraint layout 1 layout file so we can have a play around and learn about how constraint layout works. And once you've made that file, by default it should put the constraint layout as the root element. If for any reason it doesn't, it does a linear layout or something else, then you can go ahead and type constraint layout autocomplete and just completing the layout height, match parent, and of course layout width, match parent, and do a normal opening and closing tag. Okay, and then with a quick auto format to tidy that up, we should have an empty constraint layout ready to start working with. So in this first tutorial, we're going to focus on the core concept of constraints, what they are and how you can work with them. So a constraint layout is a view group. It's a container, just like our linear layout or our relative layout. If we think back to linear layouts, well, the way that container works is the views are stacked one on top of each other for a vertical layout, or side by side for a horizontal orientation. So that's our linear layout. Then we had the relative layout where we could put views relating to each other. We could say this view should be after this view, before this view, layout below that view, or align to the parent top, align to the parent bottom. Okay, so with the relative layout, we had a little bit more control putting views in relation to each other. Well, a constraint layout takes things even further. You can think of the word constraint like the word pin. When we constrain a view, we pin it to something else. So we can pin a view to another view, or we can pin a view to the parent. But with constraint layout, we can pin every side, every edge of that view. The top, bottom, the left side, the right side, we can pin any edge to any other edge. Okay? So in this first tutorial, learning how to use constraint layout, we will do exactly this. We'll put some views on the page and we'll see how we can pin the edges to other things to be able to put views pretty much anywhere we want. So in the middle of the page, go ahead and place a regular button, capital B. We'll just use a normal button, not a material button. And we'll do wrap content and wrap content for it and just do some dummy text. So we'll call this test button 1 and then a self-closing tag. So straight away, this returns us an error on the word button saying that this view is not constrained. So we haven't told this view where it's supposed to sit. We haven't constrained or pinned any of its edges to anything else. So by default, it will place it at 0, 0, which is basically the very far top left corner. But this is not ideal. You don't want to be doing this. So we need to pin this both vertically and horizontally. So the first thing we'll do, using constraints, using this idea of pinning edges to other edges, we'll try and move this button from the top left to the bottom right. So the way we could do that, if we just look at the design preview, if we could pin the bottom of the button to the bottom of the parent, to the bottom of the container, the constraint layout, that should move it to the bottom. So let's do exactly this now. Somewhere inside the button, we want to add a constraint to constrain the bottom of the button to the bottom of the parent, the bottom of the constraint layout. And the way we do this is with attributes that are called layout underscore constraint, all lowercase. And if we scroll up and down, we can see end to the end of, right to the right of, bottom to the bottom of, top to the top of. We can constrain any edge of this view to any edge of any other view, which is incredibly powerful. So if we add layout constraint bottom to the bottom of, and we say the parent, the container, then you can see the button jumps to the bottom. We've pinned the bottom edge to the bottom of the parent. We're still getting a warning that we haven't added a horizontal constraint. So to move it to the right, we can do right to the right of the parent. And just like that, we've constrained, we've pinned the button to the bottom right corner. There's actually another way to do right and left. rather than left to the left of or right to the right of, you can actually do end to the end of. Now we've seen the concept of start and end before. This means if we change to a phone which language is a right to left language like Arabic or Chinese, that rather than being the right side of the screen, the end will be the left side of the screen. And we can check this in our design preview. You see where it says default ENUS, the default language? We can select preview right to left. And you can see with this selected, end to the end of moves to the other side. If I left it as right to the right of, it would still stay at the right no matter what the language. So generally speaking, it's better to use start and end than left and right. I rarely, if ever, use left and right. I always use start and end. So end to the end of, that will respect the language that the user's phone is set to. If I remove the right to left preview, it's back to the right hand side. So that is constraining the edge of a view to its parent. As a little test now, see if you can constrain another view to the bottom left of the screen. Pause the video, give it a go yourself. So the way we do this is button. I'll do wrap content, I'll do text test button 2, self-closing tag. I'll do bottom to the bottom of again, parent, and it jumps down. We could just leave it like that, but we have got an error saying we've not constrained it horizontally. So I'm also going to add start to the start of parent, and then the error goes away. If you did left to the left of, that's also okay, but better is to do start to the start of. So the first thing we can do is we can constrain our views to the parent, any edge of our view to any edge of the parent. But the real power of constraint layout lies in constraining views to other views. If I give my two buttons an ID, so ID button underscore 1 and ID button underscore 2, I'll do a quick auto format just to tidy that up. So as well as constraining or pinning edges to the parent, we can also constrain edges to the edges of other views. So I now want to put a button that is still on the far right side or the far end, but I want it to be directly above test button 1. So the way I would do this, wrap content, text, test button 3. I would still add my end to the end of constraint, parent. But this time, I want to constrain the bottom of test button 3, so the bottom of this button, to the top edge of test button 1. So I would do layout constraint, bottom, to the top of. Now, by the way, when you're doing autocomplete, you don't have to keep typing layout underscore constraint every time. I just type the directions that I want. So with a lowercase b, B-O-T-T, and then T-O for 2, and then T-O-P, bottom to the top of. That's the way I quickly add my constraints. No need to keep typing layout constraint. So bottom to the top of, autocomplete, and I want the bottom edge of my button, button 3, to be constrained to button 1. And if you look on the screen, test 3 button is now directly above test button 1. I'm just going to very quickly add another button and place it in the top right of the screen. So I'll copy button 3. I'll change the text to test button 4. I'll delete the constraints and I'll just change it to top to the top of parent and end to the end of parent. So I've placed that button in the top right of the screen. I'll give button 3 and button 4 IDs. So for your final challenge, to be able to constrain edges to other views, could you put test button 5 underneath test button 4, so the top edge is underneath the bottom of test button 4, but also to the left of button 4, or to the start of button 4 rather. So the right edge of test button 5 finishes at the start of test button 4. Could you put a button exactly there where I've just shown you in that drawing? So pause the video, try and do this yourself. Okay, if you got stuck or you want the solution, so we make a new button, we'll say wrap content, we'll call this last one test button 5. So I want the top edge of this button to be under the bottom edge of button 4. So the top of this button to the bottom of button 4. And that will move it below button 4, but as you can see horizontally it's still at the far left side of the screen. So I also want the end, or the right side, but end is better, the end of this button to be pinned to the start of button 4. So end to start of button 4. And if we look at the design preview, you can see we have the button where we want it. If you actually click on the buttons in the XML or in the design preview, you may be able to see just about some blue little arrows, and that's showing you where the constraints are. It's kind of hard to see because the views are so close together, but the design preview does try and show you where the constraints are. So that's the first concept of the constraint layouts, constraining or pinning edges of our views to either the parent container, the view group constraint layout, or pinning them to other views. We now know how to add constraints to our views. We know how to pin any edge of a view to any edge of any other view, or to any edge of the parent, the constraint layout itself. So in this tutorial, I want to show you the effect of adding opposing constraints. What happens if you pin opposite sides of a view to different things? So I'm in a new layout file called constraint layout 2, and I've made sure that the root element is constraint layout. So if you can go ahead and do the same. So the first thing that I'm going to do this time is add an image view to the top of the screen. So if you can go ahead and make an image view tag, capital I. Now one thing that I want to quickly show you is actually you can make any of the views inside a constraint layout be match parent. If I say width match parent and height match parent, you can see with the blue box to the right it does fill the whole screen, and we don't get any warnings. And the reason we don't get any warnings is the constraint layout knows where to place this view. It knows to fill the whole box, the whole container, so we don't need to add any constraints for match parent. However, for this image view, I do want the width to fill the screen, so layout width match parent is fine, but I want to fix the height to something like 150 dp. And we get a warning saying it's not constrained vertically. It's not complaining about a horizontal constraint because it fills the width, so that's not an issue, but we do need to constrain it vertically, so I'll simply say top to the top of the parent and pin that to the top of the screen. And just so we can see something in our design preview, I'm going to give it a source, so src, and I'll just choose durable and the launcher background, that default background to our app icon. A pretty ugly green, but at least we can see something. And just to make that fill the image view, I will add scale type and I'll say center crop, so that will enlarge it until it fills the whole image view. So it looks a little bit low resolution, but for the purpose of this tutorial, we can see something in the design preview filling the image view, and that's exactly what we want. So we have an image view with match parent width filling the space, but we've constrained it to the top of the screen, top to the top of parent. And I'm just going to add an ID, so ID image underscore view, and then auto format. So what if we wanted to place a button directly under this image view? Would you remember how to do that? Go ahead and pause the video, create a button with some dummy text, and place it directly underneath this image view. Doesn't matter if it's on the left or the right, just make sure it's underneath. So the way we do that, button, we'll do wrap content, we'll do some dummy text, test button, self-closing tag, and we would do the top of the button to the bottom of the image view. And you can see that moves the button down. And we should probably constrain this horizontally. I'll leave it at the start, so I'll do start to the start of the parent, and the error goes away because we've constrained it both vertically and horizontally. Of course, if the width was match parent, then I could delete this horizontal constraint and no error because it's filling the width. Okay, so that's a new concept there. You can use match parent inside a constraint layout. But I'm going to undo that, so I'll undo the layout constraint, I'll undo the match parent, so wrap content. Now at the moment the button is quite close to the image view, something we didn't cover in the previous tutorial. It is still possible to add layout margin exactly like our other containers, so I'm going to give this some layout margin top and something like 24 dp to give it a bit of space. And when we apply the margin like this, you can see now that arrow showing us the constraint, this curvy arrow here, that shows us the top edge of our button pinned to the bottom of the image view. Of course, if I made it quite big, like 200 dp, then it doesn't need to curve so much. Okay, so I'll undo that, leave it at 24 dp. So how would we go about centering this button horizontally? We know we don't have any layout gravity attributes. We can't do layout gravity center. That's for linear layouts, okay? And also if I start typing the word center, S-C-E-N-T-E-R, there's actually no attributes at all in a constraint layout that will control whether the view is centered. So this is where the concept of opposing constraints comes in. We have pinned our view to the start of the screen. Of course, I can remove this. I can change it for ends to the end of, and then it jumps to the right. But see what happens if we constrain the end of the button to the end of the parent and the start of the button to the start of the parent at the same time. So go ahead and do this. Have an end to the end of constraint and a start to the start of constraint. Pin both sides, the opposite sides, to the parent. And you can see our button is now centered. And the lines showing where the constraints are, the line going from the edge of our button to the edge of the parent, they now have a zigzag. And that zigzag at the start and the end of the button is showing you that this button has opposing constraints. It's being pulled or constrained in both directions. And the default behavior for when you add opposing constraints is it will center the view between those two constraints. And this becomes quite a powerful thing. So we'll go ahead and add one more view in this tutorial to show the power of these opposing constraints. Underneath the button, go ahead and add a text view. Make the width wrap content and height wrap content, and do a little bit more text. We'll do text, this is my example text view, or anything you want. Do a few words, and self-closing tag. So as a quick test of what we just learned with the button, how would you go about centering this completely in the middle of the whole screen, both vertically centered and horizontally centered? Have a think, try it yourself. The way we would do this is we would add opposing constraints to the start and end. So I do start to the start of parent and end to the end of parent. And even though it's sitting on top of the image view, you can see there that's now centered that horizontally, and we have those zigzaggy lines showing the opposing constraints. But if you also do the same for the top and the bottom, top to the top of parent, and also bottom to the bottom of parent, then you can see we have zigzags on all four sides, two pairs of opposing constraints. And by constraining every edge to the parent, to the container, that makes it exactly centered both horizontally and vertically in the container. And as the container matches the screen, that's centered exactly in the center of the screen. But the power of these opposing constraints is more evident when we start to put opposing constraints not always on the parent, but in relation to other views. So now we want to leave this text view centered horizontally, like we've done. So you can leave the opposing constraints for the start and the end, leave them constrained to the parent, that's fine. But now we want to place this text view halfway between the bottom of the screen and the bottom of our test button. So if you think you can solve this yourself, go ahead and do it now. If you're not sure, we need to delete our top to the top of parent constraint, so we'll delete that. And the text view jumps to the bottom because it's got no opposing constraint now. So that bottom to the bottom of parent will bring it all the way down. But if I now add another constraint to the top of our text view, so I'll start with the word top, the top of our text view, but I'm now going to pin it to the bottom of the button. I've just realized that I need an ID for my button, so I'm going to go ahead and add the ID. Just call it button. And then if I go to my text view and add a constraint top to the bottom of the button, you can see those zigzaggy lines going from the bottom of the screen to the bottom of the test button. And that text is now perfectly centered between the button and the bottom of the screen. And this is the power of opposing constraints. And this becomes incredibly useful when we talk about the concept of responsive layouts. You may or may not have heard the term responsive, particularly when browsing websites on a mobile phone. But when we talk about responsive user interfaces, responsive layouts, we're talking about that the layout will respond to whatever shape, whatever orientation, whatever size screen the user is using. So if we now, in our design preview, next to the blue icon, click the orientation for preview icon and select landscape, if I bring this across to zoom in a little bit, you can see that even though we're in landscape, because we've used constraints and this powerful technique of opposing constraints, even though it's a totally different height of the screen, the text is still centered between the button and the bottom of the screen. And when I change it back to portrait, it adjusts automatically. So using the constraint layout container in Android is one of the best ways you can make super responsive, super flexible layouts. So whatever size phone, whatever orientation the user is using, by using constraints well and using opposing constraints to place things in the middle of other things, your layout is going to be able to handle any device, any orientation. Okay? So that is the concept of opposing constraints in our constraint layout. So the third and final of our essential constraint layout skills involves a concept called match constraints. We know how to add a constraint and pin any edge of our view to any edge of any other view or the parent. And we know that we can use opposing constraints to add a constraint to each side of a view, and that can be used to center a view in the middle of two other views or the parent. We also touched upon the concept of responsive layouts, layouts that respond to whatever size or shape the screen is. But what if we want to use the constraints that we've added to our view to determine the size of that view? So the concept of match constraints can be done to achieve this. We can add constraints to opposing sides of a view, just like we did in the previous tutorial, but rather than leaving that view as wrap content, we can actually match the constraints, and that view will stretch to fill that space. Let me show you what I mean. So I'm in a third and final layout file called constraint layout 3, if you can go ahead and do the same. And this time I'm going to close the project pane to have a bit more width. Okay. And the first thing I want you to add at the top of the screen is an image view like before. So image view, and for now do width match parent and height 200 dp. We'll need to give it some source so we can see what's going on. So we'll give it a source of the IC launcher background like before. And we need to give it an ID. So ID, we'll just call it image view, and a self-closing tag. Straight away we're getting a complaint because we haven't added a vertical constraint. So if we do top to the top of parent, the warning should go away. And this time I'm not going to do scale type center crop this thing. I'm happy for the image to be only as wide as it needs to be for the height that we've provided. So by deleting the scale type, we can see that, okay, it's not quite full width, but that's absolutely fine. And if I just quickly do an auto format to bring the ID to the top. So at the moment, we're using match parent for the layout width, like we did in the last tutorial. And this is okay. It's a quick and easy way to fill the width of the screen or the constraint layout, the container, or the height. But strictly speaking, we're not actually supposed to use this. There are some warnings on the official documentation that we shouldn't use match parent, that it can occasionally throw some anomalies, as this view group, this container, is expecting constraints. It's expecting the edges of our views to be pinned to different things. In my experience, I have used this in some personal projects and indeed at work, and match parent seems to work absolutely fine, but I just thought I'd mention that to you. So then if I'm telling you now that we are not supposed to be using match parent to fill the width, then what should we do? Well, what we should really do is we should do start to the start of parent, end to the end of parent, okay? And rather than layout width match parent, if I just delete that value, we're supposed to type something which says match the constraints given, match constraints. And the way we do this is by setting the width to be 0 dp. Okay? And when we do this, we're telling the constraint layout, determine the width automatically from the constraints. Match the constraints given. If I set the width to something fixed like 300 dp, you can see that shrinks in a little bit, and because we have opposing constraints, it's centered, okay? And I can do 150 dp like that. But when I do 0 dp, it will match the constraints. It will go all the way to wherever the constraints are. And this is the correct way to do the match parent effect, according to the documentation, okay? I'm just going to apply some padding to the constraint layouts to squeeze everything in. Also, just to show you that padding works absolutely fine on a constraint layout. So you can see there we have padding there, and that works on all sides and all of our constraints. So I'm just going to quickly auto format. Let's now use the concept of match constraints to not just fill the width of the screen or the container, but let's use the concept of match constraints to fill the space between two views. So let's add two more views now to our screen. Let's go ahead and add a text view. And we will this time use wrap content for the width and wrap content for the height. And we'll just say for the text something like my example title, and we'll give it an ID because we're going to need to constrain other views to this. So text view title, and we will constrain the top of this view, so top to the bottom of the image view. And that jumps down, and we want it centered, so I'll do start to the start of the parent, end to the end of the parent, and that then brings it to the middle using those opposing constraints you can see there. And finally, we will give it some margin to the top, so margin top, and we'll say 12 dp, just to give it a bit of space from the image view, and a self-closing tag, auto format. I'm also going to add a button to the bottom of the screen, so go ahead and add a button. This time I want it to fill the width, so we will do 0 dp, we're going to match the constraints for the width. The height we can just wrap content as normal for a button, and we'll give it some text, we'll say submit, like a submit button. And this time we want the bottom to the bottom of the parent, so that jumps down. And we want it to fill the width, we want to match constraints, so if we do start to the start of parent and end to the end of the parent, well, that stretches because we have the 0 dp. We're saying match the constraints given for the width. Okay? I could delete those constraints and change this to match parent, and Android Studio won't complain. It seems to work absolutely fine. Just do note that in the official documentation, they don't advise using match parent. They much prefer using 0 dp and the constraints. Okay? So that's a text view and a button. I will need to give the button an ID, so we'll just call it button for now. So using the concept of match constraints, I want to place a text input layout, as well as a text input edit text, inside the space between the text view and the button. Okay, so I want the width of my text input layout to fill the screen, so end to the end of parent, start to the start of parent, and match constraints. But I want the height to be determined by the space that's between my example title, you see there, and the button at the bottom of the screen. So if you think you know how to do this, you can pause the video and jump ahead and try and give this a go. That'd be a really good test to see if your first instinct is correct. The reason I want to use a text input layout is because if we change the style to outlined box, like you've seen before, that will show it nice and clear on our design preview how much space the text view is taking up. The edit text would just be an underline, it might not be so clear. So use a text input layout, set the style to outlined box, give it an edit text on the inside, and give the text input layout a hint, all the things you should know how to do by now, and try and constrain it in between the text view and the button, and use the 0 dp for the height to match the constraints for the height. If you're not sure what to do or you want to see the solution, let's go ahead and do it together now. So text input layout, you can see that there when I select it. So there's the layout container. I'll use 0 dp for the width and 0 dp for the height. I'm going to give it a hint that says this can be our multi-line text field, exclamation mark. I'm going to set the style to be text input layout. You can see there autocomplete, and then I'll do outlined box. And my font is quite big, but you can just about see that when I select it. So that one there, and then I can do a normal right arrow to give me the closing tag, and inside the closing tag I'll do my text input edit text. Okay, this time I can do match parent and match parent. The size is being denoted by the text input layout, the container outside it. So in this case I want the edit text inside our text input layout to be match parent. Okay, and now it's time to add our constraints. So I want the start to be to the start of the parent, and the ends to be to the end of the parent, so that will match the width. And now I want to constrain it in between the bottom of the text view and the top of the button. So the top of this text input layout to the bottom of the text view. And you can see that jumps down. But also the bottom of this text input layout to the top of the button. And there you have it. If I just click off this so you can see it, we have a text input layout that fills the space in between the text view and the button. I'll give it some margin top, maybe 12 dp, and some margin bottom, 12 dp. I don't want any margin at the start or the end because the padding takes care of that in the parent, in the constraint layout. If I just do a quick auto format and select off this, and that is now filling the space. We are using match constraints to put that in between two other views. So now if I turn this into landscape by clicking the orientation for preview and selecting landscape, it responds to the space it has available. It's a responsive layout. So that is the concept of match constraints. You specify 0 dp for the width or the height, and that tells the constraint layout, I'm not going to give you a width, you determine the size based on the constraints that I give you. And that's how you can make what's called a dynamic size. It will be determined dynamically depending on how much space is available. It will respond to the available space. It is responsive. It's a responsive layout. Just as one final little bonus, if I just turn this to landscape again, you could argue that the 200 dp that we gave the image is pretty big in landscape mode. It doesn't leave us much to work with. You can see our multi-line text view doesn't look multi-line at all. If I turn it portrait, it's absolutely fine. Okay. So is there something we could do? Rather than specifying the height in pixels, could we make it a proportion of the screen? So if I just scroll up to the image view, so we're saying 200 dp there. And the answer is, yes, we can. So wouldn't it be nice if rather than saying 200 dp, it was approximately, I don't know, 25% of the screen? So there is a way to do this and it's incredibly easy. Change layout height to 0 dp. So we're saying now we want it to match the constraints given. And there's one more attribute we can add. If we type the word height and then %, layout constraint height %. We also have width % as well, you can see. Okay, but if I do height % autocomplete, and I can specify a decimal between 0 and 1. So if I say 0.25, that will be 25% of the screen, whatever space is available. Please note, if you're using a height or width %, you must have 0 dp. You must tell the constraint layout to match the constraints. We're giving it a constraint, 25%, okay? So now if I turn this design preview to landscape, it only takes up 25%, and our multi-line text field looks a lot nicer. Okay, so that is the concept of match constraints with a bonus concept of width or height %. You can now pin any edge of any view to anything else on the screen, whether another view or the parent. You can use opposing constraints to center a view between two views, and you can use 0 dp match constraints to determine the size by those constraints for a truly responsive and dynamic layout. Fantastic. So let's now apply all of this learning, go back to our project and build out our main activity layout using these skills. So equipped as we are now with all of those skills for using constraint layouts, actually building this layout is going to be quite straightforward. Remember, the toolbar at the top of the screen, that is taken care of for us by our theme, so we don't need to manually add a toolbar, although do note it is possible to do this if you want to. So all we really need on our screen is the bottom navigation bar, this bottom navigation view we're going to add in just a moment, and then the container where our fragment will live. Okay, we want the bottom navigation bar pinned to the bottom of the screen, but filling the width, and then we want the container where our fragment will go, filling the remaining space between the bottom bar and the top of the screen. And everything that we've learned in the previous 3 tutorials will help us do this. So as mentioned, in Android, the view that we need to provide our bottom navigation bar is called a capital B bottom navigation view with a V. You can go ahead and autocomplete that. We could do match parent, but let's do best practice. Let's do 0 dp for the width. Let's pin it to the start and the end of the screen. But the height we can do wrap content. And then we'll do a self-closing tag. So let's go ahead now and add the constraints that we need. We want it to be at the very bottom of the screen. So bottom to the bottom of the parent. And that will jump down there. And then for the width, we'll pin the start to the start of the parent, the end to the end of the parent. And because we have layout width 0 dp, because we're saying match the constraints, you can see in the design preview we have the blue outline showing us where our bottom navigation view will go. we're going to need to give it an ID, both to work within our code, but also to add the constraints to the other view that we're going to need. So let's do ID, and let's simply call this bottom nav for short. It's always good practice to start with your IDs as what the thing is, button, text view, etc. For some of the very long ones like bottom navigation view, rather than doing this, I think it is acceptable to do bottom nav. This is quite common in code from other developers that I've seen. Okay, so bottom nav and auto format. So the only other element we're going to need on the screen is a container to swap out our fragments. When we had a quick look at the template, they provided a widget with a lowercase f called fragment like this. We're not going to do it this way in this section. We're taking a more manual approach to this, which will be better for your learning. So instead, rather than a fragment with a lowercase f, we're going to use a simple frame layout with a capital F, frame layout, and we're going to manually put the fragments into this frame layout. So we will use match constraints for both the width and the height. So we'll do 0dp and 0dp. We will pin the top to the top of the parent, to the top of the container or the screen. We will pin the start to the start of the parent, the end to the end of the parent, but the key constraint, the bottom of the frame layout to the top of the bottom nav, and then a self-closing tag. And when I click on this and look to the right, I can see the blue outline showing me that that is filling the remaining space. So the bottom navigation view is there with a blue outline, and our frame layout is there, and that's where our content will go. That's where our app fragments will live. So the last thing we need to do is give this frame layout an ID. So we'll do ID, and we'll call this our frame underscore content. Okay? And believe it or not, that is all that we need to do for this layout. But the fantastic thing is we've managed to achieve it using constraint layout. And this is an absolutely key skill for you, the Android developer. So congratulations. So the next thing we're going to need to be able to get the bottom navigation view working and swap out our fragments is have the actual options in our bottom navigation menu, the running and the cycling, or whatever sports you want to put in your app, okay? So we need to provide these options to our bottom navigation view. And this is actually done using a concept called a menu. Inside the bottom navigation view, if you just make a new line and start typing the word menu with a lowercase m, okay, we could provide a menu in here. And like most things in our XML, it's a resource. It would be a menu resource file, a bit like colors.xml, a bit like strings.xml or styles or themes.xml, okay? But there's one step that we need to do even before creating our menu, and that is we need to create the icons, the small pictures that will represent the options. The most common pattern for bottom navigation bars is an icon with some short text underneath it. And fortunately for us, rather than going on the internet and finding some icons, which we could do, there's a way that we can add icons right here inside Android Studio, choosing from a fairly decent selection of standard Google material icons. So delete this app menu attribute for now. And if you go ahead on the left and click on Resource Manager, and you can see in our Resource Manager, the only drawables, the only images we have is the background for our app icon and the foreground, which is indeed a small icon. So we want for the sports app an icon that represents the sport. In this project, I'm going to be doing running and cycling. So the way you can do this, click on the plus symbol, and rather than clicking image asset like we did before to bring in pictures, this time we're going to click on vector asset. Before we click on this, a vector is a different type of picture. Rather than being like a PNG or a JPEG or a GIF with lots and lots of data, it's actually a file that looks a little bit like XML that puts coordinates on the page. Vectors, coordinates, so that Android knows how to draw it. And these vectors are used all over the internet, just a sequence of coordinates and colors and instructions for how to draw simple images. So we can create these simple vectors, these simple icons right here, right now. So click on Vector Asset. And you can see by default we have this clip art selected here, matching our IC launcher foreground that you can see on the left. Okay, so leaving the asset type as clip art, we can choose from some pre-existing clip art icons already bundled in with Android Studio. You could also go online and download an SVG file That's the format for most vectors online. You could go ahead and find some SVGs, some other vector icons, download them and then bring them into Android. Android then imports that in a slightly different format, okay? But we're not going to do this. We're going to use the clip art included inside Android Studio. So with clip art selected, double click the clip art there. And then you can see we have a big list of icons that we can use, okay? And if you then in the top left of this icon dialog search, we can type run for running. And I can see I've got a couple of options there. A stickman running and a stickman inside a circle. So I'm going to go ahead and select the one that's not in the circle. I think that'll look a bit better. So I'm going to click this directions run. And then I'm going to click OK. So now we have this icon, this vector of a man running. By default, it starts off all icons, all of these vector icons with IC for icon, then something that describes what the image is, and then the size in dp. We're going to leave the size as 24 dp. That is a really good size for most icons in Android Studio. I don't recommend changing this to be any smaller or indeed any larger if you're using it as an icon. But we can change the thing in between IC and the size for something descriptive to us. So I'm going to do IC underscore and just call it running underscore 24 for the size, okay? We'll leave the color as black, although later on our bottom navigation view will take care of tinting that to be different colors for when it's selected. So we've chosen some clip art, we've given it a more descriptive name, and then we click next, and we want to leave it in the main folder, so we can just go ahead and click finish. You can see on the left, the resource manager hasn't done a very good job of rendering our preview, but let's go ahead and add another icon for cycling. So plus vector asset, we'll double click the previous one of running. I'm going to type bike, and I can see I've got a few there, but I like the one with a person on the bike, so I will do directions bike, you can see there. Okay, I'll delete this silly baseline directions thing, and I'll just change that to cycling. So IC for icon underscore cycling underscore the size. Select next, and then finish. So we now have our two icons that we can use. You can use them in image views, you can use them on some buttons, but in the next tutorial we're actually going to build out a menu resource file, and we'll be using them in our menu. If you're curious as to what these vectors actually are, if you go ahead and click on either the cycling or the running one, if you double click it to open the file, you can see it's just some XML. You can see the root element is a vector. It's got some attributes specifying the size. And if I scroll horizontally, there's this very long path, which is a whole sequence of coordinates that tells Android Studio how to draw this, okay? This path data thing isn't anything you ever need to understand. If you want to go ahead and do some further research on what vectors are and how they work, you can do. It's not necessary to have a deep understanding of this, but it is important to know that we can use vectors in Android. And SVG, the standard format of vectors that you find when you download them online, they don't directly work in Android Studio. You would need to import it using the vector asset dialog, select the file, and then what Android Studio will do is it will convert it into this vector XML file. Okay? But in short, we can use these vectors for our icons and simple images in our projects, which is absolutely fantastic. So now that we have our cycling and running icons, we can go ahead now and create a menu resource, use these icons to show these in our bottom navigation view. So let's do that now. Go ahead and close any vector files you may have open from the previous tutorial back to activity_main and change the resource manager back to our project pane. So as mentioned, our bottom navigation view needs a menu resource. We set an attribute called menu and we give it the name of a file. And by default, it will look for these in a folder called menu inside our resources folder. So on the left, where it says res, and if for any reason you're not in the res folder, click the little target button to jump there straight away. If we look inside this folder, we can see we don't at the moment have any menu folder. So we need to manually create this. So right click on res and click new directory and simply call it with a lowercase m menu. So now we can right click on this menu folder and click new. And Android Studio is usually quite clever. If you look in the second one down, which is usually our resource file option, it's even calling this a menu resource file. It knows that because we're making this in a menu folder, it's going to be a menu file. So click this. And we can call this anything that will make sense to us. we don't really need to include the word menu as it's going to be in our menu folder. So I'm simply going to name it by where it's going to show. And this is going to show in our bottom navigation view. So I'm going to simply give it the same name, the same ID, bottom_nav. And that will be accessible from r.menu.bottomNav. So click OK. And for some reason it insists on giving us this design preview, which doesn't make much sense. I'm going to go purely to the code view. You can see that our top level tag, our top element is a menu tag. So inside this, we can add some menu items. So with a left arrow and a lowercase I for item, autocomplete. And we need to give this three things. An ID, so the code can access it, so the code knows what option's been selected. A title that will be the text, and an icon that will be the picture. So we'll start with an ID, and we'll give this ID, I like to start all navigation IDs with nav underscore and the name of where we'll be navigating to. So this can be nav underscore running. The title we will give it as simply running, and then the icon, so not src, not source, but icon, we can do ic underscore running and then autocomplete. And you can see in the left margin next to our line number, we have a little preview of our icon there, the running man. And then simply self-closing tag. We're getting a complaint because we've hard-coded the string running. Let's go ahead and extract this now. So extract string, and we'll just simply call the string running. Okay. And we will do another item for the cycling. So ID, nav underscore cycling, title, cycling. I'm going to extract this straight away, save a bit of time later. And then icon, drawable, IC underscore cycling. I can see that there, autocomplete. And that is all we need to do. We have made a menu resource file and different parts of our app can now use this. So let's jump right back into our activity underscore main layout and use this menu resource for our bottom navigation view and see what happens when we do. So back in activity underscore main. Now in our menu attribute that we started typing, if you type the word menu, you can see we get @menu, and then we have there our one option /bottom_nav. And when I autocomplete this, straight away it applies that to our bottom navigation view, even in our design preview. And you can see we have a nice preview there of the two options, including the first option running being selected with our primary color, the default purple. Okay, so if I just open the package for menu, that is a quick introduction to how menu resource files work in Android Studio. They're very straightforward, a bit like our strings, a bit like our colors.xml, okay? And in this menu, we can define as many items as we want with IDs, with titles, with icons, and then we can start to use them in our layouts, use them in our code. With our activity layout done and our bottom navigation having its menu now that we can see there with running and cycling, we are getting tantalizingly close to moving on to fragments, to learning about this new way of displaying our user interface, having portions of the screen not in an activity but in a fragment. However, before we do that, we do need to get reference to this bottom navigation view. So we do need to go to our main activity code and find this view on the screen. And there is something new that we now need to do. So let's move over to main activity. I'm going to press Shift and main activity. And now in this file, we need to find the view. So if you remember from the Kotlin section, I said one of the goodies of Kotlin was this Kotlin X synthetic thing, this Kotlin extensions plugin in our build.gradle file. In that Gradle file with that plugin, which we're going to have a look at in a moment, rather than doing find view by ID for every single view and having a class property, we could just type the ID directly. And that saved us a lot of time. However, in Android Studio, things change rather quickly. And this is now no longer the recommended way of doing things. Let me show you what I mean. If we can head over to our build.gradle file, it's inside our app folder and it's underneath the source folder. So if you're kind of at main activity, well, you just need to close the app folder, open it again and find this build.gradle file. Remember, it is the app build.gradle file, not the project one, not this one. So go ahead and launch this build.gradle file inside our app folder. Okay, and if like me you have any pop-ups at the top of the file, just go ahead and hide them. So I'm going to hide both of those. So we're in our build.gradle file, which at the bottom has our dependencies, our shopping list, okay, some app configuration stuff that we haven't looked at yet that we don't really need to worry about, and these plugins at the top, these things to make the Gradle system work. The thing that builds that app relies on these plugins. Now, in the Kotlin section where I showed you those shortcuts to find view by ID, where we can just type the ID directly, well, that was dependent on a plugin that was Kotlin-Android-extensions. And at the time, when I recorded that video, when you made a new project, you got that by default. Well, now, in a new project, Android Studio no longer gives us that plugin by default. And in fact, if you were following along with the course and you did it more recently, you may have got to that tutorial and had to have typed it in manually. I did mention if it wasn't there, you would have to go ahead and type ID and then Kotlin-Android-extensions. Okay, so I'm just going to delete this now for 1 second. So without that plugin, if I go back to main activity and I try to look at one of the views in activity_main, like our bottom nav, well, if I just start typing bottom nav now, lowercase b, bottom_nav, you can see we don't get any suggestions, any ability to import. This thing is not recognized. And it's not recognized because we don't have the extensions by default. So let's just for the moment go ahead and put this plugin back in. So let's do ID and then Kotlin-Android-extensions, just like in the tutorial where I introduced this. And once you've changed this Gradle file, you can click sync now, or you can click the elephant with an arrow. I'll click sync now. And now when I go back to main activity, I have the ability to import this, or indeed if I start typing, I will be suggested it as a autocomplete. And the second I do that, if I expand the imports, you can see we have this Kotlin X thing, this synthetic, basically our activity_main dot star, meaning all of the available things inside this we can now use. So if I go to the layout file, I could also refer to the frame_content. So I could type frame content, okay? But this leads us to a very important question. Why is Android Studio no longer providing us this by default in new projects? And there's a very simple answer to that. Android no longer recommends us to use this for a couple of reasons. It's what's called deprecated. They're saying, we're not going to support this anymore. We don't want you to use this anymore, really. We still can, it's not a problem, but there's a couple of reasons why. And the number one reason, and the reason which I'm going to cover in this tutorial, is the fact that it's not very safe. Okay, we can actually type an ID from any layout file, not activity_main. It would import fine, we would have access to that variable fine. When we click run, the app would build, it would launch, but then the app would crash at what's called runtime. It would crash when the app is running, and that's a big problem. So to prove this, I'm going to go ahead and make another layout file. You don't have to do this if you don't want to, although you can if you want to copy along. So I'm going to go to activity_main, and I'm going to click the target button to jump to the layout folder. Okay, there we go. I'm going to right click on the layout folder and do new layout resource file. And I'm going to call this something like activity_different_screen. So a different layout. I'll leave the constraint layout and I'll just stick one view, a text view. I'll do match parent, really lazy to do that in our constraint layout. I should use 0dp, but that's fine to do that. So with match parent, no need to constrain it to anything. And I'll do some text that just says my dummy text view, and I'll give it an ID. So ID text view different layout. Okay. If I now go back to main activity, yes, I have our bottom nav. Yes, I have the frame content that's in activity_main. But look what happens when I type text view different layout. I'm able to import it. So I'll go ahead and import this. And I can even do things with it. So I can do .text to change the text. And I'll just say, I'm trying to update the text on a view that isn't in main activities layout, ! Okay, so with these Kotlin X things, these synthetic access to all of our views that saved us loads of time, It saved us the ability to find view by ID all the time. Well, I've been allowed to access and indeed play with, use a view from a completely different layout. So let's see what happens when I try to run this app now. I'm going to go ahead and click run on the emulator. Do you see that? The app crashes. We get an alert saying that it keeps stopping. So if I now go to logcat, where we can see the errors, so logcat at the bottom, and make sure it's filtered by our app, so record keeper. If I change this to error, so error, and if I just expand this a little bit, we have a null pointer exception. Text view different layout must not be null. And it's at line 16. So this is the problem line 16. So we made an attempt to access this text view different layout. So this on its own didn't fail. But when we tried to call .text on it, well, this actually returned null. Android tried to look for this view ID on the screen and couldn't find it. It returned null. But then we're doing .text on something that is null. So this is what I mean, and this is what Android means by it not being very safe. So for this reason, they don't recommend we use Kotlin extensions anymore for finding our views. What I'll do just to prove this is show you how this is now deprecated. If I now head over to my browser, and I'll just do a very specific search for Android Kotlin synthetic. And straight away you can see it's actually suggesting us this deprecated thing. So people are discovering that this thing is suddenly no longer recommended. So we'll search for Android Kotlin synthetic being deprecated. And the top result that I get is this thing saying developer.android.com/libraries/migration. Migration meaning they're telling us to move away from Kotlin synthetics. So if I go ahead and click this, Kotlin Android extensions is deprecated, which means that using Kotlin synthetics for view binding is no longer supported. Okay, this doesn't mean we can't use it, but it does mean that if we want to be best practice, we should probably move away from it. Okay, I'm going to come back to this article in a moment to see what this new view binding thing is, this thing you can see here. Okay, but first I want to show you the evolution of how we find views on Android. It's gone through various stages. So back in main activity, I'm going to remove all of these Kotlin synthetic views here. Okay. So the first way would have been to make a property for each view. So private val bottom nav of type bottom navigation view. Okay, we're supposed to initialize it in Kotlin, so I'll make it a late init that we've seen before. So late init, we'll initialize this later, and then we can do bottom nav equals find view by ID, and then we can do r.id, the name of the view. This is the very first way we did it back in the earlier sections. We did it in Java, but we had a class property at the top, and then we did find view by ID. And I can do the same for the frame layout. So frame content, that's a frame layout, and I'll do the same thing. So frame content equals find view by ID. Okay, so this is the first and original way to find the views in our layout files and start doing things with them. And it's still fine to do this. You can go ahead and make a property for each view and then find it somewhere in onCreate. Okay. The problem with this is it's not very pretty. You end up with lots and lots of class properties, more and more for every view you have on your screen, and it doesn't make for clean and tidy code. Then somewhere between find view by ID and the Kotlin synthetic thing that we've seen before was a library called Butterknife. You don't need to worry about this, you don't need to look at this, but there was some popular developer who knows a lot about Android and now works for Google called Jake Wharton, and he made a library. And what you would do is, rather than doing find view by ID, you would just do some sort of annotation like override. So you'd put something like bind view, you'd give it the ID here, okay? And there would be one line that you would write somewhere in onCreate, something like this. And then that would take care of binding the views for you. So you would have still your class properties, but you wouldn't have to do find view by ID for every single view. You would just do one butterknife.bind this. That would save us a few lines, okay? And this became quite popular at the time. I'm showing this for you just as a brief history of the evolution of Android and evolution of best practice, okay? This library is also marked as deprecated, so Jake Wharton is no longer supporting this because there are better ways. But I just thought I'd show you that if, in case in your Android developer career you ever hear the term butter knife, or you ever work on any old projects which has butter knife in it, this was incredibly popular. So we'll remove this, and I'll remove the properties for now. So the next major way to use it was these Kotlin extensions, where you would just type the name of the view, so bottom nav, and away you go. Okay, that's now been deprecated. So what is the recommended practice now? Is this thing called view binding. So having shown you the history of how we find views on our screen, from find view by ID to butter knife to Kotlin X to this new view binding practice, we'll move on in the next tutorial now to how this view binding works. We'll confirm again why we should be using this, why it's safer. And then once we've learned that in the next tutorial, from this point in the course onwards, we will use the view binding approach, at least until something better or more recommended comes along. Okay? So let's do that next. Having just covered the history of how we find views in our code, all the way from the default find view by ID through to Kotlin synthetics, and then now to this view binding, it's time to learn how this view binding actually works. I'm back on the Android documentation that talks about migrating from Kotlin synthetics, which is deprecated, over to this view binding. So now I can see there's a link to the view binding here. So I'm going to click this and have a look at the documentation for the new view binding approach. So if we read this first paragraph, it gives us a pretty good overview of what view binding is. View binding is a feature that allows you to more easily write code that interacts with views. Once view binding is enabled, it generates a binding class. Okay, so it generates a bit of code for us. And this is for each XML layout file present in the project or module. Okay, so for every layout file we have, there will be a bit of Java or Kotlin code. An instance of a binding class contains direct references to all views that have an ID in the corresponding layout. And the last line there, in most cases, view binding replaces find view by ID. So we're going to go ahead and get this set up. We're going to follow some of the instructions below. And once we're done with this, there'll be one file, one bit of code, one class, and that class will contain all of the views that have an ID in that layout file. Okay? So if I scroll down to the setup instructions, I can see view binding is enabled on a module by module basis. Well, right now we only have one module. We just have our app module. Okay? We don't need to worry at all about multi-module projects. So we have our app module. So we enable this in the build.gradle file for the module. This is the app build.gradle file, the one we've just seen in the previous tutorial, not the project one, okay? So all we need to do inside the Android tag, which we're going to see in a moment. Okay, so you see the Android and the curly brackets. We need to add another little block in this strange groovy structure. This isn't Java or Kotlin, it's groovy. We need to add build features and then view binding true. So go ahead and copy this, build features, view binding true. Don't copy the dots before it. And I'm going to switch back to Android Studio. I'm currently in main activity, so I'm going to move over to build.gradle. You can see the app build.gradle, okay? And inside this Android block here, I'm going to add a new block. It's a block called build features. I can see I've got build types, default config, but no build features block. So outside all of these little blocks, I'll put it between default config and build types. I'm going to make a few line breaks, and I'm just going to paste in that build features block. So Control V, Command V. Okay, and you can see I've got build features, a curly braces block, and then this simple view binding true property. Okay, so with that pasted, I'm going to click sync now, or the elephant with the arrow. Sync that with Gradle. That will take a moment or two. Okay, so that is done. And with this property in our Gradle file, all of our layout files you see on the left there, there will be a corresponding view binding class. So let's go back over to the guide to see what we need to do next to start using this. It tells us if we have any particular layout file, if we want to not create a class, we can do tools, view binding ignore, but that's not important right now, so we can skip past that. In the usage, it talks about if it's enabled, then for every layout file, anything with an ID will be available to us. So here's an example of a layout file called result profile with a text view, image view, and a button. And the text view and the button has an ID. So the layout file is called result_profile, and the generated binding class is called, with a capital R, result profile binding. So it converts the snake case into uppercase words, okay, and adds the word binding. So result underscore profile becomes result profile binding. Activity underscore main becomes activity main binding. That's the pattern, okay? And inside this class, inside this generated bit of code, thanks to that thing we put in our build.gradle file, inside this binding class, there will be a field, a property for every view that has an ID. So in the example above, the text view and the button has an ID, so there'll be two fields, a text view called name and a button called button. But because the image view has no ID, then there's no reference to that in the binding class. So that's the key thing to remember, that everything that has an ID, it will create a corresponding binding class with those fields, with those properties available to us, which is fantastic. So if I scroll down now to using this view binding activities, I can see we need to make a property called binding, and they're using the lateInit variable, which is fine, we'll do the same. So a lateInit variable called binding, or called whatever you want, and it's of type your layout file plus the word binding. So for us, activity main binding. You'll see this in a moment. We then assign this in onCreate, and all we do is we take the name of the class, so result profile binding, activity main binding, .inflate, and we pass in an argument called layout inflator that's available to us in all activities. So this is the key line, okay? And then once we've created that binding class, that binding variable, we set content view on binding.root. The root of this class will be the view. So this set content view, that variable, is binding.root. Now some of this might seem a bit confusing, so rather than looking at the documentation and trying to picture it in our heads, let's go ahead now in main activity and switch over to using view binding. So back to Android Studio and back to main activity. So I'm going to remove the bottom nav Kotlin synthetic thing. I'm going to remove all of those unused imports, okay? And the first thing I'm going to do is create a single class property called binding. So private lateInit var, I'll call it binding, nice and simple. And if we look on the left in the project pane in our layout folder, the layout file is called activity underscore main. So can you have a think about what the name of the class would be? Activity main binding. So capital A, activity main binding, and you can see that's available to us, so we're going to autocomplete. So this is a generated bit of code that comes from that view binding thing. From this here, it's generated for us. If I jump over to activity underscore main, I can see I've got two things with IDs, the frame layout called frame content, and the bottom navigation view called bottom nav. I can see that both of my IDs are in snake case with underscores, but just like our binding class name, just like this activity main binding, all of those views will be created to uppercase or camel case for our properties. So going back to our guide, I can see the next thing I need to do is assign the binding variable. So binding equals the name of the binding class, .inflate, and then we pass in a layout inflator that's available to us in activities. So I'll do the same thing. So I'm going to delete set content view. We're not going to do it this way with a layout file directly. So delete that, leave super.onCreate, and we'll do binding equals activity main binding. And you can actually autocomplete one of the two inflate methods. So I'll go for the first one, the one that says layout inflator. So activity main binding.inflate, and then all we pass in here is a layout inflator. And if you start typing with a lowercase l, layout, and capital I inflator, this is available to us in app compat activities, part of inheritance. We have access to this. So autocomplete that, and that is done. In this onCreate method, we will take that layout file and we will inflate it. We will read the XML and create that binding class. But this won't put it on the screen. It will only put it on the screen when we do set content view. So underneath this binding assignment, type set content view again, autocomplete. Now if I look there at the hint, I can either pass in at the very top a layout resource, layout res ID. That's what we have been doing, remember, r.layout.activity underscore main. So that's the old way of doing it. But we can also pass in a view, an inflated view. This is what happens to our layout files once they're inflated. They become a view. So we've inflated this activity main binding thing. We've inflated that layout file. All those views are ready to use. And if we go back one final time to our documentation, we can see there is a property on these binding files called binding.root. And you can see here, we can get a reference to the root view. That's the whole layout file, the top element. We can do this by calling getRoot or just doing .root. Okay, so that's what we need to do. So we can create a view variable by doing val view, and that's equal to binding.root. And then you can pass in that view variable. Okay, and actually the local variable is not even needed. We can delete this and just type into here binding.root directly. Okay, so the final thing I should do to prove that we have access to all these views is show you. So binding dot, you can see the first two suggestions are the two views we have available, our bottom nav and our frame content. And you can see it's done that as camel case, so lowercase b and a uppercase n, frame content with a lowercase f. And if I go to my activity_main, we can see the IDs were in snake case, as this is the recommended way of doing it in layout files. So just like activity_main gets converted to activity main binding with capital letters, well, our properties get converted to camel case. So frame content bottom nav becomes frame content and binding.bottom nav. So just for a moment, let's talk about why this is so good. Why is this such a useful and safe and important way of doing things? Well, first of all, we don't need to have class properties for all of our views. We don't need a private bottom nav and a frame layout. We don't need to have a variable for all of our views, like with the find view by ID method. Okay, all we need is one variable, the binding. Okay, and inside that binding will be every single view that has an ID. So this gathers up all of our views into one variable. So that's the first useful time-saving feature. The second thing, which is to do with safety and not causing crashes, unlike with Kotlin X synthetic, where you could type a ID from any layout, even one you're not using, and then if that layout happens to not be the one that's inflated, that happens to not be the one on the screen, then it crashes. Well, because we're setting the content view to be the binding.root, this activity main layout file, we can be absolutely 100% confident that all of the views are inside this layout file. It is not possible to have reference to a view that is not in this layout file. If I try and do binding.text view different layout, remember that ID from the different screen, it's just not in there. Okay, you will only have access to the fields and views that are in the file. And the final thing which makes this really safe and really secure is the typing. Okay, so remember with find view by ID, we would have to specify the type. So we'd have to do something like find view by ID and say it was a text view. Okay, but it would be actually possible to say the bottom nav was a text view, even though it's not. And that would cause a crash. So it's what's called not being type safe. Okay. We have no way of knowing if this bottom nav ID is a text view or not. However, if I assign these to local variables, I'll just call this bottom nav, and I'll call this my frame, okay? And if I do a nice little Android Studio shortcut where I'll Alt Enter or Option Enter on frame, and I can say specify type explicitly, okay? You see how it auto-completes frame layout and how this auto-completes bottom navigation view. These properties, binding.frameContent, binding.bottomNav, Android knows it's a frame layout. It knows it's a bottom navigation view. So it's what's called type safe. We are guaranteed to have all of the views and only the views inside activity main, inside this binding variable. And we're also guaranteed to have the correct types, frame layout, bottom navigation view. And it's for this reason that Android Studio now recommends that this is the best way to handle setting your content view and handling the finding the views, the find view by ID thing. Okay. And just to prove this works, let's go ahead now to our activity main and just put a text view on the screen and change the text in code. So I'm going to delete these local variables here. I'm going to go to activity_main. I'm going to comment out the frame content for now. I'm going to get rid of that for a moment and just add a text view. Match parent, we'll do gravity, we'll send to it so it's in the middle of the page. I'll do some preview text using tools. So I'll say example text, so we can see on the right where it will show. And of course, I'll give it an ID. So with giving it an ID, text view example, we will have access to it in our binding variable. So if I go back to main activity, I can do binding dot text view example. We have access to it and it knows it's a text view. So I can do dot text and it equals to we can now use view binding. Hooray. And if I go ahead now and run this app, we can see we can now use view binding. Hooray. And the binding and the set content view, it all works as expected. So as mentioned in the last tutorial, from this point forwards in the course, I will be using view binding wherever relevant, both in activities and shortly also in fragments. Okay. However, you are free in your own personal projects to choose whichever method of finding the views works for you. If I just go back to Android Studio, you might want to just do a variable for every view. Okay. You might do something like later init var and then just assign them later one by one. Find view by ID, r.id.bottom nav. That would be fine to do. You might decide you don't want a class property, a field for every single view, and you liked the Kotlin X thing. So that would be fine. You would go to build.gradle, you would put in plugin ID Kotlin Android extensions, and then you can just type the variable directly from the file like this, exactly as it is. And as long as you're sure you've got the right layout file and you've tested running the app and there's no crashes, that would be fine to do. So feel free to carry on using Kotlin X synthetic. Just because it's deprecated, just because it's not recommended by Android Studio, that doesn't mean you're not allowed to use it. That is your choice, okay? But if you want to be completely up to date, latest best practice, then the best way is to use this view binding. So I'm going to remove the Android extensions for now. Sync with Gradle. So when I go back to main activity, this will cause some errors. You can see that's no longer available. So I'm going to remove that. I'm going to remove all of the unused imports and this bottom nav thing. So if in your build.gradle you have build features view binding true, then you will automatically have this binding class for every one of your layout files. This is how we inflate it, and you'll see this over and over again from this point forward, so you'll soon get used to this. And it's just 2 lines. Assign the binding variable with .inflate, and then set content view with the binding.root, rather than the layout file directly. That's all we need to do. Once you've done that, you have all of your views available in the binding variable. Super safe, super up to date, and in my opinion, the best way of doing things. So I'm going to go ahead and remove the text view example. I'm going to go back to activity main. I'm going to undo creating the text view, undo, and undo commenting out the frame layout. Okay. So we now have our bottom navigation view using view binding, ready to start playing with and getting it working with fragments. So in the next tutorial, let's finally look at what fragments are in Android Studio and how they work. It's time now for our introduction to fragments. We've previously learned how activities work in Android, how they are the window, the container where all of our app user interface, the app UI, goes. And indeed, activities are our entry point to our app. You need to have an activity to be able to use your app. So then, what are fragments and where do they fit in? Just like previously when we learned about activities, the best place to start when learning a new major concept with something in Android is to actually look at the official developer documentation. So just like with activities, I'm going to head over to a browser, find the documentation, and then bring in the key points into this presentation so we can explore them further. So I'm simply going to search for Android fragment, just like that, and then enter. And I can see at the very top I have developer.android.com/guide/fragments. So this is the introduction, the guide that we want to be looking at. And then we can see in the center our introduction to fragments. So just like with activities, the introductory paragraph sums things up pretty nicely for us. A fragment represents a reusable portion of your app's UI, user interface. A fragment defines and manages its own layout, has its own life cycle, and can handle its own input events. Fragments cannot live on their own. They must be hosted by an activity or another fragment. So we'll stop there. What we'll do is we'll bring those 3 major points into our presentation and then go through them one by one to explore what they really mean. So, bringing those points from the Android documentation into our presentation. First of all, a fragment represents a reusable portion of your app's user interface. And I've gone ahead and underlined the word portion there. So it's key to understand that unlike an activity, which is the whole window, the whole screen, and that you can't have 2 activities on screen at once, a fragment can be used to be just a portion of the screen, a portion of the user interface. It is possible to make it fill the whole screen and be the entire UI, the entire user interface, but often you will see it used as a portion of the screen, whether the main content area above our bottom nav as we're going to be using it, or perhaps even 2 fragments side by side, okay? So, similar to an activity in that it contains a UI, it contains a user interface, but different in that it can be used, as the name suggests, to be a fragment, a portion, a small piece of the screen. It does not need to fill the whole screen, although it also can definitely be the whole screen if you set it up that way. Okay? The second point. A fragment defines and manages its own layout, has its own life cycle, and can handle its own input events. We'll be talking about life cycle later on in this section, where we look at the activity life cycle, and then indeed by extension the fragment life cycle. Okay, we've seen some of these methods before with the onCreate method in the activities. But very much like an activity, a fragment is a self-contained class, a file, which can use its own layout file, have its own views on the screen, like buttons, text views, edit texts. It is a self-managing thing. Once it's on the screen, a fragment is totally capable of managing everything in that fragment's layout file, just like an activity. And the third point, fragments cannot live on their own. They must be hosted by an activity. And I've just put in brackets, or another fragment. You can have a fragment with a child fragment, but we're not going to worry about that for a while. So, taking this point that they must be hosted by an activity, it's not possible to move from an activity to a fragment, and that the fragment is just the screen, the window. Fragments don't have the mechanism to create the window and then set a content view on that. The way that fragments work is they live within an activity, or other fragment. So there'll be some activity on the screen, like main activity or another activity, and there'll be some sort of container on the screen, a frame layout or some other kind of view group, and the fragment is added to that container. It's also possible to add the fragment directly in the XML layout file. That's possible too, but most commonly there'll be some sort of container in the activities layout, and the fragment is added to that activity. And then when it's added to that container, the fragment is hosted by the activity. It is attached to the activity, okay? But a fragment cannot live on its own. It always lives within a parent activity, and that is an absolutely crucial concept. So let's show these points in a little more detail. So a fragment represents a reusable portion of your app's UI. If I head back over to the documentation now, there's a pretty useful image that Android have given to show what this means in practice. So if I scroll down under the heading called modularity, it talks about modularity and reusability. And when we scroll down, we see 2 examples, one with a large screen device like a tablet in landscape mode, and one with a small screen device like your typical phone. So if I go ahead and take that image and bring it into our presentation, okay, so we can see large screen on the left, small screen on the right. So the whole phone window, the blue and the green shaded box together, the whole window, that will be our app's activity. And in the activity there may be some kind of component to help navigate, and that is shown in blue, activity navigation UI. On the left it looks like a drawer layout, some kind of side panel on the left with our options in a vertical list, and in the phone layout on the right, that activities navigation user interface, it looks like a bottom navigation bar, like we'll be using in our project. So the activity will have some way to navigate through the app, but then the green shaded area represents where our fragment will live. There'll be some kind of container filling that space, much like we've already done with our activity mains layout. We have a frame layout, a content frame, And as you navigate through the app, as you tap in the activities layout on that blue navigation component, then the fragments get swapped out. They get added and replaced in that content frame. So in this case, the fragment is just a portion of the screen. The activity is responsible for all of the screen, and that often contains a way to navigate and then the space for the fragment to live. So a reusable portion or fragment of the screen of the user interface. It also says that a fragment defines and manages its own layout, has its own life cycle, and can handle its own input events. So to show clearly what this means, the best thing to do will be to go to our project now and use Android Studio to create a fragment for us and see what code we get given when we make a fragment. So let's do this now. So back over to Android Studio, and as you can see, I'm in main activity and I've closed down all of the files. So just like with activities, we can create a fragment from scratch just by making a new file, or we can let Android Studio create a fragment and the layout file for us. So we'll do this now and see what Android Studio gives us. So I'm going to right click in the project pane on the package folder where it says Record Keeper. I'm going to go to New, Fragment, and just for fun we'll look at the gallery to see what options we have. Okay, so a bit like our Add Activity wizard, we have a whole lot of options here. Google Maps, Login, Setting Screens, okay, some quite useful modern user interface options. But just to see what the basic default template for a fragment is, we'll click Fragment Blank and then Next. And then we can give the fragment a name, and also we can give the layout file a name. So just like with an activity, when we make a new fragment, we also make a layout file alongside it. So I'm going to leave this as blank fragment, and I'm also going to leave the layout file as fragment_blank, and leaving the source language as Kotlin. I'm going to click Finish. And then if I look at the top, I can see I've got two new files, a layout file called fragment_blank and our blank fragment. Now, there's a whole lot of junk and comments and to-dos that you can see on the screen generated in our template fragment. To be honest, these slightly confusing extra bits of code, Android Studio have been throwing these in with new fragment templates for many years, and I find them terribly unhelpful. I remember years ago when I first got Android Studio to make me a new fragment and I saw all this stuff, params, green comments above the class, to-dos, all this kind of stuff here. I found it really intimidating. So what I'm going to do is I'm going to delete all of the extra bits that we don't need. Also, depending on what version of Android Studio you have, there may be some extra things here, or there might be some less things here. So we'll delete everything that we don't need. So above class, I'm going to delete the green comment above class. Okay. I'm also going to delete these two private const val args. So go ahead and delete everything between class and import. I'm going to leave the onCreate method, but I'm going to delete this arguments block. So just leaving super onCreate. I'm going to delete these params at the top. Okay. I'm going to leave onCreate view, but I'm going to delete all of this companion object. We don't need this at all. So everything apart from the bottom bracket, I'm going to delete all of this. So actually, the only thing we really need is onCreate view. Now I've left in the onCreate method just to show you how we have similar methods to our activities. In main activity, we have an onCreate with a saved instance state. Well, we have the same looking method in our fragment, okay? But actually, we don't even need the onCreate method. So I'm going to go ahead and delete the onCreate method. And all we really need is our name of our fragment, the fact that it extends the fragment class, okay? So a blank fragment extending fragment, and then the onCreate view here. So fragments are very similar to activities. They need to extend the correct class, fragment for fragments, app_compat activity for activities, okay? We extend fragment and we have some what's called lifecycle methods like onCreate, but the one we really care about for fragments to set the layout file is this onCreate view method. Slightly different to our onCreate method in activities, okay? We've got this inflating thing where we inflate the layout, and we'll be learning how to use this in a later tutorial. So actually, deleting all of that extra junk that the template gives us, we see actually that fragments are quite simple, just like activities. So I'm going to go back now to our presentation and just bring in an example of what the code looks like. Okay, on create view, we've just seen that. And I've shown you another method on view created, which is the place where we can get reference to our views. Okay, I'm doing find view by ID here. It's also possible to use that view binding that we've seen just recently. So very similar to activities. Fragments define and manage their own layouts. You can see the layout file there. It's got its own lifecycle with those lifecycle methods on create view, on view created, and those methods are called automatically, similar to the way activities work. And fragments can handle their own input events. You can see that I'm updating the text on the text view, and that will work just fine. So they are self-contained, self-managing portions of the screen that behave very similarly to activities. And our final point is that fragments cannot live on their own. They must be hosted by an activity or another fragment. So just showing you what this looks like under the hood in practice. So if we have our phone, and the red box there represents our activity. Okay, so we have a new activity, and that is created. And inside that activity's layout is a container, a frame or a container where we can add our fragment. And I've marked that in yellow. So activity in red, and then inside the activity there is a container, the fragment container in yellow. So to get the fragment to show on the screen, to make the fragment work, the first thing we do is we add a fragment to a container in the activity. So we would make a new instance of our fragment in code, and once we had that fragment variable, that fragment reference, we would add the fragment to that container. Once we add it to the container, the fragment will attach itself to the activity. So under the hood, the Android system will deal with the fragment being connected, attached to the activity, and attaches the correct word. Once the fragment is attached to the activity, the lifecycle method onCreateView is called. And again, this is all automatic, just like with the activity onCreate method. So once we've attached the fragment to the activity, onCreateView is called, and it looks a bit like this. Okay, we've seen that in our blank fragment just a moment ago. And then once this happens, once we inflate the layout file, the fragment is visible on the screen, and then it behaves much like an activity and the user can interact with it. Okay, but a fragment cannot live on its own. You cannot just launch a fragment from an activity directly. The fragment must be within an activity. That is the key thing to know here. Fragments are hosted by an activity. They are attached to an activity. So that's the quick high-level view of how fragments work and what they are. Just to give you now a few examples of how these are used in the real world. So one of the main ways they're used is to create smooth navigation through an app. So some examples of what I mean by this. There may be a bottom navigation bar, an activity that has a bottom navigation bar and then a content frame for the fragments. And as the user touches the options on the bottom navigation bar, the activity will swap out the fragment. And that gives the user the feeling that they never really leave the screen. They're in one screen, one place. They can move between different portions, different fragments of the app, but they never feel like they're really leaving or going anywhere. If you did this with activities, it would put one activity on top of the other, on top of the other, on top of the other, and the user would really feel like they were getting further and further away from where they were. And then once the user drills down into lots of activities, it's quite hard to then break out of there and go to one of the other bottom navigation options. So by having a bottom navigation bar in the activity and swapping out that fragment in the container, it creates a really smooth flow for the user. Similarly, there's the apps that have a drawer, the hamburger icon in the top left. They can tap the hamburger icon, choose one of the different options. Tapping one of those options will swap out the fragment in the container, but the drawer will still be there. The user won't feel like they've gone anywhere. They'll just feel like they've moved to a different portion, a different fragment of the app. Okay? And then another very, very common one is the view paging, like when you're reading a book. These are the user interfaces where you can swipe left and right and it will drag the next page or the next bit of UI into view. Okay, and that's called view paging, where you swipe through pages. Again, those pages are represented by fragments. So when you swipe left and right, it doesn't feel like the user is going anywhere. It feels like they're staying in one place and they're just moving different bits of the app's user interface into view. So fragments are very commonly used to create this smooth navigation flow, so the user doesn't feel like they're leaving the main top part of the app, but also giving the user the option to choose small pieces, small portions to be in view at a time. The home screen, the feed, the options, the profiles, that kind of thing. Fragments are also used to separate screen logic into different classes and files. It would be very easy to put all of the logic for our app in one giant activity and have all the logic of the screen in one file. Well, if you have different portions or one or two portions of the screen separated into fragments, it breaks the code up a little bit. It makes programming the app and reading the code a little bit more digestible. You might have the code for the account fragment in one file in one class. You might have the code for the news feed in another class. So rather than having all of this in one God activity class, you have it in little bits and pieces, and this is recognized as being good programming practice, separating the concerns, having things self-contained and self-managing in smaller files and classes. And finally, another way this might be used is to have certain UI elements persist throughout the screens. For example, you might have the profile image in the top right or the top left. You might have the app logo that stays on the screen the whole time, or settings icon, etc. Okay? You would put these elements in the activity, perhaps on top of the fragment container, on top of where the fragments will live, and then as you navigate through the different fragments, those activity UI elements, like the profile image and the settings icon, they will be visible the whole time, even though you're moving to different screens. Okay? So that's 3 pretty strong reasons for how and why fragments are used. All of this will start to make a lot more sense as we start to use it in our app. So let's go ahead now back to our project and start to add these fragments into our app. We've now learned the what and the why of fragments. It's now time to learn the how by jumping in and adding our first fragment to our activity. So I'm currently in main activity. I have blank fragment and the fragment blank from the previous tutorial open. I'm actually going to close these 2 tabs and delete those 2 files because we don't need them. So if you want to go ahead and right click on the layout file, fragment_blank.xml, and then delete, and then OK. If you get any warnings saying that the file appears to be in use at all, just ignore those and go ahead and delete it. So right click, delete, OK, so they're both gone. So the first thing we're going to need to do is create our first fragment, and we'll start with the running fragment, the first fragment on our screen. But before we go ahead and create the fragment class and the layout file, let's go back over to our documentation and have a quick look at the setup guide, as there's 1 or 2 things we should do first just to make sure it works properly. So back on the guide, you can see on the right there's a getting started section. So when I click this, I can see there's a link to create a fragment. So we'll click this. We've got our introduction again, and then it says set up your environment. Now if I scroll down a little bit, I can see we have a dependency to add a Kotlin one there. Okay, but we also have reference to the project build.gradle file. That's the other file called build.gradle that's in the very top folder in our project. So we'll take a look at that as well in a moment and just talk about what it is and what that does. But just on the dependency, which we're going to add in a moment, you can start using fragments without adding this dependency here. You saw in the previous tutorial, I was able to create a blank fragment and extend from the fragment class. Okay. However, this fragment:fragment-ktx dependency, it's going to give us a couple of extra things that will be quite useful to us. It will make adding the fragment to the transaction a little bit easier, and later on we're going to upgrade our frame layout where we add our fragment to something a bit better, a bit more robust, as shown in the guide later on. So this dependency, not essential to get going with fragments, but we're going to go ahead and add it right now to make sure that later on when we start doing things like adding the fragment and adding it to a specific kind of container, that we've got everything we could possibly need to do that as easily and as securely as possible. But before we add the dependency, let's have a quick look at this project build.gradle file. As you can see, it's telling us to add inside this repositories block in the build script block, this Google thing, and to also add it in the all projects repositories block, add this Google thing with brackets. Now, pretty much any new project you make in Android Studio is already going to have this, so you're going to see in just a moment how we actually don't need to add anything, that this Google bracket thing is already in there. However, we will jump over to this file in Android Studio just now, we'll take a quick look at it, confirm that we can see our Google thing in the repositories blocks, and add it if for any reason it's not there, and just very quickly talk about what this project build.gradle file does, just so you've got a very basic understanding. as we've been having to avoid it over and over again in this course, as it's not really something we change too much, but it'd be good to know what it is and what it does. So let's go over to Android Studio now. And on the project pane, if I close the very top folder and then open it again, so that's our root folder. And at this very top level, you can see we have a build.gradle file. So go ahead and open this, what's called the project level build.gradle file. Okay. And just for comparison, if you go ahead now and open the app folder, the app module, and then go ahead and open that build.gradle file. So we have them side by side. So build.gradle record keeper, if I just scroll to the top, and build.gradle app. And again, I'll scroll to the top. So selecting the one with our project, build.gradle, and then in brackets, the name of our project, record keeper. If I look at this, I can see there's a build script block here. Inside this, I can see there's a repositories block, and I can see I've already got Google, so there's nothing to change there. And again, if I look down, I can see there's an all projects block. Again, there's a repositories block inside this, and again, it's got the Google brackets command there. So nothing to change here. But in very simple terms, let me explain what this file does. You've heard me mention a few times before in our build.gradle file for the app, if I scroll down to the dependencies block, that these dependencies are a bit like ingredients. They're a bit like our shopping list, the things we need to go out and get to make our app. Okay? Well, if this is the shopping list of ingredients of things we need for our app, well, if I move over now to the project level build.gradle, these repositories are like the supermarkets, the shops where to get those ingredients. Okay? We define here a couple of places, a couple of repositories, a couple of supermarkets where all of the libraries are saved and stored. Google, JCenter. These are the supermarkets, these are the shops. We have to have something here. Otherwise, when we get to our app build.gradle file, well, the app doesn't know where to look to find these dependencies. It doesn't know where to find the items in this shopping list, okay? So, one last time in the project build.gradle file, we rarely need to touch this. Pretty much when you make a new Android Studio project, this is going to be set up ready with the two main repositories, Google, JCenter, the two main supermarkets, the two main locations where all of the libraries are saved. So if you ever see a guide to installing a new library, whether it's fragments or something else, and it talks about adding things to this project level build.gradle file, it's usually telling you where those dependencies or that dependency is located. Okay? So now we know we're going to keep avoiding this build.gradle at the project level file. So we can close this down. And I'm now in my dependencies block. So I can head back over to the guide and I can copy the Kotlin line here. Don't do the Java one, copy this Kotlin one. No need to copy the comment, just the line, copy. I can see it says $ fragment version. So that variable refers to 1.3.3. So if I just copy this and paste it underneath the other implementations, just paste it there. And then rather than copying in this variable here, actually I'll just type 1.3.3 directly. So I'll delete $ fragment version and type 1.3.3 and then sync now. Okay, so that is now done. So I can close the build.gradle file and we're now ready to start adding the fragment, adding the layout file. And because we've got that dependency, later on in this section, there's a few extra things we can do that make things just a little bit easier. It's not essential, that dependency, but it is if you want some of the shortcuts that are coming later on. So the first thing I want to do is make the fragment class, and we're going to make it from scratch now. We're not going to use the template for fragments anymore. It just throws in too much junk and extra bits that we don't need. So I'm going to click the target button to jump to where main activity is. And next to it, I'm going to make a fragment. So right click on the package, new Kotlin class or file. And I'm going to call this our running fragment, ensuring it's on class, and enter. And then the first thing I'm going to do is extend the fragment class. So colon to extend in Kotlin classes, fragment brackets. Okay, I need to import that and ensuring it's the androidx.fragment, not the crossed out android.app one. Okay, so androidx fragment, import, and that's all we need to do for the moment. Next, we'll go ahead and make a very simple layout file. So I'm going to open the resource folder, open the layout folder, and I'm going to right click and do new layout resource file. And I'm going to follow the Android conventions. So the name of the class in reverse. So what it is a fragment underscore and then running in snake case. I'll leave the root element as a constraint layout. We know how to use that now. Okay. And just to prove that this works, as we'll be running this on the emulator in a moment, I'll put a text view. So I'll do text view with wrap content. But to make it in the middle of the screen so it's nice and clear, I'll do those opposing constraints. So if I do top to the top of parent and bottom to the bottom of the parent, that'll center it vertically. And if I do start to the start of the parent and end to the end of the parent, that'll center it horizontally. So if I just add some text, I'll say, hooray, now I can add fragments into my apps, exclamation mark. I'll do a self-closing tag and an auto format, and if we look to the right, we can see we have a centered text view. Good. So, moving back to the fragment, if this was an activity, we would override the onCreate method and then call setContentView. If I just show you a main activity, onCreate, we definitely do the call to the super.onCreate, and then we do setContentView somewhere. That's how we get the view on the screen. Well, as shown in the Introduction to Fragments tutorial before, the way we do it in Fragments is we override not onCreate, but onCreateView. So if you go ahead and type that and autocomplete, and that will bring in the onCreateView method. We've got 3 parameters, inflator, container, and saved instance state. It's put them on different lines because it's quite a long list of parameters, so that's fine. And then we have a colon to say that this method returns a view, a nullable view. So we're going to go ahead and delete the initial return where we return the super onCreateView. So go ahead and delete that. And we now need to inflate the view ourselves and then return that view. So the way we inflate our layout file, a little bit like we've done in our recycler view before, we use this layout inflator. So we've already got access to the layout inflator. It's one of our method parameters. So if I type inflator above, autocomplete, and there's a method on that called .inflate. And then if I look at this hint, there's 3 things I need. I'm looking at the third one down, a resource, a layout resource, a root to add it to, and then there's also attached to root, a true or false value. And we'll get into that in a moment. So first things first, let's add our resource layout file. So r.layout.fragment running. So we tell it what layout file to look at, what layout file to read, and then create views from. So we're going to inflate that file. We have a container already in our parameters. You can see above, container, a view group. That will be the container from the activity. So that frame layout, that's the thing we're going to be adding it to. Okay. So we'll go ahead and do the same container we have available, container. This will be given to us when onCreateView runs. But it's very important that for this attached to root, that we actually set this to be false. And you might be wondering, why do we do that? Well, the notion of this fragment being attached to something, this happens in the activity. Okay, we inflate it into this container. We put the fragments layout into the container. But actually, the fragment becomes attached to the activity, not to this container. Okay, if that sounds confusing, I totally understand, but there's a bit of behind the scenes stuff happening when in the activity we add this fragment to the container. But the fundamental thing is that the fragment is attached, hosted by the whole activity. It's not attached or hosted by this container. It's not attached to the frame layout. Okay, so we must say false. I've had many a time where I've done true and the app's not worked and I've not been able to understand why. So all of this line, this inflator.inflate, where we pass in the layout file, the container to inflate it to, and saying not to attach it to this container, that will return a view variable. So if I do val view equals inflator.inflate, well, now I have my view, so I can simply do return view, and that will work. And actually, because I don't do anything with this local variable other than return it, Kotlin is suggesting why not just return it inline. So I'll go ahead and do that. Alt Enter, Option Enter. I'll take their suggestion, inline variable, return, and then this line of code. And that is all we need to do inside our fragment to inflate that layout file and make it visible on the screen. So now we are ready to attach this fragment to our activity. So go ahead now to main activity and we'll do the final bit of code. So I'm going to remove the binding.bottom nav. Now there's a slightly complicated looking bit of code to do with fragment transactions. So what we'll do in this tutorial is quickly do the code to see how simple it is, how straightforward it is. And then in a later tutorial, we'll dig in a little bit more to what a fragment transaction is, what's happening behind the scenes, and the different things we can do with a fragment transaction. But the code is quite simple. So first of all, we need to get reference to the fragment manager. Every activity has a variable, a thing. It's inside this. It's part of the app.compat activity class, and it's a fragment manager, and it's actually called the support fragment manager. They updated it a few years ago. So support meaning it's backwards compatible for older versions of Android. So the support fragment manager, that's a variable we have access to. And now, because we've added that dependency to the fragment library, we have a lovely little shortcut that makes the code a little bit easier for our fragment transaction. All we need to do is do .commit. Okay, if you don't have access to this method, if nothing comes up, make sure you sync your project with Gradle files. Make sure you've synced up that dependency. You can click the blue elephant at the top right, okay? But if you've done that, you'll have access to this shortcut called commit. And you can see that we have a prompt saying it's a fragment transaction, and we'll talk a little bit more about what this means and what this does later on. But now we have this block, we can simply type add. And then we can add as part of this transaction, as part of this thing, where we attach the fragment to this activity by adding it to the container, we can simply add a new running fragment here. So we only need two arguments here, the container ID and the fragment itself. So you might think, oh, well, we can do binding dot and then the frame content, but actually it needs the ID. We can't use the binding class. Okay, so this is one instance where for now we just do need to type in that ID manually. So we'll do r.id.frame content. It needs to be a layout resource ID. So this fragment transaction will look and try and find that in our view. And then the next thing it needs is a new instance of the fragment. So we can simply do running fragment and make a new object like that. So a little bit different to activities. We never make a new instance of main activity. We would never do this. Okay, activities are done automatically by the system. But with fragments, we do need to create them ourselves. Okay. So here, I'm just making a new instance of running fragment. So in this small piece of code here, we've gotten reference to the activities fragment manager, the thing that can handle fragments and all the things that happens with that. And we've told it to commit to do, basically, a transaction. We've told it to add to this container, our content frame, our frame layout, this new fragment. Simple as that. And when I run this on the emulator, we can see our fragment added to the layout. Fantastic. Okay, so for a quick recap, the four things we did here: we added a new dependency to make sure we get access to some of the shortcuts, including that lovely little commit shortcut. You'll see in a later tutorial where I'll talk more about fragment transactions, how that's saved us a little bit of code. Okay, so we've added the dependency. We made a new fragment and extended fragment. We made the corresponding layout file. The way we get that to show in a fragment is with the onCreateView method. We override this and we do this inflator.inflate line, a bit like we've done before in our recycler views, just manually inflating a layout file from scratch, kind of what happens in set content view under the hood, but we just do it ourselves. And then in main activity, we do a fragment transaction, and we have this lovely little shorthand where we access the fragment manager, call .commit, and then inside this block we can do things, do transactions. And the transaction we want to do is add. And when we commit this, when we run this code, the activity knows what to do. It takes our new fragment, it adds it to that container, and then it attaches it to the activity. It is kind of bound to the activity attached. So that's the 4 steps to adding fragments into our activity. Fantastic. We now know how to add fragments to a container, to a view group like our frame layout. So the next thing to move on to is switching between fragments. changing what's on the screen when the user changes the destination. Now, the way we respond to a user clicking on the bottom navigation bar, there's a bit of extra work there, or certainly it's a new concept than just our standard button click listener. And the focus of this tutorial is to learn how to switch fragments, how to swap them out, not so much the bottom navigation view and how we respond to clicks on that. So what we'll do very quickly in this tutorial is we'll just stick a couple of basic buttons in the layout towards the bottom of the screen near our bottom navigation view, just so we can show the concept of how we switch between fragments. So I'm going to move over to our main activity layout, so Shift, and then activity_main. And what I'm going to do, underneath the frame layout where we put our fragment, I'm going to put a couple of buttons, just basic buttons. So button, I'll do wrap content, and I'll just call this one running. Give it an ID of button_running. I'm going to go ahead and copy this whole thing, paste a second button, which I'll call button cycling. And call it cycling if you can go ahead and do the same. And then I'll move it towards the bottom of the screen. So what I'll do is I'll put it just above the bottom navigation view. So I'll say the bottom of the button to the top of the, then I'll do the bottom nav. You can see that jumps down on the right. And I'll make this one on the left of the screen. So start to the start of parent, and that'll be fine. And then I'll do similar on the cycling button. I'll say bottom to the top of the bottom nav. That also jumps down, but this one I'll say end to the end of. I'll just stick it on the other side. Give them both a tiny bit of margin, 12 dp layout margin. I'll copy that. Okay, so just a quick little hack to give us two buttons that we'll use to swap the fragments. Very soon we're going to be learning how to use the bottom navigation view and how we listen for clicks on that. Okay, but for now that will do. So I'm going to close down the activity main layout. And I'm going to quickly create a couple of button click listeners for those two new buttons. So underneath our fragment transaction, a few line breaks, I'll do binding button cycling dot set on click listener. And I'll type a function that doesn't exist yet. I'll say on cycling clicked with the brackets, and then I'll use the error, alt enter, create function. So I'm going to use that error to make the function. Okay. And I'm going to duplicate that line. So I'm going to click on line 23 for me, button cycling, Command D, Control D, then change button cycling to button running. And I'll change this to another method. So on running clicked, like that. And again, I'm going to use the error to make the function for me. Okay, so I've got a couple of buttons. I've got the click listener on them, and then I can do something in these two blocks here. Just to show that we are indeed switching between two distinct different fragments, let's also create a cycling fragment. So we have our running fragment that says, hooray, now I can add fragments into my app. Actually, I'll just change this for, this is the running fragment. So we know that one's running. Okay, and I'm very quickly going to create a cycling fragment and layout. So in the package, right click, new class, cycling fragment. If you can go ahead and do the same, it wants to extend fragment with the brackets. I will create a new layout, so right click. Actually, what I'll do is I'll click on fragment running, okay, and I'll do Control C or Command C, and then I'll click on the layout folder and do Control V, Command V to paste that. So I'm actually copying and pasting the whole file. And when you do this, it does give you the opportunity to rename the file. So I'll call this one fragment_cycling and click refactor. And you can see we have a new layout file called fragment cycling. Okay, it's got the same text content as the previous running fragment, but I can simply change that for cycling. But that saved us quite a bit of time there. So if you ever have a very, very similar layout file or something like that, you can copy and paste the file, give it a different name, and then just make the changes that you need. So we have, this is the cycling fragment and this is the running fragment. So when we switch between these two fragments in a moment, we're going to be able to see the difference, see that we've moved to a different fragment. Good. So I do need to inflate the view in the cycling fragment class. So if you can move over to cycling fragment, the class, and then in the class body, we'll override on create view. We want this to soon become a habit. And I'm going to leave the word return, but I'm going to delete the super.onCreateView thing. So I'm going to type inflator from the parameters above, inflator.inflate, and it's the name of the resource file, so r.layout.fragmentCycling. It's the root, the view group, so I'll use that container above, and attached to root always false, otherwise you're going to run into problems. So that's all we need to do. So now we can go back to main activity and look at how we might go about swapping these fragments out. So looking at main activity, if I just scroll up a little bit, we can see in our onCreate method that shortly after setting the content view, we perform a fragment transaction. This .commit block, which is a useful little shortcut when we added that dependency, that fragment KTX dependency. This fragment transaction is what adds the default running fragment to our screen. So on a basic level, you might think we can just copy this whole block, support fragmentmanager.commit. We can copy that and paste it in onRunningClicked and onCyclingClicked. And in a way, we can, but we're going to run into one small problem when we do this, which is good because it will teach us something about fragment transactions and what sort of transactions we have available. But for now, let's copy the whole support fragmentmanager.commit block. So .commit in the braces, copy. Let's paste that into onRunningClicked and onCyclingClicked. So of course, for the onRunningClicked button, we can leave it as the running fragment. But in the onCyclingClicked, we want to change it for the cycling fragment, and then brackets to make a new instance, to make a new object. Okay? So this will kind of work. We have a fragment transaction, and we are adding to the frame content an instance of the running fragment or cycling fragment. And the ability to add, this add method you can see here. Okay? This is something available to us in our fragment transaction. But let's see what happens when we do this. So let's run the app now. Okay, and you can see by default we have, this is the running fragment. If I just scroll up in the code, this happens in onCreate. We add the initial running fragment. But let's see what happens when I click on cycling. Okay, do you see that? It's kind of hard to see what's going on there, but it appears to have put the cycling fragment on top of the running fragment. Okay? And the reason for this is we have used the command add. We are adding this fragment. So under the hood, this fragment transaction thing, and there's quite a bit of complicated code that Android does for us that we don't have to worry about. But what it's doing is it's taken the ID of our container, the frame content, which happens to be a frame layout, although I'm going to show you in a minute how it can be any view group. Okay? But ours is a frame layout, and we're adding to that view group. We're creating the fragment. In the fragment, we inflate the view in the onCreateView method. And then once we've got that inflated view, we're adding it to the frame layout. Well, because we're simply just adding it, it's not doing anything about the previous fragment, and it's simply placing our fragment on top. And if I keep clicking the buttons, you can see the text getting darker and darker as multiple versions of that text view get added over and over again. So this isn't what we want. So if we head over now to the Android documentation on this fragment transaction thing, we can see a few of the commands we have available to us. We don't just have the ability to add a fragment, we can do other things, and we're going to see in just a moment there's a much more appropriate transaction command we can call. So heading back to our browser for our documentation, I'm currently in the Create a Fragment setup guide, but if I just look on the left where this Create a Fragment is, you can see in our fragment section, I can see there's a section on fragment transactions. So when I click this, we get quite a lengthy introduction to what fragment transactions are. We don't need to understand every single word of this, but there's a few key points to take away. So at runtime, or when the app is running, a fragment manager, well, we've already seen this, it can add, remove, replace, and perform other actions with fragments in response to a user interaction. Okay, so we don't just have to add fragments, but we can also do other things with them. And looking at this straight away, the command that we're going to probably want is replace. Okay? You can go ahead and read as much of this introduction to fragment transactions as you want, but all you really need to know is, once you create a fragment transaction, and we do that with that .commit block, that nice little shortcut, well, at that point we can do multiple things. And if I scroll down, I can see a heading called Adding and Removing Fragments. So to add a fragment to a fragment manager, we call add on the transaction. Well, we've already done this. And it tells us that this method receives the ID of the container as well as the class of the fragment we wish to add. Okay? Don't need to worry about too many of the technical details of the other things. Really, it's absolutely fine to just trust that it works under the hood. The code is quite complicated. You don't need to know everything about this. But as we scroll down, we can see use replace to replace an existing fragment in a container with an instance of a new fragment class that you provide. Okay, so we've been doing add, we're going to change it for replace. Please don't copy the example code that they've provided. They provided it in a slightly different format to what we've done, and this may not always work depending on what Android Studio version you have. So ignore their code for now. The code we've got is good, but we just need to change the command for replace, and hopefully things should work well. So heading back over now to Android Studio, I'm going to change both of the button click listeners for replace. So simply typing replace instead of add. Okay, I'm going to copy that and paste that. If I now run the app, this should now work as we expect, swapping out that fragment each time. Okay, so we have our default running fragment in the onCreate block, and when I click cycling, it simply swaps over, and then running, cycling, running, it replaces it each time, which is absolutely fantastic. And actually, you might be thinking, well, do we need to use add for the very first fragment and then replace for all subsequent ones? Actually, you can just do replace for all of them. And if there's nothing in the container already, if there's no fragment added initially, it's not a problem. It will go ahead and add it. But if there is something, then it will replace it. So in my personal projects, I tend to use replace all the time. There's not many use cases where I need to add things on top of each other. Okay, so that's my number one tip really. If you're playing with the fragment transactions and you want to swap out fragments, just use replace for everything. If I go ahead and run this, I'll show you how that's absolutely fine. There's no problems. We can see on app load, our running fragment is added absolutely fine. Okay. Of course, if I remove this block in the onCreate method, if I remove this and I run the app, well, initially we don't have anything until we start clicking. Okay. So you might be thinking, okay, so do I always have to add in code programmatically a block for my first fragment? And the answer is actually no. If we head back over to our documentation just for the last time in this tutorial, you may or may not have seen this line here to do with adding and removing fragments. It is strongly recommended that the container is a fragment container view, okay, and not a frame layout. So if I just go back to our layout code now, so back in Android Studio, and I'm going to shift into activity_main. So we've used a frame layout, which is of course a view group. If I control click on frame layout or command click, frame layout extends view group. Okay, it's a container for other views. I'm just going to close this down. So we can actually add any view group. You can even add linear layouts. I could change this frame layout for a linear layout. I'll just set the orientation to vertical. And if I run this, you can see it still works exactly as expected. So you can pretty much use any view group for our container. But the documentation says to use fragment container view. And actually this fragment container view is only available to us because we added that dependency a couple of tutorials ago. It doesn't come by default in new projects. But because we added that dependency, we have access to this fragment container view. So let's go ahead now and change our container for this. So I'm going to double click linear layout and start typing with a capital F, fragment, capital C, container, capital V, view, and autocomplete. Okay, so we're now using the recommended container, the recommended view group. And when I control click or command click on the fragment container view, we can see it actually extends a frame layout, which in turn, when I command click, as we know, extends a view group. So a fragment container view extends frame layout, which extends a view group. So a fragment container view is, by extension, a view group, but it is the recommended one to use. There's a few extra things it does under the hood to make the swapping and the remembering of the fragments much, much more secure. Okay, so I'm going to close this fragment container view code. But one major benefit to us using the fragment container view, as opposed to a simple frame layout, is one extra attribute called name. If you start typing name and autocomplete, this Android : name we can now give the name of the fragment that we want to initialize this container with. And this is a wonderful little shortcut. Pretty much most of the time we're going to want to have an initial fragment showing in a container. So rather than having that commit transaction somewhere and on create, we can actually just put the name of the class here, and this fragment container view will know what to do with that, and it will take care of initializing our first default fragment. The only tricky thing is the way we do this is by typing the full package name of our fragment. So if I look on the left, I can see my package is com.vinnorman.recordkeeper and then .running fragment. So you're going to need to type your package name exactly as it is. Okay, so for me it is com.vinnorman. Autocomplete won't work here, unfortunately, not at the moment anyway. Maybe in a later version they'll change this. But com.vinnorman.recordkeeper, one more dot, and then the name of the fragment as it shows in the project pane. So for me that is running fragment. So now we have a fragment container view. This is the recommended view group from the documentation. It gives us access to this name attribute that wouldn't work in a frame layout or a linear layout. It only works in this fragment container view. So when I go back to main activity, I can actually delete the initial fragment transaction. I can remove that completely. So I've completely removed the initial transaction. And I've just got the transactions for when we click on the buttons. So if I run this now for one final time, and we can see we have our initial running fragment thanks to that name attribute. And when I click the buttons, the fragment swaps out. So we have one activity, one main activity, and inside this we have the ability to swap between fragments, swap between portions of our screen, which is absolutely fantastic. We're pretty much exactly where we need to be to start making this work with our bottom navigation view. Okay, so the key takeaway is, for the most part, you want to be using replace. There's not many examples where using add is particularly useful to us. So go ahead and use replace for your fragment transaction to swap out any existing fragment. And rather than writing this transaction for our initial fragment, if you use a fragment container view, then you can add the name attribute. You'll need to give the full package name of your fragment class, so the package plus the name of the fragment. But then when you do that, the fragment container view will take care of initializing our fragment. So we've now got fragments working perfectly inside our app. And we're now ready to move on to plugging this in to our bottom navigation view. It's time for another programming concept, this time on interfaces. We're in main activity and we've got our fragment switching out nicely with fragment transactions, and we've simulated navigating around using two buttons with manual button click listeners. So all we need to do to hook this all together is get the fragments to switch from the bottom navigation view. So above those buttons, if I type binding.bottomNav, well, similar to a button click listener, we need a certain type of listener for our bottom navigation view. And I could go ahead and tell you what that is. It's called a navigation item selected listener. So I can see you've got this set on navigation listener. I'll just choose the top one for now. And this is expecting a bottom navigation view dot on navigation item selected listener, which is a bit of a mouthful, okay? And very similar to our on click listener for buttons, it's the thing that we need to register when it's been interacted with, when it's been clicked or selected. So underneath this, if I go ahead and type out that interface, so on navigation item selected, and I'll choose the top one that says bottom navigation view on the right, okay? If I now command click or control click into this, we can look at the code for what this listener is. Okay, and back in Java, which is why I insist on teaching Java in my courses. But yes, we have public interface on navigation item selected listener. So this is an interface, something we've not discussed before. I can see it looks a little bit like a class, and then there's one method. It returns a boolean, a true or false, and it's called on navigation item selected. But when I look at this, I can see there's no actual code. It's just what looks very similar to a class with a class name or interface name, and then a method, but no method body. So if I just close out of this, so we've seen something like this before with our button click listeners. If I just underneath type the view.onClick listener that we've used many times, including below in those curly brackets, when I command click on the onClick listener, again I see public interface onClick listener. Looks a little bit like a class. except the word interface, not class, and a method, but no method body. So rather than diving in and just me showing you the code to type out and copy out for this navigation item selected listener, now is the perfect opportunity to finally understand a little bit about what interfaces are and why we might use them. So I'm going to go ahead and remove all the code now after set content view, ready to do this properly. And it's time now to go back to our Scratch files and learn the concept of interfaces. So in the project pane, I'm going to close the top folder, the project folder. I'm going to open up Scratches and Consoles, and then Scratches. And then I'm going to put the file in the main Scratches folder. It's not a Kotlin Foundation tutorial, it's a general programming concept. So right-clicking on Scratches, New, Scratch file, and making sure we select Kotlin. Now, normally I would go ahead and rename this straight away to interfaces, but I've been finding that the Scratch file warnings and error highlighting doesn't really work sometimes if I rename it first. So I'll do the renaming at the end. But this Scratch file is where we're going to learn about interfaces. So I'm just going to go ahead and close the project pane, and we can work in here now. So the first thing I'll do is I'll put a heading for the Scratch file, so a comment // and then 3 stars, and then interfaces, our programming concept. And we're going to start with the what. What is an interface? What does it mean? I remember early on in my programming career hearing about interfaces, knowing of them, but being a bit scared to really dive into what they are and what they mean and why we would use them. Interestingly, interfaces themselves are one of the simplest concepts, but understanding the purpose and where they fit in can in many ways be one of the most complex that we've seen so far. Okay? So I think a really good place to start with getting our head around what interfaces are is with the actual definition of the word interface. If I just head over to a browser and type define interface, and we'll go for the noun, interface as a thing, a noun, a point where 2 systems or subjects, organizations, etc. meet and interact. Okay, so I'll take the first part of that, so a point where 2 systems or subjects meet and interact. So let's bring that definition right into our Scratch file and build upon that. This time I'll do a code block, so / and then enter. I have a code block and I'll do a tab. So definition of interface, a point where 2 systems / subjects meet and interact. And if we actually take this definition, it actually fits very nicely with what interfaces are in code. What I'll do to make this definition a little bit clearer is I'll give a very simple example to illustrate it. So let's take, for example, a computer user, and that user might interact with a computer. Okay? So if we think about this, a person sitting in front of a computer, wanting to do things, wanting to interact with that, and then the inner workings of the computer, the circuit boards, the hard drives, and the motherboard and the processor. Well, there is the user interface. For example, Windows, Mac OS, Ubuntu if you're a Linux user, etc. Okay? I'll just continue and say this could be a display, a mouse, a keyboard. So let's think for a moment about what the user does and what this user interface is and where it sits in between the user and the computer. Well, the user can use a mouse, cursor, to click on icons and symbols, to request the computer to do things, and return things like photos, files, etc. Okay? So a very simple, easy to interact with layer between the user and the computer. We can click on these little symbols, these very friendly and easy things, and then the computer does its thing, and then occasionally gives some things back to us. So the computer then returns its output to the user on the same screen / interface. And the point I'm trying to make here with this is that the user doesn't directly control the computer. I'll just put a semicolon. You know, the circuit board, or directly reading the bytecode data, all those 1s and 0s, okay? The user doesn't do that. The user doesn't directly compute things or make connections on the circuit boards. Instead, the computer and the user meet in this user interface. So I know that's quite a big paragraph that I've typed out, and please do either copy this along or make your own version of this. But the important thing is the interface sits in between two parties, two subjects, and it simplifies the process of those two things interacting with each other. That's what we mean by interface, and that's exactly how it works in code. So let's go ahead and quickly type out an interface. So the way we do this is similar to a class, but rather than the word class, we use the word interface. So with a lowercase I, interface, and then the name of the interface. So this interface is going to be a coffee provider. Then we do the class curly brackets. So we're going to have a layer, a point in between somebody who wants coffee and a place that can make the coffee. And in the middle will be this coffee provider that actually gives the coffee to the person. Okay, so we've defined an interface, and now we need to type out some methods, some things that this coffee provider can do. How do I interact with this coffee provider? What behavior does this coffee provider offer to me, the user? So the first thing a coffee provider should be able to do is it should be able to serve coffee. So we'll do a function called fun and then serve coffee. And that's all we type. No method body. All we're doing here is defining the methods that anything that's a coffee provider should be able to offer. So a coffee provider should be able to serve coffee. And just to show you that we can have normal methods with parameters and return types, we'll have another method called greet. So fun greet. And this time we'll take the user's name. So we'll say name string, and we'll do a colon to say that it returns a string. So we'll combine the name with some kind of funny greeting and then return that string. So two normal methods with or without parameters and return types, but no method body. And that's all there is to an interface. The magic comes in when something implements this interface, when something says, hi, I am a coffee provider, let me roll out those methods, let me do that behavior. So the interface itself is very simple. So let's make a note saying exactly this. Interfaces are very simple. In terms of how we do it, we type interface, then the name of the interface, much like a class. Okay, we can have a coffee provider class, okay, but we get a complaint saying we haven't provided a method body. And you might be thinking, well, an interface looks a little bit like an abstract class, and you would be right. Very similar. If I say abstract class and abstract function, then we have an abstract class. We'll come back to this point in just a moment, but for now, much like a class, the word interface and the name of the interface with a capital letter. So if we don't provide any behavior, any method body in the interface, then what's the point of it? And a really, really good thing I got told a while ago to help me understand what role interfaces play in our code is to think of an interface like a contract, a promise. If something says, hi, I'm a coffee provider, I implement the coffee provider interface, what they're saying is, I guarantee you I will have these methods exactly like this. I will have a greet method which takes a name string and returns a string. I will have a method that serves coffee. Okay, so that's a really good thing to think of when working with interfaces. So let's make a note to say this. Think of interfaces like a contract. If something is a coffee provider, then it promises to have these methods. Okay, so here we specify the contract. And we'll just confirm in the interface. Once we've defined the interface name, then we type out all of the methods, including any parameters or return types like you see below. We want, but we don't write a method body. So that just about wraps up our introduction to interfaces and how to create them. The next programming concept is where the fun starts, where we learn how we implement interfaces. So let's do that next. So let's now dive into how we would implement these interfaces. And when we say implement, we mean how we would write out the code to actually do this behavior. So let's make a simple class, and this class can be a fictional coffee shop. So we'll say class, and we'll call it Easy Coffee. Okay? And much like with inheritance, the way that we say we implement the interface, the way that we say that this class, Easy Coffee, is a coffee provider, is with a colon, just like inheritance. So colon, and then coffee provider, autocomplete. And then we do the curly braces, and then we have our class body. So straight away we're getting a warning, and when I hover over that warning, it's saying the class Easy Coffee isn't abstract, and it doesn't implement the abstract members serve coffee and greet. So what that's saying is we're promising that we're a coffee provider. We're promising that we have the behavior serve coffee and greet, but we haven't implemented those methods. And we're not an abstract class. We can't have unimplemented methods like that. Okay. So we can go ahead and use the error now to actually create those two methods. So I'm going to do Alt Enter or Option Enter, implement members. I'm making sure I select both of these two methods in our coffee provider. I can see here our interface methods with them selected, pressing OK. And then we have our two interface methods, serve coffee and greet. I'll just delete the to do in both of those. And just for fun, I'll move the greet method to the top as we'll do this one first. OK. And we'll return an empty string for now. So above, we've defined our interface, we've specified our contract, the things that coffee providers must promise to do. And below, we have a class, and we're saying that we are implementing this. We are going to provide the code that a coffee provider should offer. So in a moment, we'll go ahead and actually provide some behavior in these two methods, but let's make a couple more notes for our reference. So we'll say a class can then implement the interface. In Kotlin, it is done exactly like extending a class or inheritance, as we've seen before. And that's with a colon followed by the name of the interface. Apologies for the long line. If I make a new line, we can see exactly this here, colon and the name of the interface, just like inheritance. It's probably worth saying, just so we know if we ever see Java code, that in Java, it is done with the word implements. For example, public class my Java class implements my Java interface, and then the class braces. Okay, so just for reference, that's how we do it in Java. And the final point to note is that once you state you are implementing the interface like this, then you must fill out all the methods in the interface. You must fulfill the contract. So let's scroll down now and actually provide some behavior for our Easy Coffee provider. So the first thing we'll do is we will return a friendly greeting. So we'll say, welcome to Easy Coffee. And we'll use our wonderful Kotlin string templating by just doing $name and an exclamation mark. Welcome to Easy Coffee name. Note, of course, that the methods in the interface will need the modifier word override, just like inheritance and or abstract classes. Okay, so we have a greet method that we have implemented. We said we're a coffee provider, we promised to have this method, and indeed we provided the code for that method. It does return a string. It does accept a string parameter. And now we will just do a comment to say some complicated way that Easy Coffee makes coffee. And then rather than returning a string, this method doesn't return anything. So we'll just do a console print line and we'll say, here is Easy Coffee's finest coffee. And that's pretty much it. Underneath the class, I can make a variable called Easy Coffee with a lowercase e, so it's a variable this time. I could say it's of type Easy Coffee. I could do this, okay? And I'll make it a new Easy Coffee object instance, you can see there. And we can do easycoffee.greet. I'll do my name. And if I look to the right and scroll down, welcome to Easy Coffee Vin, so that works. And I can also do the serve coffee method. Here is Easy Coffee's finest coffee. But the beautiful thing is, as well as saving it as a variable of type Easy Coffee, if we think back to that bonus tutorial on polymorphism a while ago, I can also save it as a variable of type coffee provider. So now, if I scroll down, I see it still works. I don't know anything about the Easy Coffee class. I just know that this is a coffee provider. I know it will have those two methods because it's in the contract, it's in the interface, it's promised to have those methods. And so I can use it just the same. So this leads to our first benefit to interfaces. If I actually now make another method in Easy Coffee, a new one called the Easy method, and I'll move the complicated fictional code that we haven't typed for serving coffee into there, and instead I'll just call that method, okay, the Easy method. I'm not going to make the method private, so it would be possible to access this. So if I change this back to an Easy Coffee variable, I see that we can do easycoffee dot the Easy method. Okay, but if I change it to a coffee provider, then I don't know anything about this method. This method belongs to an Easy Coffee object. It's not in the coffee provider interface, so I can't see it, okay? So this is one of the first reasons why we use interfaces, and we'll type it above the serve coffee method, this comment. So why reason 1 **. We can hide underlying complexity. Think back to our computer. We can click on the start menu or the launchpad icon on a Mac, and it will show all the apps that are installed on our machine. There's probably quite a lot of complexity in the computer to go to the hard drive, find all the applications, and then get the image icon for that application and show it on the screen. But the user doesn't care about that. We just click an icon that says, show me my applications, please, and up they come. So the interface, the user interface on the computer, hides that complexity. And the same thing happens here with our coffee provider. So this is a coffee provider. So we know it has the method to serve coffee. The caller of this method doesn't need to know anything about the inner workings of how it serves the coffee. They just know that it can serve coffee. I'm just going to comment out this line and say, this won't work. Coffee providers don't have this method. So I'll do another class. This time I call it coffee for you. Okay, again, it's a coffee provider, and I'll do the class curly brackets. I could use the error to implement the interface methods, but this time I'll just type them. So I'll start typing greet, G-R-E-E, and Android Studio knows, because we're implementing a coffee provider, that we probably want to override that method. So I can autocomplete and achieve the same thing. I'll just do the same thing for the serve coffee method. Okay, so that's another way you can quickly do the interface methods. And for greeting, this time we will do return greetings, name, exclamation mark. We have some coffee, ... for you. And then again, we'll have some hidden inner methods. So we'll call this the method for you. Okay. Some technical code for coffee for use process. Okay. So we can call that inner working code inside our serve coffee method. Okay. Nice, tidy, short methods. And then we can have the line to serve the coffee. So we'll just say something like, yum, enjoy your coffee for you, coffee. Okay. And I'm going to go ahead and just copy the whole class and make a third and final shop. So we'll call this shop best coffee, spelt wrongly. And greeting can be something like, you've made the best choice. Name. And then the hidden inner method can be the best method. And I'll make sure to call the same line of code. And we'll just say something like, throw away the rest. This is the best, brackets, coffee. Very good. So nice and quick, we've got 3 different classes, easy coffee, coffee for you, and best coffee, and they are all coffee providers. They all promise to have these 2 methods, greet and serve coffee. So we can move on now to a second reason why interfaces can be good. So you'll notice for best coffee and coffee for you and easy coffee, they all have an extra method, their own secret inner workings, their own secret way of doing it. Okay? Well, the big second reason is this. So why reason 2? We don't need to make the whole class available to other parts of the code, just the interface methods. Okay, if I make a quick variable of type best coffee, so val best coffee, and I'll make this of type best coffee, so the actual class, not the interface variable type, and we'll say this equals a best coffee instance. Well, if I'm just a plain old simple coffee drinker, I just want my coffee, but it's possible for me to directly tell them to go and do it with the best method. I can directly call this complicated technical code. And it might not always be safe or appropriate for me, the coffee drinker, to know these things. So we can put a comment above this method call to say exactly this. It might not always be good to make the inner workings of a class available like this. Okay? And if this point is slightly confusing you, let's bring it all the way back to our activities. Okay? If I go back to main activity, and if I actually just undo things to get the button click listeners back, and remove this. So we have this view click listener interface. We have this part of the activity that is saying to our buttons, hi there button, I can handle clicks. I'm a click listener. I promise to do this behavior. I promise to have an on-click method. Okay? It kind of happens with a bit of a shortcut inside here. So we say to the button, here is the code to handle the on-click. But we could just pass the whole activity to our button. We could do something like button cycling dot set activity, and we could give the whole main activity to the button. And we could promise that every single activity would have an on-click method. Yeah, we could have an on-click method in every single activity as part of app-compat activity, and then just say to button, hi, here I am, the activity. You have reference to me, the activity, and then you can call my on-click method directly. Well, the problem with that is the button wouldn't just have access to the onClick method, but it would have access to everything. It could call onCreate. It could call some other lifecycle methods that we haven't seen yet, like onDestroy. Okay, it could actually control the slightly dangerous inner workings of an activity. So we don't want to make the whole activity available to our button or to our button navigation view. We want to use an interface, so the button can only see the methods that it needs to see. Okay, so I'm going to go ahead and delete the onClick code there and go back to our Scratch file. So reason 2, we don't need to make the whole class available. Again, like we saw before, if I make it of type coffee provider, I still make it the same object, the best coffee object. Call this best coffee 2, there we go. Okay, well now we can't see the inner workings. We can just see the method that we need, serve coffee. So we're pretty much through what interfaces are and a couple of good reasons why we might need them. There might be some of you who might remember the lessons on inheritance and abstract classes who might be thinking, well, couldn't we do all of this with inheritance? Couldn't coffee provider just be a class, an abstract class, and then best coffee, easy coffee, coffee for you can just extend coffee provider rather than the interface? And there is a subtle distinction there between, yes, a parent abstract class and an interface. And this leads on to reason 3 for why we use interfaces sometimes and not always inheritance. So why reason 3 is this. Many totally different types of thing can implement an interface. Okay, so sometimes inheritance doesn't really work. All sorts of crazy different things could be a coffee provider, not just shops, okay? It could be a shop, it could be a vending machine, It could be a family member if you're lucky, okay? They can provide coffee. And it could even be a man with a bicycle to go and fetch coffee for you. And if you think about those 4 different types there, well, a shop might extend the building class. A shop might already be a type of building. And we've not really touched upon this, but you can't have multiple inheritance. You can only extend one thing, but you can have multiple interfaces. So a shop could extend a building, but it could promise to serve coffee by being a coffee provider. A vending machine could extend machine. A family member or a man with a bicycle could extend person, okay? But they can say that they promise to serve coffee, that they can fulfill that contract by adding on this interface, by saying we implement the interface. So we use interfaces for times when we want simplicity, just exposing 1 or 2 methods to hide all the inner workings. So we use an interface to make it really easy for any class to promise to fulfill certain behavior. Okay, so we'll say just this. Interfaces allow a really simple way that any class can promise to fulfill certain methods. So just to prove this point, we will make a 4th and final class. We'll call it class man with a bicycle. Again, even though it's not a shop, this man can be a coffee provider. This particular man with a bicycle. Okay, I'll do the class braces. I'll scroll down a little bit. I'll do my easy shortcut. So Alt Enter, Option Enter, implement members, making sure they're both selected. I'll remove the greeting to the top, and I'll go ahead and fill these out. So the greeting can be something like return hi name. Please don't make me go too far. And we can have a funny method like go get the coffee. And then just whatever the code would be for the poor man having to cycle to the nearest coffee shop and back. Okay, so the way that a man with a bicycle serves the coffee is he goes to get the coffee before then serving it to our user, the person who wants the coffee. Okay, the nearest shop was 12 miles away and your coffee is cold, but here it is. And just as a bit of a fun bonus, at the very end of the class, we'll have a bit of fun with polymorphism and for loops. So shop 1, and we'll say it's a coffee provider, but this can be our coffee for you shop. Okay, I'm going to copy and paste that line. This can be shop 2, but this can be our best coffee shop. Copy this for shop 3. This can be our easy coffee. And then we'll have our man. Again, he's a coffee provider. And it's man with a bicycle. So let's now make an array of all of these coffee providers. So we'll do val our coffee providers, oops, capital P. And we'll say it's an array of type coffee provider. So this array doesn't know the specifics of what type of class they are, just that they can provide coffee. We'll use that wonderful array of shortcut and we'll pass in all of those variables. So shop 1, shop 2, oops, shop 3, and the man. And now we'll do a for loop and I'll show you how it works in Kotlin world. I'm not sure we've seen this before actually. Nice, easy syntax. The name of the variable for each variable. So we'll call it a provider. So for each provider in our coffee providers, it's the in word, okay? Slightly different to Java. And then curly brackets, so it will go round and round all the coffee providers. So we can actually print the greeting. So I do print line, the provider greeting. I'll greet Vin again. And we can also then directly do provider dot serve the coffee. And if I then scroll down to the very end, I can see all of the for loop there. Greetings Vin, we have some coffee for you. Serving it. You've made the best choice and then serving it. Welcome to Easy Coffee and then Easy Coffee serving it. And then the man, hi Vin, please don't make me go too far. okay, it was 12 miles away and your coffee is cold. So interfaces, very simple. Just the name of the interface and defining the methods, the behaviors that you want. Fill out your contract, specify what a coffee provider should do. That's all we need to do. When I go to view click listener, that's all it does. It says that a click listener must promise to have an on-click method. That's all it is, okay? And then when it comes to making your classes that implement them, you do a colon and then the name of the interface and then just fill out the methods. And that's all there is to it. And we think of an interface as a layer between two subjects, two parties, a user and a computer, a coffee drinker and the coffee provider, okay? And in the next tutorial, we're going to go back to main activity. We're going to make our on navigation item selected listener, which is an interface. We're going to fill out the interface so that our bottom navigation view can handle clicks. And as well as looking at the on navigation item selected listener, we're going to have a look at one or two different ways that we can actually do that. A couple of different ways we can make the interface so we can respond to the bottom navigation view. So if you don't immediately get every single word in this interface concept, don't worry. But as we start using them, as we start seeing them more and more in this course, I'll keep making reference back to this. So the concept of interfaces and why they're useful becomes super clear. And we will be using them many, many more times in the course as we move forwards. So let's go back to the project. So we know what interfaces are. We know that they're a place in between two subjects, two things, that simplifies the way those two things interact. And in the case of our main activity, it's a simple way that a button can interact with an activity or a fragment, the view on click listener. The button doesn't need to know any of the inner workings of the activity. It just needs to know that that is an on click listener. Okay, so that's what an interface is. We've seen a few reasons why they're important. Hiding the underlying code, making sure the button can't access the whole activity and do dangerous things. And also that anything could be a button click listener, an activity, a fragment. And in the last tutorial, we saw a few different ways of how we can implement an interface. Make a brand new class file, make the main activity class itself be the interface. And we finally learned that very scary, complicated sounding concept of anonymous classes, which explained all that new .view on click listener code we saw a long time ago in Java. But we now understand what's happening there. We're just making a new class that extends an interface in line, right there in the code, without having to name it. That's where the word anonymous comes from. So if I go ahead now and remove our two buttons, we're now faced with a choice of what we do with our bottom navigation view. If we just go ahead and get reference to our bottom navigation view, so binding.bottomNav, and we saw a few tutorials ago that the method we need is .setOnNavigationItemSelectedListener. And rather than going with a shortcut one, that lambda, those curly brackets that kind of do it all for us, we'll go with this top one that is expecting the interface. And as we can see, that's expecting a listener of bottom navigation view.onNavigationItemSelectedListener. So we know that we're not going to go ahead and make a brand new file separate to main activity and implement that interface there. That's going to have the major problem of giving us no access to the things we need in main activity. So we're either going to pass in the word this and make main activity implement it, or we're going to do one of these anonymous classes. Well, I mentioned for buttons that if you have more than one button on the screen, it's not always ideal to say this main activity is the interface, because in that case you'd only have one on-click method in activity, and if you had multiple buttons, that method would grow and grow and grow. You'd have to have a different if block for every single button, checking its ID. Well, let's just think about our user interface and our user experience on Android. Pretty much 99.9% of the time, if you have a bottom navigation view on your screen, you're only going to have one. There's only going to be one bottom navigation view. So that problem of multiple different bottom navigation views sharing the same listener isn't really a problem. We can type in the word this, which refers to this instance of main activity, this object. So we'll say this, and we're getting an error, and that error says we require an on navigation item selected listener, but we only found main activity. And this leads to one of my all-time favorite ways to use an error to do a shortcut. If you do Alt-Enter, Option-Enter, and the bottom one says, let main activity implement the interface. I love this shortcut. Go ahead and select that one and press Enter. Make sure you select the on navigation item method and press OK. And that does two things. It sticks the method in for us, you can see there, override on navigation item selected, and it also does the comma and adds the interface. So that's a really useful shortcut, okay? But we now have the method we need in main activity. I can delete the to do. We can see that the on navigation item selected method needs to return a boolean. I'll explain why very shortly. For now, I'll just return true. We'll talk about what that does in just a moment. Now, this is my preferred way of implementing an interface, which is only going to be used once in a main activity. Actually, having this method in the activity, on navigation item selected, to me it reads really nicely. I can see in my activity, here's the space where the navigation is handled. That's really nice to me. For my buttons, if I just scroll up a little bit, I do the shortcut way, that lambda, which is a shortcut to our anonymous class. I do this for our buttons. Usually, even if I only have one button, I still do this because I like to see the code for the button in line. I often refer to a specific method like on running clicked and on cycling clicked. So this kind of shortcut of using the lambda, using the anonymous class shorthand here, and then directing immediately to a method, this kind of allows me to have very small methods for each individual button. That's my preferred approach, even with just one button. But for the bottom navigation view, I like to just pass in this, make the main activity implement the interface, and then override that method, the on navigation item selected. I should just show you for comparison what the choice would be. If I remove this, and I'll remove the interface from the main activity, so this won't work. The other possibility is to do that anonymous class. I could do object, implements, bottom navigation view dot on navigation selected listener, making sure it says selected and not reselected, okay? Then I'll do the curly brackets as if I'm doing a class, and then I will use the error in the object, so implement members on navigation item selected. You can do this, that's okay to do, but it can start looking a bit messy to me, that. Of course, the object syntax is a little bit messy. I can use their suggestion to make it into a lambda, that's shorthand. Okay, if I just put that on a new line, you can see there's this strange it thing. So it is actually a variable, which is the menu item, which is how we're going to know what's been clicked on. And you can actually name it if you want. You can do something like menu item and this arrow syntax, which I will show you later on in the course. It's a feature of this lambda thing that we kind of get a variable of any of the parameters in our method. So we get this it variable, but you have the permission to name it if you want. So we can say my menu item variable name, do the arrow, and then you can start doing things with that, like getting the ID. Okay, so it's possible to do the lambda, the shorthand, but actually I really like doing this, letting the activity implement the interface, and then having the method right there in my main activity. So please, for this tutorial, do what I've done and do this and make main activity implement the interface, okay? And then we will do the method in the main activity file. Later on, as you develop your career as an Android developer and make your own projects or roll out solutions for a company you might work for, you will have choice as to which way you go about doing it. And I've seen many projects which do it as an anonymous class. And there's a strange syntax where you don't type the word return in a lambda. Okay, so there's a few little things like that, and the menu item thing that I showed you where you can call it what you want. There's a few little weird quirks which to me can make it a bit complicated, especially to new developers. It's kind of okay for our button click listeners, but yeah, I don't recommend this approach if you're a beginner, but feel free to use this if you would like later on, or if indeed later on if you see some code which does this approach, at least you know what's going on. It's an anonymous class, okay? But that's pretty much all we need to do to have the main activity respond to navigation clicks. The main activity is the interface. It is the listener. We filled out the contract. So the last thing to do is to do our clever bit of code to switch to the different fragments, our two existing methods, depending on what's been clicked. So let's delete the button running click listener. Now we finally have our bottom nav working, and we'll do a couple of if statements to detect which bottom navigation item's been selected. So we can do if, and then brackets, and we'll say if the item, this menu item, you can see we have that passed into us by the bottom navigation view. If the item's item ID And if you remember, in our menu file, we have some IDs. If I do Shift, and I just type the word bottom nav, and you can see here the top one, bottom_nav from our menu folder. If we just jump into this file, we gave the running icon an ID of nav_running, cycling an ID of nav_cycling. So we have access to this in this menu item. If the item.itemID equals r.id.navcycling, we can do something. Else, if the item.itemID equals r.running, we can do something. Else, if for some reason it's some completely different ID which we're not expecting, we should do something else. So this is how we're going to be able to detect which icon's been clicked on. So if they select cycling, let's do the onCyclingClicked method. If they've done onRunning, we'll do the onRunningClicked method. We are still getting an error saying at the very bottom, it's expected that we return something. We're expecting a Boolean to be returned. So in this method, what the Boolean does, what the true or false return type does is, if you return true, after they've touched that option, it will select that item. If you return false, you can still capture whether they press that button or not. This code will still run, but it won't tell the UI to select that item. So a really good thing to do is, if it's our nav cycling, we'll run the code cycling clicked and then return true to select the cycling icon. If the running icon is tapped, we'll run the running code and then return true to say, yes, you can highlight the running icon. And if there's anything else which should never happen, we can return false. I don't want you selecting some unknown menu item that we're not expecting. And then the error goes away. So actually, with the bottom navigation view click listener working, we've removed the button click listeners. We should probably go to the layout and remove the buttons as well. So you can actually command click on the binding variable. If you do control click or command click, that will go into our code. I'm going to remove these two buttons now. We don't need them anymore. We've finally hooked it into our bottom navigation view. So if I now run the app on the emulator, we can see we have our running fragment by default because it's in the fragment containers layout code. And when I click on the different items in the bottom navigation view, they switch out the fragment. If I just move the emulator over a little bit, main activity is implementing the interface. Main activity is fulfilling the contract that promises I can handle bottom navigation clicks. It's the interface. We say this, and then we implement that behavior here. The bottom navigation view, when it's clicked, will give us the item that was clicked. We can inspect the item's ID. If it's cycling, we can do our cycling switching code. If it's running, we can do our running switching code. And we return true to say, yes, please highlight the icon for those two. But if it's anything else, then no, please don't highlight the icon. We're not expecting that. And that is all we need to do to get the bottom navigation view responding to clicks perfectly. And we now have done this by fully understanding what interfaces are, why they're important, and the few different ways of how we can go about implementing them. So we're now ready to start developing our fragment layouts and start making this app look awesome. We've got our bottom navigation working and the fragment switching out properly. So the next thing to do now is actually flesh out our layouts for both the running and the cycling fragment. Kind of a fun tutorial now. We can start making this app look really good. So I've got my two fragment classes open, the running fragment and cycling fragment. You can see at the top there. So I'm going to start in the running fragment and we'll start fleshing out that layout. And then for the most part, we'll be just copying that over to the cycling fragments layout and making a few changes to the text and the image. So we only really need to do this once. So command click into fragment running or get into that file another way, the layout file. And I'm going to close the project pane for this tutorial so I've got the full width available to me. And I'm going to move the preview pane over until the preview starts to shrink. There, okay, good. So, pretty much the first thing that I do when I make a brand new layout file for a brand new screen is ask myself, is this likely to be more than the height of the screen? And not just in portrait, but also in landscape. And the answer is yes, if the user were to turn their phone sideways, they would run out of height. So because of this, I'm going to put the whole thing in a scroll view. So if you can go ahead and do the same, scroll view. Of course, we need to put the layout height and the layout width in again. So remember, for scroll views, we make the height and width match parent. So we have the scroll view fill the screen, but its contents can then be wrap content. The contents can be as high as they need to be. So scroll view's height match parent and layout width match parent. And I'm going to change the self-closing tag for a regular opening and closing tag. And that's pretty much all we need to do for the top level element, the root element. So I'm going to make the main view group inside the scroll view. A scroll view can only have one child. So the one view group inside the scroll view, I will make a constraint layout, as we know how to use that now. So start typing constraint and then autocomplete. So this, I'll make it match parent, as wide as the screen, but height will say wrap content. So it can be as high as it needs to be. And then a normal right arrow, so we get our opening and self-closing tags. And now we can get to work. So the top section I want to be a nice image of either running or cycling, with my usual trick of having a gradient going from see-through white to see-through dark, just so that when we put some white text on top of that picture, it will be visible, it will look okay. I use this trick quite a lot, and so does Google actually. If you ever go to Google Maps, they sometimes do this effect. It's where I got the idea from. So for this image section, I'm going to use a frame layout to achieve this effect. I don't know that we've used the frame layout too many times before, or even at all. It's a very, very simple view group, very, very simple container, but it's pretty easy for us achieving what we need to achieve with this image effect. Quite easy to layer views on top of each other. Pretty much all it can do. So we'll make the width. We should probably do 0 dp rather than match parent if we're going to use the constraint layout properly. So we'll do 0 dp for the width. But the height I'll set to a fixed amount of density independent pixels. So 200 dp, 200 density independent pixels. And when I look on the right, I can see the blue outline. That seems to be an okay proportion of the screen. I will do a normal right arrow to give me the opening and closing tags, but I need to fill out a few things. I've got an error because I've not constrained this at all. So we'll start off by saying top to the top of the parent. And then for that 0 dp, for that match constraints thing, I'll do start to the start of parent and end to the end of parent. It kind of achieves the same effect as match parent for the width, but it's the correct way to do it in constraint layouts, so the documentation says. And one thing I'm going to remember to do right from the start is give every view inside our constraint layout an ID. Every view needs to know how to constrain itself in relation to other views or the parent, so because of this, we need to have an ID for every view. So ID frame underscore heading, the heading image. And what I'll do now is I'll do the 3 views that I need inside the frame layout to achieve my clever image effect. So I'll need an image view. This can be match parent. Remember now we're not inside a constraint layout, we're now inside a frame layout. So we'll do match parent and match parent for the height. Remember the frame layout is set to a height of 200 dp. So because of this, we can use match height for the image view and some of the other views. So match parent, and for now, I'll just do a self-closing tag. We'll come back to this in a moment once we import our images. So I'm going to want an image view. Then, layered on top of this image view, I'm going to want my see-through gradient effect to slightly dim the image. So this will be a regular view with a background set on it. So we'll do view, again, match parent. And then we'll need a text view to put the text on top of the image and on top of that gradient. So I'll do text view. I'll do match parent for the height, but I'll do wrap content for the text. I'll hard code our text in for now. So I'll do text running. So you can see in the right, we have this text view in the top left. And to position this at the bottom center of our frame layout, we can use layout gravity. We can say inside this layout, have this gravity move to this position. So layout gravity will move this within its view group. So if we say bottom, it jumps to the bottom. But because we've got match parent for this text view, you can see it fills the full width. We can actually control the internal gravity of the text view. So gravity, and we can now do center. So this is a good example of using both layout gravity and gravity in one view. A bit of a recap of some concepts we've talked about before. So layout gravity controls this view's gravity within its parent. Can move that wherever we want within its layout, within its parent, within its view group. But just the plain gravity attribute controls the internals of this view. Okay, everything inside this view. So that gets the text roughly in the right place. So I guess the next thing we should do is actually import our 2 images that we need. So if I now go to the left and open the resource manager. So for a quick and easy way to import these images, I'll go to the folder where these pictures are saved. I'll select both of them and I'll simply drag and drop them into this resource manager. I'm happy with the file names, running_heading, bike_heading, and then I'll do that no DPI thing for the density. So density, no DPI. This is a workaround to help reduce the chance of memory issues. Very soon in a future section, we're going to be looking at an image processing library that will take away all the pain with image memory management. But until we get there, this is a quick and easy shortcut to make sure it doesn't upscale or downscale and do anything funky with the images. Okay, so density, no density on both of them. Next. Both of these images are available in the resources section for this tutorial. They're about 40 and 70 kilobytes each, so they are pretty small. So fingers crossed you won't run into any memory issues with these pictures if you use these ones. Do feel free to use your own images, but do make sure they are as small as possible until we get to our image processing library in a later section. So import. So I have them there now. I can see running heading, bike heading, so I can close the resource manager. And in my image view, I can do src for image source, and I can type running heading. Okay, so we can see our running picture. It's not quite the same aspect ratio as the container, so we can do one of our scale types. So when I do scale type, center crop, it will zoom in until it fills the whole container, and then it will crop the bits at the edge, keeping it centered. So this is often the one that I use the most to fill image views. Center crop, that looks to be okay to me. So yes, we can't really see our text very well at the moment. In fact, let's do the text next. So we'll do font family sans serif light, my nice modern light font that I like to do. We'll do text color white. And now it looks like we have a color white already in our colors file. Let me just command click on that to make sure. Okay, that's good. So present versions of Android Studio are giving us the color of white and black by default in our colors file. You could of course hard code the color by doing #FFFFFF. Okay. If for any reason the color isn't in your colors file, feel free to do the hash code directly, or in the colors file, make a new color, name it your name, give it a value, and then you can refer to that in your code, your name. Okay. So if you haven't got white for any reason, feel free to put it in, or you can hard code it for now if you want to. So as I can see, running it's white, it's not very visible. I can try making the text size larger. So text size 24 dp, and probably give it a bit of margin from the bottom of the picture. We'll do layout margin bottom, something like 16 dp. But it's still not very visible, so I'm going to do my tried and tested gradient trick. So we can make a gradient drawable, a gradient file, which we can overlay on the picture with this view thing. So we'll open up the project pane. I'm actually going to use the target to jump to my resources folder, but we're going to actually make a drawable. So right click on the drawable folder, new drawable resource file. Okay. We'll make the root element a shape. So you can do shape and autocomplete, and simply call this something descriptive like our gradient overlay. Okay. And fairly straightforward, just one attribute to do this. You can have this in your projects for reference code. You don't need to memorize this at all, but we'll do the angle of 270, so it goes from top to bottom. We'll do start color, and I'll just hard code this. So we'll do fully translucent. So the first two of an 8-digit hex code is the translucency, so 00, and then FFFFFF. When you get a 6-digit hex code, that's a color. When you get an 8-digit hex code, that's adding some translucency, making it transparent. And then the end color, I'll make hash, almost opaque, but not fully, AA, and then black, 000000. Okay, so this is a fully transparent white, fading to black, but becoming slightly less see-through as we go down. So then a self-closing tag, that's all we need to do. A nice, quick and easy gradient fade that you are free to use in your own projects. So back to fragment running, if I set the background on this view to be our gradient overlay, then we can see the picture dims and we can see our text clearly. So quite a neat little trick that. That's our heading section done. No need to give any of these views inside the frame layout IDs because we're not using them for any constraints. Remember, they're inside our frame layout. But also we're setting all the values in the XML code. We're not going to be talking to these views at all in our code. We've set the picture, set the gradient and set the text. We don't really need to do anything else in here. I am going to do just best practice and extract the running string. So extract string resource, just call it running. Okay, that's best practice. I've made a mistake. I've done 24 DP when it should have been 24 SP. Okay, and that warning goes away. We have got one more warning saying it's usually good to provide content description attributes on images. This is for people with visual impairments or people who are blind. So what you can do, you can actually Alt-Enter, Option-Enter on that and set the content description. And then such users with visual impairments will tap around the screen with their thumbs, feeling for things and touching things, and they'll get a audio description. So you can simply just say this is the running image. As usual, we will do a string extract in case they want it in a different language. So we'll call this our running image description. Okay. So we've done two things there. We've provided the image a description, which is best practice for accessibility. You want to make the apps usable for people who are blind or have other visual impairments, okay? So when they tap around the screen, they'll tap and discover this big section at the top, but now it will read to them that it's the running image, so they'll know what they're touching. And by extracting the string resource, even of the content description, we've removed all of the warnings so far in our layout file. You can see the green tick. So this is best practice with layout files so far. So now we need the 4 records, or however many records you want to do. So under the frame layout, I want 4 touchable, tappable sections with a heading, a value, and a date. So I will do each of those sections in their own constraint layout, but actually I want them stacked on top of each other, top to bottom. So for this purpose, a simple vertical linear layout will be absolutely ideal for our needs. You don't always need to use a constraint layout for everything. So if we do a linear layout now, we'll make the width 0 dp for our constraint layout, but the height we'll set as wrap content. Okay, so we're going to make the top to the bottom of the frame layout, the frame heading, start to the start of parent, end to the end of parent, and then the orientation we will set to vertical, and then we'll do a regular right arrow. So we've now got a linear layout that will grow with every element inside it. And then for each of our records, each of our tappable distances that we can set values for, we will have a constraint layout. So we get lots of control for where to put things in each mini section. Okay. So we'll do our first one first, and then we'll probably be able to copy this 4 times. So another constraint layout inside our linear layout. And now we're back in a linear layout. We're not inside another constraint layout. So I'll make the width match parent and the height wrap content. And then I'll do a right arrow. And we will give this an ID so that the user can touch it, and we can add a click listener to this. So I'll do ID, and we'll call this our container for our 5 kilometer record. So the first thing I want approximately in the top left is a text view heading that says the distance. So we'll do text view. We'll make it wrap content this time. We don't want it to fill the full width, and wrap content for the height. I'll just do a self-closing tag for now. So first of all, we'll add the constraint. So we'll make it in the top left of the constraint layout. So we'll do top to the top of the parent and start to the start of the parent, but that's it. Okay, just scrolling down. And we'll hard code the text for now before extracting it in a moment. So we'll do text 5 kilometers. Okay, we can just about see that there. Very small, not styled yet. In fact, even before styling this text view, I can see I'm going to want some padding both on my linear layout and on each individual constraint layout. It's far too close to the picture, far too close to the edge of the screen. So on the linear layout, let's squeeze everything in with some padding. We'll do something like 16 dp. So that squeezes things in for the whole linear layout for every individual section. And another thing I'll do is I'll add some more padding to each individual record. Because if you look at that blue outline, you can see it's very close to the contents. But this might make it a bit tricky for the user to tap or to touch. Remember, we're going to put a click listener on this so they can tap it and change it. So if we add a bit of padding, it will make the touch area, the click area, a bit easier for the user. So let's do padding and add a further 12 dp. And you can see that's going to add a bit of extra space, so when the user touches and taps, it'll be a bit more responsive for them. Good practice when you're making things that aren't buttons clickable. Give them a bit of extra padding, make touching them and tapping them that little bit easier. Okay, so now I can see my 5 kilometers a bit better. Let's start to style this now. First of all, we'll make it a bit bigger, so the text size can be 20 dp. 20 SP, I always forget that. scaled pixels, so it will grow and shrink if the user changes the global text settings on their phone. I will give it a nicer font, so font family. I want this one to be a bit heavier than the rest of the text. It's a heading after all, so simple sans serif will be better, give it a bit more weight. And just for fun, we will color this in our app's primary color. We haven't changed the default colors for now, so I could go to our themes or our styles.xml, it's themes for me, and look and see that the color primary is this purple 500. So I could just change the text color to color purple 500. I could do that, but then when we change our theme color later, we'll go ahead and we'll change its primary and primary variant colors later on to our nice green for a change. Well, when we change the theme, then this color that we've hard coded here, purple, it's going to be wrong and we might forget to change it. So there's a neat little shortcut to refer to attributes in our theme. You can do $ATTR, so this is referring to an attribute that we've got defined somewhere else. Weird syntax, I know, don't worry about remembering this. But now we can type color primary. So that still refers to the same purple, but then when we go and change our theme to something like, I don't know, let's say I changed it to teal 200. Well, when I go to fragment running, it changes with it. So it's a very strange syntax, this $ATTR, attribute slash, but that refers to any attribute that we've got defined in our themes, okay? So this is a really good practice thing to do if you want your text colors or button colors or anything in your layout files to follow what you've got in your theme. So neat little shortcut. Don't worry too much about the what and the why of this strange thing. I'm not even sure I know why it's called this. I do know that it's referring to attributes rather than hard-coded values. It's a really good way to keep your app in line with your theme. So I'll go ahead and change that back to purple 500 for now. That jumps back. So we'll have our theme primary color for the text. And otherwise that looks pretty good. Let's move over now to the other two text views. So text view, wrap content. This time I want it to be in the top right, so I do end to the end of the parent, and again top to the top of the parent. And this time I don't want to hard code any text because we'll be setting this based on the code, depending on what the user has stored. So I do tools to have the preview, so tools, and if you hover over it and do Alt-Enter, Option-Enter, you can import the tools namespace at the top there, tools, okay? So now I can do tools text, and this won't appear when we run the app. So I'll do an example time. I'll do my actual 5K PB. Recently got 2204. Don't think I'll ever get sub 20, but something to aim for, I guess. So 2204. Let's do some gentle styling on this one now. This time we'll make the font family a bit lighter, so it stands out from the heading. So sans serif light. We'll still make it the 20 SP size, so we'll match the size, but because it's slightly lighter font, it will seem less strong. That's good. And we'll do a slightly darker grey than that. So we'll do text color. And I think best practice, I shouldn't hard code the color here. So I'll go to my colors and I'll make a new grey. I'll duplicate this line, white. I'll change the name to a dark grey. And I'll do something fairly dark, like, actually I'll click on the color on the left and I'll choose one. Something down there. 323232, that seems to be okay. Can barely see it, must match the same color as the margin. So 323232. So now I can refer to color dark grey. That looks a little bit better. So I will do a self-closing tag. I'm in a constraint layout, so I should give these IDs. So we'll say ID text view 5 kilometer heading. And this can be the text view 5 kilometer value. That's good. So now I can do my final text view for the date of the record. Again, wrap content. But this time I'll do top to the bottom of the 5 kilometer value. Now that we've got the ID to put it in relation to that. And again, I'll do end to the end of, so I want it at the far side. And I don't want to hard code a date, so I'll do tools text just for a preview date. When did I actually achieve this? I think it was sometime in November last year. So there we go. I want to give it a bit of margin from the top, so do margin top 16 dp. And I want the font family to be light again. So font family, sans serif light. I want it to be bigger than default, which I think is 14, but not quite as big as the others. So I do 16 SP. And I'm probably okay with the default color. Yeah, the default color is okay. I think it's slightly lighter than our gray. Okay, so that's nicely formatted. I'm going to want some sort of divider line between each section. So after the constraint layout, a really quick and easy way to do a divider line is do a view. We'll make the width match the parent, because remember the parent is the linear layout, but it's got some padding. You can see that blue line there, that's fine. But if you make the height 1 dp, or however thick you want your line to be, and then you can set a background of a color. So I'll go and define a light gray color. So I'll duplicate that line and do light gray. I'll just choose something a bit lighter, maybe that seems okay. So we've got a light gray color. So if you set the background to be that color of light gray, you can see we have our divider line. I probably want it to be even lighter than that, so I'll just change it to something right near the top left. That looks a bit better. So yeah, we've got a divider line. I'll do a normal self-closing tag, and I'll give it a bit of margin from the top of that section. So margin top 16 dp. And that's all we need to do. We don't even really need an ID because we're inside a linear layout. So that looks to be okay to me. So again, if I do an auto format, and then what I'm going to do is I'm going to copy this view, this divider line, and the entire constraint layout above it, our 5 kilometer record. And I'm going to copy all of this 3 more times. So 1, 2, 3. I'm going to go ahead and delete the last line, which we don't need. And I've got a whole load of errors because I've got duplicate IDs, but that's fine. I can use those errors to show me what I need to change. So I'm going to leave the first errors because that's our first 5 kilometer container. If I scroll down to the second one, right. So from here, we can change this to container for 10 kilometers. I'll change the text view for 10 kilometer heading. Okay. Do take extra care here that you're changing the right values. It's easy to get muddled up when we've got so many views, so many attributes and elements in our layout file now. But looking on the right, I appear to be on the right one, so this is good. So this is now the 10 kilometer value. And the 10 kilometer date. I'll leave the dummy text values the same because I don't really care about that being accurate in my layout file. I've got an error now because this 5 kilometer value isn't in this container, this constraint layout. So I'll just copy that 10 kilometer value, and now that should fix the layout. Good. So you see that we've got 10 kilometers nicely working. This will be the half marathon time. Okay, actually I'm going to copy half marathon like that and then swap out everywhere where I see 5 kilometers. So text view half marathon heading, text view half marathon value. Should also change the text as well for half marathon date, and then making sure to do the correct half marathon value there. Okay, just looking to the right to make sure we've done it correctly and that the layout works, and it does. And then the final one is the full marathon time. So container marathon, I'm going to copy that. Marathon, marathon, marathon. I'm making sure to lay this out next to the text view marathon value. And when I look to the right, that looks done to me. So quite a big file here. If you've made any mistakes or anything's not looking right or you've got any errors, then do be sure to check over all the code carefully. Very easy to make a mistake when you're going through so many attributes. I'm going to make this layout file get the nice green tick. Just got 4 things to do, and that is extract all the hard-coded strings. So I'll extract this and call it 5 km heading, and then 10 km heading, half marathon heading, and then our, oops, I didn't change this one. Good thing I checked. Marathon, there we go. And then our marathon heading. And then we get the nice green tick in the top right of our layout file. So this is quite a long tutorial. So what I'll do is I'll stop the tutorial here, and in the next tutorial, a really dead easy short one, we'll see how we can go about copying this entire layout file to a new layout file name for our cycling fragment, and then just changing the values that we need. It'll save us loads and loads of time. We've done all the hard work of styling this and formatting this in this layout file, so the next tutorial should only be a couple of minutes at most. Okay, see you in the next tutorial. We just need to do now the same layout for the cycling fragment and just make a few changes to the IDs and the labels of each record. There'll be different records for cycling. However, before we do that, there's just quickly one thing we need to fix from the previous tutorial. When I look at the preview, to me, the 10K, half marathon and marathon records, they're not spaced enough from the line above. We've got this nice 16 dp between the 5K and the line, but then if you look, the other three records, they touch the line, so we're kind of missing some margin from the 10K, the half marathon and the marathon. So before we go ahead and copy the whole file, which is kind of wrong, let's fix the running fragment and then we can go ahead and copy that file. So in the fragment running, I'm going to scroll down to the first record, so that's the 5K, so no need for any margin for this one. But when I go down to the container for the 10K here, if I just add some layout margin top and of the same 16 dp that the view above has, you can see that view's got also 16 dp margin top, so 16 dp, and then when I look to the right, that looks a lot more evenly spaced. So I'm going to copy that whole line, layout margin top, I'm going to put it in the half marathon container and also in the marathon container, and a quick auto format, and then when I look to the right, that just looks a little bit better. Okay, so for this tutorial, dead easy, we're just going to copy the whole file and rename it. So if you go ahead and open the project pane and then find the fragment running either in the folder or you can press the target button. Okay, so fragment running. So you can see we've already got a fragment cycling. If I just go ahead and open the file, you can see it's just a basic layout with a text view saying this is the cycling fragment. So you can do one of two things. You could either go to fragment_running, Control-A, Command-A to select all and then copy it, and then select all in here, delete and paste. You could go ahead and do that, or if I just undo that, you could actually delete the file. So I could do right-click, delete, press OK. If you get any warnings saying the file's in use, because we are using it in our cycling fragment, you can see there, well, don't worry about any errors because we're going to create this file again. So I'll show you both ways just to make sure you know what to do. So now I'm going to select fragment running, Command C, Control C to copy the file with it selected, okay, or you can right click and do copy, okay, then clicking on the layout folder, then right clicking and paste, and that gives us the option to rename the file. So here I can do fragment_cycling. So you've got two ways you can go about copying a layout file directly to a new file name. Either copy the code or copy the whole file. Okay, so I'll click refactor and that creates me a fragment cycling, which right now says running. So I'm going to go ahead and close the project pane and I'm going to right click on the fragment cycling and do close others. That's a nice little shortcut to clear off every file apart from the one we want to focus on. Okay, so we just have our fragment cycling. So I'm going to set you a quick challenge now. We want to have different records for cycling and also a different header with a different image for cycling and the word cycling in that heading. So changing the records, changing the header section and changing the IDs so the IDs are named correctly for our click listeners, okay? Now the records that I'm going to do for my record keeper app for my cycling section are longest ride, biggest climb and best average speed. You are free to do the same three or a different three or some more records. You could choose yours by distance, 10K, 50K, 100K, or in miles, or whatever you want to do. So decide on what records you want for your cycling section, or indeed if it's a different sport for this different sports section. But your challenge is to pause the video now and on your own, without my help, change all the things that you need to change to make this layout unique for the cycling section or whatever sport you have. Okay, it's quite intimidating being a big file with so many elements, so many attributes. You saw in the last tutorial how I made a mistake. I forgot to rename the marathon header label, the purple thing in the bottom right, you can see there. So see if you can challenge yourself, pause the video and try and change everything that needs changing. And then once you've done that, you can unpause, follow along with me and see if you missed anything. And I'll try and get it all correct as well. Okay, so if you fancy a challenge, pause the video now. Otherwise, I'm going to go ahead now and fly through changing all the things we need to change. So I can leave the frame layout ID as frame heading, that's fine. I can see I've got the content description as running image. So I'll change the image first. So I'll double click on running heading, delete that, and I think it was called bike heading. So bike heading, there we go. So that changes out the picture. And now I will change the running image description for my cycling image. So I'll just say cycling image. Remember, this is for our users with visual impairments. They'll get a description, an audio description when they tap this area. I'll extract that and call this my cycling image description. I'll fix all my layout warnings the second I get them this time. Okay, moving down, I can leave the gradient overlay, but I'll change the text of the heading to cycling. So I'll just type the word cycling and then straight away extract that. That's fine. So now I can move on to my fields, to my actual records. So the first one for me, I'm going to do a record called longest ride. So this is my container longest ride. I want to make sure that my container IDs have the correct names. This will be my text view longest ride heading. I'm going to copy that value there. I'll change all the IDs first. Text view longest ride value, text view longest ride date, making sure to lay out the date below the longest ride value. Good. And then just need to remember to change the label as well. So this will say longest ride. And I can extract that. I'll just leave it exactly as Android Studio suggests, longest_ride. Okay, good. Moving on, that seems to be fine. The view is fine, leaving as it is. The next record for me is going to be my biggest climb. That means the most amount of climbing in one go. I'll copy the biggest climb ID. I'll do the IDs first, so swapping out 10K, 10K for biggest climb, 10K for the date, and then I could just do biggest climb there as well. That works. Yep, good. Not forgetting the text label. So I'll say biggest climb and I'll extract that straight away. Good. And then just one more to do. So half marathon I'll change for my best. I'll just call it best speed, but I'll actually describe it as best average speed. I'm not really interested in my top speed, but I do sometimes like to know what my average was for a particular ride. So changing out half marathon for best speed, and text view best speed value. So that's all the IDs changed. Not forgetting to change the text value. I wonder if you're keeping up. Lots of things to change, lots of things to remember. Don't worry if you try this yourself and you missed one or two. Okay, best average speed. I'm going to extract that straight away. And the final thing to do, because I'm only interested in 3 records, is delete the last section. So I can actually press the little minus symbol to collapse the whole marathon container. And I can delete that. That's a really quick and easy way to make sure you delete a whole section. Okay, and I think I'll also remove the last line to be consistent with the running section. So I absolutely flew through that. Don't worry if you had to pause a few times, or if when you tried it yourself you made a few mistakes or maybe forgot to rename an ID. Actually, if they were named poorly, the IDs, it wouldn't necessarily be a problem. It'd just look a bit funny in your cycling fragment code to be referring to running distances. But it's always good practice to make sure your IDs, your views, are named sensibly. So looking at the right, that looks pretty good. So the last thing we should do now actually is run this on our emulator and see what our app now looks like with a brand new UI and fragments that switch between this beautiful running section and beautiful cycling section. So let's go ahead now and run this on the emulator. So for me, this actually failed to build, And if you look at the bottom build pane that has popped up, this section here, it says it found the item string running more than one time. So if I actually click on the bottom error, and then usually somewhere in this build output you'll get a link to the problem file. And if I click strings, yep, there I can see it. I've got running twice and cycling twice for some reason. I'm not sure why, but it's not a problem. I will remove one of the cyclings and one of the runnings. Okay, and that fixes the problem. So just thought I'd show you that rather than going back to edit my video. Sometimes we can make mistakes, sometimes we can duplicate resources, and of course if you have a duplicate resource or duplicate layout file name or drawable or something like that, the app will fail to build. So I believe I've fixed that now. So if I go ahead again and click play, I can close the build pane now. Okay, and we now have our record keeper, and straight away I can see that wonderful running fragment. We don't have any values at the moment because we use tools text, so in a moment we'll look at having a little placeholder, a little hint to tell the user to tap to add their first record. And of course it's a little bit bigger than the height of the screen, but it's in a scroll view so I can scroll it no problem. And also I can switch over to the cycling fragment. And of course that does fit, there's only 3 records. Okay, and that's looking really, really nice. I may decide later on to actually shrink the heading down a bit to maybe 150 dp or something, just so that we do get all 4 records, at least in portrait mode. I'm not a big fan of the user having to scroll in portrait if they don't have to. But yeah, a nice looking UI, lovely image with the gradient effect. So for the most part, that's the layout of both our running and our cycling fragment done, and we're ready now to move over to the fragment code and start developing the clicks and the behavior there. Having pretty much finished the layouts for our running fragment and our cycling fragment, it's now time to move back to the fragment code. So I'm inside running fragment, you can see there. If you can go ahead and close down all of the files and open up the running fragment class code. So at the moment we are using the inflator.inflate method directly to inflate the fragment running layout, you can see there. This returns a view. The onCreateView method of a fragment requires a view. It works a little bit differently to activities. In activities we call setContentView, but remember in fragments we just return a view in the onCreateView method. And again, if I command click on the inflate method of the inflate.inflate, so control click, command click this, a bit of Java code, a bit of complicated Java code at that, but you can see public view, so this method returns a view. Okay, I'll just close this down again. So we've recently learned how to use view binding, the current best practice way to handle views in our layout code, rather than find view by ID or the Kotlin X synthetic thing. So we don't really want to be using this, we want to use our binding. So first of all, let's take a look at our main activity code, see how the binding that we've already set up works in main activity, just as a reminder, and then we'll come back into our fragment code and get it set up, looking at the 1 or 2 differences of using view binding in fragments. It's very similar to activities though. So I'm going to shift into main activity. So shift, and I'll type main activity. So we did a couple of things. We declared a late init variable, a variable which we're going to initialize later. So late init variable, we just called it binding, although you can call it anything that you want. And it's of type activity main binding. And this variable name will pretty much be the name of the layout in uppercase. So activity underscore main becomes activity main binding. I'll just quickly show you in the project pane. So project, and you can see in the layout folder, activity underscore main. So capital A for activity main binding. And remember, this binding class, this useful bit of code that's generated for us with all of our views inside, this exists because in our build.gradle in the app folder, if I just scroll up, you can see build features view binding true. So because we have that, we have access to all of these binding classes. So we're going to need to make a binding variable like this in our running fragment. We can do the late init var, same thing in our fragment for our fragment running binding. And then in the method where the activity or the fragment is created, we can assign that binding. So in activities, we do activity main binding dot inflate, and we just give it the layout inflator. So in a moment in the fragment, we're going to see how it's slightly different. We'll have a quick recap of how fragments attach themselves to activities, just so we know fully what's going on and why the code is what it is. And then of course in activities, we set content view by doing the binding.root, and the root is the top element of the layout file, the parent, the root element, and that will be a view. So similar but not the same in fragments, but there's our recap. So let's go ahead now and do the view binding in the fragment. So I'm going to close main activity. So the first thing we're going to do is at the top of the class declare our binding variable. So make a few line breaks, and then above onCreateView, let's declare a private variable. We only want this class to see it. Private, late init var, you can autocomplete that. Again, we'll just call it binding, keep things nice and consistent. We can start to generate our own styles and patterns by naming the same types of variable the same thing. This is good practice. And this will be of type fragment running binding. You can see there the fragment_running layout file. So the name of the generated code that the view binding makes for us is fragment running binding. And you can go ahead and autocomplete that. So we've declared the variable. The second thing to do is actually assign it. And rather than doing it in onCreate like we do in activities, best practice is to do it in onCreateView. So at the top of the method block, but before the return line, let's do binding equals. And again, we start by typing the name of the binding class. So we'll do fragment running binding. And you can see we've got a few methods to choose from there. .bind, well, we'll ignore that one, but we've got two .inflate methods. .inflate where we just give it a layout inflator, like we do in the activity, and the second one down, layout inflator parent, and you can just about see attached to parent boolean on the right side of the screen. So this one here with 3 arguments, the 3 parameter method, inflator, parent, attached to parent. Where have we seen this before? Well, if I just escape out of this, if you look on the line below, return inflator.inflate, a layout name, container, and attached to root. So not the same, but very, very similar. We have these 2 extra arguments, these 2 extra parameters. The container to inflate the code into, to actually put the views inside of, and then whether or not we attach it to this container. But remember, we don't say true, we say false, because we're not attaching to the container, we're actually attaching to the activity. So that's really, really important. So recapping that bit of knowledge about this inflator method from a few tutorials ago, we actually do use the 3 argument or the 3 parameter method in this binding class. So if I just do that again, fragment running binding, and I can autocomplete the, well, you can autocomplete either of the methods, but I'll choose the one with 3 parameters, inflator, parent, and attached to parent. So rather than the below method where we give the name of the layout file, this fragment running binding class that we're using, it already knows what the layout file is, so we don't need that. So instead it actually needs the layout inflator. And remember, we have this above in the onCreateView parameters. Can you see there? Inflator, layout inflator. So we can pass this inflator that's given to us from the activity. We can pass this straight in for the first argument. So we'll just say inflator. But we must do the 3 parameter, the 3 argument method you can see on the second line of the prompt there. So if I do a comma, so the parent is going to be that container in the activity layout code, that fragment container. And remember, this is given to us again in the method above. You can see the word container. So this fragment is created and we have access to that fragment container. So that will be our parent. That will be the thing that we inflate this code into. So we can go ahead and just type the word container. And then again, we ask the question, do we want to attach to this container, attach to this parent? And the answer is no. We want to attach to the activity, but not directly to this container. We just want to inflate the views, to put the views inside the container. We don't want to attach to it. So we say false, and then that is done. We have made this binding variable, this fragment running binding, with everything that it needs to be used in a fragment. Slightly different to main activity. We do these 2 extra parameters, container and false for attached to parent. So go ahead now and delete this return line. And we're not going to return that inflator.inflate thing. We're going to return the root that lives inside this binding variable. So we can type the word return, and then we can now use this binding variable, and then it's binding.root. And that will be the root element of our layout file. And as you can see there, it knows it's a scroll view. If I just command click or control click on this .root, that will take us to our layout file, and you can see that the root element is indeed a scroll view. So if I close that, this fragment running binding class is pretty clever. It knows what the root variable is. So we're returning the root view of that layout file, and that is all we need to do to set up view binding in our running fragment. And as an added bonus, this nullable return type, view which can be null, well, now Android Studio knows that this binding.root will never be null, one of the many advantages of using view binding. So we can actually get rid of the fact it's a nullable returned view. It's definitely not going to be null. So you can go ahead and delete that yellow warned question mark there. So that's all we need to do to use view binding in Fragments. I thought it'd be worthwhile just going over a couple of the previous concepts to do with this view binding class, why we have access to this because of our build.gradle, and also looking at that 3-parameter version of the inflate method that we inflate it into a container and always doing false for attached to parent. Okay, but that is view binding in Fragments. So we'll stay inside running fragment for now. We'll do pretty much all of the running fragment code at once, and then later on we can go ahead and do the same thing for the cycling fragment. So we've got our fantastic binding variable, which will have all of our views inside it. So now we can go ahead and set up the click listeners for our running records, those running containers. We can make them all clickable. So best practice in Fragments, once you've inflated the view, once you've set up your binding variable and returned the view, you don't really want to do anything else in onCreateView. There's another fantastic lifecycle method, and we're going to get onto the activity lifecycle and the fragment lifecycle in just a few tutorials' time. But there's another very useful method that happens automatically. It's not onCreateView, it's onViewCreated. So if you can just underneath the onCreateView method, but before the class curly brace, just make some line breaks. So we're going to start typing another method that exists to us in all fragment classes. You can see we're extending fragment, and that method is called onViewCreated. You can go ahead and autocomplete that. Definitely leave the super.onViewCreated method. Let the call to the parents method happen. Very, very important. It does all that setup code. But after that super method, we can start doing things here. Fragments work a little bit differently to activities. There's the state of it, creating the view, doing the inflation, gathering up all of that code and returning that scroll view that you can see above in the return binding.root. But at this point, it's not actually on the screen. It's made the fragment views and it's created it, but it's not actually being shown. It's not actually in the activity yet. That will happen after the onViewCreated method happens. Okay, so you can sometimes run into problems if you start doing too much stuff, setting click listeners, changing views, changing text views in this onCreateView method. Really good practice. Other than returning the root view, setting up the view here, don't do anything else in onCreateView, but instead do it in this onViewCreated method. Many, many times I've had experiences running into bugs and crashes by doing too much in the onCreateView method. So do pretty much all of your view setup once the view is on the screen in the onViewCreated method. So because we have our fantastic binding, our fragment running binding variable, all of our views in that layout file are available to us. So we can go ahead now and start setting up all of our click listeners. I could do them one by one in the onViewCreated method. I could do binding.container5k and just set an onClick listener. I could do this, but always trying to steer you towards best practice and writing clean code. These standard lifecycle methods like onCreate, onCreateView, onViewCreated, we don't really want to be doing too much in there, putting too much code there. It's always good practice to gather up any bits of code that do the same thing into another well-named method. That way, if something goes wrong and the app crashes, it will tell you what method went wrong. And if we have a method like set up the click listeners and that crashes, then we know exactly what's wrong with our code. If it says, oh, something went wrong in onViewCreated and you have tons and tons of code in onViewCreated, it's hard to see from that crash, from that error or those debug logs, kind of what's going on. So lots of reasons why it's good to get out of these lifecycle methods. So I'm going to remove this line of code and instead I'm going to create a new function and we'll make it a private function. We only want it to be visible by this class. So I do private fun and we'll call it set up the click listeners. And then just normal curly brackets, no return type, and just the curly braces. Just a recap there of creating a function from scratch in Kotlin. So now we can call this method setUpClickListeners, and you'll see that the function becomes yellow to tell us that it's being used. Until we use it, it will be grey. Okay, so that's now being used, and we can do the button click listeners inside here. So I'm just going to scroll down, and one by one I'll do binding dot, and it's the whole container, the whole constraint layout we want to be clickable, so the user can tap anywhere to set the record. So container5k dot set onClickListener, and we'll choose this second one down, these curly brackets with the 3 dots. That is the shortcut to our anonymous class, our ViewClickListener interface. Okay, we now understand a bit more what's going on under the hood with this code, but it is such a useful shortcut. A lot better than having to do the object, the anonymous class you can see there, colon, view.onClickListener, and then overriding that method. Okay, that's quite a lot of hard work. So we let Kotlin use that wonderful shortcut, that lambda, that kind of does it all for us. Okay, but at least we know what's going on under the hood there. So there's our click listener. I'm going to go ahead and duplicate this 4 times, or 3 more times. So Command D, Control D, 2, 3, 4, and just change the container. So we'll do container 10K, container half marathon, and then container marathon. So we have our 4 container variables, and we've set a click listener, but we just have some empty brackets. We're not really doing anything at the moment. So we need to have a quick think about what we want to happen when the users click on these records. It might be possible to click and something happen in the view and something changes to an input field, but that might be a bit fiddly. What's going to be best, I think, is quite simply when you tap on these containers, it moves to a brand new activity, a brand new screen that's going to pop up and sit on top of these fragments. And in that activity will be a couple of fields where we can set the value and the date, and then save or delete or that kind of thing. So we'll have it that when the user clicks on the record, it navigates to a new activity. We won't set up the activity and do all the layout and all the code for that for the time being, but let's just quickly make a blank activity just for our running records, not for our cycling records, and then we'll have these click listeners navigate to that new activity. This is recap. We've made many activities before, should be fairly straightforward to do. So in the project pane, I'm just going to move it over a little bit. I'm going to right click on the main package, my record keeper package, and do new activity and always empty activity. Keep things nice and simple. And I'm going to call this my edit running record activity. Okay, a bit of a long name for an activity for a screen, but nice and clear, nice and descriptive. And I'm happy for the layout name to be activity underscore edit running record. That's fine. And we leave it in Kotlin and we can click finish. So quick and easy, making a new activity using the activity wizard. And you can see we have a brand new activity class here and the layout file, which is just completely empty. We can go ahead and put a quick text view in here just so we can have a little play with this in a second. I'll do wrap content, wrap content. I'll just constrain it top to the top of the parent. Start to the start of the parent. That will do just in the top left. And I'll put some text that says, this will be where we'll edit our records, or running records rather. Just something that we can see when we have a play with this in a moment and run it on the emulator. So yeah, we've got our running layout file and our running activity code here, but otherwise we'll just leave this for now. So now we have an activity to navigate to. So for the time being, all I want to happen is that whichever of these records they click on, it will just launch this edit running record activity. We'll figure out later on how it can distinguish which record's being edited, but for now we just want it to navigate to that screen. So I could go ahead inside these click listeners and put some code, the same code to navigate to that, but far better is going to be to have one method that is responsible for launching that activity. So I'm just going to undo those line breaks, and this time I'm going to type a fictional method that doesn't exist. So we can call this the launch running record screen. Something descriptive. And I'll do the curly brackets to say this is a new function, a new method. And I will use this error to make the method for us. So Alt Enter, Option Enter on the red error, and create function. And that's been done. We can delete the to do. And it automatically makes it private, which is good practice. So we have our launch running record screen. So I can go ahead now and fill out the code for this. So we're going to make an intent variable. So we'll do val intent, and it's going to be a new explicit intent to move from this screen to a new activity by name. So we'll do the curly brackets. So it is the 4th hint down, this package context and name of the class, or class bracket star, that we need to use. Now, interestingly, in activities, we would just do this for this screen, or more specifically, this activity. So we would do this, or main activity.this if we were in some kind of interface, okay? let's just try this for now and see what happens when we type this. So it would be from this context, this screen, and it would go to the name of the class. So we'll type edit running record activity, and we've got to do the weird : class.java thing. We have to point to the Java code for these intents for it to work properly. Okay, but unfortunately we get an error, and when I hover over the intent, it says none of the 2 argument constructors for this intent variable that we're making, none of the 2 argument constructors work with what we've given it. Okay, and that's for a very subtle reason, and that reason is that a fragment, you can see at the top there, a fragment is not automatically a context. An activity is, but a fragment isn't. And this is a little bit awkward. However, there is some good news. We have access to a context variable. And again, if I scroll up, this is given to us by being part of a fragment class. So if I just make a line break above this intent variable, if you just start typing the word context, and you can see the top one, it's from a Java method called getContext. If I autocomplete that, you can see it's italicized. That means it's a variable not in our running fragment class, but in our parent class. Okay, so this context variable is available to us, and that will be whatever context this sits in. Remember, this fragment is being inflated into a container, and then it's being attached to an activity. So this fragment kind of knows that its context is that activity. There's some other subtle ways that fragments can be used in applications, so the context might be different in those situations. Don't really need to worry too much about that. If you can just take it on faith that this context variable will be the activity's context. So rather than typing this in this intent constructor, we can use this useful little context variable that we have access to. Okay, it is nullable. This context can actually be null. A fragment can be floating and not attached to anything, but the intent constructor here can handle nullable context. So by typing context, the error goes away. So the short version there is, in activities we can use this, because an activity class, that is a context. Main activity.this or this activity. In a fragment we can't use this, but we can use this useful little context variable that we have access to. And that will actually be the same context as the activity. We don't need to worry too much about that. Giving it this context variable, the intent will take care of the rest. Okay? If that trips you up once or twice and you type in the word this and you can't work out why the intent is complaining, you may need to refer back to this tutorial in the future. It's a common mistake with Android developers getting used to using fragments, but we can just use context, this useful little variable, okay? So we've made our intent variable, so now we can just do start activity and give it that intent, and that should work. So we should just make sure all 4 button click listeners call the same method. So I'm going to go ahead and copy the launch running record screen method call and put it in the middle of all those curly brackets. Do a quick auto format to tidy that up. Remove the line break. I'll remove these line breaks to keep our code nice and tidy. And yeah, that should be good to go. So let's run this on the emulator, make sure we've hooked everything up correctly and that our view binding works and our button click listeners work. Before we do, actually, there's worth checking to make sure that the new activity wizard did add that activity to the manifest. If I just double click the manifest, okay, I can see here, edit running record activity, good. So the new activity wizard is still putting our activity for us into the manifest. Without this, it would crash at runtime. It would crash when you clicked. I'm just going to do a self-closing tag to get rid of that warning. Okay, so pretty much 99% of the time when you use the new activity wizard, it will put the activity in the manifest. Without this, the app would run, but it would crash when you clicked on the buttons. It would crash here. It would say it couldn't find this in the manifest. Just a little recap there. It's been a while since we made a new activity. Okay, this should definitely work now. So let's run it on the emulator. I'm just going to close down the manifest while we're waiting. We have our nice running fragment, and all of these containers should be clickable. So let me go ahead and click the 5 kilometer record. Okay, and we have a new activity. You can see the name of the app at the top, Record Keeper, and then we have our little text view. This will be where we will edit our running records. And I can press the back button to go back, and all of the records open up the same activity. And you can maybe just about see with the animation, it's kind of sitting on top of the fragments. It's a new screen that goes on top. So we've got our new activity, our blank edit running record activity. Later on we can flesh that out and figure out how we're going to save our records and recall them and edit them and delete them and all those kind of things. But we've got our view binding working nicely and our button click listeners all set up, which is exactly where we want to be. So when the user clicks one of the records, they get a new activity, a new window where they can edit the record. But thinking a little bit about the user experience for when they move to this screen, at the moment in the title of our new activity, it still says the name of the app, Record Keeper. Okay, we're going to put some fields in here, some input boxes where they can type the record and save it and all that kind of thing. But rather than just the name of the app, it might actually be good if the record itself, the thing they're editing, was in the toolbar. Edit the 5km record, edit the marathon record, or something like that. And also it might be nice if there was a back arrow. It's quite common when you're in an activity that's on top of another activity or on top of another screen that you have this back arrow, and that kind of tells the user that they're not the home destination, they're somewhere a bit deeper in the app. They've drilled down a level or two, and that back arrow is an additional way they can go out of where they are. They can use the back arrow on their keyboard, but because they see the arrow in the top left, they can also go back that way. So a couple of things to do will be to have this toolbar title be dynamic, and we'll talk about what dynamic means in just a second, and also give them the back arrow, and when they click that back arrow, it will back out of the activity. It will go up a level to where they were previously. So first of all, on this word dynamic, it's a word you hear quite often in programming. So dynamic means, rather than a fixed value, a hard-coded edit record, which will be the same for every record, instead this title can be flexible. It can be different depending on the condition or the circumstances. So we have the ability for the title to be one of many values, and that value will be driven by what the user does. Dynamic, flexible, determined at runtime, determined by some other conditions, the opposite of hard-coded. So you'll hear this word dynamic quite a lot. Whenever you hear it, it's referring to the ability for the data piece in our code, to be determined at runtime, to be determined as the user is using the app. Dynamic, flexible as per what the user does. Okay? So dynamic titles. If we just minimize the emulator for now and go to our code. So we're going to go now into our edit running record activity code. And one of the first things we should probably do is just straight away switch over to using view binding. Should be mostly a recap now. We'll go ahead and make a private late init var called binding, and we should know that our binding class, our generated code, will be activity edit running record binding. Quite long-winded, but it is just the name of the layout file in uppercase with the word binding at the end. So then after the super dot on create, we can assign this binding equals activity edit running record binding dot, whoops, not the dot bind one, I want the dot inflate one. Okay, and in activities, in the app compat activity class, we have access to a layout inflator that's always available to us. And because it's an activity, we just do the one argument method, the layout inflator, that top one there. We don't do the 3 argument one with a parent and attached to parent. That's for fragments. So now we have the binding class. We can simply set content view and pass in the binding.root. So there you go. In less than a minute, we've switched over to using view binding. Fantastic. So now we've set the content view. We have this window with our very simple layout. So it's actually possible to change the title, to hard code change the title, by calling a title variable that is available to us in app compat activities. If you make some line breaks after the set content view and just type the word title, and you can see this top one from getTitle/setTitle, we can use this same Kotlin property called title to either retrieve and or set the toolbar title ourselves. So if I go ahead now and use this title variable and assign it to something new, we'll just hard code something for now. We'll say my new toolbar title. If I now go ahead and run this code, and when I click on a record, my new toolbar title. Fantastic. So we've discovered that we have the ability in code to manually change this title. So that's the first thing we need to know to be able to have control over the title at all. If I go back to the code, so now we need to have a little think. We're able to set the title manually in code, but this edit running record activity, this code needs to know which record launched it. It needs to receive somehow something that says, I was launched from the 5km container. I was launched from the half marathon container. So if we have a little moment to think, do we know the method, the way that we can pass values from activity to activity? And we have done this before. See if you can think what it is. It's to do with intents. So the answer is intent extras. We can add something to our intent. Our intent, which is like our envelope, saying, hi, please find me this class, find me this screen, and launch it and open it. Well, in that envelope, in that instruction to the Android system, we can pass with that envelope some extra bits of information, hence the word extra. So we can use the intent extras to pass some extra information, and then once we're in this edit running record activity, we can receive that extra, receive that bit of data, and then we can do some clever stuff with it to make sure we have a custom title and that we're updating the correct record. So first things first, let's go back to our running fragment and add that extra bit of information that we're going to need. So somewhere between creating this intent variable and starting the activity with the intent variable, we can add some data to this intent, to this envelope. So the way we would do that is we would do intent, the variable itself, dot, and we're going to put something inside this envelope. We're going to put some extra data. So type the word put, and then it is extra, put extra. Put something inside the envelope. And as you can see, the first value is a name, the name of this extra, the identifier to be able to retrieve it. And then it takes all sorts of things, ints, bytes, characters, longs, floats, strings. We even saw before we can make a serializable class. We can actually put a whole class, a whole object full of data. But for us, it's going to be completely sufficient to just have a string that tells us what the record is. So you don't have to choose any one of these in particular. In fact, you can just type put extra manually and do the brackets. So 2 arguments, 2 parameters. The first is the name of the record. So I'm going to call this distance. After all, we have 4 different distances from 5 kilometer all the way through to marathon. So it'll be good enough for me to identify this as the distance. So we'll do distance as the name of the extra, as the identifier, and then we'll put some sort of string. Now, right now in this launch running record screen method, we don't have any variable that says what the distance is. So can you think how you would change this code to make it so that whichever container clicks on it, we're able to determine a specific string, a specific identifier for that container? Pause the video and have a go if you think you can solve this problem. These are the sorts of problems that as an Android developer you need to be thinking of and solving when you're given a piece of work or feature to add to an app. So the way we can do this, have all 4 containers call the same method, but determine individually what string it is, what's the individual record, is by adding an argument, a parameter to the method. So let's add an argument and we'll call it the distance with a lowercase. And we'll make this variable, this argument of type string. So now above we're getting 4 errors because we're not giving anything to this method. So we can simply type in a value and we can make it a user-friendly value, the value we want to show the users who are playing with our app. So we can simply do 5 km for the 5 kilometer one, 10 km for the 10 kilometer one, and then a nicely formatted half dash marathon for the half marathon, and then marathon for the full marathon. So we have a launch running record screen method which has a distance parameter, and we're passing that argument in. Remember, argument A for the actual value, parameter for what's in the method. Okay, so we're passing in the individual distances. So now we can pass along this distance string. So I put in the word distance. So we're putting it inside our edit running record activity intent, inside that envelope, an extra bit of information. That information is labeled as distance, and then we're giving it the specific distance, which we define here. So now in the edit running record activity, we can receive that piece of information. Later on, we'll look at tidying up our code and we'll probably have it as a class variable, as a property. But for now, we can just retrieve it directly just before we set the title. So let's do a new variable, a value. We'll retrieve it and we won't change it again later. So it can be a fixed value, VAL, and we'll just call it again the distance. If you can go ahead and remember how to retrieve extras yourself, then please again pause the video and try and challenge yourself. But the way we do it is intent. We have access to the intent, one of the many things available in our app compat activity. So we can get the intent which started this activity, and then we can do .get, the reverse of put. But this time we need to know what is the type of thing we're getting. We can't just say get extra, we have to say what kind of thing it is, and we know it's a string extra. So get a string extra, and we get it by name, distance. Okay, Remember, I used a capital T. It is case sensitive, so it must match directly. So now we have this distance string. If I specify the type explicitly using Alt-Enter, Option-Enter, you can see it's a nullable string, but that's not a problem. With the getStringExtra, if it can't find it, it will just return null. It won't crash. I'll delete the variable type. We don't really need that. Just thought I'd show you that. So now we can use a string template and we can set a user-friendly title. So we can simply say the name of the distance and the word record, 5 kilometer record, half marathon record, and that will tell the user what record they're editing. So we'll use the $sign and use that distance string, distance, then a space, and then with a capital R, record. Half marathon record, 5 kilometer record. And that's all that we need to do to have a dynamic title, a title that will be determined by the user as they're using the app. So let's go ahead now and run this and make sure that our dynamic title works nicely. So when I click on the 5 kilometer record, we have 5 kilometer record in the toolbar. If I press back and do half marathon, we have half marathon record. Now just being consistent, I'm doing half hyphen marathon there, but I call the record half marathon with a capital M. So I'm actually going to go and change that. I like to be consistent. So if I just change that to half marathon, and I think I can do not the left icon that says run app that will stop it and then run it again, but there's this apply changes. So because the app is running, we have two different ways we can launch it. We can launch it from a cold start. That's the one that's got a stop icon there. Or we can do this one with an A. And if possible, it will try and rerun it without closing the app. So if I quickly click that, I can see apply changes. Okay, that seems to have worked. So I think if we just click half marathon, yes, it's fixed it without having to restart the app. That sometimes works, it sometimes doesn't. It depends how destructive the changes you make are. If you just make some small changes in your code, you can click this rerun icon with an A, and it will try and apply the changes without actually restarting your app, and that can be quicker. Okay, if it doesn't work, it will tell you it has to reinstall the app, in which case you can just stop it and run it fresh, or just click the left icon there. But I don't think I've talked about that before. It's good to know what these two different things do and the subtle difference between them. Okay, good. So yes, we are using a dynamic title. We're using an intent extra. So now the edit running record activity code knows what record it is editing. So the last thing to improve the user experience will be to give the activity a back arrow to tell the user you're in a deeper level of the app. You can back out of this. You can back up to the main screen. And you might remember from previous tutorials, the simple way that we can do this is by specifying a parent activity in the manifest. So if we go ahead now and open the Android manifest and find the edit running record activity entry, which for me is at the top, and then just after the first attribute, the name attribute, but before the closing slash and arrow, make some line breaks, and we can simply type parent activity name, and we can make the parent activity main activity. And that's a very, very quick and easy way to give us this back arrow behavior. So one more time, if I run the app, and now when I click the records, I have the name of the record in the toolbar, and I have the back arrow, which when the user clicks, takes them back to the main screen. So that is a pretty nice experience for diving into the place where we're going to edit our records. The user can get in and out easily. They can see which record they're editing. It's right there in the toolbar. And we've learned how to set titles in code using the title property. And we've even recapped about intent extras, passing the record to the new screen and displaying that to the user. So this is a pretty good place to be. We've pretty much done most of what we need to do in our fragment code for now. But of course, we've only done it in one fragment, the running fragment. So before going any further, we should flesh out the cycling fragment with the same concept. In the previous few tutorials, we've fleshed out the running fragment. If I just scroll to the left again. So we've moved the fragment over to view binding with a view binding variable. And we've set that up with a 3-argument call to the inflate method here. Then we set up the view click listeners. We know to do this in the onViewCreated method rather than onCreateView, as you can run into problems if you do too many things in the onCreateView method. So we set up our click listeners for all of our records. We have one method to launch the edit record screen. We have a separate activity for our edit running record activity. So we added a parameter to the launch running record screen method for the distance, for our running record distance. And then we create the intent to move to the new screen, passing that distance variable as an extra, and then we start the activity. And then in our edit running record activity, we set up view binding, and then we retrieve that extra, and then we set the dynamic title. So quite a few things to do there, but put simply, it's set up the fragment view binding, set up the click listeners, create a launch running record screen activity method, and then creating a new activity, retrieving the extra, and setting the title. So about 4 or 5 things to do there. So this will be a really good mini challenge for you. Without any help from me, how much of that do you think you could do for the cycling fragment? If I just move over to the cycling fragment code. Lots of little things to do there, but if you can give this a go yourself now as a mini challenge and just see how far you get. You can refer to all of the code that you've just done in the running fragment and the edit running record activity. But if you can do all of that on your own, or most of that, that'll be a really good marker for how you're doing with fragments, how you're doing with intents and intent textures, and all of the core Android concepts that we've learned so far. So challenge yourself now and try and do all the changes that we need to make in the cycling fragment code yourself. If you get stuck, you can unpause, or you can just do your best and then check your answers afterwards. But I'm going to go ahead now really quickly and do all the things that we need to do. So then we have the code for our running fragment and cycling fragment and the 2 new activities that we need fully set up, ready to go, ready to start saving and editing our records. So pause the video now. For those of you who want to check the answers or just continue, let's do this. So first of all, let's change cycling fragment to a view binding class. So private, latent int var, I'll call it binding, and it's fragment cycling binding. I'm going to delete the return line, and I'm going to assign the binding variable in my onCreateView method. So binding equals fragment cycling binding dot inflate. And I've got the inflator available to me. The container is available to me for the parent, and always attached to parent false. Otherwise, you will have problems. And now I can return for our onCreateView method binding.root. And Android Studio says view class is no longer null, so I can remove that warning. That's that done. So the next thing to do is create our button click listeners. So I'll do the onViewCreated method. This is where you should do your setup in fragments. And I'll just call another method called setup click listeners again. I'll use the error to make my method. I do this so often in my personal projects and at work. It's the quickest way to make a method in my opinion. So now I'll do binding dot, and they're called different things. So what is it in order? It's longest ride, biggest climb, best speed. So longest ride dot set on click listener. I'll duplicate that 2 more times and just change these over. Actually, no, I won't. I will type the name of the method in here. So this will be launch the edit cycling record screen. And I'll give it the name of the record. So this will be the longest ride. So now if I use this error to create the method, it knows that I'm trying to pass in a string. So if I do create function, you can see it automatically creates the string parameter. Fantastic. And I'll simply call this just the record rather than the distance. It's just a record. Good. So now that I've done that, I can duplicate this 2 more times, saving a bit of time later on. So this is now my biggest climb. And I'll make I'm going to close down the project pane, give myself full width. There we go. So yeah, biggest climb, I can change the display, the title to biggest climb. And this will be my best speed, or rather best average speed. I think I just named the ID something shorter. So yeah, this is the best average speed. Good. And now I can do the intent code here. So val intent equals an intent object. Okay, and the context is the word context in fragments, not the word this. We get the context from the fragment, and that will actually be the activity's context. So context, and then yes, I need to make a new activity now. So I'm going to escape this. I'll leave my intent object broken because I don't actually have the activity yet. So I'll open up the project pane. I'll right click in this package, new activity, empty activity. I will call this edit cycling record activity. I'll leave the layout name as that. That looks fine. Kotlin, good. Finish. I'll come back to this code, but I will leave the layout file and the code file open for now. So back to cycling fragment, I can now type edit cycling record activity : class Java. That strange syntax that I pretty much only ever need to do for intents. You soon get used to it. So now I'll do intents.putExtra, and this time I'll call it a record rather than a distance. And I'll just pass along that record string in the method parameter above. And then I can start the activity with the intent variable. So that'll give my new screen the record. I'm going to quickly go to activity, edit cycling record, and I'm going to just do a little text view again. I'll do wrap content, just something to say this is where we'll edit cycling records, just so we can have a look at the app, have a play with it and see where we are in the app. I'll do top to the top, do start to the start, nice and lazy, just stick it in the top left of the screen. I can close this down for now, close, and then I can move over to my edit cycling record activity code. Should probably switch over to view binding straight away just to get into good habits, make this view binding setup become second nature to us. So what is it? Activity edit cycling record binding. And then I can, after super.onCreate, assign this variable. So activity edit cycling record binding. I'll try and find the inflate one. Good. And because it's an activity, it just needs the one parameter method call. So I just give it the layout inflator, and that's available to me in all app compat activities. So just layout inflator. So that sets up our binding. So now in set content view, I can delete the layout resource and just do binding.root. And then we just need to retrieve the extra, set it on the title. So this can be the record, and that is from my intent that I have access to. Intent.get string extra, and I believe I called it record with a capital R. So now we can set the title with title equals, and I'll do the $ string templating. So for example, biggest climb space record. And the last thing to do is add that back arrow into the toolbar. I wonder, those of you who did this on your own, if you remembered that, that's the one that I would have probably forgotten. So into the manifest. Yes, we have the edit cycling record activity. Still, Android does the opening and self-closing tag and then complains about it. I don't know why they haven't changed that yet. So yeah, self-closing tag, get rid of that warning, and then just adding in one more attribute, the parent activity name, again, making that main activity. And I think that is it. I've not checked my workings. I've not tested this. So let's see if that works. I'm going to go ahead and run this. And we're hoping that the cycling fragments work like the running ones do. So the running ones, when I click them, I can see the running record on the toolbar and I can press back. So let's move over to the cycling fragment. Okay, so when I click longest ride, yep, longest ride record and the back arrow works. Okay, we've come back to our running fragment, which is interesting. And we're going to learn about why this happens in a moment in our activity lifecycle. Okay, but yeah, we're back to the running fragment. That's a bit annoying. Let's press cycling again though, and then biggest climb. And when I press back, it throws me back to the running record. That's quite annoying as a user experience. And then best average speed. Yes, that works as well. Good. So yes, fantastic. Quite a few things to change. As you're getting better as an Android developer, I'm going to keep challenging you to try and jump ahead and do these things yourself without me showing you. So the more that you can pause the video and jump ahead and try and do things before I show you, the better you will get at memorizing things, at internalizing things, so they just become natural and second nature to you. So well done if you tried some of that yourself, and don't worry if you missed one or two things. We're not supposed to be perfect at this stage, but the ability to give it a go yourself is a fantastic attitude to have. So we're pretty much done now, up to the point where we actually start to edit and save the records. Just time for a couple of more concepts in this section before moving on to finding out how we save things in an Android phone, how we can store values and have them between app launches. And we've also just seen there a little sneak preview of why this activity lifecycle, these methods of onCreate and onCreate view for our fragments, why they might matter. We've just seen with going back to the activity how it keeps putting us back to that same fragment, which is pretty annoying if you're a user who's just been in the cycling records to keep going back to the running screen. So just 2 or 3 more videos left of this section, and then we can finally dive into learning how to store these values, which opens up a whole new world of exciting possibilities to us as Android developers. So let's press ahead.